Generative AI is the most demandable skills nowadays across industries. If you see, all the industries have started using generative AI in their product development. If you want to level up your skill and if you want to crack good job nowadays with a good package, definitely you should know about generative AI. If you are looking for well-organized end-to-end complete generative AI course, I have a very much good news for you. Recently, I have published one amazing end-to-end generative AI course. So here I have covered everything you need to know to master the generative AI. This course will cover basics to advanced concept of generative AI. So here we are not only going to focus on the theoretical part, we'll be also focusing on the practical implementation of generative AI. We'll be exploring different kinds of large language model. With that, we'll be creating different kinds of generative AI based application. So let me show you the course content of this course. So guys, as you can see, this is the course content. As I already told you, we'll be starting from very basics of the generative AI and we'll be covering till advanced part of the generative AI. So here we'll be starting from introduction of the generative AI. So if you're completely new to this field, no need to worry. I'll cover each and everything you need to know about generative AI. Then we'll be learning about data preprocessing and embedding, because going forward, whenever we'll be using large language model, and to give your data to the large language model, first of all, you have to know how to process this data and how to generate the embeddings of the data. And to process our data, we need to know some of the techniques. So here we'll be covering these are the technique in this section. Then we'll be starting with the large language model. We'll be learning about different kinds of large language model. We'll be learning about commercial large language model. We'll be also learning about open source large language model. We'll be starting with the Huggingface platform and its API, because if you see the Huggingface is having all kinds of large language model. Whether it's a commercial model, whether it's an open source model, all kinds of model are available inside the Huggingface platform. Then we'll be also learning about OpenAI and its platform, because if you see nowadays OpenAI is evolving a lot. They are coming up with different kinds of large language model, like they are coming up with image model, language model, okay, different kinds of model they are bringing. So in this course, we'll be learning about the complete OpenAI and its platform, so that you can use OpenAI platform to implement any kinds of generative AI based application. We'll be learning about prompt engineering, because if you see, prompt is everything for the large language model. So if you are designing a good prompt, definitely you will be getting a good response from the large language model. So here we'll be learning how we can design an efficient prompt, and we'll be also learning about different kinds of prompting inside large language model. In this course, we'll be mastering the vector database. We'll be learning different kinds of vector database like Pinecone, Weaviate, ChromaDB, Fies, and so on. This vector database will help you to create a knowledge base. So whenever you will be creating any kinds of RAG based application, any kinds of LLM powered application, this vector database concept will help you a lot. In this course, we'll be mastering different kinds of generative AI based framework, like we'll be mastering Langchain, LlamaIndex Chainlit, and so on. These are the framework will help you to implement different kinds of Gen AI based application. In this course, we'll also learn one very important topic inside generative AI called retrieval augmented generation, that means RAG. So we'll be learning how we can create different kinds of RAG based application with our custom data. Even we'll be also learning how we can fine tune any kinds of large language model on top of our custom data. After completing all the topics inside generative AI, we'll be starting with some end-to-end project implementation with the deployment. So here we'll be implementing this kinds of project from scratch. We'll be using modular coding to implement this kinds of project. At the last of the course, we'll be also discussing about LLM ops. If you see inside generative AI, LLM ops is the most trending topic nowadays. We'll be learning how we can use different kinds of LLM ops platform, like we'll be learning about Bedrock, Vertex AI, and we'll be learning how we can use these are the platform to implement efficient large language based application. So yes, this is the complete curriculum of our course. So if you want to start your career with generative AI, guys, so this would be the amazing course for you. So make sure you complete this course till the end. And this is my promise, guys, you will become champion inside generative AI. With that, guys, all the best, and I will see you in the course. Hi everyone, welcome to the course of Generative AI. My name is LlamaIndex and I am a data scientist and mentor. I am having more than 4 years of working experience in the field of machine learning, deep learning, generative AI, ML ops, and so on. I have already worked with so many multinational companies as a developer. Even I also work with so many edtech companies as a mentor. I have also taken lots of batch related generative AI, machine learning, deep learning, computer vision, natural language processing, and so on. So throughout the entire course, I'm going to be your mentor. So as I already have some experience from the industry, so in this particular course, I'm going to share my knowledge and experience with you. So in this course, we'll be starting with the very basics concept of generative AI and we'll be completing till advanced part of the generative AI. So if you're a beginner, if you want to start your career with the generative AI, so this course is for you. I have designed this particular course in such a way so that anyone is coming from any kinds of domain, they will be also able to understand. So if you're from non-tech background, if you're from tech background, it doesn't matter. So if you are interested in generative AI, only you just need to start with this course. Everything I will take care. Apart from the theoretical understanding, I'm also going to show you lots of practical in this particular course. We'll be doing lots of hands-on in this particular course. We'll be solving different problem statement in this course so that your understanding would be more clear. Hello everyone, welcome back with another video. In this video, we'll be discussing about what is generative AI. So before discussing about generative AI, first of all, let me introduce some of the real world application of the generative AI you are using in your day-to-day life. So I think you know about ChatGPT, Google Gemini, Meta Llama, right? So these are the application you are using in your day-to-day life. I hope everyone has used ChatGPT at least, right? So inside ChatGPT, what we can perform, we can give any kinds of prompt. We can do the conversation. We can do the summarization, we can generate the content, we can generate the code, we can do the text summarization, any kinds of task we can perform in the ChatGPT, right? So similar wise, Google has developed their own product called Gemini, okay, Google Gemini. So with the help of Google Gemini also we can perform the same things, the things actually we perform usually in our ChatGPT. So the same thing we can perform with the help of Meta Llama 2 as well. That means ChatGPT is developed by OpenAI, Google Gemini is developed by Google, and Llama is developed by Meta, okay, Meta AI, that means Facebook. So all the tech giants companies are working on generative AI. Day by day, they are improving this particular generative AI. They are bringing actually different large language model, and they are launching different application, okay, for the users. Nowadays, all the companies are using generative AI to implement their product. So currently in the market, generative AI having more popularity. So that's why you have to know what is generative AI exactly, how generative AI works. And definitely if you want to work in the current job market, you have to know about this generative AI. You have to learn about this generative AI. Okay, this is the idea. See, all the application I showed you here like ChatGPT, Google Gemini, Meta Llama. So they are using something called large language model in the backend. Okay, with the help of large language model, they are able to perform, these are the operation. Now, first of all, let's try to understand what is generative AI exactly. See, generative AI is nothing but generative AI generates new data based on training samples. Generative model can generate image, text, audio, video, and so on data as an output. So I think you have already worked with machine learning, deep learning, computer vision, and so on, right? So there you used to use something called discriminative model. And what is discriminative model? Based on some input, actually, it will predict the output of that particular data. Okay, so this was actually discriminative model. And to train the discriminative model, actually, we used to use something called label data. That means whenever we used to prepare the data for the training, we used to prepare the, let's say, input data as well as the output data. That means you have to pass the X data and Y data. That means input and output both. Okay. And if you give input and output both, it will learn the relationship between input and output. It will learn the pattern from the data. Then it will able to predict something on top of the test data. So that was the idea in the discriminative model. That means in the prediction model, right? But generative models are different. Okay, so generative models can generate a new data based on the training samples. So here you will be giving some training sample which is called unstructured data. So based on this training sample data, it will try to generate some new data. That means inside Gen AI, whenever you are giving any kinds of unstructured data as an input, your generative model will try to understand this unstructured data. It will learn the pattern from the unstructured data, and it will try to generate something from that particular sample you are giving. Okay, this is the idea. And output can be anything. It can be text, it can be audios, it can be videos, and so on. Okay, as I already told you, inside generative AI, we not only work with the text, but also we also work with the image, videos, audios, and so on. Okay, so all the unstructured data can be used inside generative AI. This is the idea. So that's why I've written generative AI is a very huge topic. Inside generative AI, actually, we are having generative image model as well as the generative language model. That means you can work with the languages, that means text. You can also work with the images, videos, okay, and audios. So there is another model you can consider, generative audio model. But at the end, you are converting this audio to the text representation, that means language representation. That's why I haven't mentioned this audio model separately. Okay, this is the idea, because audio is nothing but it's a frequency, and from the frequency we can convert to the textual representation. Okay, this is the idea. There are so many API you will get. Even Google has the API. You can let's say convert speech to text. Okay, with the help of speech to text, you can easily convert any kinds of audio to textual representation. Okay, this is the idea. That means what is generative AI? Generative AI is nothing but it generates new data based on the training sample you are giving. And generative model can generate any kinds of output, whether it can be image, it can be text, or it can be audios. Okay, now let me tell you how they got the idea, like how the generative model can work. See, this idea had taken from real life only. Let's say if I give you 10 different cat book. Okay, let's say if I give you 10 different cats book, and if I tell you just try to read all the 10 different cat book, Let's say you have read all the 10 different cat books. Now, if I'm asking anything related cats, okay, you will be able to give me the answer because you have already studied about the cats. Like 10 different books I have given, and this was the enough data for you, right, to learn about the cats. So that's why if I'm asking anything related to the cats, you will be able to give me the response. So here you have become one cat model. Okay, you have become one cat model, and that is why if I'm giving any kinds of question, you will be able to give me the response. Okay, so similar concept applied in the generative AI also. So they implemented one model called generative model. In the generative model, they feed actually tons of data. That means huge amount of data. They trained, okay, that particular model, and then actually they were giving some kinds of question, and that particular model was able to give the response. Okay, this is the idea. That means here you are feeding tons of unstructured data, and your model is able to let's say learn the pattern from the unstructured data, and there would be a position your model will be able to capable enough to give any kinds of response, okay, based on the question you are asking. Now you can ask me why generative models are required. See, I can give you thousands reasons of the generative model requirement, but here I have listed down some of them. So the first thing you can consider, understand the complex pattern from the data, because nowadays you can see people are using unstructured data a lot. Unstructured data means it can be text data, it can be audio data, it can be videos data, right? So this is called actually unstructured data. And in today's world, actually, people are using internet broadly. And in internet, actually, people are generating huge amount of unstructured data. Okay, they are using different social media. They are using different platform. So that's how actually they're generating tons of unstructured data. So that's why it's very hard to understand the pattern from these kinds of unstructured data without traditional machine learning model. Okay, so that's why this generative model comes into picture. So it can easily understand the complex pattern from these kinds of unstructured data. The second thing you can consider the content generation. That means your generative model can generate any kinds of content. It can generate code. It can generate, let's say, any kinds of story. It can generate any kinds of music, any kinds of videos. Now, I think nowadays you have seen like there are so many applications came in the market. So if you give any kinds of prompt, it will generate the video for you. Okay, the complete video for you. That means it is generating some content. Okay, it is generating some content based on the prompt you are giving. And that's how for the content creator also, it is becoming one of the very used tool, okay, for their content generation and all. Let's say you are a blog writer. Now you don't need to write the blog from scratch. So what you can do, you can just pass the topic and your model will generate the blog for you. And what you can do, you can just modify this particular blog with respect to your requirement and you can publish, okay, anywhere. You can also generate any kinds of videos. You can also generate any kinds of reels, okay. Everything is possible nowadays with the help of these generative models. Okay, so that is why content generation is one of the very important, let's say, features inside generative models. Okay, I can talk about. Now the third thing you can consider, build powerful application. As I already told you, we are already using tons of powerful application in our day-to-day life, like ChatGPT, Gemini, okay, then Llama. So different actually powerful application we are using in our day-to-day life. And just try to think about when we didn't have these kinds of application, we had to complete lots of work actually manually. But nowadays we are having this kinds of powerful application. Now you can do any kinds of work actually in a few seconds. Okay, it is possible. Let's say if I give you one example as a developer, whenever let's say you are getting any kinds of error, okay, from your, let's say, application, what you can do? You can copy that error and you can ask through the ChatGPT. ChatGPT will give you the solution, okay, how we can solve it. But previously when we didn't have any kind of ChatGPT, what we used to do? We used to search that particular error inside Google. We used to open the Stack Overflow and we used to see lots of, let's say, solution. Then we used to solve that particular, let's say, error. And nowadays, actually, we are using this kinds of application and it is actually saving lots of our time. So we don't have to spend actually lots of time to fix any kinds of bugs. In a few seconds, actually, it is possible nowadays if we are using this kinds of powerful generative AI based application. Okay, this is the idea. Those who have already studied about artificial intelligence, machine learning, deep learning, maybe you have already seen this kinds of Venn diagram. Okay, this is the Venn diagram of our AI, the complete AI. Now you can see machine learning is a subset of artificial intelligence. Deep learning is the subset of machine learning. And now here you can see generative AI is the subset of deep learning. Okay, it is the subset of deep learning. That means machine learning is the subset of artificial intelligence. Deep learning is the subset of machine learning and generative AI is the subset of deep learning. Okay, this is the complete Venn diagram of the complete artificial intelligence. Okay, I hope it is clear. Now let's try to see the difference between discriminative model and generative model. You can see discriminative model is nothing but it's just a prediction model. Let's say here you have given two input. One is the cat image, another is the dog image. what your discriminative model will do, it will try to predict whether it's a cat image or whether it's a dog image. That means you are trying to do some prediction here. I think you already use this kinds of model in your deep learning. Let's say whenever you used to perform something called image classification, there we had different model like ResNet 50, Inception V3, right? MobileNet, VGC16. So with the help of this particular model, we can perform the image classification task. On the other hand, generative model can take actually any kinds of sample data, any kinds of noise data, and from that particular noise data, it will generate a complete new image for you. Okay, new data for you. Now let's say here you are passing one noise data. Noise data means it can be any kinds of unstructured data. And what generative model will do, it will try to understand the pattern. Okay, it will try to understand the pattern from these kinds of data. Okay, then it will generate a new data for you, new data point for you. This is the idea. Okay, this is the idea of the generative model. See, I have kept another example here. Let's say, so here we are using discriminative model to classify the music type. You can see here we are giving actually different music, rock, classical, and romantic. So here your discriminative model, that means your discriminator deep learning model will try to classify whether it's a rock music, whether it's a classical music, or whether it's a romantic music. On the other hand, generative model, what it will do, you will just give some music sample, okay, and generative model will try to understand the pattern. It will generate a complete new music for you. Maybe you have already heard of AI has created music, AI has created songs, AI has written story. How? That's how actually they're using something called generative model. They're actually feeding lots of training samples, okay, and this model is learning and it is generating a new content, okay, with respect to the data they are giving. This is the idea of the generative model and the discriminative model. I hope now it is clear. Now, if I discuss a little bit low level, like how things are working here. See, maybe you have heard of something called supervised learning. Okay, in supervised learning, what we do, we give the X data as well as the Y data. That means input and output. And here we try to find the relationship between our input and output. Okay, this is called actually supervised learning. And whatever actually, let's say, discrete model actually we're using, it is called actually supervised learning. On the other hand, we are having another learning called unsupervised learning. In the unsupervised learning, what we used to perform, we used to perform something called clustering technique. Let's say here we are only giving the X data, that means the input data. And what my model will try to do, it will try to make a cluster. Let's say this is one cluster, this is another cluster, this is another cluster. That's how it is separated out my data. Okay, that's how it will find out the relationship between the data. Okay, this is the idea. Now you can consider this unsupervised learning as a generative model. So generative model will also work in the same way. So instead of actually finding the relationship, what it will try to do, it will try to make a cluster. Okay, it will try to make a cluster from the unstructured data actually will be feeding. This is the actually low level actually understanding I'm giving you how things are working here. But on top of that, they have added some more technique to actually build these kinds of generative AI model. Okay, this is the idea. So in summary, actually you can see generative AI is a subset of deep learning, and generative models are trained on huge amount of data, as I already told you. While training the generative model, we don't need to provide any kinds of label data. We only give the unstructured input data, because whenever you are working with huge amount of data, it's not possible to label the data. Okay, that's why you are giving the unstructured data as an input to the generative model. So here you can see in generative AI, we give the unstructured data to the large language model for the training purpose. And whatever things I explained so far, you can see what your discriminative model will do. It will try to actually predict whether it's a dog image or whether it's a cat image, okay, by finding the relationship. On the other hand, your generative model will try to make a cluster. Okay, let's say this is a cat cluster, this is a dog cluster. Okay, then with the help of that, it will able to generate a new content from you. I think you have heard of something called GAN, the generative adversarial neural network. Okay, so GAN is also called generative model. Okay, because here you will be giving noise data, and from the noise data itself, it will able to generate a new content. Okay, new data. This is the idea of the GANs. So far I told you about generative model, but what exactly this generative model? See, generative model is nothing but it's a large language model, which is also called LLM. See, a large language model is nothing but it's a foundational machine learning model that uses a deep learning algorithm to process and understand the natural language. These models are trained on massive amount of text data to learn patterns and entity relationships in a language. It can be also considered in a image data as well. Okay, not only text data, you can also use LLM for the image as well, because I told you we are having two kinds of model, generative language model, generative image model. Okay, so you can also use image data here, not only text data. And it is a language model which is responsible for performing tasks such as text to text generation, text to image generation, image to text generation. As I already told you, generative model can support actually all kinds of data. you can generate text to text, you can generate text to image, even you can also generate image to text. Okay, everything is possible with the help of this large language model nowadays. Okay, and we also call it as multi-model. That means you can perform multiple tasks here, not one specific task. You can perform multiple tasks like text to text, text to image, and image to text generation. Apart from that, you can perform some more tasks. Let's say you can perform language translation, you can perform text generation, you can perform, let's say, text classification, you can perform sentiment analysis, name entity recognition, all kinds of tasks you can perform with the help of only one model, and which is nothing but our large language model. Okay, and large language model is nothing but our generative model. Okay, this is the complete idea about our generative AI. I hope it is clear now. Now let's try to understand what makes LLM so powerful. As I already told you, in case of LLM, one model can be used for whole variety of the task. Okay, I told you now, text generation you can perform, chatbot you can perform, summarization you can perform, translation you can perform, code generation you can perform. That means whatever task actually you have inside the NLP, all the tasks you can perform with the help of one model, which is nothing but large language model. So that's why we call this LLM is so powerful, and that makes LLM so powerful, because in our traditional model, whatever model we used to use, that means the language model only, we can only perform one specific task. Let's say you want to do actually language translation. For language translation, you need to only train one language translation model. That model can't do the code generation, or let's say text summarization. That model can't perform. But if you're using large language model, you can perform all kinds of tasks with the help of one model only. Okay, so that's why LLM is so powerful, because of this particular idea. So as I already told you, if you're using your traditional actually language model, it can only perform one specific task at a time. Let's say you want to build a sentiment analysis. So one model you have to train for the sentiment analysis, which will only able to do the sentiment analysis, whether this particular, let's say, sentiment is positive, neutral, or negative. Let's say you want to perform language translation. You have to train another model for the language translation, and that model will be able to translate any kinds of text. Okay, that means you have created two separate model, okay, for two separate tasks. But if you are using large language model, you need to only train one specific model, okay, and that can perform multiple tasks. This is the idea of large language model. So let's see some of the large language models. So here you can see we are having Gemini, GPT, XLM, then we are having T5, Llama, Mistral, Falcon. Apart from that, there are so many large language models are available over the internet. I'm going to discuss, I'm going to show you each and everything. So here I just mentioned some of the large language models just to show you. But I will tell you how you can see all the large language models are available over the internet. Even I will also show you how you can access those models and how you can use those models to create your application. Okay, on top of it, everything I'll try to clarify. So yes, guys, this is the introduction of generative AI. Now I think you got the clear-cut idea about generative AI, like what exactly is generative AI, and inside generative AI actually what are the things are available, and why it is actually mostly used technology inside any kinds of software product nowadays. And inside generative models actually what is uses, it is uses something called large language model. And not to worry, I'll discuss about large language model in detail, like how large language model works, and inside that what are the architecture they're using. Everything I will try to clarify. And now you can ask me what is end-to-end pipeline of generative AI. No need to worry, I will explain each and everything, what is pipeline and all, and why pipeline is super important whenever you are working in the generative AI field. See, it's not like that whenever you are getting some problem statement from your company, whenever let's say you are receiving the data, it's not like that you will be directly applying the model on top of it. Before applying the model, we have to perform some specific task, okay? And those step-by-step task is called pipeline. So you can see generative AI pipeline is a set of steps followed to build an end-to-end Gen AI software. Okay, that means here you will be breaking the problem statement into several sub problems. Then you will be trying to develop a step-by-step procedure to solve them. And here you can see, since language processing is involved, okay, inside generative AI, so we would also list all the forms of text processing needed at each step. This step-by-step processing of the text is known as a pipeline. Okay, that means whenever you are getting any kinds of problem statement from the company, first of all break that problem statement in a several sub problems. Okay, then try to solve one by one. And to solve that, you have to perform some steps. Okay, you have to perform some steps, and those steps is called actually pipelines. Okay, pipelines inside generative AI. Now let's see one end-to-end pipelines actually we have to follow for all the projects we'll be developing in futures. See, in generative AI pipeline, we are having, these are the steps we have to follow. The first step actually we have to follow the data acquisition, because here data is everything, right? At the end, you have to work with the data here. So first of all, you have to get the data. And these steps falls into data acquisition part. Okay, then after that data acquisition, we have to perform something called data preparation. Okay, what is data preparation? I will let you know. That means here you will be doing the cleaning of your data. Okay, after that you will be starting with something called feature engineering. Inside feature engineering, there are so many steps you can follow. Like, so the main step actually you'll be doing inside feature engineering called text representation. That means you will represent your text to the vector, that means number, so that your model can take the input. Then after that you'll be doing the modeling. Then you have to select different model and you have to feed the data there. Okay, this is the idea. After modeling, what you have to do, you have to evaluate that particular model, because unless and until you are not evaluating the model on top of test data, you won't be able to decide whether this particular model is suitable for our production or not. Okay, then once, let's say you got your let's say production model, what you can do, you can do the deployment of your model. You can host your model so that other people can use your model. Okay, other user can use your model and they can give the feedback. Okay, based on the feedback, last step what you can do, you can perform monitoring and model updating. That means you have to monitor, you have to keep on monitoring your application. Like I think you saw the ChatGPT, right? So previously I think you saw in ChatGPT, whenever let's say you are giving any kinds of prompt, so it will give you one, actually, let's say input form. It will tell you, are you enjoying this ChatGPT, or any kinds of feedback you want to give or not. So there actually they were taking the input in real time. Okay, this is called actually monitoring. Okay, monitoring their application. That means they're monitoring whether this application is working fine or not in the production. If something going wrong in the application, if let's say user is giving negative feedback, that time what they will do, they will try to update this model again. Okay, this is the idea. So it's not like that you are only building your model, you are only deploying your model. It's not like that. You have to monitor the model in production, and based on the feedback you have to keep on updating the model itself. Okay, this is the complete idea, and these are the steps involved inside the generative AI pipeline. I hope it is clear. Now let's break down all the, let's say, pipeline steps one by one and try to understand what we have to do in each and every step. The first step was actually data acquisition. So inside data acquisition, you can follow some step to collect your data. So the first thing, you have to check whether you have available data or not. So available data. Available data means, let's say you are having a CSV file directly, you are having, let's say, text file, you are having, let's say, PDF documents, you are having docs documents. Then you might also have something called Excel SX. Okay. So if you have, these are the files. Apart from, if you have any other file format, it's completely fine. But first of all, you have to check whether you have available data or not. Okay, this is the idea. Now, if you don't have the available data, what you have to do, you have to look for other data. Okay, other data means you can collect the data from the database. You can see in the internet whether someone is having the data set or not. Then you can also use the API. Let's say someone will give you the data, but you have to fetch the data through the API. That time, actually, what you can do, you can collect the data from the API itself. Okay, then you can perform something called scraping. That means web scraping. Let's say you don't have the data in database, internet, API. Then what you can do, you can do the web scraping. Okay, web scraping means you will be scraping the data from a website. Okay, this is the idea. Now there is another possibility, you have no data. That time what you will do? Okay, that time you have to create your own data. Create your own data means either you can collect the data. Okay, either you can do the survey, you can collect the data, or what you can do, you can use large language model to generate the data. Okay, LLM to generate data. Nowadays, actually, you will see people are using OpenAI. Okay, OpenAI GPT model. Okay, GPT model to generate the data. Okay, so with the help of LLM also you can generate your own data. But whenever you are creating your own data, there is a possibility, let's say your data will be less. Let's say here I will just write, you have to note, let's say whenever you are collecting your own data, your data quantity might be less. So that time what you can do, so let me write here, if you have less data, then you can perform data augmentation. I think you know what is data augmentation. Okay, so data augmentation is nothing but you will be augmenting the data. Let's say I'll give you one example. So the first augmentation technique you can perform, so let me give you the example. You can do something called replace. You can do replace with synonyms. Okay, now how to do the synonyms? See, let's say here is one example I will give you. let's say I am a data scientist. Okay, so let's say this is my text. Now what you can do, you can just replace this synonyms. So here you can write I am a AI engineer. That means you are replacing this particular entity with this entity. So this is called actually replace with synonyms. Okay, this is the idea. I hope you got it, because here you will be working with textual data mostly. And if you have the image, that time what you can perform. So there are lots of image augmentation technique as well. Let me show you. So you can simply search image augmentation. So there are different technique you can follow. See, let me show you one example. Let's say this is the example I can show you. Let's say this is your original image. So what you can do, you can do the horizontal flip, you can do the vertical flip, you can do the rotation of the image, you can also do the negative rotation, you can do the blur operation, you can change the brightness, you can add some noise, you can add some darker. Okay, so that's how actually you can change the original image. Okay, you can change the original image and make different variants. Okay, this is called actually image data augmentation. Because I already told you, inside Gen AI we use both kinds of data, whether it can be textual data, it can be image data, it can be audio data. Okay, anything actually you can consider here. Now the next technique you can apply, which is called bigram flip. Bigram flip. Now you can ask me, sir, how to perform bigram flip? See, it's very easy. Let's say I'll give another example. I am Bappy. All right. Now you can write this sentence like that. Bappy is my name. Okay, so this is called actually bigram flip. That's how actually you can also do that data augmentation, because at the end you are increasing the data. That is the idea. And whenever you are increasing the data, it should have the meaning. It doesn't have the meaning, that means there is no use of the data. So you have to make sure whenever you are performing, these are the technique, this data should have some meaning. I hope you are getting my point. Now the next thing you can perform, third step you can perform, back translate. Back translate. Now how to perform back translate? Let me show you. So let me go to my translator. So I'll open the translator. Okay, Google Translator. Let's say here if I write one sentence, or I can just copy one story. Let's say here what I will do. Let's say I will copy this text, and here let me paste it. Now you can see it is translating to the Bengali. Now what I will do, I'll copy this Bengali translation, and here the input language I'll be selecting the Bengali right now. So let me select the Bengali and I can paste it here. Now here you can select any other language. Let's say I'll select Spanish. Now see, Spanish text it is giving. Now let me copy. Okay. Now what I can do again, I can come here, I can paste the Spanish text, and let's say I want to convert to English again. So here let me select the English. You got your English text. Now so here if you see carefully, some of the word would be different, okay, than your previous actually text you have copied after doing the bigram flip. That means you will be converting a language to another language, that language to another language, then again in your English language. So that's how if you do multiple time translation, you will see some word would be changed. And see, this will work if you have actually lots of text, actually lots of sentence, not like that you are only copied 1 to 2 line. If you have multiple, let's say line, multiple text, that time actually the reflection actually will able to see. Okay, I'm just only showing you how we can perform the back translation, because there are so many API nowadays inside Python you can use for the back translate. I think translation API is already there. With the help of that, you can do the translation. First of all, let's say you have the English text. First of all, try to translate to the Hindi to, let's say, Spanish to English again. That's how you can do the back translation, and you can increase the data. So this is another amazing data augmentation technique you can follow. Okay, I hope you cleared. The last step actually you can follow something called add additional data or additional noise. How we can add additional noise? Let's say here you have one sentence, I am a data scientist. So with this sentence you can add one more line. Let's say I love this job. Okay, so this is your additional data or additional noise you have added, okay, with your data. So again, this is called actually data augmentation technique. And again, it's an amazing technique you can follow, okay, altogether. So these are the steps actually you can perform inside data acquisition, okay. So first of all, try to check whether you have available data or not. If you don't have, try to see the other data. If you don't have, try to create your own data. For this, you can use large language model. Even I will also show you how we can generate your data with the help of large language model. And after generating, let's say if you have less amount of data, in that case, you can perform something called data augmentation technique. Inside data augmentation technique, these are the steps you can perform. Okay, so this is the first step of the pipeline. Now let's discuss the second step of the pipeline. Okay, the second step, I think you remember, data pre-processing. So inside data pre-processing, you can perform cleanup operation. Okay, cleanup operation. That means you can remove HTML tags. Then you can remove, let's say, emoji. You can do the spelling check. Okay, spelling correction. Fine. So these are the technique actually you can perform inside cleanup. Now there is another step you can follow called basic pre-processing. I'll tell you what are the basic pre-processing are available. Even I will also show you the practical how you can perform. Then you can also perform something called advanced pre-processing. Because nowadays the application actually we have, let's say, ChatGPT, Gemini. So these are the actually advanced application, advanced, let's say, large language model. So for this, we have to also perform some advanced pre-processing technique. Okay, let's say whenever I'm having that data nowadays, because let me show you. Let's say if I open my ChatGPT, okay, if I open the ChatGPT, see if I give any kinds of emoji nowadays inside ChatGPT, still it will be able to understand. Let's say if I give this haha, okay, haha, let's say emoji. Now if I send it to my ChatGPT, see, it is automatically detecting what's so funny. Okay, so that's kinds of text also we need to handle, because whenever we are collecting the text data, it will have emojis, it will have HTML tags. Okay, so many things it will have. So sometimes it is also necessary to keep the emojis, because I told you now, this kinds of application is advanced. So it is also understand the emojis, any kinds of text. So we also need to handle these are the, let's say, text in that time. Now inside basic pre-processing, let me just write here. Inside basic pre-processing. So inside basic pre-processing, the very important things you have to perform something called tokenization. Okay, so you have two kinds of tokenization. One is called sentence level tokenization. Another one is word level tokenization. So I'll be discussing each and everything, no need to worry. And there are some optional pre-processing are available. So inside optional pre-processing, the first thing you can perform, stop word removal. Okay, stop word removal. Then the second things you can perform something called steaming. And this is like very less used nowadays. Okay, less used actually technique. The third thing you can perform something called lemmatization. And the lemmatization actually more used. Okay, I'll tell you what is steaming, lemmatization whenever I'll show the practical, that time I'll discuss. Then the fourth things you can perform something called punctuation removal. So punctuation means, let's say you have question symbol, you have dot, you have comma, you have exclamation sign, okay, you have dollar symbol. So these are the things are actually punctuation. So you have to also handle the punctuation. Then you have to perform something called lowercase. Then the sixth, you can perform something called language detection. Because nowadays, if you open the ChatGPT or Gemini, if you give any kinds of language, it will first of all detect in which language you are asking the question. Based on that, it will give you the reply, okay, in the same language. So so they are also applying this language detection technique, okay, in the backend. So that's actually one real world product implement. Okay, it's not like that you are getting the data, you are directly applying the model. It's not like that. So you have to follow the entire pipeline to build the end-to-end software. Okay, that's why I'm showing you these are the pipeline. Why this generative AI pipeline is super important, and what are the steps are involved, okay, inside the pipeline, so that after learning it, it would be easy for you to develop any kinds of software in future. And this is my promise. If you understand this, okay, if you can do this, you can design any kinds of software in future. Okay, because what is generative AI? Generative AI is nothing but just a technology. So you have to use the technology. You have to learn how to use the large language model, how to prepare the data for the large language model. Okay, how to use, let's say, Langchain, how to use vector database. You have to connect everything together. Then you have to build one application. That is the idea only. But the root things available inside the pipeline, how you're designing the pipeline, whether pipeline has all the steps available or not. I hope you're getting my point, right? So now I think these are the steps are clear. But I think some of them still you are getting confused, like what is steaming, what is, let's say, lemmatization, what is, let's say, why we have to perform the lowercase operation, and what is this tokenization. See, let me just discuss all of them one by one. So first of all, let me discuss the tokenization. That means, let's say you are having a sentence here. Let's say my name is Bappy. So this is a sentence, right? This is a complete sentence, right? So whenever I will be converting this sentence to number, that means vector representation, first of all, I have to actually do the tokenization. Tokenization means you will be taking the individual words, let's say like that, my, comma, name, okay, comma, is, comma, Bappy. This is called actually word level tokenization. Okay, word level tokenization. Okay, that means you had one complete sentence, you just did the tokenization and you got the word as a token, okay, everywhere. Now you can take the word and you can convert to number. There are some technique we can follow. I'll tell you those are the technique, what are the technique you can follow to convert your text to number representation. Okay, and there is another technique called let's say sentence level tokenization. Let's say you are having a sentence like that. Let's say my name is Bappy. I am a data scientist. Okay, now if I perform sentence level tokenization, so sentence wise actually I have to convert. So it will come like that. My name is Bappy. So this is my one token, then comma, then I am a data scientist. Okay, this is another token. That means two token I'm having in the list. Okay, this is called actually sentence level tokenization. Sentence level tokenization. Okay, so we'll be using this word level tokenization a lot. Sentence level you can also use. Sometimes you have to use sentence level tokenization. Sometimes you'll be using word level tokenization. But most of the application I saw, people are using word level tokenization. That is the idea. So this is what actually our tokenization. Okay, now let's try to understand what is steaming. See, steaming is nothing but you are bringing one word in a root form. Let's say here we are having three kinds of word: play, played, and playing. So if you see them carefully, meaning are same, yes or no? Meaning are same, only the word representation is different. Now instead of taking actually three, okay, separately, what I can do, I can convert in a root form. So root form is nothing but play. Okay, because play represents sports. Okay, sports. So this is called actually steaming. That means you have different actually word form, that means different verb form, and you are trying to bring in a root representation. Okay, this is called actually steaming. And again, it's important because it will reduce the dimension. Okay, it will reduce the dimension whenever, let's say, you will be converting your data to the vector representation. Because if you have three word, so it will create actually three dimensions separately. But if you convert it to one, let's say word only, so it will only have one dimensional. And we know that inside artificial intelligence, dimension is like the issue. So if you have, let's say, more dimension, that time your model will get confused, because there is a concept of curse of dimensionality. So you have to also take care about the dimension. Okay, that's why we perform this steaming operation. And lemmatization is the same. Okay, the way actually perform the steaming, lemmatization is also same. Only whenever you will perform the lemmatization, your root meaning of the word would be readable. But whenever you will perform actually, let's say, steaming, sometimes it won't be readable. I'll tell you whenever I'll do the practical of it, that time actually will get it. Okay, what I'm trying to say. That is the idea. Now you can ask me what is lower casing. Okay, because punctuation you already know. Now you can ask me why lower casing is important. Why you have to perform the lowercase operation. Let's say if I write to sentence, Bappy is very good boy, and Bappy is a data scientist. Let's say these kinds of sentence we are having. Now here you can see, I think Bappy and Bappy, both name are same, but here you can see the first character it's a capital one, the second character it's a lower one. So as a human, actually, you can consider these two BAPI are same. But whenever you will be passing to the model, that means in your computer will be considering these two word is a different word, because here you are using capital and here you are using lowercase character, because all the character is having their ASCII value, right? That means the ASCII code, Unicode. So with the help of that, it will consider these two words are separate. So that time, this BAPI would be different, this BAPI would be different, although they are same. Okay, this is another issue. So that's why we perform lowercase operation. So whenever actually we are having the uppercase, will try to convert to the lowercase. Okay, we'll try to convert. So let me show you. We'll try to convert to the lowercase. Okay, so this is now you can see this BAPI and this BAPI will become same. Okay, now if you give pass to the computer also, your computer will identify this BAPI and this BAPI is the same right now. Okay, so that's why we perform the lowercase operation, so that my model won't be getting the confused. Okay, this is the idea. So I think most of the things I clarified, and yeah, so everything I'll show you as a practical as well, how we can perform as a practical. I'll discuss it. Okay, no need to worry. Now, apart from basic pre-processing, I also told you we have something called advanced pre-processing as well. Now let's try to see what are the steps are involved inside advanced pre-processing. So inside advanced pre-processing, we have something called parts of speech tagging. Parts of speech tagging. So if you're good with English grammar, I think you know what is parts of speech. Okay, then you are also having something called parsing. Then you have something called co-reference. Okay, co-reference resolution. Now if you want to understand them, let me show you one image. I think then this part would be clear. So guys, I think you can see this image. So here you can see this is the input text. We are having Chaplin wrote, directed and composed the music of for the most of his film. Now if I perform tokenization and lemmatization, so I already told you what is tokenization. You will be taking individual words. See here I have taken individual word here, and if you perform the lemmatization means it will bring the let's say any kinds of verb in a root word. Now you can see wrote, if I bring to the root word, it will be write. Directed, it will be direct. Okay, then compose, it would be composed, it will be compose. So that's how actually you can understand the tokenization and lemmatization. Now, what is POS tagging? POS tagging means parts of speech tagging. The things I showed you in my advanced pre-processing. So this is what actually parts of speech tagging. That means you are assigning what is noun, what is verb, what is adjective. Okay, so that's how you are defining different kinds of parts of speech. If you're good with grammar, I think you will be understanding better than me. Just try to consider here you are tagging everything. That means you are tagging all the, let's say, noun, verb. Okay, then pronoun, everything you are tagging. Now there is another one called parsing. Okay, I think I showed you parsing. So this is the parsing tree. That means you will be creating a tree, and inside this tree you will have the entire sentence word. You can see Chaplin wrote, directed. Okay, all the words. So in the parts tree you will be again assigning the POS tagging. Apart from that, you will be also dividing these are the word in a separate form. Again, this is a advanced actually grammatical rules you have to learn, but no need to worry. Let's say whenever you will be working in the industry, there you will have something called domain expertise. Okay, let's say language expertise actually people you will get, so they will help you to do it. Because I know as a developer, you don't know about, let's say, this English grammar and all, but whenever you will be designing the software, that time language expert will help you. Okay, how we can perform the parsing, how we can perform the POS tagging, everything they will help you out. Now this is the last example, co-reference resolution. So co-reference resolution means, let's say Chaplin wrote, directed and composed the music for the most of his film. Now here Chaplin and his, it is indicating the both person, it is indicating the same person, right? So this is called actually co-reference resolution. Sometimes your model has to understand this Chaplin and his. So it is mentioning the both, it is mentioning the same person. Okay, so this is called actually co-reference resolution, because nowadays if you see the ChatGPT, Gemini, so these kinds of application is able to understand, okay, this kinds of input, this kinds of prompt. Okay, so in the backend actually they're handling like that. I hope it is clear now. Then the third actually step were available inside Generative AI Pipeline, which is nothing but feature engineering. Feature engineering. So inside feature engineering, you can perform text vectorization. So to perform the text vectorization, you can follow some technique like you have TF-IDF, you have something called bag of word, you have something called word to vec, You can also perform something called one-hot encoding. Then you can also use some transformer, transformers model to perform the text vectorization as well, because these are the very old technique. So if you're using any deep learning and machine learning model, that time you can use these are the technique. But if you are creating advanced application, like let's say if you're using large language model, transformer based architecture, like say encoder and decoder architecture, that time you have to use transformer model to perform the text vectorization technique. Okay, I hope it is clear. So these are the steps that are available inside feature engineering. So inside feature engineering, you will just try to convert your text to vector representation. It can be also work with the image as well. Let's say you are having an image. Okay, let's say you are having an image, and in that image actually you are having a cat image. Let's say this is a cat. Let's say this is a cat. Okay, now image is nothing but it's a pixel. So if you just see the image, so here you will see different pixel value. Okay, different pixel value. So that time what you can do, you can use any kinds of vision transformer model to convert this image to the vector representation. Okay, vector representation, and you can pass to the model. Okay, so that is the idea. Now fourth step, actually I think you saw, after feature engineering you can do the modeling. Okay, modeling means you'll be training the model. That means you'll feed the data to the model. Okay, so here you can choose different model. You can choose actually different kinds of model. So here you can either use open source, okay, open source LLM, that means large language model. Either you can use paid one. Okay, paid model. So what is the difference between open source and paid? See, if you're using paid, one, this model would be available in the server. That means you don't need to download this model in your machine. Okay, so you don't need to download. Instead of that, what you will do, you will only, let's say, pass the data. Okay, let's say you are using OpenAI, because I think you know OpenAI provides actually paid model. That's a GPT model. So in OpenAI, you will upload your data, and in their server, it will train the model. Okay, you don't need to download the model in your machine, and you don't need to train there, because I know that people won't be having good GPU in their system. Okay, it's not possible actually to buy expensive GPU for training these kinds of large language model, because if you see this large language model, it's very huge. Okay, if you see the parameter size is very huge, so we can't download in our machine and we can train it. It's not possible. So that's why most of the time we'll be using cloud platform to train the model. Okay, so that time actually you can use the paid model, because paid model, if you're using paid platform, if you're using everything, they will take care. Only you have to upload your data there. But if you're using open source large language model, that time you have to download this model in your machine. You have to prepare everything. You have to set up the environment, and then you have to train the model. And for this, you need a good GPU. Okay, good GPU, good CPU, good memory. Okay, everything you need. And after training this model, you have to deploy this model in a cloud platform. Okay, manually you have to deploy this model in a cloud platform, and again you will get the challenges there. Like you have to buy a good instance, then you have to set up the load balancing and all. Okay, then you have to deploy this particular model. But if you're using cloud platform, they directly will get one option to deploy the model in their server only. Okay, so that people can access the model in their platform only. Okay, so you don't need to take care about the infrastructure. You don't need to take care about the instance. Everything they will take care. That is the difference. Got it? We'll be also understanding how we can use paid model, how we can use open source model. And I will also discuss the difficulty level actually you will be getting whenever you will be using open source LLM, whenever you will be using, let's say, paid LLM. Everything I'll try to clarify. No need to worry. Training your model, you have to perform something called model evaluation. Okay, evaluation. So inside evaluation, you have to perform two kinds of evaluation. One is like intrinsic evaluation, and that is like extrinsic evaluation. So intrinsic evaluation means you'll be using some metrics. Okay, you'll be using some metrics to evaluate the model. I think you know we are having different metrics for the evaluation. Let's say we are having accuracy score, R2 score, then we are having AOC card. So these are the different metrics we are having. Okay, so after training a model, you have to perform something called intrinsic evaluation, and this is performed by and this evaluation will perform by the GenAI engineer. Okay, GenAI engineer, because they're training the model, and after training the model, they have to actually evaluate the model with the help of these are the matrices. And the extensive evaluation when they have to perform after doing the deployment. Okay, after doing the deployment. So this evaluation can be applied during the production. Okay, let's say whenever this model is in the production, people are using it. At that time, this extensive evaluation can be performed. Let's say I already told you, ChatGPT will launch one input. Sometimes it will ask you give the feedback. Not only ChatGPT, if you see any kinds of application. So if you just consider your phone keyboard, so whenever you use the keyboard, okay, so initially I think you won't be getting any kind of suggestion, but whenever you will be using that particular keyboard, okay, long time, then you will see that automatically you will get the suggestion, because it is learning, okay, what kinds of input you are giving, it is learning. And sometimes it will ask for one kinds of feedback, whether you are enjoying this app or not, okay, any feedback you want to give or not. And whenever you are giving the feedback, whenever you are giving the 5 rating, 4 rating, that time, so that time actually they are getting this application is working fine, there is no issue. But whenever you are giving negative feedback, that time they're getting actually there is some issue with the application. That time what they will do again, they will retrain the model, okay, they will retrain the model and they will again push the model through the production. Okay, so that's how extensive evaluation works. That means after deployment, after going to the production, okay, after going to the production of that model, you will be performing this particular extensive evaluation. This is the idea. And the sixth, I told you, you have to perform deployment. Okay, deployment. And inside deployment, you will be also doing the monitoring and retraining. Okay, retraining. Because you will be doing the monitoring in the extensive evaluation, and if something going wrong, you'll be doing the retraining of the model. This is the idea. So these things are involved inside. So the entire generative AI pipeline, I hope it is clear. So first of all, data acquisition, then data preparation, then feature engineering, modeling, evaluation, and deployment. And here one thing you have to remember, because going forward, I'll be using this term a lot. So let me just write here a common term. Let me copy this text and let me paste here. Let's say this is my data. Now here you will see some of the actually, let's say common term. The first term actually we'll see called corpus. Okay, corpus. Then the second term you will see, which is nothing but vocabulary. And the third term you will see, which is nothing but documents. And the fourth you will see something called word. Okay, word. Now what is corpus? Corpus is nothing but the entire text. Entire text. That means the entire text is called corpus. Okay. And what is vocabulary? Unique word. Unique word. Now you can see this is unique word, this is unique word, this is unique word, this is unique word, this is unique word. Okay. So these are the word is unique. And if you see any of the word is coming duplicates, only you have to take the unique word. Okay. This is called actually vocabulary. Okay. Then what is documents? Document is nothing but one row. That means one line only. So till here actually one documents, D1. Then this is called actually D2. Okay, D2. Then D3. So this is called actually documents. So I can write one line. Okay, one line is the documents. Okay, or one row. And what is word? Word is like thus single word. Okay, single word is called word. So you can see this is a single word, this is a single word, this is called actually word. So these are the common term you have to remember, because going forward, whenever we'll be actually playing with the data, that time actually I may tell you these are the actually common term. Okay, that time you won't be getting confused. What is corpus, what is vocabulary, what is documents, what is word. Okay, that's fine. So that's why I showed you, okay, here in this video. So yes guys, these are the actually generative AI pipeline, and here I have just showed you as a theoretical. So in the next video, we'll be doing the practical of it, like how we can perform different text cleaning technique, like different text preprocessing technique. After that, we'll also see how we can perform feature engineering technique as well. Okay, different feature engineering technique. Because what I feel like, before starting with our large language model, first of all, we have to understand the data. First of all, we have to know how to prepare the data for the model. Okay, then we'll be starting with the large language model. Okay, so this thing actually is thing actually very important before learning your generative AI, before learning the large language model and application building. So that's why I'm teaching you this part. In our previous video, I already discussed about end-to-end generative AI pipeline. So there I told you what is the use of data preprocessing, right? Because if you want to use the model, that means large language model, the first thing you have to do the data preprocessing. Because unless and until you are not processing the data, how your model will try to understand that one, right? That is the idea. So here we'll be learning various kinds of technique to clean up our data. So for this, what I have done, I have created a beautiful collab notebook. So there actually I have added all the examples you can use for the data cleanup operation. So guys, now let's try to see how we can do the data preprocessing part. So guys, as you can see, this is the notebook I already prepared. So here you can see I'm using one dataset from Kaggle. So let me open the link. This is the link. So the dataset name is IMDb dataset, and it is having actually 50k movie reviews. Okay, 50k actually movie reviews. If you are already from, let's say, machine learning, deep learning background, I think you know about this dataset, right? It's like very common dataset. And why I took this particular dataset, because in this dataset you will see there are so many actually unnecessary text. Okay, because it's a movie review. So what they did actually, they extracted, they scrapped this data from the IMDb website. If you don't know, this is the IMDb website, IMDb. So in this website you will see all the movies reviews and rating. And what they did actually, they published this dataset in the Kaggle website, so that if anyone is working in the field of, let's say, generative AI or natural language processing, they can use the dataset. Now here, what you just need to do, you just need to download this data. Okay, it's around I think 27 MB. Just click on download button, it will download. Okay, so I already downloaded this dataset, so it is available inside my download folder. So I'm going to upload in my Collab notebook. So here, first of all, what you have to do, you have to connect this particular notebook. So there is a connect button, just try to connect. And no need to worry, I will also share this notebook link in the resources section. From there, you can open it up. So my notebook is connected. So first of all, let's import some of the library. First of all, I need something called pandas, because if you see the data, it's a CSV data. Okay, it's a CSV data. So let me upload and let me show you. So if you want to upload anything in the Google Drive, just try to right click and there is an upload button. Click on upload and try to upload this data here. Now see, it's a CSV file. Okay, and if I want to load any kinds of CSV file, JSON file, or let's say Excel file, whatever file, you can use the pandas package for that. So you can see my dataset is uploaded. Now if I want to load the dataset, what I have to do, I have to assign the path. And see, you don't need to execute these are the code, because this code I have added. Let's say if your dataset is available in your Google Drive, that time what you have to do, you have to mount your Google Drive. First of all, mount means you will be connecting with your Google Drive, then we'll be relocating the folder. Okay, like inside which folder you kept your data. Okay, with the help of cd command. CD means change directory. Okay, then after that, what you will do, you will assign the data path. But here I haven't kept my data inside my Google Drive, I kept inside my Collab. Actually, you can see drive. This is the Collab disk I am using. Here you will get around 74 GB of space. So here you also can keep your data. So I don't need to execute this code. What I will do, I'll just go below, and if I check my current working directory, that means pwd, you will see I'm inside content. Content means this is the directory right now. Now here I'll just simply define my data path. So I'll copy the path, copy, and let me paste it here. Okay, that's it. Now let me execute. Now see, if I now load the data, pd.read csv I'm doing. So now see, it will load the data. See, it has loaded the data. If you want to see the shape of the data, this is the shape. Okay, you have around 50k actually movies reviews in this particular CSV file, and two columns. Two columns means one is the reviews column, another is like the sentiment column. Okay, sentiment means whether it's a positive sentiment, whether it's a negative sentiment. This kinds of sentiment you will get here. I hope it is clear. Now see, here I'm having 50k movie reviews, but here I'm not going to use all the reviews. Here I'm going to show you the demo, like how we can perform the text preprocessing. And if I'm taking all the 50k reviews, so it will take like lots of time to process those are the text. So what I will do, I'll only take the 100 example. Okay, the first 100 example I'll be taking, and on top of that I will perform all the text processing task, right? So this is the code you can execute. So it will load 100 example. Now if I show you the shape, see, now we are having 100 example and only 2 columns. Fine. Now if I want to show you the data, see, this is the data. So I think you remember in my theoretical class I was discussing about some pre-processing technique here, I think. So here you can perform something called HTML tag removal, emoji handler, then spelling correction. Then in the basic pre-processing we saw that we can perform something called tokenization. Then we had some optional pre-processing as well, like stop word, streaming, lemmatization, punctuation, lowercase, okay, language detection, each and everything. So first thing we'll be learning how we can perform the lowercase operation. And why lowercase is important, I already explained here. I think you remember. Let's say if one of the name is containing uppercase character, it will consider these are actually separate name. Okay, these are actually separate entity. That is the idea. So that's how we have to bring everything in a lowercase character. So that's how you have to apply this lower operation. And how to perform lower operation, I think you already know. In Python, we are having a function called lower. With the help of lower also we can do it, right? Now see here, let me show you one example. Let's say I'm taking the reviews 3. So here I'm taking the three number rows. This is the 3 number rows. Now you can see some of the character is uppercase character here. So this is uppercase, this is uppercase. Okay, so that's how actually you will see different uppercase character would be there. Now if I want to make them lowercase, what I have to do, first of all I have to select my column, like in which column you have to apply the lower function. I have to apply on top of my review column. Now first of all I'm converting everything to the string. Okay, string data type. Then I'm applying the lower, because lower is a string method. Okay, lower is a string method. I think you already know that. Then whatever changes actually I'm doing, I'm saving inside my column. That means I'm just doing the permanent change, okay, inside my column. So that's why I've given a review again. That is the idea. Now if I execute, now see if I show you the data. Now see guys, all the character has become lowercase right now. Now if I want to show you the, now if I again execute that review 3, you will see that all the character has converted to the lowercase character. Okay, that is the idea. Now the next thing we'll be learning how we can handle the HTML tags. That means how we can remove the HTML tags. For this, here I have written a function. Here I'm using something called regular expression, regex. Okay, so inside regex you can give a pattern. Let's say here you are giving a pattern. If you are getting this kinds of symbol, okay, if you are getting this kinds of symbol, it's a like HTML tag. You have to remove those HTML tags and you have to replace with empty. Okay, empty string. That is the idea. Now this is the function we can use. Now if I execute, now let's say this is a one text I have prepared. You can see in this text actually we are having lots of HTML tags. Now if I pass this particular text to my function, see it will automatically remove all the tags. Now see, I'm only getting that text, okay, relevant text. That is the idea. So this notebook I prepared in such a way so that you can use it as a template. Let's say whenever you need anything, any kinds of functionality, you can come here, you can copy those functions. So please try to keep this particular notebook with you, because this is going to help you a lot. Okay, whenever you'll be developing the projects, this is going to help you a lot. Now if you want to apply on top of the entire data set, again just call this column name, let's say review column. Okay, and there is a function called apply, and inside that just try to pass this function. Okay, apply function takes actually one function object. Now here I'm giving the function object. So what it will do, it will try to apply this particular function on top of the entire rows you are having in your data set. Okay, now see if I execute, and the changes actually I'm doing, I'm saving everything permanent. Okay, now let me execute. Now if I show you any kinds of random, let's say rows, now you'll see all the now let's see if I also show you 7 number rows. Now just try to see, there is no HTML tags in this particular text. You can pick up any kinds of, let's say index. Let's say if I show you the 10, nowhere you will see the HTML tags here. Now we'll be learning how we can remove actually URL. Let's say if you are having some URL in the text, how we can remove it. For this again I'm using regular expression, and there is a pattern I have given. If you are getting this kinds of, let's say a word http then slash then www, that means it is a URL and you have to remove the URL with the empty string. Okay, this is the function. Now let me execute. Now here I have just mentioned some of the URL. So this is my YouTube channel URL, this is my LinkedIn URL, and google.com and kaggle.com. Okay, now these are the text I have prepared one by one. Now let's say if I'm passing any kinds of text inside my remove URL function, it will remove that URL. Let me show you. See, I'm giving the text to, that means my LinkedIn URL. Now you can see, check out my LinkedIn. I hope it is clear. See, again I'm telling you, it's not a mandatory things. Let's say you need URL in your data. At that time you can keep it. Let's say you need actually HTML tags, you can keep it. But if you don't need it, you can remove it. Because I already told you, nowadays actually we are having advanced generative AI application. It also supports all kinds of text like emojis, HTML, okay, everything it supports. So if you are creating this kinds of advanced, let's say, application, that time you need these are the data. You don't need to remove it. Okay, but sometimes actually you also need to remove this data set. So that's why I'm showing you how we can remove it. And if you want to keep it, you can also keep it. It's up to you. Okay, you have to decide based on your project architecture at that time. This is the idea. Now we'll be learning how we can handle the punctuation. So if you want to see the punctuation, so there is a string package you can use. Now if you just write string.punctuation, you will see all kinds of punctuations are available. Now what I have done, I just stored these are the punctuation in a variable called exclude. Now here I have written a function. Okay, here I have written a function called remove punctuation, and here I have written a for loop. So I'm just looping through this punctuation one by one, and user is giving the text, and I'm just checking whether if there is any punctuation. Okay, I'm just replacing with the empty string. Now let me show you how it will work. Now let's say this is one text string with a punctuation. You can see there are so many punctuation I have assigned. Now if I pass this particular text to my punctuation functions, it will remove the punctuation. Now see, there is no punctuation right now. Even I'm also calculating the time, like how much time it is taking to remove the punctuation, because there is another way you can follow to remove the punctuation. I'll tell you how you can do it. See, this is the function, guys. So here you can use something called text.translate. Inside that, just try to use this particular function. Okay, make translate, and inside that, just try to mention the punctuation. So what it will do, it will take your text and it will remove all the punctuation. So this is another approach. Now see, if I calculate the time of this function, you will see that this is the time. That means this function is taking less time than your this function, because here you are using one for loop, and for loop has the linear time complexity. I think you know that. If you are familiar with DSA concept, I think you know that it is having linear time complexity. Okay, so this particular approach is good. So let's say if you are applying this particular logic on top of 50k data set, just try to think how much time it will take this for loop. And in other hand, if you are using this particular method, it will take very less time to perform the operation. Now, if you want to see the time difference, you can also see the time difference. Now, if I show you my text, now see, inside this text, actually, I'm having lots of punctuation. Now, what I will do, I will use my remove function one, that means this particular function, and inside that, I'm going to pass my entire review. Now, see, it will remove the punctuation. Okay, see, all the punctuation has been removed. Now, you can also pass the entire data. Like that, you can also pass the entire data. It will remove all the punctuation inside your entire data. Now we'll be learning how we can handle the chat conversation. See, sometimes whenever we perform the chatting operation, we give like lots of shortcut. Let's say if I want to write as far as I know, what you will give? You will give AFAIK. Then let's say away from keyboard, AFK. Then as soon as possible, ASAP. That's how we use lots of chat keyword. Okay, we use lots of chat shortcut keyword. Okay, here I have listed down some of them. You can see for your information, FYI. So that's how I have listed all the chat conversation short word. Now let's say you are working with actually social media dataset. In the social media dataset, you will see these kinds of data a lot. People will be using short form. Okay, short form. So how we can handle this particular short form? For this, first of all, try to create a dictionary like that. The entire dictionary you have to create. Then after that, here I've written a function. So this is the function chat conversation handle. So inside that, I'm just taking the text. Okay, I'm just taking the text and I'm checking. And inside that, with the help of this for loop, I'm checking if we are having these kinds of word. Okay, if you are having these kinds of word, what we're doing, we're just mapping with the value. That means, let's say, if anyone having actually this particular, let's say, a shortcut word, let's say FYI. What I will do instead of FYI, I will just return for your information, because this is a dictionary. If I want to get the value, I want to call the key. Okay, that's how we are mapping. Now see, if I execute the program. Now let's say here we are giving a short message, do this work ASAP. Now see, it will return me, do this work as soon as possible. Okay, because here it is coming here and it is mapping and it is giving me this value. Okay, this is the idea. Now let me see how we can handle the incorrect text. Let's say sometimes what happens whenever you are using real-time data, there would be lots of spelling mistake, right? Let's say this is one example, certain spelling is not correct, then condition spelling is not correct. That's how you'll see different word is having the spelling mistake. So how to handle this spelling mistake? For this, you have to use one package called text blob. So let me import this text blob. And now see, here I'm having my incorrect text. Now if I pass this incorrect text to my text blob, and if I call this particular function called correct, now see, it will handle everything. Now see, certain conditions during several, see, all the word has been corrected. So this is one amazing package you can use if you want to handle the spelling. Okay, spelling of any word. Now the next thing we'll be learning how we can handle the stop words. So inside English language, not only English language, inside all kinds of language, we're having some stop words. Okay, now here we're working with the English language. So let me show you some English related stop words. For this, I will be importing stop words from the NLTK. NLTK is nothing but it's a natural language toolkit library. So with the help of NLP also, you can perform lots of NLP related tasks. So here you can see I'm importing the stop word. So here I'm performing nltk.download. It will download all the stop words from the internet. Now see if I click this cell, it will download the stop words. Now if you want to list down all the stop words, you can just write stop words, and here you can specify the language. So here I'm working with the English language. So here I've given the English. Let's say you are working with Hindi, Bengali, you can give that language also. It will give you the stop word related that language. So you can see the documentation of NLTK. We'll see that how we can pass the parameter here. Now see, these are the words we are having inside English. So this is called stop word. So this word doesn't have any kinds of meaning, okay, in a sentence. Okay, we use it to represent one sentence, but there is no meaning. So let me show you why I'm telling there is no meaning. Let's see if you want to perform sentiment analysis. So let's say there is one review we are having. So let me just write, this movie is awesome. I loved it. Now just try to see, here you are having some stop word, right? Like is there, this is there, I is there, it is there, right? But if I want to get the sentiment of this particular, let's say reviews, I can see movies is required, awesome is required, loved is required. Now if I'm getting these kinds of word, actually this kinds of positive word, that means it's a positive sentiment. Okay, it's a positive sentiment, yes or no, right? So here actually I don't need these are the stop word. Okay, I don't need this as the stop word to understand whether this particular reviews is a positive or negative. And if you're using these are the stop word in the sentence, so what will happen whenever you will perform the text vectorization, it will make actually extra dimension. Okay, it will make the extra dimension in the data. And whenever it is making the extra dimension, that means if dimension is increasing, that time your model might get difficulties, right? Because we know that there is a concept of curves of dimensionality. So we always need to reduce the dimensionality somehow. I think you have learned in your machine learning. Okay, machine learning, let's say, topic. So that is why we don't need these are the stop words. So we have to remove this particular stop word sometimes. And sometimes actually we have to also keep it. So these are the stop word, guys, you saw. Now let me show you the length. So around we are having 179 stop words present inside English. Now here I've written a function. So this function will remove the stop words from a text. Now let me show you. Let's say this is a text I have given. So inside that you can see different stop words are there. Now if I pass to my function, so see, now see, there is no stop word in this particular text right now. Okay, that's how you can use this particular function. Now again, this is my data. And if I want to apply on top of my entire reviews, I can do it. I can use the apply function and I can pass my function object, remove stop words. And if you want to store permanently, what you can do, you can write this code. Okay, df reviews is equal to df reviews apply stop words. Okay, it will save everything permanent, but I don't want to save it permanent as of now because I'm showing you as a demo. If you want to do the permanent, you can do it. So now guys, I think it is clear how we can remove the stop words. Now the next thing we'll be learning how to handle the emoji. Okay, see, emoji is nothing but it's a Unicode actually character. Okay, if I show you, if you just write emoji Unicode, you will see different Unicodes of different emojis. So let me open it up. See, here we are having different emojis. Based on that, we are having the Unicode. Okay, Unicode character. Okay, Unicode character. So that's why I just collected some of the Unicode character, like for the emotions emojis, symbols, then pictographs. Then we are having transport, map, symbol, flag. Okay, so these are the emojis related Unicode I collected here, and I just written a function. Okay. And again, I'm using the regular expression. So here I'm telling if you are getting this kinds of Unicode in a sentence, that means it's an emoji. So what you have to do, you have to remove those emoji with an empty space. Okay, now let me show you. So let's say this is one text I'm giving. Love the movie, it was flying kiss. Okay, now see if I pass this particular text, now see it will remove the emojis automatically. Now this is the next one. Now see, only Lamo is coming. Now sometimes actually I told you emojis are required. Because let's say I told you in the ChatGPT example. So if you pass any kinds of emoji to the ChatGPT, it will also able to understand, okay, what you are trying to say. Let's say if I pass any kinds of emoji here, let's say I'll give this emoji. Hey there, what's on your mind today? See, it is trying to understand my feelings, right? Now, if I want to handle these kinds of situations, what I have to do, I have to keep the emoji. That time, what I can do, I can extract the meaning of the emoji. So for this, I can use one library called emoji. Okay, now let me show you. First of all, you have to install it. Now just import the emoji, and inside emoji you are having one method called demojize. Okay, now inside that just try to pass the text Python is fire. I'm giving the fire emoji. Now see, it will automatically convert to the word Python is fire. Okay, that means it is trying to extract the meaning of that particular emoji right now. I hope you cleared. So that's how whenever you are passing any kinds of emoji as an input to the ChatGPT, it is trying to convert this emoji to the word and is trying to understand what you are trying to say. Now there is another example I have given. I love this movie, it was flying kiss. See, love this movie, it was face blowing a kiss. Now we'll be understanding the tokenization. I told you we are having two kinds of tokenization, sentence level tokenization and word level tokenization. So let's try to see. See, if you want to perform the tokenization, directly you can use the split function, because the split also will give you the individual word in a list. See, if I have one sentence, now if I perform the split operation, see, I'm getting actually individual word. So with the help of split also you can perform the tokenization. So similar wise, you can also do the sentence level tokenization. This is the word level tokenization. Now for this, you have to mention this particular full stop sign. So whenever it is getting the full stop, that means this is one sentence. Okay. Now see if I execute. So here I'm having 3 sentences. So I am going to Delhi. I will stay there for 3 days. Let's hope the trip to be great. Okay. See 3 sentence I'm getting. So this is called sentence level tokenization. So again, some of the example with the split function. Now with the help of regular expression, you can also do the tokenizations. So this is one example I kept with the regular expression. So here is my sentence and it will give you the individual word. This is the sentence level tokenization. Okay. And this is the pattern for the word level. This is the pattern for the sentence level. Okay. This is the idea. Now you can also use something called NLTK. Okay. That means Natural Language Toolkit Library for the tokenization as well. Inside that, we are having two actually function word level tokenizer and sentence level tokenizer. Now let me, and if you want to perform the tokenization, you have to download this particular thing called PUNKT. Okay. This particular thing you have to download. Okay. Now see, here is my sentence and I want to perform word level tokenization. I will pass this. So it will give me the word level tokenization. So automatically this function will handle. Now if you want to perform sentence level tokenization, you can use send tokenizer. Okay. From here. And you are getting the sentence level tokenization. Okay. So again, some of the example you can try I have given. And I created this notebook in a such a way you can use it as a template. I already told you. I have written like the function wise, right? If you need any kinds of, let's say, cleanup technique, you can copy from here and you can use it in your code. That's the idea. Now there is another package you can use called Spacey. With the help of Spacey, also you can perform the tokenization. Fine. So you can explore this part. Now let me go to the schema. Okay. I already told you what is schema. Schema means you are trying to bring the different word in a root form. That means let's say you are having play, playing, played. So what you will do, you will apply schema and you will just try to convert it is to the, and you'll just try to convert to the root word. That means play, right? Because it is meaning the same. Okay, in a sentence. So now let me show you. So inside NLTK, we are having this streamer, porter streamer. Now we are importing porter streamer and here we have created the function stream word. So whenever you will give any kinds of, let's say, sentence, it will perform the streaming operation. Now see, here I'm giving work, works, walking, work. Now if I give this particular sentence, it will give me the root form. That means work, walk, walk and all. Okay. Now see, here I kept one sentence. So this is the entire sentence you can see. Now I want to perform streaming operation on top of the sentence. So I'm using my function inside that. I'm passing the sentence. Now see, it will give me the streaming word right now. Now see, probably it has been probable. Okay, probable. That's why I told you streaming is not readable. Sometimes you will get some kinds of word, it's not readable. But your model will try to understand. Okay. But as a human, it's not readable. See, favorite has been converted to favorite right now. Okay. So in case actually what you can use something called lemmatization. Okay. Lemmatization will handle this kinds of situation. It will give you a readable word actually. Now see, this is the lemmatization code. So it is available inside NLTK. I'm importing the lemmatization, initializing the lemmatization. And if you want to use lemmatization, you have to download these at the things, WordNet and OMW. And now if I execute this code, you will see that it will give you the lemmatization for all the words. See. So this is the word, this is the lemmatization, this is the word, this is the lemmatization. Now see, it's readable. Okay, it's readable. Then your streaming one. I hope it is clear. Fine. So that's why I just written streaming and lemmatization are same to retrieve root words, but lemmatization is worked good, lemmatization is slow, and streaming is fast because lemmatization will give you the readable output. That's why it's a little bit slow than your streaming. Okay, I hope it is clear. So yes, these are the technique you can follow for the text pre-processing. If you are having any kinds of text, you can perform text pre-processing with the help of these are the technique. You can clean up your text. Okay, and again I'm telling you it's not required to perform all the text cleaning technique. Sometimes if you need anything, just try to keep it as it is. That is the idea. Fine. So yes, this is all from this video. And what you can do right now, you can download any other dataset from the kaggle.com, because Kaggle is having different dataset, not only movie dataset. You will also get something called Twitter dataset. I think Twitter dataset is also available. See, Twitter dataset is also available. Just try to download the Twitter sentiment dataset and try to apply these are the text pre-processing on top of the Twitter dataset. Okay, so this should be one task, guys, from my side. Please try to attempt, because unless and until you are not practicing, things would be more complicated. And whenever you will be doing the practical, okay, by yourself, things would be more clear here. So in the next video, we'll be learning how we can perform the data representation. That means text representation, how we can vectorize our text. That means we'll be converting our text to numbers, okay, for the model. So I think you already know what is data representation. That means inside generative AI, you will be working with textual data. So not only textual data, you will be also working with something called image kinds of data. Now, these are the actually raw file. If you see any kinds of text data, any kinds of image data, okay, so these are actually raw data. These are actually unstructured data. So I can't directly pass these kinds of data to my model, because model is nothing but at the end, it's a mathematical equation only, right? And mathematical equation can only support numerical data. So what we have to do, whatever text data, whatever image data we are using here, we have to convert them to the vector. That means we have to convert them to the number, okay, numerical representation. So this concept, we call it as a data representation. You can also call it as a data vectorization. Okay, so here we'll be seeing couple of technique we can follow to perform these kinds of vectorization technique on top of our data. Even I will also show you some drawbacks with different technique, and which technique actually at the end you have to follow for the generative AI. If you're working in the generative AI, if you're working with the large language model, so which technique would be suitable for your task. Okay, so here everything I'll try to clarify, so please try to watch this video till the end, and if you have any kinds of doubt, you can also ask me in the comment section. So let's start, guys, with our data representation topic. So guys, in this video I'll be discussing about like what is feature extraction from text. You can also consider as image. Then we'll be discussing about why we need it. Then third, I'm going to discuss why it is so difficult. Then we'll be discussing about what is the core idea and some techniques. So this should be my entire video agenda. So first of all, we'll be discussing about what is feature extraction from text. You can also consider as image, because I told you na, in generative AI you can use any kinds of data, whether it can be text, image, audio, okay, anything. See, first of all, we have to understand what is feature extraction. See, feature extraction is nothing but, let's say you are having a unstructured data. Let's say you are having a text data, or let's say image data. So from this data, you are extracting some features to represent that particular data. So I think those who are already familiar with computer vision, you already learned about convolutional neural network. So with the help of CNN, what we can perform a feature extraction. That means we just try to extract some of the features from an image. So what kinds of features? Let's say the edges, okay. Then you'll be also extracting some patterns. So these are the actually features. So with the help of these particular features, my model will be able to understand about the data, and it will be able to predict something, okay, on top of the test data. So this is the idea. So in generative AI also, what kinds of data actually we're using, we also need to perform something called feature extraction, because whether it can be text data, image data, any kinds of data, the first thing what you have to do, you have to extract the features from that particular data. Okay, this is the idea. And feature extraction means you are converting your textual data to numerical representation. That means to the vector representation. Okay, this is the idea. Then the second thing actually you can see why we need it. Because as I already told you, in generative AI, whatever model you are using, whatever large language model you are using, every model is a mathematical equation. And mathematical equation can't take actually your textual data or image data directly. So for this, definitely you have to convert to the number. Okay, numbers. You can also call it as a vector. Okay, vectors. So if you can convert to the numbers or vectors, then your model will be able to take this particular data as an input, and it will learn, okay, what kinds of actually pattern it is having. Based on that, it will try to generate something. This is the idea. Okay, now why it is so difficult? So whenever I'm talking about text data, okay, whenever I'm talking about text data, it would be a little bit difficult for you to extract the features from the data. Why? So let me show you some example. Let's say if I'm considering, let's say ML in machine learning, I think you remember, inside machine learning, what kinds of data we used to use? I think you remember, we used to use something called tabular data. Okay, tabular data. Tabular data, like we used to use something called CSV data, then Excel. Fine. So these are the actually tabular data. That means here you will have a table. So let's say this is your table. So it will have one fixed table. So in this table, you will have the fixed column size. Let's say you are having here 1, 2, 3, 4 column, and sum of the rows. So 1, 2, 3, 4 columns. 1, 2, 3, 4, 5 rows. Okay. So here your table dimension is 5 cross 4. Okay. So this is the table dimension. That means it's a fixed size. It's a tabular data. Okay. It's a tabular data. So here you will have the column. Okay. Here you have the column. And here you will have the row. I hope you cleared. Now you will store the data. Fine. Now whenever you are taking any kinds of, let's say, machine learning model, let's say this is your machine learning model, your ML model. So what you will do, so what is the X feature size? X feature size is nothing but your input size. Okay, input size, that means the independence variable. Let's say you are doing house price prediction. So let's say this is number of room. Let's say this is the area of the house. Let's say this is number of bathroom, and this is the price of the house. So this is your Y variable. Okay, and these are your X variable. Okay, so X variable I'm having how many? 1, 2, 3. 3 X variable I'm having. Okay, that means you will give 3 input to the model and only 1 output you will get, which is nothing but Y hat. Okay, this is the idea. That means to the model you have to give X data 3 column and Y data 1 column, which is nothing but your price, and this is your target variable. Okay, and once you pass the data, you will get the output. That means here your column size is fixed. So here what you saw, your column size is fixed. That means your input size is fixed. Okay, to the model. Okay, there is no issue. That means we can easily use our tabular data. Okay, for in the machine learning, or you can also use in the deep learning. For this, you have to use something called neural network. That means artificial neural network, right? Now let's consider image data. Let's say inside computer vision, we use something called image data. Okay, image, videos. And whenever I'm talking about videos is nothing but it's a frame of image, right? It's a sequence of image. So you can convert videos to image, then you can analyze, again you can convert to videos. So let's consider image only here. So let me show you. See, image is nothing but it's a pixel. Okay, inside image actually we'll see different pixel values. So let me show you one example. So guys, here you can see, here I kept one image, and this is a MNIST digit image. So here you can see 3 has been written. So if you just zoom this image, what you will see these kinds of pixel. Okay, and inside pixel you are having different numbers. You can see these are actually numbers. So this number range would be 0 to 255. Okay, 0 to 255, this is the range of the number. And one thing, wherever you can see the 0, okay, 0 number, you can see it's a white pixel. Okay, it's a white pixel. And whenever you see some number, okay, it's a black pixel. You can see whenever you can see much darker color, it's that means it is close to 255. And whenever you see some mild like darker color, that means it is close to 0. Okay, so this is the idea. Let's see your 3 looks like that. Let's say this is the 3 in this image, and here is the 3 representation in the number. That means if you zoom this image, you will see some numbers, that some value, pixel value would be there. Okay, so that's how actually your 3 looks like. So whatever image you are taking, you'll be getting this kinds of pixel value. Okay, at the end. Now whenever I'm talking about image data, so you can easily convert image to a table representation because it's a pixel value at the end. So what you can do, you can create a fixed table. You can create a fixed table. Let's say this image dimension is 28 cross 28. Okay, now just try to calculate the pixel value. Based on that, just try to create the table and add all the number here, add all the pixel. Now if you calculate all the pixels here, so if you just multiply 28 cross 28, you will get something called 784. Okay, I think that many of pixel. So this should be your input size. Okay, this should be your input size. Now what you can do, you can create a neural network. Okay, dot 784. Now just pass all the data one by one. Okay, pass all the data one by one, and so on. Okay, till 784. Okay, so that's how again you can create a easy neural network. And here input size is also fixed, which is nothing but this is the input size, because all the image will have the dimension, fixed dimension. Okay, I hope it is clear. That means there is no issue with the input size. Now the next data, let's talk about audio data. Okay, audio data. So audio is what? Audio is nothing but, so what is audio? Audio is nothing but it's a frequency. You can see it's a frequency. So whenever you will see some audio, you will get this kinds of frequency response, and the parameter of the audio would be dB. Okay, that means decibel. Okay, this is the frequency of the audio. Now you can easily convert this audio signal to a number representation, because here you can see, let's say this is your hertz. Okay, this is your hertz, frequency hertz, and this is your dB, that means decibel. Like, and now you can see this is the actually frequency. Now just try to see the graph, and based on that just try to collect the number. Let's say you have created one table. Let's say this is your table. So one column you just consider, let's say this is the frequency and this is the decibel, okay, dB. Now just try to collect the data. Let's say here you can see 400 hertz and the decibel value was, let's say, minus 10 dB. Okay, that's how just collect all the data. Okay, collect all the data. Now again you will see we'll have one fixed table. Okay, we'll have one fixed table. Again you can take a deep learning model here, let's say artificial neural network, and you can feed the data. You can feed the data and you can get the prediction. Okay, again you don't have any issue with the input size. But whenever I'm talking about, let's say, text data, whenever I'm talking about text data, so here you will get the difficulty. How? So let me show you. So let's say this one sentence I'm having, my name is Bappy. So here just try to see how many tokens you are having. So we are having 1, 2, 3, 4. That means 4 tokens. Let's say somehow you converted this text to a number representation, that means vector representation. Let's say my you are considering as 0, name you are considering as 1, is considering as 2, and Bappy you are considering as 3. Now you will be creating a network. Let's say this is your neural network, 1, 2, 3 and 4. Then what you will do, you will feed the data. Let's say my will come here, name will come here, is will come here, and Bappy will come here. Okay, now let's say you have taken some hidden neural network, and here you will get the y hat. Okay, now let's say there is another sentence, how are you? Now see, here you will get the difficulties, because in the previous sentence how many tokens I had 4 tokens. Now if you count this sentence, you are having 1, 2, 3, only 3 tokens. Now let's say you have represented these tokens 4, 5, 6. Okay, let's say this is your vector representation. Now tell me, can I pass this particular data to the model right now? Because what is the model input size? 4. But here what is the input? You are having 3. So here you will get one dimensional issue. Okay, dimension issue you will get. Okay, so it will give you one error. So it is expecting 4-dimensional input, but you have given 3-dimensional input. Now just try to consider, whenever we write any kinds of text, it doesn't have any kinds of input length similarity. Okay, you can write anything. You can write, my name is Bappy, how are you, I'm okay. So it should be any kinds of length sentence. Okay, it can be any kinds of length sentence. And there actually we usually face the difficulty whenever we use these kinds of textual data, because it doesn't have any kinds of input size, because it's a completely unstructured data. And representing this text to numbers is very much difficult, because I can't assign 0, 1, 2, 3 like that. Because if you're assigning 0, 1, 2, 3 like that, your model won't be able to understand. It's not a meaningful number. But previously, the data I showed you, we can easily convert them to the numerical representation, because tabular data is already a numerical representation data, right? Then image is already a numbers, because at the end you are getting a pixel here. Then audio is already a number, you are getting a number here. But what about text? Text is a string. But how we can convert a string to a number representation so that it will have the same meaning of my sentence? Let's say here I have written, my name is Bappy. So after my name is coming, after name is coming, after is Bappy is coming. So with the help of number, how I can, let's say, contain that particular relationship? Is it possible? Yeah, it is possible, but it would be a little bit difficult for you initially, because you don't know like what kinds of, let's say, vectorization you can perform here to represent this particular sentence to a, let's say, meaningful representation. That is what I'm trying to say, right? So now you can ask me, sir, we can apply actually 2 techniques we have learned previously. I will tell you what kinds of technique we can apply. You told me, let's say the first technique we can apply something called one-hot encoding. One-hot encoding. So this encoding technique you have learned in your machine learning, right? That's whenever you have any kinds of categorical data used to perform this one-hot encoding, right? Then the second technique, you can also perform something called bag of word. Bag of word. We can also call it as a bow. Okay, bag of word. So now let's try to discuss these 2 techniques, how it can be applied and what are some drawbacks. Okay, if I were applying these kinds of technique. Okay, so first of all, let me discuss one-hot encoding. So what I'll do, I'll just create a table here. So let me create a table. So here I will take 2 columns and 4 rows. As of now, I'm only taking 4 example just to show you, okay, how things will be working. But in actual way, we'll have more than actually 4 rows. Okay, that means you might have thousands rows, let's say lakhs of rows. Okay, it doesn't matter. Let's say this is your data 1. So here you are having a sentence. Let's say people watch. Let's say I'll give my YouTube channel name DSwithBappy. So if you don't know, guys, this is my YouTube channel name. If you're interested, you can also visit. Then let's say data 2 we are having DSwithBappy much DSwithBappy. I'm writing any kinds of sentence, guys, as of now. Whatever things I'm thinking in my mind. Now it's a data 3 you are having people write comments, and data 4 I'll be writing D4 DSwithBappy write comments. Okay, let's say these kinds of data we are having initially. Fine. So that means how many rows we are having? We are having row 1, row 2, then row 3, and row 4. That means only 4 row we are having as of now. Okay, for example, we are having 4 data points we are having, right? Now, if I want to perform one-hot encoding, so first thing what I have to do, I have to take the entire corpus. Okay, and I already told you what is corpus. I think in my previous session, the text preprocessing session, at the last I was discussing about some like key important things you have to remember. Okay, so whenever I'm talking about corpus, that means your entire data. So just try to collect your entire data. Let's say people, then you have the watch, then you have the DSwithBappy, then you are having then again you are having DSwithBappy, then again watch, then again DSwithBappy, then you are having people, then write, then comments, then again DSwithBappy write comments. Okay, so this is your entire corpus. Okay, corpus. Okay, corpus of your data. Now from here you have to figure out how many unique word you are having. So we are having people, we are having watch, DSwithBappy, then write, and comments. So these are the unique words. That means 1, 2, 3, 4, and 5. That means n is equal to 5. Okay, 5 unique word we are having. Now what we have to do, we have to create a table. Let's say I'll create a table with these 5 unique words. So the first word will come people. The second one will come watch. Then the third one will come, let's say DSwithBappy. Then write. Then comments. Okay, comments. Okay, so that's how your one-hot encoding will try to represent the data. Okay, let's say whenever you are using any let's say library in Python, so how this library works exactly to perform the one-hot encoding, that is what I'm explaining here. Fine. Now see how it will try to convert your text data to numerical representation. So first of all, it will take the row 1, that means D1, let's say people. Now just try to find people here. So you can see people is there. That means this should be 1 and everything would be 0. Okay, then watch. Now just try to find out the watch. So here is the watch, so it should be 1 and everything would be 0 again. Okay, then DSwithBappy, so it should be 1 and everything would be 0. Okay, so here the number actually we got, this is for the D1, that means data 1, row 1. So here I can write like that. Let's I'll just simply write D1. Okay, D1 is equal to, so here I got one 2-dimensional vector. So here 1 0 0 0 0. Okay, then comma 0 1 0 0 0, then comma I got 0 0 1 0 0. Okay, so this is my D1, that means sentence 1. Okay, this is for the sentence 1. Okay, I hope you clear. Now again you will take the sentence 2, that means D2. Okay, D2. Now you will just try to find the numerical representation. Now let's find a D2 as well. So let's say DSwithBappy. So again, let's say this one would be 1 and everything would be 0. Okay, so this is for actually D1, and now we are doing for D2. Now again it will see the watch. So watch is here, it would be 1 and everything would be 0 again. Now the next thing would be DSwithBappy again. So let's say this is a DSwithBappy and everything would be 0 again. Okay, so this is what actually your D2. So again I can represent like that. Let's say D2 is equal to 0 0 1 0 0, comma 0 1 0 0 0. Okay, then comma I'll take 0 0 1 0 0. Okay, so this is my D2. So that's how you have to complete for all the sentence. That's how you have to complete for all the sentence, and at the end you will get all the vector representation. Okay, you will get all the vector representation. I hope it is clear. Okay, how one-hot encoding can be applied. Now let's say you have completed for all the sentence and you got your vector. Now what you will do, you will just try to create a neural network. Now just see the input size. The input size for the model, you can see input size would be 1 2 3 4 5, because we are having 5 unique word only. So everywhere you can see 5-dimensional vector 1 2 3 4 5. That means you will be taking a neural network like that 1 2 3 4 and 5. Okay, inside that you will take some hidden layer and you will get your y hat here. Okay, so that means you will pass the data. Okay, you will pass the data in this particular layer. That means you will take this particular vector. So first of all you will do for the D1, you will take this particular vector, you will pass it here. Okay, then the second one you will pass it here, then the third one you will pass it here. Okay, that's how you will be passing for all the sentence. Okay, you will be passing for all the sentence. But let's say in case in your corpus, okay, in your corpus the number of unique word is 1000. Number of unique word is 1000. In that case, what should be the input size of the model? Definitely it will also become 1000s. That means you have to take 1-dimensional, sorry, 1000s neuron. Okay, at the very first. That means again complexity is increasing. Let's say in your entire corpus you are having 2000. Okay, 2000 unique word. So you have to take 2000s actually neurons. So if you're using one-hot encoding, that means the number of unique word you are having in that particular corpus, based on that your input layer would be decided. Okay, it's not a recommended, because if your input, if your let's say unique word is increasing, your neurons is also increasing, and whenever you are increasing the neurons, your calculation would be increased also, because at the end you are doing neuron calculation, you are doing the computation here, so computational cost will also increase, right? So that's why it's not a recommended way. Again, there is another issue. Let's say I'm having a sentence and which have actually the word which is not present in my corpus. Let's say I can write my name is Bappy. Let's say this sentence actually I'm having. Okay, now just try to see, these are the word is having in my entire corpus. No, these are the word is not present inside my entire corpus. Okay, that means what will happen, it would be out of vocabulary issue. That means the vocabulary you are having right now, it is not present inside your corpus, so your model won't be able to understand these are the word, because you haven't used this data during training. So whenever you are giving during testing, definitely it won't be able to understand what kinds of sentence you are giving. So again, it is called actually out of vocabulary issue, OOV. Okay, out of vocabulary issue. So if you're using one-hot encoding, so you will get this kinds of issue. Okay, out of vocabulary issue. And another issue I think you saw here, you are having lots of zeros. You are having lots of zeros, and zero is what? It's a sparsity problem. That means it's a sparse matrix you are having. Okay, and whenever you are doing the computation, and whenever you are using zero, okay, to perform any kinds of operation with number, so there is no meaning, right? That's why zero is an unnecessary number here. Zero is unnecessary number here. So you are unnecessarily increasing the computation here, because you can see zeros is increasing the dimension in this particular case. So let me just write some of the drawbacks of the one-hot encoding. So here I'll just write the drawbacks. So the first drawbacks, you can see the sparsity. That means here you are having lots of zeros. Then the second, you can see the no fixed sized, because anytime your sentence might be anything. Okay, let's say here I have taken people watch DSwithBappy. I can take also my name is Bappy Ahmed and I'm a data scientist. Now just count of the sentence length, you will see that it would be bigger. Okay, so you can write no fixed size. Then the third, you saw OOV, that means out of vocabulary issue. And the fourth important things, it is not capturing semantic meaning. Semantic meaning means after people watch is coming, after watch DSwithBappy is coming, before DSwithBappy watch is coming, before watch people is coming. These kinds of semantic information, semantic relationship, this is not capturing, because it's just a number. And whenever this word is present, it is giving 1, otherwise everything it is giving as 0. That means this particular number is not capturing the semantic information of your sentence. But whenever we are using text data, so definitely it will have the semantic relationship. That means it will follow one grammar. What kinds of grammar? Let's say whenever I'm writing any kinds of sentence, let's say my name is Bappy. So my is a subject. So my is a subject, name is noun. Okay, is verb, Bappy is also a noun. That's how it is following one grammatical rule. Okay, that means after my name will come, after name is will come, after is Bappy will come. Okay, so it is following one relationship. It is following one relationship like that, right? So these kinds of relationship, it won't be able to capture if you're using one-hot encoding. Okay, so that's why we can't use this particular method. Okay, we can't use this particular method whenever we want to convert our data to numerical representation, that means vector representation. Okay, inside generative AI. So this technique you don't have to follow, because it's like very basic technique. If you're doing any machine learning project, if you have some level of categorical data in a column, you can use this one-hot encoding there. But whenever you are working with completely textual data inside generative AI, I won't suggest, don't use this particular method, because I already showed you some of the drawbacks you will get here. So now the second technique we'll be discussing about bag of word. Okay, bag of word. Now let's try to see the bag of word example, like how it will work. So for this, I'm going to copy the same table. So again, you can consider the same things, corpus. So I'm using the same table. That means it will have the same corpus. Again, the number of, let's say, unique word would be 5. And you have to create a 5 unique word table. So let me again copy. Now, how this bag of word will work? See, this bag of word will work based on the count. Okay, based on the count of the word present in your entire corpus. So let's say, first of all, it will see people. So now just try to tell me how many times people you can see in this particular sentence. I can see only one time. So people is coming only one time. Okay. Now the next word, watch. So how many times watch is occurring in this particular sentence? Only one. Then DSwithBappy, one time. And write is there? No. So write is not there, it would be 0. And comment is not also there, it would be 0. Okay. Then the next sentence, you can see DSwithBappy, only one. DSwithBappy now occurring 2 times, so it would be 2. Then watch is occurring only one time, 1. And people is not there. Write is not there. Comment is not also there, right? Now the third sentence, people is coming one time. Write is coming one time. Okay. Comment is coming one time. And watch is not there. DSwithBappy is not there. Now the last sentence, DSwithBappy only one time. Write is only one time. Comment is only one time. Watch is not there. People is not there. Okay. So this is how actually you'll be generating the vector. Okay. This is how actually you'll be generating the vector. Now just try to match with your previous vector. What you have observed, you see the bag of word technique you have applied, it is having very less zeros than your one-hot encoding. Okay, that means it is slight better than your one-hot encoding. Okay, because it is working based on the counting. Okay, based on the counting. Okay, counting of the word present in the sentence. Okay, this is the idea. Now research proven, research already proven that if you want to do something called classification kinds of task, let's say sentiment analysis. Okay, sentiment analysis. Then let's say we are performing positive negative reviews. Okay, these kinds of tasks you can use this a bag of word technique to perform the text vectorization, because this is suitable for this particular task. Because if you see any kinds of sentiment analysis problem, let's say here I'm having some sentiments, this movie is wow, or you can also write this movie is amazing performance. Okay, performance. Let's say these kinds of reviews you are having. Now if I want to find the positive, okay, positive or it's a negative, I can see the, let's say, word. So movie amazing performance. Okay, you can see amazing, this particular positive was is occurring like multiple time. That time I can consider it's a positive review. Okay, it's a positive review. So that is why it's a frequency based actually approach. So it will always try to see the frequency count in a sentence, and based on that it will decide whether it's a let's say positive sentiment or whether it's a negative sentiments. Okay, so that is why it is recommended if you're performing any classification kinds of task inside a text, you can use this particular approach. Okay, but again, one drawbacks you will see, it is not capturing the semantic information, like after DSwithBappy what is coming, after what DSwithBappy is coming, or let's say people what is coming, after what DSwithBappy is coming. So this kinds of semantic information it is not able to capture. So again, it's a drawback. Okay, and some of the zeros still you can see. Okay, because again it will increase the your computational cost, because zero doesn't have any kinds of meaning if you are doing any kinds of operation, right? This is the idea. Fine. So apart from that, we are having some more technique we can follow, like we are having something called TF-IDF. So we are having TF-IDF. Then we are also having another technique called word to vec. So this one use one statistical, let's say, equation to perform let's say vectorization, and this one is the deep learning based actually vectorization technique. Okay, and from this technique actually lots of idea came how we can use the transformer model to perform the feature extraction. Because whenever I'll teach you this word to vec technique, I'll show you the feature extraction technique. So how it will extract the features from a sentence, let's say from a text. Okay, so from here actually idea came, then people have actually launched transformer based actually encoding technique. That means with the help of transformer model you can perform the text representation. That means you can convert your text to vector representation, and whatever large language model you are using, okay, LLM, you'll be using this transformer based approach only to convert your data to the numerical representation. So whenever we'll do the practical, that time definitely I will show you. Okay, we'll be downloading the model from the Huggingface. Huggingface is also having lots of tokenizer. That means this kinds of encoding model. Okay, with the help of that we can easily convert our data to the numerical representation. Fine. So as of now, let me show you all the practical. That means that's bag of word, then TF-IDF, then what to vec. Okay, how we can use it and all. But before discussing TF-IDF and what to vec, I just wanted to show you this bag of word practical. So for this, what I will do, I will open up my Colab notebook, and there I'll show you this particular practical. So guys, here you can see I already prepared one Colab notebook for you. So one-hot encoding I'm not going to show you, because you already know how to perform one-hot encoding. So with the help of pandas library also we can perform one-hot encoding. Even we also have one, let's say, class inside sklearn library, okay, to perform the one-hot encoding. So I'm expecting if you already work with machine learning, you know how to perform one-hot encoding. And again, we are not going to use one-hot encoding technique in our analysis, but bag of word will be using sometimes, because I told you now if you are doing any kinds of sentiment analysis and all, that time you can perform, because it's easy to implement. Okay, at the end. Now see, bag of word, for this I need two library, NumPy and pandas. So let me import them. So with the help of pandas, actually I'll be creating a dataset first of all. So the same dataset example I have taken, the dataset I showed in my whiteboard. Okay, so you can see people watch DSwithBappy, DSwithBappy. Okay, this kinds of example I have taken. Now let me prepare the data frame. Okay, so this is my data frame. And here I also have taken another, let's say, column called output. Let's say whether it's a positive, whether it's a negative. So that's how I've just given a number. Okay, it's just an assumption number as of now. Don't try to think it's an actual number. Fine. 1 means it's a positive, 0 means it's a negative. Okay, but whenever you will be using actual data, there will have the positive, negative previews. Okay, based on the text you are having. I hope it is clear. Now, if you want to perform bag of word technique, you have to use one library called sklearn. From sklearn, you have to use something called count vectorizer. Okay, so count vectorizer is nothing but it's a bag of word technique. So I know that many of you already use this count vectorizer in your machine learning, but you don't know this is a bag of word. Okay, so now just try to remember it's a bag of word technique only, right? Now we have created the counter vectorizer object. Now here I just need to fit my data, and I want to fit my data on top of my text. That means textual data. Now here I'm fitting the data. Now it will return me all the vocabulary. Now see what will happen here. It will just assign some of the index number. Okay, it will just assign some of the index number with all the words. Now whoever having actually 0, that means this is the first index. That means this word would be considered at the very first. Then this one, that means number 1, then 2, 3, and so on, right? Now how it is generating this particular array, so let me just try to discuss. Now just try to see which word is coming at the very first based on the index comments. Now just try to see, comment is there in the first sentence. No, comment is not there, that's why it is coming as 0. Got it? Now the second sentence you can see. Now the second word you can see, DSwithBappy. Now tell me, DSwithBappy is there? Yes. How many times? Only one time, that's why it's coming as 1. Okay. Then the next one, people. People is there? Yes. How many times? Only one time. Okay. Then the next word, watch. Watch is there? Yes, is there. How many times? Only one time. Then the next one, I think last one, right. Right is there? No, right is not there. That's why it is coming 0. Okay. Now let's consider the second sentence. Okay. Now again, you have to consider based on the index. Again, comments is there. No, comment is not there. So that's why it's 0. Now next thing, DSwithBappy, yes, it is there. How many times? 2 times. That's why it's coming as 2. Okay. Then you can see the next one, people. People is not there. That's why it's coming as 0. Okay, it's coming as 0, 0. Then after people, actually, we are having watch. Watch is there. Yes, there. How many times? Only one time. Okay. Then after that, we are having something called this one. Right. Right is there. No, right is not there. That's why it's coming as 0. That's how you have to consider for all the sentence. I hope it is clear how it is generating this particular number. Okay. And this is your vector. Okay. This vector actually you can pass to the model. Okay. This vector you can pass to the model. So if you're only printing this bow object, see what you will get one object here. Okay. You will get one sparse matrix object. And if you want to get the number, that means the complete array, you have to use this particular method called toArray. That is why every time I'm doing this one. Okay. Just to show you all the number. That is the idea. Fine. Now, if I want to perform on top of my new data, let's say this is one sentence I've given, Bappy watch DSwithBappy. So I have to use this particular transform. Okay, transform function that time, cv.transform, pass your data and convert it to array again. You will see your data representation. Fine. Now what you can do, you can store your x and y data. Let's say x is nothing but my entire bow and y is nothing but my output. So this is my output. Okay, positive or negative. Now you can pass this data to the model. Okay, this is the idea. Got it? Now there is another things inside bag of word called n-grams. Okay, what is n-grams? N-grams is nothing but here you see, n-grams is nothing but here you do the same thing, only you give one n-grams parameter. So let's say if n-gram parameter is 2, so what will happen? Let's say n-gram parameter is equal to 2. That means it will consider 2 word as a 1 token. Okay, 2 word as a 1 token. See, previously I took individual word, right? Now it will consider 2 word as 1 token. That means here it will come people watch. Okay, inside this box people watch will come. Then watch DSwithBappy will come. Okay, so that's how we have to take pair of word. Okay, and you have to perform the same thing. So this is called actually n-grams. Now let's say n is equal to 3. That time 3 pair will come. That means 3 word you have to consider. Okay, but I saw that people are using only 2 parameter because sometimes it is required. So let me show you one example why it is required. So let's say here I'm having a review. Movie is very good, and here I can write it, this movie is not very good. Now this one is the positive sentiment, you know, this one is the negative sentiment, you know. Okay, but how about your model? Okay, how it will identify? Because I told you based on the frequency count it can decide. Let's say you are having some word, let's say very good movie. Okay, that means it's a positive one. And if it is coming to the second sentence, let's say this is the first sentence, this is the second sentence, again it can consider movie very good, and it will ignore this one because it's a stop word. I think I taught you the stop word concept, right? Not would be considered as stop word. So again your model will try to consider it's a positive. Okay, it's a positive review, but although it's a negative review. But how I can capture this negative information? So if I am doing this n-grams, that means if n is equal to, let's say n-gram parameter is equal to 2, it will consider 2 word as a pair. Okay, 2 word as a pair. So the first word, then second word, then this two word, and this two word. Okay, so it's a positive one. You can see now, you can see it's a positive one. So this movie very good. Okay, now again, if I just make this sentence, let's say this word, this word, this word, this word, and this word. Now you can see easily it is capturing is not. Okay, is not. Now see, it is easily capturing this is not. That means not word as well. Okay, now easily your model can identify it's a negative. Okay, it's a negative sentiments. Okay, so that's why sometimes we have to perform this particular n-grams operation. Okay, because if you are giving n-gram parameter is equal to 2, that time it will consider 2 tokens. Okay, in one just let's say representation, and it can capture some of the hidden information. Okay, this is the idea. Now let's see the practical. So here you can see the same example only. You have to use the counter vectorizer. I'll convert to the text. Now see, whenever I used counter vectorizer, here I have given a parameter n-grams range is equal to 2, 2, that means it will consider 2 words. Okay, now you can see people watch DSwithBappy, watch. Okay, now it is considering 2 tokens. Okay, in just one representation. That's the idea. If you give 3, so if you give 3 here, it will consider as a 3 word. Okay, 3 word as a count. Okay, that's how you can consider. Fine. And if you're using 3 word, that means it would be considered as a trigram. Okay, trigram. And this if you're using 2 words, if you're using 2, it would be considered as a bigrams. Okay, this is the idea. Now there is another technique I already showed you, TF-IDF, that means term frequency inverse document frequency. So this will work based on one equation, based on one, let's say, statistical equation. So simply in Google you can search for this equation TF-IDF. So you'll see this particular formula. So yes, this is the formula, guys, it use, okay, to perform this text representation technique. Okay, so it will work based on the, let's say, weight. Let's say if anyone word is having, let's say, frequent count, okay, in a sentence, it will give more weight. Okay, it will give more weight. Now if I show you the representation, so you have to use this sklearn to initialize TF-IDF vectorizer. Now inside that you can pass your data. Let's say text data I'm passing, I can name converting to the array representation. Now see, you are getting the entire array. Okay, now see, none of the number is 0, complete 0. You will still get some number. Okay, it would be a floating number. So this technique helps us to reduce that sparse matrix dimensionality issue, because if you are using 0, okay, 0 in your, let's say, vector, you are doing unnecessary computation. That's why it will assign the weights, and weight is nothing but it's a floating number. Okay, and everywhere you will see the floating number. So this particular issue will be resolved, because still after performing bag of word, you are generating some zeros. But if you're using TF-IDF, you are not generating any kinds of zeros. Okay, so this is the main benefit here, and this is better than your let's say this one bag of word. Okay, sometimes you can also use this TF-IDF technique. Again, I won't be recommended to use this one, because we have some better option to do. Next thing I'll be teaching you that what-to-vec technique. That means we'll be using deep learning model for the feature extraction. Okay, and this will contain the semantic information, because again, if you see, this TF-IDF is not able to actually contain the semantic information. That means after, let's say, people watch is coming, after watch DSwithBappy is coming, this kinds of semantic information is not able to capture. Okay, so again, I won't be recommended to use this TF-IDF technique here as well. Fine. And here is the some TF-IDF value. Okay, if you are understanding this formula, you will get it. Okay, what kinds of things it is generating. But initially I won't be suggesting you to deep dive in this equation, because again it's not a recommended. We won't be using it. Okay, we'll be understanding whatever actually we need, okay, for our large language model. That's the idea. So yes, these are some actually practical I showed you for the text representation technique and word embedding technique. Now the next thing we'll be discussing about this one, what-to-vec technique. What-to-vec technique. Okay, now let's try to see how what-to-vec technique works. Okay, so guys, now we'll be discussing about what-to-vec. So this is the deep learning approach actually. So how what-to-vec works and how it will extract the features from the data itself, I'll try to clarify. See, what-to-vec actually use two kinds of architecture. So if you want to see, just write what-to-vec architecture. So you will see it has actually two kinds of architecture called CBOW. So here you can see, guys, it uses two kinds of architecture, CBOW and skipgram. So it's a neural network only, right? So let me show you the core mechanism of what-to-vec, like how it extracts the features. Let's say you are having documents. Let's say you are having an entire corpus, and in the corpus, let's say you are having some unique words. So let me create a table. So I can create a table. Just a minute. So here I'll be adding all the features. And this side I'll be adding all the unique word. Let's say you are having the word of king, let's say queen, let's say man, let's say woman, and let's say monkey. So as of now, just try to consider these are the unique word you are having in that particular entire corpus. Now how your word to vec will try to extract the features. So see, it's a neural network, and neural network works based on the back propagation, because every time it will adjust the weight, based on that it will learn. And if you see the neural networks, you can't see like what kinds of feature it is extracting, because it's a completely hidden thing. If you see for the, let's say CNN, if you see the for the NN, so these feature extraction things is a completely hidden. You don't know what kinds of feature it will extract. But as of now, let's consider it has, let's say, generated some of the features. Let's say the first features it has generated based on this word gender, because gender features can match with all the words you can see, because all the, let's say, word I'm having, let's say all the entity I'm having, it has the gender, yes or no, right? Then it has also generated another features, let's say wealth. Now you can see wealth is also matching with all the words. Now you can also consider power, then weight, then speak. See, as of now, I'm just assuming these are the features my model has generated, because here we're using deep learning model. I think I showed you. Now see, that's how actually it will identify the features. That means the vector representation. First of all, it will see king has gender or not. Yes, king has gender, and it's a male king. Let's say male king. Queen has gender. Yes, let's say 0. 0 means female. Man has gender. Yes, 1. Woman. Yes, that means 0, because man I'm considering as 1 and woman I'm considering as 0, right? Monkey has also gender. Let's say 1. Now wealth, king has wealth. Yes, king has wealth. Let's say I can assign as 1, because king is having lots of wealth. Queen is also having wealth, let's say, because queen is a part of king, right? Man is also having wealth, but less than king and queen, so I can give, let's say, 0.5, okay? Or I can give, let's say, 0.2, fine, because again they are king and queen, right? Woman has also wealth, let's say 0.2, less than man. Monkey doesn't have any wealth, I will give 0. Now power, yes, definitely king has the power. Queen also has the power, okay? But I can just decrease a little bit. Let's say less than king, okay, I can give 0.7. Man has also power, let's say 0.3. Woman has also power, let's say 0.2. Monkey, no, monkey doesn't have any power. Now weight, yes, king has weight, let's say I will give 0.8. Let's say this king is a little bit obese. Queen, yes, she has also weight, I can give, let's say 0.5. Very slim queen. Man, let's say 0.7. Woman, let's say 0.5. Monkey, let's say 0.3. Fine. King can speak. Yes, king can speak. Queen can also speak. Man can also speak. Woman can also speak. Monkey, let's say, can't speak. Okay. Now see, beautifully, I have generated some of the vector. Okay, beautifully, I have generated some of the vector. And I haven't generated, it has generated by your word to vec algorithm. Okay, word to vec model. That means this architecture, the deep learning architecture you saw. CBOW. Okay, CBOW and skipgram. Okay, so these are the architecture. Let's say it has generated these features. Now if I tell you, just try to give me the king vector. So what it will give me? It will give me, let's say, king is equal to, let's say this is the king vector. So I can write here 1, then 1, then 1, then let's say 0.8, let's say 1. This is my king vector. You can also give me the queen vector. So here is the queen vector 0, 1, 0.7. Let me just write 0, 1, 0.7, then 0.5 and 1. Okay, this is the queen vector. You can also give me the man vector. Yes, the man vector 1, 0.3, 0.3, 0.7. 1, 0.3, 0.3, 0.7 and 1. Okay, then woman 0, 0.2, 0.2, 0.5, 0, 0.2, 0.2, 0.5 and 1. Then let's say this is the monkey vector 1, 0, 0, 0.2, monkey 1, sorry, should be 1, then 0, 0, 0.3, 0, 0, 0.3, sorry, 0.3 and I think 0. Okay, see all the vector I got. Now if you plot them in a dimensional space, let's say this is my dimension, As of now, I'm just drawing two-dimensional dimension, okay, because 3D, 4D I can draw here. That's why I just consider two-dimensional space. Now here you can, let's say this is your X coordinate, this is your Y coordinate. Now let's say first of all I want to, let's say, represent king here. So let's say king is here. Let's say this is the king. This is the king vector. Okay, this is the king vector. I can write this is the king. Now if you just plot the queen also, you will see that queen will come close to king. Okay, queen will come close to king. Why? Because if you see the vector, okay, if you see the vector, they are very closely related vector. You can see, let's say if you calculate the queen distance with respect to all the vector, you will see that queen will have very less distance with the king because both are similar. Okay, both are similar. Okay, because you can see queen is the part of king, so all the features are already matching with the king. That's why it is coming to close. So that means it's a cluster. Okay, it's a cluster of king and queen, so they are falling in the same cluster. Now similar wise, if you plot the man and woman vector, you will see that they will come nearly. Let's say this is your man. Okay, man vector, and let's say this is the woman vector. Because if you see carefully, man and women vector, they are closely related. Okay, they are almost similar, so that's why they are coming in the same cluster. So again, it's a cluster, okay, for man and woman. And if you see the monkey, okay, monkey is a completely different entity. You can see the vector is also different. So let's say monkey will come here. So I can take a new pen. Let's say this is the monkey. Monkey, okay, and monkey, it is present in the different cluster. Okay, so that's how it is capturing the semantic information, okay, between multiple words. Now let's say there is another sentence you are writing. Let's say I am a princess. Okay, princess. Now tell me where this princess will come, in which vector, in which space, okay, in which cluster. It will come definitely inside this particular cluster, because if you just extract the features from the princess, you will see that it would be close to king and queen. Okay, so that's how this word2vec can actually understand the semantic information of a word. Okay, so that's why it is word2vec is the much better than your previous whatever technique you have learned so far. Okay, and from here actually your actual concept starts, like whatever things you will be learning in future. Let's say transformer based encoding, like how transformer model extract the features. That's how it extract the features. Okay, because at then it's a deep learning model, and by the backpropagation itself it will generate these are the features. But as a human you won't be able to see the features, but here we are assuming, let's say these are the features your model may create, and based on that, that's how it will generate the vectors embedding. Okay, and when it comes to semantic information, that's how it will let's say capture the semantic information, because it will plot all the vector in a dimensional space, and there it will try to find the relationship whether king and queen are same or not, man and woman are same or not, monkey is a different or not. Okay, I hope it is clear now. So let me show you one image actually, experiment of word2vec. You can see this is one experiment for the word2vec. So here you can see we are having three kinds of word: king, man, and woman. And whenever word2vec is applying on top of it, it is generating some features. You can see. So these color represent the features. Let's say these are the features it has generated. Let's say this is wealth, this is power, this is speak, this is, and let's say this is the weight. Now you can see king color is different than your man and woman. Now see, man and woman color, they are closely related. You can see all the color is matching. Okay, all the colors are matching. That's how it is making a separate cluster of man and woman, and king is a different entity here. Okay, I hope it is clear now. So now let's see the practical of word2vec, how we can use word2vec in a Python code. So for this I'm going to use one dataset. So let me show you the dataset here. So the dataset name is Games of Thorns book dataset. Okay, dataset in Kaggle. I think you know what is Games of Thorn. Okay, it's a series actually. So if you don't know, you can simply search on image. See, this is one actually series. Okay, this is a movie series actually, Games of Thorns, and it is having different characters. So if you have already watched this particular, let's say, series, you will know okay about this particular character and all. So based on this particular series, one book has been published, and this dataset is available in the Kaggle also. This book dataset. Now this book contains all the dialogue, okay, present in that particular series. Okay, see all the dialogue. It is having different txt file. You can see based on the, let's say, season. Okay, it is having different dialogue from all the characters. So what I'll do, I'll just try to download one txt file, and I'll just try to apply what to wake on top of it, and I'll try to see what are the character are closely related. That means I'll see these kinds of, let's say, representation. That means whether some character are in the same cluster or not. Because if you see this series, some of the character would be closely related. Okay, let's say character 1, let's say character 2, they're similar kinds of character, so these two vector will come closely. Okay, that's how we want to see the relationship, okay, between the data. So I already downloaded one txt file. You can also download, just try to search for Games of Thrones books in Kaggle, you will see this particular data. Just try to download one txt file. So let me show you the notebook. So guys, this is the notebook, and here we'll be showing you the what to fake. Now let me connect, and this dataset is already available in this link I have already given. Now let me download and let me upload in my Google Colab. So here I can upload this data. So I'll create a folder here called data, and inside that I can upload this txt file. Now first of all, let's import some library, NumPy, Pandas, and GenSim I'm importing because what to wake is there inside GenSim library. Okay, if you want to use what to wake, you have to use this particular library called GenSim. Inside that you have the what to wake architecture. Now let me import them. Now if you're using Google Colab, first of all you have to update the GenSim, because otherwise you will get some of the issue. So let me update. Okay, update is done. Now I'm importing like sentence tokenizer from the NLTK, and I'm also importing simple preprocess from the GenSim library, because before passing my data to my, let's say, what to wake model, first of all I have to apply some processing. Okay, processing means it will do some cleaning operation and all, then you can pass the data. So let me import them. Now this code snippet will load your data from the data folder, you can see. Okay, so here I'm having test.txt, so it will load the data, and it will extract all the, let's say, word, that means all the sentence one by one, and it will perform the tokenization. Okay, it will perform the tokenization. That means every word will have the tokenizer. Okay, now if I show you the story, that means story list. Now see, you got your all the sentence. Okay, see, this is the entire sentence, and inside a sentence you have done the word level tokenization. Okay, this is the idea. Now if you check the length of the entire story, you have more than 8,000 actually, let's say example here. So here you are having more than 8,000 sentence, that means 8,000 dialogue. Okay, now we can see the entire story. Now if you want to see the story 1, that means the first let's say dialogue, the first sentence, this is the first sentence. Okay, you can see, and again we have done the word level tokenization. Okay, individual token. Now we have to initialize the GenSim model, so that's how we can initialize the GenSim model. So let me initialize. Then if you want to let's say convert to the vector representation, just try to call this particular function build vocab. Now inside that pass your data, then you have to train the model. So you have to give your data total example, then total example, you will get total example from the model.corpus count. That means it will count the entire corpus, and it will give the count, and you have to give the epoch. Okay, epoch, you can take the default actual epoch from the model itself. Now see, my training is completed. Now if I want to see the similar, so similar of Denarize. So Denarize is a character inside this particular, let's say, series. So see, she is the character. Now you can see the similar score of the Denarize with these are the word. Okay, these are the word. But see, again you will get some, let's say, random output, because here we are only using one dialogue, that means one txt file. I'm not using the entire txt, entire dialogue, because unless and until my model is not getting the entire dialogue, it would be a little bit difficult for it to match those character, yes or no, right? So if you're doing it, just try to take all the data and try to perform this job. But here, just to show you, I have taken only one txt file. Now you can see with still word, it is having 0.99 okay percent relationship. Okay, Denarize. Then and Prince. So Prince is another character. Prince in Games of Thrones. See, with him actually, her character is matching. If you watch the series, actually you will see that with him her character is matching. Okay, mostly. So you can see. Then Deny. Then Dotarki also is a character. See, okay. So that's how we can actually match Now see, it's not actually properly visible. So what I can do, I can also plot them in a, I can also plot them in a visual graph representation. I'll tell you, but before that, let me show you. If you want to, let's say, see the relationship between two characters, you can use this similarity function inside that give two characters, let's say Arya and Sansa. So if I give Arya and Sansa, so they are having, this is the relationship. Okay. Now, if you want to get all the vectors, you can execute this code. It will give you all the vectors. Okay. All the vectors for the entire text you have given. Okay. And the shape of the vector. See, now let me show you the visualization. I will apply the PCA, that means principal component analysis, to reduce the dimension. That means I want to plot in a 3-dimensional space right now. So here I'm initializing PCA component. Now PCA.fit, I'm giving my data, that means vector. So it will give me the 3-dimensional vector right now. That means from 100 dimension, it has reduced to 3-dimensional vector. I think you know what is PCA, principal component analysis in machine learning. We can use it to reduce the dimension size. Now you can see the dimension right now. So this is the dimension 3. And here we are having 3840 example in this particular entire text. Now see, if I want to plot it, I can use plotly library. Now inside that, just pass your data and set the color. See, it will show you the entire representation of the data. See, that's how we are getting a 3D space. See, this is the 3D space. Now see the different word. Okay, different word and their similarity. So here you can see they are closely related. These are the cluster. So this word is nothing but, so this red is nothing but, just try to see, it's a take, and this blue is nothing but, it's a put. That means put and take, they are falling in the same cluster because they have the relationship. Okay, if you just find in a grammatical way, you will see that they have the relationship. And apart from that, you will also see some character. Okay, you can also match the character. You will see that they are falling in the same cluster. So you can play with this particular graph. I'll share the notebook. You can play with this particular graph. See, that's how beautifully it has stored the data in the dimensional space. Okay, and that's how your model will identify, okay, the semantic relationship, okay, between two words. That means I showed you now here the semantic information from the word itself. I hope it is clear now. Fine. So yes, so that's how actually we can use this word to vec. And if you're using word to vec, you have to pass this particular data. Sorry, after this data. Okay, the vector we are getting, the entire vector, that normalized vector. Okay, and this is your vector representation. This vector you have to pass to the model. But again, we won't be using that. We have just learned this word to vec just to understand how my transformer architecture will be working, how it will extract the features, and how it will get the, let's say, semantic information. So in transformer architecture, you use something called attention mechanism. Let's say attention model. With the help of attention model, it can actually understand the semantic information in a good way. Okay, this is a little bit advanced concept. Okay, that's the idea. So yes, this is what actually we can perform our data representation, that means text representation. And that's how we can perform the vectorization technique. So why we learned this? Because going forward, whenever we'll be learning about, let's say, large language model and all, before understanding large language model, I just wanted to let you know how data would be prepared for the model. Okay, now I think you got it, how we can prepare our data for the large language model. Okay, if I have any kinds of raw text, how we can convert to the numerical representation, and which approach would be better. Because finally we saw that this word to vec approach is better because it is able to extract the semantic information. Okay, semantic information, because it is a deep learning model. Okay, this is the idea. So yes, I hope guys you got it. Now in the next video, we'll be using all the, let's say, topic we have learned so far, let's say text preprocessing and text representation technique. And we'll be doing one small project with the help of machine learning. We'll be doing one text classification project, which as of now we have learned about text preprocessing and text representation technique, like how we can convert our textual data to numerical representation. That means the vectorization, right? So we'll be using all the concept we have learned so far, and we'll be doing one hands-on. That means we'll be doing one practical. So here we'll be implementing one text classification model. So in this video, my main objective is to show you how we can prepare your dataset for the model. That means how we can apply all the preprocessing technique, how we can apply these kinds of text vectorization techniques so that you can use those data, okay, for the model training. But model wise, actually, I'm not going to use a large language model. As of now, I'm going to use simple machine learning model. Later on, I will also show you how you can use large language model. Okay, because it's the like very initial phase we are doing. As of now, we haven't learned about the LLM. That's why I'll be using simple machine learning model. So let's open up our Google Colab and let me show you the text classification practical there. So guys, as you can see here, I already prepared one notebook for you. And the dataset actually I'm going to use. So this is the link of the data. So the dataset name is IMDb movie review dataset. So this dataset is having 50k movie reviews. So you can download this data from the Kaggle. So Kaggle website, it is available. So it is having reviews based on the sentiment, whether this reviews is a positive or negative. Okay, so it's a classification problem statement. So I already downloaded the data. I have already given the link. You can download the data. So let me upload the data here. So I'll just try to upload. So this is my data. So here, let me upload it. Okay, my dataset is uploaded here. Now, the first thing what we have to do, we have to import some of the libraries. So here I've already listed down all the libraries you need for this experiment. So I need NumPy, Pandas, Matplotlib. Okay. Then I also need tensor split, counter vectorizer, TF-IDF transformer. Okay, so everything I have just imported here. And as of now, I'm not going to use this Keras. So let me just remove it. It's not required. So here I already told you I'll be using simple machine learning approach. So I don't need to use any kinds of deep learning library as of now. So fine, you can see guys, I have imported all the required library I need, and definitely I will explain whenever I will use it. I'll tell you, okay, why we're using this particular library. Now let me import all of them. I think NumPy and Pandas we already imported here, so I don't need it. I can delete it. Now you don't need to execute this line because here I have my data in my Google Colab. You can see Google Colab space. But if you have your data in your Google Drive, that case what you can do, you can mount your Google Drive. So I'm not going to execute this line. So directly I'm going to assign my data path. So I'll copy, and here I'm going to mention the path of my data. Okay, so let's say this is my data path. Now I'll execute. Now I will load the data with the help of Pandas library. Now see guys, this is the entire data you are having, and here you are having the this one, your reviews as well as the sentiment of that reviews. Now if you want to see the shape, so here you are having 50,000 movie reviews and 2 columns. Reviews and sentiment. Now see here, I don't want to take all the data because again, if I'm taking all the data, it will take lots of time to process. So I'll only take the 10,000 example, okay, from this 15,000 example. So here you can see I'm taking only 10,000 example, first 10,000. And now you can see this is my data. Now if I show you the data shape, now see only 10,000 example I have taken. Now if you want to see any kinds of reviews, you can also check. This is the first reviews. Now, if you want to see the sentiment value count, that means how many sentiment it is having. It is having 2 sentiment, positive and negative. You can see. So positive sentiment is having around 5,000, and negative sentiment is having around. It is also more of around 5,000. You can see 4,972. That means it's a balanced data. Okay, we don't have any issue with the data. Now let's see whether it is having any missing value or not. For this, I can use isNull function. Now see, there is no missing value. Now let's see any duplicates is there or not. So you can see we are having 17 duplicates. What I can do, I can drop the duplicates. For this, you can execute this line of code, drop duplicates, and in place is equal to true. That means you want to permanently delete the duplicate. Now if I execute, now see, there is no duplicate data in my dataset right now. Now let's perform some basic pre-processing. So as I already told you, inside basic pre-processing, you can perform HTML tags removal, then lowercase operation, stop word removal. So these are the things you can perform. Now see, from my previous notebook, that text pre-processing notebook, I have taken the same function, that removes tag function. That means it will remove all kinds of HTML tags from the data, because if I show you the data, it is having lots of HTML tags because it's a extracted data from the website, right? So let's apply this function. I will apply on top of the reviews. So it will remove all the, let's say, HTML tags. Now see, this is the clean data I'm having. Now see, there is no HTML tags present inside this data. Now the next pre-processing technique will be performing the lowercasing operation. So let's perform it. So here you can see I'm applying lowercasing. Now if I show you, see all of my word has become lowercase right now. Fine. Now what we'll be doing, we'll be removing the stop words, because as I already told you, so stop word doesn't have any kinds of meaning in a reviews whenever you are performing any kind of sentiment analysis, because it will see the positive and negative words, okay, to differentiate whether this sentiment is a positive or negative. So here you can see here I have written a lambda function. So it is doing the same thing. You can also use the previous function I showed you in that notebook. Either you can also follow this particular approach. Okay, so here I'm using lambda function, and lambda is a one line function. Okay, in the one line I'm taking all the word one by one, and if any stop words is there, okay, I'm just trying to remove that stop word with the empty space. That is the idea. Now let me execute. Now see, there is no stop word present in this data right now. Fine. Now let me show you my head of the data. Now what I have to do, I have to just separate out my x data and y data. That means my independent variable and dependent variable. So independent variable means this is the review one, and dependent variable means this is the sentiment. That means this sentiment is my label right now. So I'll store inside x, and label I will store inside y. Now this is my x. That means the entire review, and this is my y. That means my sentiment. Now one issue you can see, sentiment is nothing but it's a text. Okay, it's a text. You can see it's a string, but what I have to do, I have to convert to the numerical representation. So here I can simply apply label encoder. So it will assign positive with 1 and negative with 0. So let me apply. So for this I'm using label encoder from sklearn, initializing the object, and I'm feeding my y data. Now see, your data will become 0 and 1. Okay, that means it has converted to the numerical representation. Then what I have to do, I have to perform the 10 test split, because I have to keep my data for my training as well as the testing. And the test size is I have given 0.2. That means 20% data I'm keeping for the testing and 80% data I'm keeping for the training. So let me perform. Now this is the training size and this is the testing size. Fine. Now I'll be applying first of all bag of word. Okay, I already taught you the bag of word. I think you remember. So I can use the counter vectorizer for this. Now I have to apply the bag of word on top of my reviews. Okay, reviews is my like input data, right? Then I'm also performing on top of my test data, because I'm having two kinds of data, training data as well as the testing data. And I think you know, whenever you are performing on top of training data, you have to use feed transform. And whenever you are performing on top of a testing data, you have to only use transform, okay, math function for this. Then I'm converting to the array representation. Now this is my training vector. And if you want to also see the testing vector, this is your testing vector. Okay, now here we'll be using one machine learning model called naive Bayes. Inside naive Bayes, we're having one naive Bayes version called Gaussian NB. Okay, Gaussian naive Bayes. We'll be using this particular algorithm. So here you can see I'm feeding my data, so x train and y train. Now let me train my data. So here I'm only showing you how we can preprocess your data, how we can prepare your data for the model training and all. But going forward, here we'll be using actually transformer based architecture. Okay, that means large language model we'll be using here. Now this is the training I have done. Now we'll be doing the prediction on top of my test data. Then we'll be calculating the accuracy score. Okay, now let me execute. See, this is the accuracy score I'm getting if I'm using Gaussian NB and if I'm using bag of word. Okay, bag of word technique. So I'm getting 63% accuracy. Now you can see this is the confusion matrix. Now if I'm applying random forest classifier on top of it, so now let's see the accuracy I got. So guys, you can see after applying random forest classifier and I was using bag of word, I'm getting this accuracy, 84% accuracy. Now see, we'll be using bag of word only. Now instead of taking all the features, what I will do, I'll take maximum features 3000. Okay, now you can ask me what is maximum feature 3000. I think you saw the entire corpus, right? I already told you the corpus. Okay, about the corpus. Corpus means the entire data. And from the entire data, I'm only considering 3000 unique word. Okay, 3000 unique word, 3000 frequent unique word. Okay, this is called maximum features. Because see, I don't need all the features, because if I'm using all the features, my dimension will increase, right? And I don't need to increase my dimension. Okay, if my dimension is increasing, that means my model will get more complexity, right, to perform the prediction on top of it. And here I'm using a machine learning model. Okay, I think you can see. So that's why I'm taking most frequent 3000 maximum features instead of taking all the features, right? Now it will create 3000 dimensional space. Okay, 3000 dimensional space instead of taking all the unique word, right? Now see, again I'm performing the bag of word operation. Now again I'm taking random forest classifier and I'm training and checking the accuracy. Now if I execute, so you can see this is the result, but this result is not good enough. So we are getting closely related accuracy only if I'm using all the, let's say, features, and if I'm taking 3000 features, the accuracy I'm getting, it is almost same. Now let's try with n-grams, because I already told you about n-grams, right? What is n-grams exactly? So here let me pass the range of 2 to, because I want to consider a pair, okay, pair of word. That's why I have given 2 to. That means it will consider 2 word, okay, as a one pair. That's the idea. And here I'm only taking 5000 most frequent word. Okay, now again I'm performing bag of word operation, then random forest classifier, then I'm calculating the accuracy. Now let me show you. So guys, you can see this is the result actually I'm getting. So now in the summary you can see your like bag of word is working fine instead of taking the n-grams. So in some case actually bag of word will work fine, in some case n-grams will work fine. It's completely experimental things. Okay, you have to perform. Now let's try with TF-IDF. Okay, TF-IDF technique. So here is the TF-IDF code, I think you remember. So first of all we have to initialize the TF-IDF, then I will apply on top of my data. Okay, training data as well as the testing data. So it will give me the vector, and again I'll be using random forest classifier to train the model, and I will show you the accuracy score. Now see if I show you the accuracy. So here we are using machine learning model, that's why performance is not good. But if you're using any kinds of deep learning model, you will see that your model will perform good. Now here you can see this is the performance of the, now you can see this is the accuracy I got. So here I showed you almost all the vectorization technique we have learned. But one thing I want you to explore, this what to wake one. So I already shared you the code of the what to wake. So what you have to do, just try to apply what to wake, get the vector and try to train with random forest model and just observe the accuracy. Okay, so this should be your task guys from my side, because unless and until you are not doing anything, things would be much difficult for you to learn, right? But if you're practicing by yourself, I think this will help you a lot to learn any kinds of topic. So yes, this is how actually we can perform the text classification with the help of machine learning. And that's how actually we can perform the data cleaning task like data preprocessing and text representation. Okay, everything we can perform like that. But again, I'm telling you guys, this is not an actual way we create our application. This is just a basic introduction I have given, like how we can like do the data preparation. Okay, this is my main objective. Now in the next video, we'll be learning about large language model, like what exactly this large language model and how this large language model got trained. Okay, everything we'll be trying to discuss. So as of now, we have seen so many things, like we saw the entire generative AI pipeline, we saw the text preprocessing as well as the data representation. And I also did one practical. I just implemented one text classification with the help of machine learning model. But I already told you, see, it was just experiment, but going forward, actually, we have to use something called large language model, because here we are learning generative AI. And inside generative AI, the core component is the large language model. Now let's try to understand what exactly the large language model is and what is the code architecture behind this large language model. So guys, as you can see, a large language model is a trained deep learning model that understand and generate text in a human-like fashion. Okay, LLMs are good at understanding and generating the human language. As I already told you, inside generative AI, we're having large language model. We also call it as a generative model. And what is the use of generative model? Generative model can generate a new data. Okay, so that is why here I have mentioned a large language model is a trained deep learning models that understand and generate text like a human fashion. That means whatever model you used previously, let's say whatever traditional model you used, let's say machine learning model, it can be any kinds of traditional deep learning model, those are the model can't generate the text like a human fashion. Okay, it can only do the prediction, because I told you the difference between descriptive model as well as the generative model. But here this large language model can generate a text, okay, and it would be human fashion. That means the way human generate any kinds of text. Let's say currently I'm speaking, right? I'm giving you the understanding. So the same concept can be applied in the large language model also. So large language model can also mimic the human behavior. Okay, this is the main idea here. And LLMs are good at understanding and generating the human language, as I already told you. And how this LLM works? See, the core working mechanism inside LLM, it will generate the next word. So here I've given an example. Let's say the garden was full of the beautiful. Now see, this particular sentence you are giving to the large language model, okay, and large language model is able to generate flowers. That means it is trying to generate, okay, next word always. Okay, it is trying to generate next word. That is the main core idea inside large language model. That means whatever, let's say, prompt we are giving, okay, whatever prompt we are giving, whatever, let's say, text it is generating, it will try to generate the next word always. Okay, this is the main logic behind the large language model. So here are some more example. You can see it's raining cats, and so this is my, let's say, input to the large language model. Large language model will try to actually generate this particular word called dogs. Okay, now there is another one. I have 2 apples and I ate one. I'm left with. So this is the input you are passing to the large language model. So Palm is nothing but it's a large language model, and it is able to predict one. Okay, that means it is able to generate the next word of the prompt you have given. Okay, this is the main working mechanism of a large language model. Apart from that, there are some more advanced technique it usually used. I will also explain. So I'll also explain like how ChatGPT was trained and how it is working and all. Okay, I think this concept would be more clear. As of now, this is the high level understanding I'm giving you how this model is working. Okay, let's say whenever it is generating something new data, how it is working. This is the main idea here. Now let's try to understand why we call it as a large language model. Because you can see, because of the size and complexity of the neural network, as well as the size of the dataset that it was trained on. That means if you see any kinds of large language model, okay, over the internet, any kinds of LLM model, you will see it is using very big and complex neural network. Okay, very big and complex neural network. Even it is trained with massive amount of data. Okay, and the model actually we are using, it is called actually pre-trained model. That means this model is already trained with massive amount of data. Okay, it is called pre-trained model, and we call it as a transfer learning. I think you have already learned transfer learning in your previous days, right? In deep learning, computer vision, machine learning. So what is transfer learning? Transfer learning means we are using an existing model. Okay, that model is already trained with some kinds of data set. Okay, this is called actually transfer learning. So here, so this transfer learning makes this generative AI so powerful because they are training these kinds of complex neural network with the massive amount of data set. So as you can see, researchers started to make this model large and trained on huge data sets that they started showing impressive results, like understanding the complex natural language and generating language more eloquently than ever. Okay, this is the main idea. That's why we call it as a large language model. Now you can see the large language model core architecture. Now many people has this kinds of question. What is the architecture actually LLM is using? Okay, see, this is the core architecture all kinds of LLM are using. A large language models are based on the transformer, a type of neural network architecture invented by Google. Those who have already learned about natural language processing, right? Those who have already learned about attention mechanism, transformer. So you are already familiar with this architecture, yes or no, right? So you are already familiar with this architecture, and this architecture is known as transformer architecture. Okay, and it is invented by Google. Okay, and this was the main breakthrough in the field of natural language processing, even in the field of generative AI, because based on this particular architecture, all kinds of large language model you can see over the market. Okay, everything has been developed. Fine. So this is the main architecture here. So it is having two kinds of part. One is the encoder part, another is like decoder part. And inside that you are having something called multi-head attention. Okay, no need to worry. I will explain this particular concept. I will create a dedicated video for this. How this transformer architecture is working inside our transformer architecture, what are the component it is having. Okay, everything I'll try to clarify. Okay, for this I'll keep a dedicated video. Okay, so that you can understand this transformer in depth. Fine. As of now, just try to consider this is the core architecture behind all kinds of large language model. Okay, and it is invented by Google, and this is known as transformer architecture, and it is having two layers called your encoder layer, and this is like decoder layer. So this one left side, this is called encoder layer, and right side this is called decoder layer. Okay, inside that you can see different component like input encoding, multi-head attention, add normalization, feed forward. Okay, that's how you are having different component inside that. I hope it is clear. Fine. Now on top of this architecture, what they did actually, they added some more layer, they added some more functionality, and they brought this kinds of large language model, different large language model. Now let's try to see some large language model, but before that, first of all, let me tell you what makes large language model so powerful. Because I already told you, in case of LLM, one model can be used for whole variety of tasks. Like you can perform text generation, chatbot, summarization, translation, code generation, and so on. With one model, you can perform all kinds of tasks. But whenever we used to use our traditional NLP model, that means only the language model, we can only perform one specific task. Let's say you want to do language translation. For this, you have to only use language translation model, and that model can't do the code generation. Okay, but here in the large language model, you can do whole variety of tasks. I think you saw the ChatGPT. Let me show you one example. So guys, this is our ChatGPT. Now inside that, I can give any kinds of input. Let's say I'll give me the German translation of this text. Now here you can pass the text. Let's say, how are you? Fine. Now see, if I give this prompt, so it will give me the translation in German of this text. Okay, Now see, this is the translation in German. Now I can also do the sentiment analysis. So here I can write, give me the, let's say, sentiment, okay, of this text. See, it's a neutral sentiment. Now we can also perform something called language detection. So I'll give me the language, or I can write detect the language. Okay, detect the language of this text. Now see, it should give me English. Fine. So that's how, with the help of one model, you can do variety of tasks. You can also generate the code. So I'll give me a Python code for adding 2 numbers. See, it can also generate the codes. So this is how actually large language model works. Okay, and that makes LLM so powerful. Now let's try to see some of the large language models are available over the internet. See, I've just listed down some of them, but you will see thousands of models are available. I will also tell you where you will get all the model list and all. Okay, so as of now, just try to see, guys. We are having different large language model like Gemini. So I think you know Gemini, right? Gemini was developed by Google. Even we are having also one application of the Gemini. Let me show you. So in Google, if you search for gemini.google.com, so you'll see this kinds of application, and this is the same kinds of application like your ChatGPT. Okay, here also you can give the prompt, and here also you can get the response. Let's say the previous prompt I have given here, I can also pass it here. Okay, and in the backend they're using something called Gemini model. Okay, Gemini large language model. Then we're having something called GPT. Okay, GPT stands for Generative Pretrain Transformer. Okay, the model was developed by OpenAI. That means the ChatGPT you are using, it is using something called GPT based model. Okay, we are having GPT-3, 4. Okay, these are the model we are having. Even recently, actually, GPT published one amazing model. I think GPT 4o model. Okay, with that you can also generate videos. You can also generate like so many things. Okay, if you just search on Google, you will see different version of the GPT even there. Application and all, like, okay, everything you can see there. Then we're having something called XLM, that means cross-lingual language model. Okay, so this is one of the large language model. It is also available. Now we're having something called Llama. Okay, and it was developed by Meta AI. So Llama is having different variant like Llama 2, Llama 3. Okay, recently Llama 3 was published, 3.1 is published, I think. And this model is amazing. It can also, let's say, generate text like a human. Even going forward, we'll be also learning how we can use Llama 2, 3 model, okay, in our application. With the help of that, we'll be building different application. Now you can see there is another model called Megatron. So Megatron is a large language model, and it's like very powerful transformer model, okay, developed by NVIDIA research team. I think you know NVIDIA. So we are using NVIDIA GPUs in our system, right? So NVIDIA team has developed this particular Megatron model, and this is one of the large language model. Now we're having something called M2M 100. So this is called actually multilingual encoder and decoder sequence to sequence model. Okay, and it was developed by Facebook. So these are the models actually we are having. Apart from that, I told you now we are having thousands of models. Let me show you. So this is the GitHub, guys. So the GitHub name is Open LLMs. Okay, now what this guy did, actually, this guy actually listed all the large language models are available over the internet. Okay, now see, he has created one beautiful GitHub repository, and in the readme file he listed down all the large language model as well as their checkpoints. Let's say you want to download this model, you can also download this model from this particular link. If you want to read the papers and blog of this particular model, he has also given the link. Apart from that, the parameter size, context length, and as well as the license. So every information you will get of any kinds of large language model. Now see, T5 is one of the large language model, then RWKV4, okay, then GPT Neo X, then YAML, UL2, Bloom, Chat GLM. Okay, now see, different large language model you are having. See, okay, Falcon is also there, then Llama 2 I already told you, then Mistral is also there. Okay, see, different large language model, and it is having so many large language model, guys, so many large language model. If you want to export, open this particular link, just write Open LLMs inside Google, you will be able to see these kinds of GitHub. Okay, and you can also keep this link with you, so that if you need any model later on, if you want to develop any kinds of projects with the help of any kinds of large language model, you can use this repository later on, so that you can see the paper blog link. Okay, it will help you to understand this particular model. So guys, as I already told you, all the large language model using one core architecture, which is nothing but transformer architecture. And inside transformer architecture, I showed you there are two kinds of layer called encoding layer and decoder layer. Okay, now see, here is the transformer architecture, let's say, and it is having two kinds of part, like encoder and decoder. Now I think I showed you different large language model, like thousands of large language model. Now see, all the models are not using both layer, that means encoder and decoder layer. Some of the models are using encoder layer, some of the models are using decoder layer, okay, and some of the models are using both layer, that means encoder and decoder both. Now here I've listed down some of the models, so this will give you the idea of what kinds of models are using encoder layer only, what kinds of models are using decoder layer only, and what kinds of models are using both layer. Okay, you can see encoder based architecture. These are the encoder based architecture like DistilBART, BART, Robata, okay, XLM, then Albart, Electra, okay, then DBARTA. So these are the model based on the encoder layer only. Okay, now you can see the decoder layer model. So GPT, GPT-2, GPT-3, okay, whatever GPT series you are having, it is using something called decoder layer only. Okay, decoder architecture only. Fine. Then both actually layer, that means encoder and decoder both layer. So we are having something called T5 BART. Then we are having something called see, this is BART actually, B-A-R-T, not B-E-R-T. Okay, this is another model. Now M2M100 and Big BART. So these are the models are using encoder and decoder. See, it's not possible to list down all the models here. That's why I just listed down some of them. But there are so many models that are using like both architecture. There are so many models that are using only encoder architecture. There are so many models that are using decoder architecture. Okay, and this is called actually transformer T. Okay, this is called actually transformer T. So by referring this particular T, you can easily understand what kinds of models are using which kinds of architecture. Okay, this is the main idea here. Now let's try to see some OpenAI based large language model, because going forward we'll be using something called OpenAI platform. Okay, we'll be generating OpenAI key and we'll be implementing different projects. Now see, inside OpenAI we're having different models like GPT-4, then GPT 3.5, GPT based, DALL-E, Whishper, embeddings model, even moderation model, GPT-3 legacy model. So these are the models are available in the OpenAI platform. Apart from that, I think recently they have released more model, because it's a continuous research field. It's not like that it will be like fixed research. Every day they are bringing new technology in their platform. Okay, so if you want to learn all of them, you have to keep updated with their technology always. For this, what you can do, you can refer their website. Okay, you can refer their website and try to see what are the models they are bringing. Okay, so like that actually you will be learning a lot. It's not like that you only need to rely on your mentor. Okay, as a mentor I can give you the entire path how you can get started with. I will teach you how you can use them, but as a learner, what you have to do, you have to explore by yourself. Unless and until you are not exploring by yourself, it would be very much difficult for you, okay, to learn any kinds of topic. So that should be my suggestion. Please try to explore from your end. After this actually video, what you can do, you can search OpenAI, you can search different open source website, and you can see what are the models are came actually recently. Okay, that's how actually you can learn. And you can also create a GitHub repository like that, and you can list down all the models, okay, you will be exporting, okay, in future. That is the idea. Now let's try to see some other open source large language model. See, there are two kinds of large language models are available. One is like commercial model. Commercial model means this is the commercial model, like OpenAI based model. So if you want to use these are the model, you have to pay. Okay, you have to pay. You have to take their subscription. Okay, but if you're not interested in paying, what you can do, you can use open source large language model. So these are the models are available in the Huggingface platform. So if you're using these are the model, you don't need to pay. Okay, freely you can access, but there you will get some difficulty, because these are the model you have to download manually in your system. You have to set up everything. Okay, let's say you want to fine tune this Mistral. What you have to do, you have to download the Mistral model in your system. Now just try to see what is the size of the Mistral model. Okay, more than 30 to 40 GB. Okay, so you should have good actually resources in your system. Let's say you should have good CPU, good GPU, good memory. Otherwise you can ever train this particular model. But if you're using commercial model, okay, let's say you are using OpenAI model. Okay, that time what you can do, you can use their platform like OpenAI platform to fine tune these are the model. Okay, you don't need to download these are the model in your system. So going forward, I will teach you how you can use a commercial model as well as the open source model both. Then you can decide which one you will be using. Okay, it's up to you. Now these are some open source large language model like Mistral, Llama, Gemini, Falcon, okay, Cloudy, then MPT 30B and StableM. Okay, these are the models actually we are having as an open source model. Apart from that, there are so many models. I will tell you. There is a platform called Huggingface. Inside Huggingface, you will see all kinds of large language models are available there. Fine. What can LLM be used for? I already told you, you can use large language model for the text classification, for the text generation, for text summarization, conversation like chatbot, question answering, speech recognition, speech identification, spelling correction, and so on. That means whatever task you can see in the field of natural language processing, okay, all kinds of tasks you can perform with the help of large language model. Only one model. I think I showed you one example of the ChatGPT. Now there is another concept you will be getting inside large language model, which is nothing but prompt engineering and prompt designing. Now you can ask me what is prompt engineering and prompt designing. So you can see all the text that we feed into an LLM as an input, it is called actually prompt. And this whole art is known as prompt designing or prompt engineering, which is about figuring out how to write and format prompt text to get LLMs to do what you want to do. Okay, that means whatever input you will be passing inside large language model, okay, this is called actually prompt. And the way actually you will be giving the prompt, the way actually you will be preparing the prompt, this is called prompt designing or prompt engineering. Okay, now let's say here two example I have kept. It's raining cats and, okay, let's say this is your prompt. You are giving this particular input to the large language model, and your large language model will try to predict dog. I think I showed you, okay, that text word generation. Okay, next word generation. Then I have another example. I have 2 apples and I ate 1. I left with, this is the input. Now your model will try to generate 1. Okay, now apart from that, we are having some types of prompt like few shot prompt, 0 shot prompt. Okay, these are the types of prompts are available. Let me show you. So this is called actually 0 shot learning, 0 shot prompting. That means here you are only giving the, you can see the approach using a single command to get an LLM to take on a behavior. It is called actually 0 shot learning. That means you are only giving a input, and your large language model will give you the output. Let's say this is your prompt: write me a poem about Ada Lovelace in the style of Shakespeare. Okay, this is the input. Now there is another one: explain the quantum physics to me like I am 5 years old. Now you are giving this prompt to the large language model, and large language model is generating the response for you, the answer for you. Okay, this is called actually 0 shot learning. Okay, 0 shot learning. Now there is another learning called few shot learning. In few shot learning, in addition to just providing an instruction, it can be helpful to show the model what you want by adding the example. It is called actually few shot learning. So in few shot learning, what you will do, you will give some example. Okay, the prompt actually you are giving, let's say here you are giving a prompt: convert the text from English to French. So with this prompt you will pass some example like English to French example. Let me show you. So let's say this is the few shot from example. Let's say this is the prompt you are giving: convert the text from English to French. Now you are giving English as well as the French, English as well as the French. Okay, that means you are passing some example. Okay, instruction as well as the example, and your model will try to give you the response. Okay, after that, that means you are teaching your model how you're expecting the results. Okay, this is how actually you can pass the few shot learning or few shot prompting inside large language model. Okay, so going forward we'll be also learning this thing, how we can add our system prompt, how we can add the user prompt. Okay, how we can give few shot actually prompting, how we can give, let's say, 0 shot prompting. We'll be learning whenever we'll be using large language model. And always try to remember, if you want to get a good response from the large language model, you have to go with the prompt engineering and prompt designing. This is the main idea here. So yes guys, this is all about our large language model, okay, which is LLMs. So I hope you got the clear cut understanding about large language model, what exactly large language model is, and what is the core architecture it is using in the backend. So in the next video, I'll try to explain that core architecture, the transformer architecture, how transformer architecture works, and what are the components are available inside transformer architecture. So here we'll be discussing one amazing research paper called Attention is All You Need. So this research paper published by Google, and Google actually brought this particular research called transformer. So here is the research paper, guys. Attention is all you need. If you are interested, read this particular paper. What you can do, simply search by this name. You will get this research paper. You can see this is from Google Brain. Okay. And you can see this is the architecture, transformer architecture. But I know that first time it would be a little bit difficult for you understanding this architecture from this particular paper. So what I will do, I'll just try to break down this actually architecture, and I will discuss each and everything, all the components, like what is input encoding, like what is multi-head attention, what is add normalization. Okay, everything I'll try to discuss. Okay, then this part would be more clear. Then once we got the understanding, then if you come to this paper, this would be very much easy for you to understand this architecture. Okay, like how they have let's say created this architecture. And if you're interested learning the mathematics behind it, you can go through this paper. Okay, if you want to deep dive into this, you can go through the paper. It will give you the comprehensive idea. Now to explain this actually transformer, let's say, concept, I'm going to refer one amazing blog by J. Alamar. Okay, so this is one of the amazing guy and he has created so many content related actually NLP. So this is one of the best resources you will find over the internet if you want to understand the transformer architecture. So this guy actually used so many visualizations, so many images to explain this architecture. Okay, so we'll be referring this blog to understand the entire architecture. I could have written everything on my blackboard, but I thought if I show you the visualization, it would be more, let's say, good than the writing on my blackboard, right? So if you want to understand this transformer architecture, so what I feel like this is going to be one best resources for you, because it is having so many visualization. Okay, we can easily understand what is happening inside transformer architecture. So now guys, let's try to understand this architecture. Now let's say this is your transformer architecture. As of now, just try to consider this is a black box. Okay, it's a transform architecture and you don't know what are the component it is having. So here you are giving one input data, okay, and you are getting one output data. That means you are performing language translation operation. So here you are passing this French input and you are getting English output. Okay, this is the idea. Now let's try to see what inside this particular transformer, okay, transformer block. Now see, inside transformer block you are having two kinds of layer. One is the encoder layer and another is the decoder layer. As I already told you, transformer architecture is having two kinds of layer. One is encoder layer, another one is decoder layer. Now you are passing the input, okay, you are passing the input to the encoder layer. See, this French input you are passing to the encoder layer, and the output you are getting, that English translation you'll be getting from the decoder layer. Okay, this is the main idea. Now let's try to break this encoder and let's see what are the components we are having inside encoder layer. Now see, if I show you this entire architecture, okay, in a low level, now you can see inside encoder we are having some more encoder layer. Okay, we are having some more encoder layer. How many encoder layer? You can see 1, 2, 3, 4, 5, 6. That means 6 encoder layer we are having. And how many decoder layer we are having? Again, we are having 6 decoder layer. That means the architecture you can see here. Okay, the box you can see here, encoder box and decoder box. Inside that you are using 6 stack of encoder and 6 stack of decoder layer. Okay, and inside that your input is going and it is processing this input and you are getting the output. Okay, this is the, so that's how this architecture consists of. Okay, I hope it is clear. Now let's try to see what we are having inside the encoder layer. Okay, now if I show you the encoder layer, see, inside encoder layer we are having two kinds of layer. One is like self attention, other is like feed-forward neural network. And what is feed-forward neural network? I think you know. That means the artificial neural network. Okay, if you're already familiar with ANN, you know what is feed-forward neural network. Okay, it's a artificial neural network at the end. Now let's try to understand the self-attention, because I know that many people will have the confusion what is self-attention here. Okay, now let's see. Now we can see this is the encoder. Inside encoder we are having self-attention as well as the feed-forward, and inside decoder also we are having self-attention, and another actually additional layer we are having which is called encoder and decoder attention, and the last layer you are having which is nothing but feed-forward neural network. So this part we'll be discussing later on. As of now, let's try to discuss this encoder layer and this self-attention part. Okay, now let's say you are passing the French input. You can see this is your French input. I don't know how to spell them, but just try to consider this is your French input. So the first thing what you have to do, the first thing you have to perform the text preprocessing, then text representation, yes or no. So here first of all you have to convert your textual data to the vector representation. Okay, so based on the paper they are using something called what to vec technique to perform the text representation technique. That means they are converting their text to vectors with the help of what to vec technique. And what is the dimension? Okay, what is the dimension of the vector? They are getting 512 dimension. Okay, 512 dimension for the each of the vector. Okay, this is the idea. Now let's say they have converted to the vector representation. Now what they are doing, they are passing this particular input to the self-attention layer. You can see they are passing the input to the self-attention layer. Self-attention layer is giving one output which is nothing but Z1, Z2 and Z3, and this Z1, Z2 and Z3 will pass to the feed-forward neural network. Okay, now let's try to understand how it is encoding. Okay, how it is encoding this particular input. Now see, to simplify this particular understanding, what JLMR is doing, he is using two words actually, which is nothing but thinking and machines. Okay, let's say you are having two words, thinking and machine. First of all, what you have to do, you have to convert this text to vector representation with the help of what to vec. And what dimensional vector you will be getting? 512. I think I showed you here, 512 dimensional vector it will return. And this vector will be passing to the self-attention layer. Self-attention layer will give you Z1 and Z2. Then it will be passing to the feed-forward neural network. Again, feed-forward neural network will give you some of the output, and that output again you will pass to the encoded 2 layer. That means I showed you now we are having stack of the encoder layer here. See, stack, that means after getting one output from one encoder layer, it will go to the another encoder layer, then again it will pass to the another, then another, then another. That's how actually it will pass through 6 encoder layer. Okay, so that is what actually he is explaining here. You can see, so here you can see after one encoding it is passing to the second encoding layer. Okay, this is the idea. Now let's try to understand what we are having inside self-attention. Now see, self-attention at high level. Let's say here we are having a sentence, the animal didn't cross the street because it was too tired. Now here just try to understand, the animal didn't cross the street because it was too tired. Okay, it was too tired. Now who was too tired here? Okay, definitely the animal was too tired. Yes or no? So as a human actually we can understand, it means this is the animal, it is indicating the animal. But what about the machine? How machine will identify whether this animal is the it or not? Okay, so for this it use something called self-attention. Okay, self-attention mechanism. Now let's try to understand how it will use that particular concept. But before understanding self-attention, just try to see how it will give the self-attention to the word. Let's say here you are having the input. So this is the input, the animal didn't cross the street because it was too tired. Okay, now whenever I'm referring this it, now here what it represents? Definitely it represents the animal. Okay, you can see this darker color, that means it is more focusing on the animal part. Okay, the animal part, because the animal is nothing but it. Okay, that means your machine will try to understand, okay, if I want to consider it, I have to give the weightage to the animal didn't. Okay, these are the actually what. Okay, even two also. Okay, too tired also, these are the what it has to give the attention. Okay, unless and until it is not giving the attention to this word, how it will identify whether this 8 is represents the animal or not. Okay, now you can ask me how it is identifying whether it has to give the more weightage to these words or not. Okay, so for this we'll be understanding the self-attention in detail. So here you can see he has given one example. Let's say this is your input. Input means your two words, thinking and machine. So the first thing what you have to do, you have to convert them to the embedding representation, that means the vector representation. Then what will happen, your transformer will generate actually 3 weights. Okay, you can see it will generate 3 weights, W, okay, WQ, WK and WV. And how weight initialization happens, I think you know. Okay, there are different techniques for the weight initialization, and these weights would be updated during backpropagation. Okay, BP. I think you already know about artificial neural network. Okay, how it got trained usually, right? How it do the backpropagation and all. This is like very basic concept. I'm expecting you are familiar with already, right? So these are the weight would be initialized at the very first, and this weight should be updated during backpropagation technique. Okay, now you can see it is generating some more actually vector. The first vector it is generating queries, keys and values. Okay, now you can ask me how it is generating these are the values. See, first of all, what it will do, it will take this particular x1. Okay, it will take this particular x1 and it will multiply with the wq. Okay, it will multiply with the wq. So it will return you q1. Okay, then it will take the x2. It will multiply with the wq. It will return q2. Okay, so that's how actually we'll be getting something called query vector. Okay, query vector. Then again, it will multiply x1 with wk. Okay, and it will return you k1. Then it will multiply x2 with wk, it will return you k2. So here you will be getting keys vector. Okay, then you will be multiplying this x1 with wv and it will return you v1. Then x2 with wv, it will return you v2. Okay, so that's how you'll be getting values vector. Okay, so that's how this 3 vector would be generated, queries, keys and values. Okay, I hope it is clear now. Okay, now let me clear all the line here. Yeah, now let's see the next actually mechanism. See, I think you got it. That means we are having our input data. That means input word, thinking and machine. And first of all, we have to generate the embeddings. Then after that, with the help of x1 and x2, that means this vector, we are generating queries, keys and values. Okay, and how, I think you got it, the multiplication actually strategy. Now the thing is like it will generate one score. Okay, how it will generate the score? See, to generate this code, it will use this q1. Okay, q1 vector, and it will multiply with the k1. Okay, that means q1 will multiply with the k1. Okay, this vector, that means keys vector. Query will multiply with the keys. Okay, and you will get one score. Let's say as of now, this is the assumption score he has given here, 112. Fine. Then for the next word, you can see it will multiply q1 with k2. Okay, q1 with k2, and here the score, let's say 96. Okay, now from this score you can see it is giving more score to the thinking word, okay, to the thinking word than the machine word. Okay, that means it will more refer this thinking word, it will more give the attention to the thinking word. Okay, and that's how actually it is calculating this particular score. I think you saw this graph now. So how it is giving the attention to the word, okay, that's how actually it is calculating. Okay, with the help of this particular vector calculation, it is creating this score, and based on the score value it is giving the attention to that specific word. Let's say we are having two words, thinking and machine, so it will give the more attention to the thinking word. Now see, after getting the score, what it will perform, it will perform this softmax operation. Now see what will happen. You are getting the score. Now this score would be divided by 8. Okay, that means you will divide this score by 8. Now if you divide this number, you will get 14, and if you divide this number, okay, you will get 12. Now we'll just calculate the softmax. Okay, I think you know the softmax. Okay, softmax is an activation function, it's an equation of the probability score, and if you just add this probability score, you will see that it would be 100% probability. Okay, always. So here you are getting actually 88%, and here you are getting only 12%. That means it is giving more attention to the thinking word. That means 88% attention it is giving to the thinking word, and only 12% attention it is giving to the machine word. Now I think it is clear how it is giving the attention to a specific word. Now in the 6th step, what will happen? See, I think you saw we are getting the softmax output. Now with this softmax output, what it will do, it will try to multiply this value. That means the value I think you are getting, remember this particular value. So it would be multiplied, and after multiplying, you will get one vector called v1, and again it will perform for the next word as well. So here you will get v2. Now let's see, you are having multiple word. So for all the words actually it will do the multiplication with the value. So here he only used 2 words, but you can consider more than 2 words as well. Okay, the working mechanism will remain same. Then after getting this v1 and v2, what it will apply, it will apply the summation operation. That means it will sum up these 2 vector, and you will get z1 and z2. Okay, and now I think you remember what is this z1 and z2. So let me show you that high level architecture. Here, see, this is the z1 and z2. That means this z1 and z2 is the output from the self attention. Okay, self attention layer. And how self attention is working as of now, whatever discussion I have given you, whatever, let's say, operation I showed you, this is the work of self attention, and that's how actually it will perform all the mathematical operation, and it will return z1 and z2, and this z1 and z2 will pass to the next, okay, next layer. Okay, next layer means I think this layer, yeah, to the feed-forward neural network. Okay, this is the idea. Now whatever I have discussed so far, if you want to see as a matrix representation, see the same thing. That means you are getting your input. Okay, you are getting your input. That means here we are giving our input. It will first of all convert it to the vector representation. Then it is generating some weights. Okay, WQ, WK, and WV, I think, remember. Then we are getting query, keys, and values. Okay, then it was multiplying this query with keys. Okay, and we are dividing with 8. Okay, and we are calculating the softmax. Okay, and softmax. And after that, whatever softmax output we are getting, we are performing the addition operation with the values. Okay, and it will give me Z. Okay, Z. That means the output. Now so far whatever actually operation you saw, this is for actually single head attention. Okay, single head attention. That means only one self attention. Okay, only one self attention mechanism. Now inside transformer architecture, they're using something called multi-head attention. You can see. So here is the term called multi-head attention. So what is multi-head attention? See, if I show you this graph again, see, if I'm considering it, that means it is giving attention to the animal did. Okay, these are the word. Even you can see it is also giving some attention to this word as well. But see, this thickness is like very less here, because it is not able to give the proper attention to this word. Okay, because it is using only single head attention. Okay, and it is only using this 3 weight. Okay, this 3 weight is not enough. Let's say you are having huge amount of data, your input length is very big. That time actually only this 3 vector is not, only this 3 weight is not actually enough. So for this actually what we have to do, we have to apply something called multiple actually weights. Okay, and if I want to apply multiple weights, so what we have to do, we have to use something called multi-head attention. So Google introduced actually multi-head attention. So they're telling, instead of only using one head, okay, one head attention, so they're telling instead of using only single head attention, we'll be using multi-head attention to perform the same operation. That means what will happen? See, this is the attention head 1, that means single head attention, and you will be taking another attention head. Okay, so this is called attention head 1. That's how we'll be taking another attention. And how many attention head it will be taking? I'll tell you. As of now, let's try to consider we are having multi-head. That means only 2 head. Okay, 0 and 1. Now the same thing they are doing, that means they're generating these weights. Okay, also this side also they are generating the weights, and the same operation would be happening as here as well. That means the operation I showed you now previously, the same operation will be happening here as well. Now you can ask me what is the main objective to perform this multi-head attention, because if you see in the transformer architecture, we can give very big size input. Let's say my input prompt would be very big. I think you saw in the ChatGPT, we can pass a very bigger prompt. Okay, very bigger prompt to the this one, our ChatGPT input, right? That means to my GPT model. So how it is processing that particular bigger input, because it is using this multi-head attention concept. That means with the help of multi-head attention concept, it is able to give the attention to all the specific word actually present in that particular prompt. Okay, so this is the main idea. That means if you're only using single head, it won't be able to handle that particular bigger prompt. That's why you have to use multi-head attention here. Okay, otherwise this is the main concept. Now see, that's how actually things are working. Let's say you are passing two words, thinking and machine. So you are passing as a vector representation. So this vector will go to the different attention. And now here you can see they're using 8 different attention heads, 8 different attention heads. That means whatever things we have learned so far, we have learned for only one self head attention, right? Well, self attention. Okay, but they're using something called 8 different self attention. 8 different self attention. Here you can see. Okay, attention head 0, 1, ... 7, because it is starting from 0. That's why it is ending till 10. Now if you count it, they are using something called 8 different attention head here. Okay, so inside 8 different attention, all the calculation is happening. After that, whatever z0, z1, z3 they are getting, they are doing the summation operation. Okay, and this is your final vector. Okay, this is your final vector. That means the z, that means this one. Let me show you this one. Okay, now inside that they're using 8 different self attention, and this is the z1 output you are getting. Okay, I hope you got it. Now see how beautifully JLMR created this blog, how beautifully he has used all the visualization. Okay, so to explain this particular concept. So that's why I feel like this is the best resources for the transformer. Okay, if you want to understand, you can use this particular blog. Now I think we have understood till here. That means we are getting the Z. Now see, if you see the entire architecture, that's how it is working. So you are having the input, you are it is initializing the weights. Okay, so it is generating the weights for 8 different actually self attention. Okay, then you can see the query keys values, then the Z. Okay, that means the output from my self head attention. Then it is concatenating all the vector, and we are getting only one vector, which is nothing but Z. Now see, after using multi-head attention, that is how your output looks like. Now see, it is able to give the attention to all of the word actually it needs. Okay, to represent this particular it right now. Now see, this line is more darker right now. Okay, this line is more darker. That means it is performing better than previous. That means previous we are using only one head attention. Now we are using multi-head attention, and the performance is very good right now. Okay, this is the main idea. Now see, he has captured some of the images. Okay, experimental images you can see here. Now let's try to understand another important things. I told you now. So let's say whenever we are using any, let's say traditional embedding model, let's say TF, IDF, word to wake, or let's say any other embedding model, let's say this one, bag of word. So it won't be able to capture the semantic meaning. Okay, semantic meaning of a sentence. Let's say here we are having a sentence. This is the, let's say, French sentence. Z Swiss A to the end. I don't know how to spell, but let's say this is my sentence. Now after Z, this particular word is coming. After this word is coming. Okay, how it will remember? That means how it will understand the contextual meaning. That means the sequence meaning. Okay, sequence meaning of a sentence. So to understand that sequence actually meaning, they're using something called positional encoding. Okay, positional encoding. Now let's try to understand what is positional encoding. See, let's say this is my input. It is converting to the vector. Now you can see this particular vector they are adding with the positional encoding. Positional encoding is nothing but it's a vector only. Okay, it's a vector only. You can see T1, T2, and T3, and they're doing the addition operation. Okay, after that they are getting the embedding with the time signal. That means whenever we write any kinds of, let's say, sentence, let's say my name, okay, is Bappy. So it always follows one time sequence. Let's say my I have written at the time of T1, name I have written at the time of T2, is I have written at the time of T3, and Bappy T4. Okay, that's how it follows one sequence. Okay, so that's why text data can be also called as sequential data. Okay, it's a sequential data because it follows the time. Okay, so that's why they are telling embedding with the time signal. That means whatever input you have given, okay, whatever input you have given, it is having one time. Let's say T1, T2, and T3, and so on, right? So on. So with that, they're adding this positional encoding. Now how this positional encoding helping us to identify whether after Z this word is coming, after Swiss this word is coming, because if you see positional encoding nothing but it's a vector, okay, and after adding this vector with my embedding, so again we are getting another vector, yes or no? Okay, now if you calculate the distance, okay, between these three vector, you will see that this vector and this vector would be closely together, because if you just do the subtraction, okay, if you just find the distance, you will see that you will get very less distance between these two vector, okay, and you will see that this vector and this vector distance would be more, okay, because you can see the number, okay. So that's how actually it is identifying after Z this particular word is coming, after this word is coming, okay, based on this particular vector, okay. That's how they're doing distance calculation, and they're trying to understand the sequence information of a sentence, okay. Let's say after my Bappy is coming, after my name is coming, after name is coming, after is Bappy is coming, okay. I hope it is clear. So that's how they're handling this particular sequence, okay. Now I think you got it. Whenever we are passing any kind of bigger prompt to the large language model, how it is identifying that particular contextual meaning, how it is remembering that particular sequence. Let's say after this sequence is coming. Now he has added some more graphs, so as of now let's skip, okay, it's not required. Okay, now the next thing we'll be discussing about the residual block. Those who have learned about like computer vision, so I think you learned one model called ResNet, okay. So in ResNet also we had this kinds of architecture, okay, I think you remember. So let's say here we are having different layer, okay, different layer, fine, and we also had something called residual block. So that's how actually it will look like. That means whatever input actually you give usually, so sometimes let's say if this block is not working good, okay, let's say this block is not working good, then what will happen? It will skip this block and this output will go to the next block, okay. This is called actually skip connection, okay, skip connection, okay, and this is called actually residual block. So we already learned this residual block in our CNN architecture. So the same residual concept has also applied in this particular transformer architecture as well. So here we are also having residual connection. You can see, let's say this is the input we are giving, okay. Let's say if this particular self attention layer is not working good, what will happen? This input will go to the next, okay, next layer. Now they're also using something called add and normalization. And what is normalization? I think you know, with the help of normalization, we just bring our data distribution in a normal, okay, normal distribution. I think you remember, right? This is whatever weight actually we're having. So if you just visualize them, you will see it will be a normal distributed, okay, normal distributed output. So it helps us during back propagation whenever it will try to find the global minima, okay. That time actually this concept helps a lot. Now you can see again we are having another residual block connection, skip connection, okay. So that means if any of the layer is not working good, this will actually skip this part and it will go to the next, okay, next layer. So this is the idea of the residual connection, because it's a very huge layer, because you can see this transformer architecture, it's a very huge layer. So sometimes let's say if you are using any simple data, very simple data, say you don't need all the layer, you don't need all the layer to process your let's say input. So sometimes whenever you are having the simple data, it will go to some of the layer and it will perform better, okay. That time actually it will skip. These are the, let's say, layer, okay. So this is called actually skip connection and residual block. And if you want to see the normalization, how it is performing the normalization, so here you can see the normalization. So it will do the addition operation x and z, okay, z vector, and it will perform the normalization like that, okay. Then whatever output it is having, it will pass to the feed forward, and feed forward again will pass to the add normalization, and again it will pass to the next, okay, layer. This is the idea. Now here you can see the entire architecture, guys. So far whatever we have discussed, now he has given inside one block only. Now we are giving our input, we are adding the positional encoding, then self attention, then we are also adding something called add normalization, then it will pass to the feed forward, then add normalization again, then it will pass to the next encoder, okay. And inside that we are also having some residual connection, okay. Then whatever output we are getting, okay, let's say whatever, let's say encoder we are using, like I think I showed you 6 encoder layer we are using. So this output will go to the decoder, okay. Now see, directly it is going to the decoder layer. Now at the same time, this output is also going to the encoder and decoder attention. Now you can ask me, what is encoder and decoder attention? See, this is the same, whatever things we have learned, encoder and decoder, the same architecture they're using in this particular layer, okay. That means whatever output you are getting here, again passing to this particular encoder and decoder, again it will process those are the input and it will pass to the next layer, okay. So that's how actually your output is passing to the encoder and decoder as well as the decoder. And how many decoder we had? We had 6 decoder layer. Now let's try to see the decoder side. Now see, here we are passing the input. So this is the input we are passing to the encoder. Encoder will pass this output to the decoder. But before passing this output, it will add some vector. You can see K vector and V vector. Okay, it will first of all multiply, then it will pass to the decoder. Okay, and decoder will pass to the linear and softmax. That means it will apply the softmax function on top of it. Now one thing will happen. Let's see if you are doing actually language translation. So the input you are giving to the encoder. So this output actually you are passing to the decoder, and decoder will predict something. See, decoder will predict something. It will generate something. Let's say I. So you are giving French input and you are getting English output. Let's say Z means I, Swiss means am, and educant means student. Okay. So that means it is first of all, see, if you see the first iteration, let me show you. So it's an animation. If I show you the first iteration, see, this is the first iteration. First of all, it is predicting I. So this I again, it is coming as an input to the decoder side. You can see I. Then it is predicting am. Again, this am will go to the input of the decoder side. Okay. Then it will predict something called A. That means based on these two words, it is predicting the next word. Okay. Based on these two words, it is predicting the next word. Okay. I already showed you now that LLM concept, like it will predict the next word always. Okay. That's how it is predicting the next word. Okay. Unless and until it is having the EOS sign, that means end of the sentence. Okay. EOS. Okay. This is the tag, I think you know. Okay. What is EOS? And there is another one called SOS. Okay. Start of the sentence and end of the sentence. Whenever it is getting the tag, that means this sentence is complete and it will stop the execution that time. Okay. So that's how your encoder and decoder is working. Okay. And inside encoder, whatever things we are having, I already explained. Inside decoder also, whatever things you have, I already explained. Okay. That's how it is actually building one amazing architecture called transformer. Okay. Transformer. And that is why transformer is so powerful, because it is having so many components inside that. It is using something called multi-head attention. Okay. That is the main concept here. So this is the entire understanding, guys. And I hope, guys, you got the high level understanding of this transformer, like how it is working and what is the internal mechanism of the transformer. Now, if I open the actual architecture in the paper, now I think you will get it. See, this is the encoder side. Okay, this is the encoder side. And now I think you know what is input embedding and what is the positional encoding, what is multi-head attention, what is add normalization, and what is these are the arrow. That means this is the skip connection residual block. Then feed forward again, add normalization. Again, you are passing to the multi-head attention, and you are also passing this in output to the decoder side. You can see this is the decoder side, and inside decoder we are having multi-head attention again, add normalization, multi-head attention, feed forward. Okay, softmax and so on. Okay, and whatever output you are getting, you are again passing this output to the input of the decoder input. Okay, this is the idea. Now I think this architecture is clear how they have developed. Okay, now you simply just try to go through this paper once, just try to read, or you can also read this particular blog. Okay, so it will give you the clear-cut idea about the transformer architecture. Okay, so this should be my suggestion, guys. Please go through one time this particular blog, just try to read everything. Okay, see the way actually he has written, if anyone is from college background, they will also be able to understand. Okay, that much easy it is. So yes, this is all about our transformer intuition. I hope you got it, how transformer is working. So based on this transformer, today's actually whatever large language model we are having, they have developed. Now in the next video, we'll be learning about like how ChatGPT got trained, because you can see ChatGPT. So ChatGPT is using one large language model called GPT. Okay, so we'll be understanding how ChatGPT actually they train, like what is the internal mechanism of the ChatGPT. Okay, we'll be discussing this part. So I think you are already familiar with ChatGPT, right? So ChatGPT is a product of OpenAI. So inside ChatGPT, we can pass any kinds of prompt and we can get the response. So it is kinds of conversational, let's say chatbot they have developed. But by that particular chatbot, what you can do, you can perform all kinds of NLP tasks. I think I showed you one example. I think you remember. We can perform language translation, text summarization. We can also perform sentiment analysis. Okay. We can also, let's say, generate the codes. Everything is possible, because I already told you, na, LLM, why it is powerful, because it can perform multitask, right? Multiple tasks it can perform with the help of one model only. Task wise, it is clear like how it will able to perform the task, right? But what about the conversational agents? Let's say whenever I'm passing any kinds of prompt, how it is identifying, okay, how it is identifying what kinds of, let's say, prompt I'm giving, and what kinds of tasks actually I'm expecting from my ChatGPT. Okay, so this is what actually we'll be understanding in this particular video, because if this understanding is clear, so going forward, whatever model you'll be learning, whatever application you'll be building, this would be more clear in your mind. So first of all, you have to remember one thing. See, ChatGPT is not a model. Okay. So ChatGPT is just an application. Internally, it is using a LLM, which is GPT 3.5 or GPT 4. It has trained on large amount of data, which is also available over the internet. That means over the internet till 2023, whatever actually data we are having. So all the data they have used to train this GPT 3 or GPT 4 model, right? Now to train this ChatGPT, they actually follow 3 steps. The first step is generative pre-training. The second step is supervised fine-tuning. And the third step is reinforcement learning. I'll discuss all of them one by one, no need to worry. But first of all, just try to see, as I already told you, ChatGPT is not a model. It's just an application. It's just an interface, right? So whenever you are giving any kinds of prompt to the ChatGPT, it is using one OpenAI API key, right? I think you know what is OpenAI API key. With the help of OpenAI API key, it is sending that particular request to the model. You can see it can access different model of the GPT, like GPT 3.5, GPT 4, okay, or any other model actually GPT is bringing in future, right? So this is the idea. Let's say you want to perform language translation. You are giving the prompt here. So this ChatGPT interface receiving your prompt, then it is sending that particular prompt to the model with the help of OpenAI API key. That is the idea. Okay, so that means ChatGPT is an application, and it is using internally it is using some kinds of LLM, which is known GPT-4 or GPT 3.5. Now, as I already told you, they used actually 3 steps to train this model. Now you can see the first stage is generative pre-training. So here you can see this base model GPT trained on a bunch of stuff from internet for a whole bunch of different things by using the transformer architecture. That means they're using a transformer architecture internally, and they're training on top of the internet data, okay, or internet documents data you can talk about. Then they are getting something called base GPT model, okay, base GPT model. Then this base GPT model, then again they are doing something called supervised fine tuning. Okay, in this stage 2 they are doing supervised fine tuning. So what is supervised fine tuning? I'll discuss everything, no need to worry. So next, with the human AI trainers, you get to have conversation where they play both sides, you and AI assistant. Okay, now after performing the supervised fine tuning, they get one model called fine tune ChatGPT model. Now they'll be performing something called reinforcement learning through human feedback. So here you can see next, let's take the model to the next level by optimizing its even more reinforcement learning by training it against a reward model. Okay, that means they will be creating something called reward model. And why they'll be creating the reward model, I'll tell you. Then after that, they will be getting the ChatGPT model, and this is what actually we are using. Okay, this is what we are using in our day-to-day life. This is the idea. Now let's discuss all the stages one by one. Now first of all, let's try to discuss generative pre-training. Okay. Now see, what is generative pre-training? As I already told you, they're using a bunch of data from the internet and they're training one transformer model. Okay, so they're using the code transformer architecture only. On top of that, they're adding some more layer. Okay, and they're creating one GPT model. Okay, this is called a GPT model. Now this model will be able to do actually various kinds of tasks like text summarization, sentiment analysis, sentence completion, translation, and so on. But what is our expectation from our ChatGPT? So here user can pass any kinds of prompt. He or she can chat and conversation with this let's say application, yes or no, right? But after training this particular, let's say, transformer model, we are only getting the actually task output. Let's say this model only can perform text summarization, sentiment analysis, sentence completion, and language translation. Apart from that, actually, it can't do anything. Let's say it can't do the chat conversation with the human. Okay, this model can't do. So this is our expectation. Okay, with that, this is our expectation. So for this, actually, what they did, actually, they followed another stage called supervised fine tuning. In supervised fine tuning, what they have done, so they have actually taken 2 human. So one human called human agent acting like a bot, another human, the actual human agent. Okay, that means both are human, but one human actually will act like a bot and another human will act like a human only, right? So this particular human will give some request. Okay, let's say he will put some, let's say, text. Let's say, how are you? So this human will give the reply. Let's say, I'm fine. What about you? Again, he will give, I am also fine. Then he will tell, I need help from your side. This particular, let's say, human will tell, so this particular human will tell how I can help you. Okay, so that's how actually they will be doing the conversation, the way actually we do the conversation with our ChatGPT. Okay, so initially we have to create our data. That means chat data. Okay, chat data. So to collect the chat data, they're using this particular technical supervised fine tuning. Okay, supervised fine tuning, they're supervising the model. Okay, this is the main idea. Now see, after doing these kinds of conversation, you will have different data. Let's say from the human side, you will get lots of requests, and from the bot side, that means human agent bot size, you will be getting lots of response. Now you'll be using this particular data to train again your base GPT model. Okay, you will be again fine tuning your base GPT model, and you will be using something called stochastic gradient descent optimizer. Okay, SGD optimizer they are using, and they're training one model called SFT ChatGPT model, that means supervised fine tuning model. Okay, this is the main idea here, and this is called actually SFT and supervised fine tuning. But one issue actually they observed after doing the supervised fine tuning, this model can only perform related to the training data. Let's say if someone is giving any kinds of input which was not present in the training example, at that time this model was giving some random output. Okay, so to actually overcome this issue and to make this particular model more good, they followed something called reinforcement learning through human feedback technique. So inside reinforcement learning through human feedback, what they are doing, whatever, let's say, conversation having between this human agent and SFT ChatGPT model, so they're trying to rank the results. Okay, rank the response. You can see, let's say this SFT model will give actually multiple response. Now there will be a human. Okay, there will be a human agent. So this human agent will rank the result. Let's say here we are getting 1, 2, 3, 4 different response. Let's say A, B, C, and D. Now between these 4 results, which one is the good? Okay, which one is the good and which one is the, let's say, suitable with the user input user has given. Now he will just try to rank the results. Now let's say B response is good, then A, then D, then C. Okay, this is the rank response. That's how actually he will try to prepare. Then what they have done, they created one reward model. And what is reward model? Reward model is nothing but it's a reinforcement learning model. Those who are familiar with reinforcement learning, I think you know what is reward model. So here you can see they're giving actually different response, and they're actually generating one score. Okay, like what is the score for this response? What is the score for this response? Okay, that's how they're generating the score. Now whoever actually having like more score, this particular response would be considered as my final output. Okay, that's how actually they're doing reinforcement learning through human feedback, and they're improving the accuracy of the model. This is the main idea. That means if you see in high level, so you are using reward model and you are ranking this particular, let's say, response based on that based on that actually you are providing the actual response, and this reward model will give some policy. Let's say if this response is good, if user is liking that particular response, so definitely it will give some reward, otherwise it won't be giving any kinds of reward. So sometimes in the chat GPT will see that it will ask for your feedback, whether you are getting the correct output or not. If you give the, let's say, low rating, that time they will consider this model is not working good, that time they will give negative reward. So again, this reinforcement learning will automatically learn, okay, how to improve the quality of the model. And if you are giving positive feedback, that means it will give the positive reward that time. Okay, so that is how actually reinforcement learning works. So here in the environment, you just put one agents, that particular agents learn the environment, and whatever activity you are doing, it will try to learn, and based on that, it will try to update the reward model. This is the main idea, right? So yes, this was the actually core concept to train this ChatGPT model. And that's how actually not only we get that task specific model, we can also perform the conversation with that particular model. Okay, because they have done, because I think I showed you now how they have done this particular entire strategy and how we can perform the conversation. So whenever we are giving any kinds of prompt, first of all, it will try to understand my prompt because of that particular supervised fine tuning. Let's say I'm giving a prompt, I want to do the language translation French to English. So it will try to understand that particular prompt. Then based on that, it will decide what kinds of tasks you want to perform. Okay, apart from that, if you are doing some casual conversation also, it can also handle, because again, it was trained with huge amount of data. Okay, that's the idea. So yes guys, I hope this makes sense now, and you got how ChatGPT was trained. And now this concept will help you to understand whatever, let's say, model will be understanding in future. Okay, so I think you enjoyed. So if you don't know about Huggingface, Huggingface is a platform. So with the help of this platform, you can do Generative AI project, you can do NLP project, even you can also perform computer vision related project. So here we are more focusing on the generative AI. So we'll be using this Huggingface platform for the generative AI related task. So this Huggingface platform is having all kinds of large language model. Even it is also having so many datasets you can use to train these kinds of large language model. And Huggingface provides one pipeline. So with the help of this pipeline, you can easily perform any kinds of task. And Huggingface is also having one Python library called Transformer. With the help of Transformer library, you can easily implement any kinds of generative AI based project. So let me show you this Huggingface platform. What are the things it is having? So guys, if you want to open the Huggingface platform, just search for Huggingface. Okay, Huggingface in Google. You will see this first link. Just try to open it up and make sure you create one account here. So for me, I already have one account. So what I will do, I'll just try to log in with my account. So if you don't have the account, you just need to do the sign up operation. Okay. So with your email address, you can also create an account. So let me log in with my account. So guys, as you can see, I already logged in with my account and this is the interface of the Huggingface. Now, as I already told you, Huggingface is a platform. So with this platform, you can perform lots of tasks. You can perform generative AI related tasks. You can perform natural language processing related tasks. Even you can also perform computer vision related tasks. Okay, even you can also do audios kinds of tasks. Let's say you are having audio data. Okay, you can also do these kinds of tasks in this Huggingface platform. Okay, now it is having actually different services. The very popular services it is having called models. That means this Huggingface is having all kinds of large language model. Let me show you. If I click on the model section, now see, it is having that many of model. Just try to see the count. That many of models are available, and these are the models are completely open source. So you don't need to pay here. Okay, if you want to use these are the model, you don't need to pay here. Only you just need to use Huggingface Python library for this. Okay, with the help of Huggingface Python library, you can easily access these are the model. Even I will also tell you how we can access different open source large language model and how we can implement different application on top of it, right? Now, if you see left hand side, it is having different tasks. You can select the multi-model. That means if you want to generate image text to text, if you want to do visual question answering, if you want to do, let's say, document question answering, if you want to, let's say, do video text to text, everything you can perform here. Then it is having computer vision related tasks. You can perform object detection, image classification, image segmentation, text to image. Okay, all kinds of computer vision related tasks are available. Even nowadays, whatever multi-model you can see, let's say large language model will generate image, large language model will generate videos. These kinds of models are also available in this Huggingface platform. Now you can see it is also having natural language processing related tasks. That means you can perform text classification, token classification, summarization, feature extraction, text generation, code generation, everything you can perform here. Okay, apart from that, I already told you it is also having some audios model. Let's say you want to perform text to speech, text to audio, okay, automatic speech recognition. These are the tasks also you can perform here. Apart from that, it also provides tabular kinds of tasks. Let's say you can perform tabular classification, tabular regression, time series forecasting. These are the tasks you can also perform. Then they have added another amazing technology, the reinforcement learning. So those who are interested in reinforcement learning, you can also perform reinforcement learning operation with the help of Huggingface platform. So it is having all kinds of reinforcement learning model. You can also perform something called graph machine learning with this Huggingface platform. So here I'm not going to focus on all the actually task here because we are more focusing on the generative AI, and for generative AI actually we'll be more focusing on the NLP, that means natural language processing, and we'll be focusing on the multi-model section. Okay, because it is having different large language model, as I already told you. Now you can select any kinds of task. Let's say you want to perform, let's say this one, you want to perform, let's say a text classification. Okay, just select the text classification. Now see, automatically it will suggest you all the text classification related model. Now see, these are the model from different organizations. See, this model is from Meta AI. Okay, Meta Llama. See, with the help of Meta Llama, you can also do text classification, and this is one of the large language model. It is having 86 million parameter, and this is the download. See, this is that many times actually this model got downloaded. Okay, so you can also download this model if you are let's say you like this model. You can also start this, you can also like this. Even they have already given the model card. Let's say you want to read about this model, like what this model can perform, how many parameters it is having, what kinds of data it got trained. Okay, everything they have given. Okay, everything they have given. Even they have also given the code snippet you can use. Okay, let's say you want to test this model, you can copy this code snippet and you can execute it here. Okay, so it's one of the amazing platform, guys. If you are working in the field of generative AI, so definitely you should learn the Huggingface platform. And no need to worry, everything I'm going to teach you here. So let me show you what are the things we'll be discussing here. See, inside Huggingface actually, we have to learn some of the very important concept. The first concept we have to learn the pipeline, because inside Huggingface everything is all about pipeline. Okay, whenever you will be using one Python library of the Huggingface called transformer. Okay, transformers. See, transformers is the architecture, but they have also named it as a library. Okay, because it is having all the model which is based on the transformer architecture only. So that's why they named this particular library as a transformer library. Okay, So inside transformer library, whenever you will be writing the code, let's say you want to perform language translation, summarization, you have to create a pipeline for this. Okay, so we have to discuss the pipeline. Then we'll be discussing different NLP tasks you can perform with the help of this Huggingface library. Then we'll be discussing very important concept called tokenization. Okay, because in Huggingface everything is all about tokenization. So whatever pre-processing, whatever text representation you have to do with the help of tokenization only. Then we'll be discussing about the dataset, like what are the dataset it is having. Then we'll be also discussing about another super important service called Spaces. Let's say you don't have good configuration PC, but you want to train one large language model. So what you can do, you can also take the Huggingface Spaces. That means Huggingface infrastructure, but definitely you have to pay for this. So there actually you can train any kinds of large language model. Okay, and this machine is like very good configuration machine you can take there. Then the fifth topic we'll be discussing about fine tuning. Okay, fine tuning LLM. Okay, with the help of Huggingface. That means we'll be learning how we can fine tune any kinds of LLM. Okay, with the help of Huggingface platform. Then at the last we'll be seeing some of the project implementation. Okay. So with the help of Huggingface, we'll be doing some of the project implementation. That means we'll be doing text summarization, language translation. Even we'll be also doing the research paper summarization. So these are the projects we'll be implementing one by one. So I hope this is enough to know about Huggingface. And if you understand these are the concept, definitely you can use Huggingface platform if you want to build any kinds of application, okay, later on. And trust me guys, if you want to use open source large language model, that means Open LLM, okay, Open LLM. So Huggingface is the only way, okay, you can use Open LLM. Okay, Huggingface is the only platform. It will help you to work with the open source large language model. But if you want to work with paid large language model, let's say if I want to take any kinds of commercial large language model, that time you can use something called OpenAI. Okay, OpenAI platform. Even there are some cloud platform as well. Let's say Bedrock is there. Okay, Amazon Bedrock is there. Then Vertex AI is also there. So we'll be also learning these are the things one by one, no need to worry. First of all, let's try to understand the Huggingface, because this is the starting point. Okay, this is the starting point in the field of generative AI. So what I feel like, if you want to understand the generative AI, if you want to understand the large language model, if you want to, let's say, use them as a practical, so I will suggest first of all start with Huggingface platform, then try to learn OpenAI and whatever services you are having. Okay, everything I'm going to teach you, no need to worry. Okay, so apart from that, it is also having datasets, guys. As you can see, different datasets. Let's say you want to train one language translation model. So simply you can select the task here. Let's say I want to do the language translation. I'll select the task here. So this is the translation. Now see, these are the data related language translation. Okay, see, these are the data related language translation. So it is having all kinds of language translation data, you can see. So see, this dataset is containing Canadian actually text as well as the English text. That means you can perform Canadian to English, otherwise English to Canadian, I think. Okay. Apart from that, you are having different dataset. Even you can also search here. If you want to, let's say, find any kinds of dataset, you can also search here. It is also possible. Now, apart from that, you can also select different libraries. Let's say I want to perform one task. Let's say I want to find a model. Let's say I want to perform something called text classification. Now I want to use one specific library. So see, it is having different library. You can use PyTorch, then you can use TensorFlow, then you have Safe Tensors. Okay, then you are having Keras, different library it supports. Let's say I want to perform with the help of PyTorch. Okay, PyTorch framework. So these are the model related PyTorch. So if you want to use these are the model, you have to use PyTorch code. So similar wise, if you want to perform with the help of, let's say, TensorFlow, you can select the TensorFlow. It will give you all the model related TensorFlow that time. Okay, that time you have to install TensorFlow library. Okay, not the PyTorch library. So that's how it has given different flexibility, different functionality, so that you can filter out the specific model, filter out the specific data. Okay, everything you can do here. And it is having another amazing service, as I already told you, the Spaces. So Spaces will give you, let's say, this infrastructure. If you want to train any kinds of large language model, you can use their Spaces service. So there you can buy their instance and you can train your model. See, it is having different spaces. Even you can also create your own spaces. Now, apart from that, it is having another amazing documentation. Now see, if you want to deep dive in this Huggingface platform, like how you can use this Huggingface platform properly, so they are also having their official tutorials. If you just go to the documentation, so they are having one documentation, and inside that you will get one section called task. Now let's click on the task. Now see, let's say I want to perform image classification task, so I'll just simply click here. Now see, it will give me the official tutorial. So they have their also YouTube videos. You can also refer the YouTube videos. Even you can also refer their blog. Okay, how we can perform the text classification that time. how we can perform the image classification. So everything they have written here. Okay, so this is one of the amazing, actually, let's say, platform I personally prefer if I want to implement any kinds of project, and if I want to learn anything. Let's say I don't know about, let's say, zero shot image classification. I'll come here, I'll go to their tutorial section, and easily I can learn, okay, how we can use this particular model. Okay, so that's how actually you can also deep dive. But if you cover this video, I hope you will be learning everything about this Hugging Face platform. But still, if you want to deep dive, you can refer their tutorial as well. Fine. And if you want to take the premium subscription, you can also see their pricing and all. You can also check it up. But as of now, premium subscription is not required. We'll be using free services. Okay, free services is enough for us, because here we'll be only accessing the models dataset. Okay, these are the thing. As of now, I'm not going to take the spaces. Everything I'll be doing in my Google Colab, because in Google Colab we'll be getting free GPUs. Okay, that is the idea. So yes, guys, this is the introduction of the Hugging Face. Now I think you got it, what exactly this Hugging Face is, and we saw like different services of the Hugging Face. Now in the next video, we'll be doing some hands-on on top of the Hugging Face, like how we can use the Hugging Face with the help of Python programming. So there we'll be installing one amazing library called Transformer. Okay, with the help of Transformer, we'll be using the Hugging Face. And it is also give you the API functionality, guys. If you want to take the Hugging Face API key, you can also take. For this, you have to go to the settings. Now here you are having something called access token. Okay, you can also take the access token. So with the help of access token also, we can access the model. Let's say some of the models you will be getting here, those models actually you can't directly download. For this, you need this Hugging Face access token. Okay, so we'll be also learning how we can use the access token to access any kinds of model, and how we can generate these are the access token as well. Fine. So here I already created one collab notebook, and here I have already mentioned each and everything you need for the Hugging Face. Okay, practical understanding. So as I already told you, if I want to use Hugging Face platform with the help of Python, we need to install one library called Transformers. Okay, so this is the library. So Transformers library is having all the functionality present inside the Hugging Face platform, right? So if you want to install Transformer library, so you have to execute this command called pip install Transformers. Okay, now let me first of all connect this notebook. And the resources would be shared, guys, in the resources section. So from there you can download, and you can also code with me. Okay, it is connected now. Now the first thing what you have to do, you have to select the runtime to GPU. Okay, because I'm not going to use the CPU configuration machine here. I'll be taking the GPU machine, because here we'll be using large language model. So definitely you have to select the GPU based machine there. Fine. So let me select the GPU machine. And if you're using free Colab, you'll be getting T4 GPU. And if you're using Colab Pro, there also you can take actually different. See, let me show you. If I click on change runtime, see, you can also take A100 GPU and L4 GPU as well. Okay, these are the GPU you can also access. So now, guys, you can see my notebook is connected. Now if I want to check the GPU, you can execute this command called NVIDIA, okay, -SMI. So this will show you the GPU configuration you got. So here I'm using free Colab, that's why I got Tesla T4 GPU. Now first of all, I have to install the Transformer library here. See, Transformer is already installed. Now see, inside Hugging Face, we are having different tasks, as I already showed you. So if I, let's say, click on the models, and if you see the left hand side, you can see you are having different tasks. So here you are having different tasks. Let's say here we are focusing on generative AI, that means the natural language processing. So here we can perform different tasks. Let's say we can perform text classification, token classification. Okay, all kinds of tasks actually you can perform. Whatever tasks actually you see in the field of NLP, or in the field of, let's say, generative AI, all kinds of tasks you can perform here. So if I want to perform these are the tasks, I have to use one functionality from the Hugging Face called pipeline. Okay, so here you can see I have imported this pipeline from the Transformer. Okay, so it is available inside Transformer. Now let's say we are having various NLP tasks, as I already showed you, text classification. Then we are having here you can see text classification, token classification, table question answering, zero shot classification, translation. Okay, now see, I have listed down all the tasks here. Now let's say if I want to perform text classification, so what you have to do inside pipeline, you have to mention I want to perform text classification. So this Transformer library, what it will do, it will automatically try to understand you want to perform text classification. So all the code actually it is having in the backend, it will execute that particular code snippet. That means it's a high level wrapper. Okay, on top of, let's say, Hugging Face, it's a high level wrapper, this particular Transformer library. So you don't need to write the code from scratch. Let's say you don't need to write the code. I want to perform text classification. So code you don't need to write from scratch. Only you just need to give this particular input to the pipeline, and pipeline will automatically take care. You have to do the text classification task. And for this, whatever let's say strategy you have to follow, everything it will take care. Okay, I hope you got it. Now see, similar wise, if you want to perform token classification, you can mention token classification. If you want to perform question answer, you can also give question answering. If you want to perform text generation, summarization, translation, even also you can select the model. Let's say which model you want to use. As I already showed you, now we are having so many model. Now let's say I want to perform translation. Now see, you are having different model. Okay, different model. Now see, you can also give the model. Okay, model ID. Now let's say I want to use this model. I'll just click here and I'll copy the model ID. This is the model I'll copy, and here I just need to mention. So it will automatically download this model from the Huggingface. So you don't need to manually download it as well. So that much powerful it is. Okay. So that is why I told you, you have to master this pipeline concept, because going forward, whatever actually, let's say application you'll be implementing, you need this particular pipeline approach. Fine. Now see, I have given different actually example, a computer vision example also. Let's say you want to perform image classification in the pipeline, just mention image classification. Okay. Even also you can specify the model. It's up to you. Now see, different example I have given just for your reference, so that you can refer this notebook later on. Now let's perform one specific NLP task. Let's say I want to perform sentiment analysis. So here you can see the task, as well as you will also get the all kinds of tasks in the documentation section. So here you are having one tab called task. Now see, all the task is also visible. Read that, computer vision, natural language processing, audios, and multi-model. Okay, everything is there. Now let's say I want to perform sentiment analysis, and sentiment analysis is what kinds of task? It's a text classification task. I think you saw it's a text classification task. Okay, now either you can give the text classification. Okay, either you can pass the text classification here, either you can also give the sentiment analysis. Okay, both it will work. So I've given sentiment analysis. Okay, I want to perform sentiment analysis in the pipeline. Now it will give you one object called pipeline object, and this is my classifier. Now inside that you have to pass the input. Let's say here I've given the input. I was so not happy with the last Mission Impossible movie. Now this is the sentence I have given. Now see, if I execute this line of code, so it will automatically download one specific model. Now see, here I haven't given any kinds of model name. So it will download one default model, and it will try to predict whether this particular sentiment is a positive or negative. Okay, let me show you. See, if I execute this code, see, it is using one model, default model called DistilBart based case. Okay, fine-tune SST to English model. And this is the link of the model. If I open it up, see, it is using this model. This is the default model. Okay, and here is the prediction, guys. It's a negative sentiment, and it is telling 99% confidence it's a negative sentiment. Okay, that means it is performing amazing. See, that much actually it is easy to use this transformer library, and that's how actually pipeline helps us to perform any kinds of task I want to perform. So I don't need to write the code from scratch. Only I just need to mention that specific task name. It will automatically do it for me. Now there is another way you can pass the input. Let's say here is my pipeline. Inside pipeline you can mention the task I want to perform. Let's say a sentiment analysis, and the second parameter you can give the input. Let's say this is the input I have given. I was confused with the Barbie movie. Okay, now it will give you the same output. So either you can follow this approach, either you can follow this approach. This is the one line approach. Okay, so both it is possible. Now if you are having any big text, that time what you can do, you can also use multi-line actually string. There also you can pass the text like that. See, again it's a positive review, and this is the confidence score. Fine. Now let me show you how we can specify any kinds of model. So let's say now I want to perform sentiment analysis, and I want to use any other model. Let's say I want to use this model, Facebook BART large MLI. Let me search this model. You will see this is one of the large language model. You can see BART large MNLI. See, again, it's not a large language model. I can say it's a language model, because this model only can perform one specific task, which is nothing but the sentiment analysis. But going forward, we'll be using large language model, like we'll be using Llama, Mistral, Falcon, Gemini. Okay, so these are the model actually we'll be using, and these are the model is multitasking model. Okay, that means large language model. So there are two kinds of models are available, guys. Just try to remember. One is the large language model, that means LLM. Okay, and this is like only LM, that means language model only. So language model can only perform one specific task. Okay, one specific task. And large language model can perform multiple tasks. Multiple tasks. Even it can also perform chat operation. Okay, chat operation, because I already told you na how large language model was trained. Okay, because of that supervised fine tuning, reinforcement learning, through human feedback. These are the technique has applied. But whatever LM model you can see, it has only trained with the transformer architecture. Okay, transformer architecture. Okay, I think I showed you the transformer architecture example. I think you remember. Fine. So these are the model we are using. This is called actually language model only. It can only perform one specific task. So that's why here we are mentioning the task name sentiment analysis. Now see, here we are giving the model name. Now we can use any kinds of model. Just go to the model section. Go to the model section. Now let's say I want to perform sentiment analysis. For this I have to use text classification. Now just try to get any kinds of model. Let's say you want to use this model. Copy the model ID. Try to paste it here. Okay, it will download that model and it will do the operation. Now let me show you. See, first of all, this model will be downloaded from the Huggingface. Now see, it is downloaded, and see the model size. It's around 1.63 GB. This is actually sentiment I'm getting. This a neutral sentiment. Okay, it's not a positive, it's not a negative, it's a neutral sentiment, and this is the confidence score you are getting. Fine, great. Now how to perform the batch actually sentiment? If you are having batch data, let's say multiple, let's say sentence, that time how you can do? You can use something called batch sentiment analysis. So again, just try to create a pipeline, and whenever you are preparing your input data, just try to give inside a list. You can see it's a Python list, and inside that I'm having different sentence. Okay, different sentence. Now you have to pass this particular list inside your classifier. Now see, it will take one by one all the sentence and it will show you the sentiment. Now see, this is the first sentence sentiment, second sentence, third sentence, and fourth sentence. Okay, I hope it is clear. But the model actually, it is using the default model. It is having only two label, which is nothing but positive and negative. But if you see this sentence, it is having some emotion. Okay, it is having some different sentiment. And if you want to capture different sentiments, you can use any other model. Let's say I will be using this model, Robota based Go emotion model. So this can actually detect a multiple sentiment from a sentence. Okay, you can see all kinds of sentiment they have mentioned. See, these are the sentiment it is having. Okay, so that many of sentiment it can detect. Now let me use this model and let me again apply the same data. Now see, it will give you different sentiment. See, again it is downloading the model. After that it will do the sentiment analysis. Now the first sentence, it is admiration, second one confusion, then amusement, then anger. Okay, I hope you cleared. So I can say this is one of the very powerful library. Okay, if you want to work in the field of generative AI or natural language processing. Now you can also perform text generation task. So for this, in the pipeline you have to mention text generation only. Okay, I think I showed you different tasks. Let's say I want to perform text generation right now. So text generation, I think it is there. Natural language processing, text generation. Okay. Now see, they have also mentioned in the tutorial, you have to give text generation in the pipeline. Okay. And you can also give the model. So the same thing I'm doing. Text generation model, I'm using DistillBut. And inside that I'm passing my input. Today is the rainy day in London. Now it will refer this sentence and it will generate the text. Okay. Based on this particular content. Now if I execute, see. See guys, beautifully it has generated the text. Today is rainy day in London, and one that no other city can remember or ever even know. A few days here ago, the police arrested. Okay, see, beautifully it has generated the text. Okay, so that's actually, you can also perform text generation. Now if you want to perform question answering, just give question answering, and you have to give the question as well as the context. Okay, so based on the context, it will so by referring this context, it will give you the answer. Okay, let's say this is my question, what is my job? And here I'm giving the context. I'm developing an AI model with the Python. Okay. Now, if I give my question as well as the context, it will give me the answer. Again, you can check their documentation for the question answering. So they're telling like that. So you have to give the question context and you have to pass to the pipeline. Okay. Now see, answer is developing AI model. That means this is my job. Okay. I hope it is clear. So I hope guys, now it is clear how we can use this Huggingface platform if I want to perform different tasks and how we can access different model. Now let's say you want to use large language model, that means LLM. So I think I showed you one amazing GitHub, Open LLM GitHub. So you can open this GitHub and you can see different large language model name. Let's say you want to use this model. Let's say you want to use let's say we want to use this Falcon model. Falcon is a large language model. You can copy the name and simply you can go to the Huggingface, go to the model section and simply search here. Okay, simply search here. Now see, Falcon model would be there. See, Falcon models is there. And Falcon is nothing but it's a large language model. It's not a language model. Okay, with the help of Falcon, actually we can perform different tasks. Even we can also perform chat operation. Not only that, all kinds of models are available. Let me show you. Let's say Llama 2. If you want to use Llama 2, I'll copy and I'll come here. I'll search for the Llama 2. See, Llama 2 is from Meta AI. Okay, like that we are having some another model also. Let's say Mistral is there. Then we are having something called Jimma. So this model is from Google site. So that's how we are having different large language model, and no need to worry. Going forward, we'll be using these are the model. But before using these are the model, we have to learn some additional, let's say, tools and technology. Like we'll be learning some generative AI framework like LlamaIndex, then Langchain. Then we'll be also learning about vector database. Okay, then we'll be learning these are the model as well. Fine. So yes, guys, this is all about from this video. I hope it is clear now. So in the next video, we'll be understanding about tokenizer. Tokenizer inside actually Huggingface. What exactly is tokenizer? Okay, and why we need it. Okay, why tokenization is required. So as I already told you, inside Huggingface actually we're having another super important concept called tokenization. And now we'll try to understand why tokenization is important and why we use tokenization inside Huggingface. I think you remember I taught you one concept called text preprocessing and text representation. So there, whenever I was passing any kinds of text to my model, first of all, I was doing the processing, then I was converting that particular text to the vector representation, right? And for this, I was using different technique. Like for text vectorization, I was using TF-IDF, word to vec, bag of word. Then that time actually I told you, we are also having some other technique, which is nothing but transformer based technique. Okay, because it is having something called attention mechanism. And then I taught you the attention mechanism concept, the transformer architecture. So there I showed you how it will give the attention to a specific word. Now it's time to show you this part as a practical. That means now we are using transformer based architecture, transformer based model, and whatever data actually we are passing as an input to my model. Okay. So internally, how it is processing that. Okay, internally, how it is processing that, internally, how it is converting to the vector representation. So it is using something called tokenization technique. Okay, tokenizer. So inside actually transformer, we are having something called auto tokenizer. Okay, so inside auto tokenizer, we have to first of all give the model name, like which model you have to use for that particular tokenization task. So to explain this tokenization, I just simplified this particular code. So first of all, I'm importing some of the necessary library I need. And here you can see I'm importing auto tokenizer. Okay, so let me import all the library. If you want to use any kinds of tokenization, so first of all, you have to define the model name, like which model you want to use. So here I'm using this model, BART-based multilingual unkissed sentiment model. So this model will, so with the help of this particular transformer based model, first of all, it will perform the tokenization. That means this input we are giving to the model right now, yes or no, right? So first of all, it will, this tokenizer, what this tokenizer will do, it will first of all pre-process. Let's say if it is having some HTML tags or any kinds of stuff word, it will try to remove. Then it will try to convert this text to the vector representation. Okay, then it will pass to the model, and model will actually do the sentiment analysis. Now see if I execute the code. So first of all, it will download the tokenizer. Okay, then after downloading the tokenizer, it will also initialize the model. After that, it will do the sentiment analysis. So this is the high level understanding. Even I will also show you the low level, how it is generating the vector. Even we can also visualize the vector as well. See, now you can see this is the result we are getting. Fine. Now let's try to see how tokenizer is working. So if you want to use tokenizer, you have to import one library called auto tokenizer from transformer. The first thing what you have to do, you have to load one pre-train model. Okay, pre-train transformer based model. So here, let's say we are using BART based case model. So this is one of the transformer based model. Okay, you can see this one of the transformer based model. So we're giving the model ID here. Then this is my example text. Let's say I'm giving into my tokenizer. Okay, so inside tokenizer, we're having another function called tokenize. Now after tokenize it, I'm just printing. Okay, after tokenizing, I'm just printing. Now let me show you what it will give me the output. So I can cut, these are the example. Now let me execute as of now. Now see, when you apply tokenizer.tokenize, it will give you the individual token. That means the tokenization we used to perform with the help of analytical library, I think you remember, right? Sentence level and word level tokenization. Now it is possible with the help of this tokenizer class only. Okay, that's why I told you transformer is like very powerful. So it's a high level wrapper. Inside that they have written all kinds of code. It will handle each and everything. You don't need to write any kinds of code from scratch. Okay, now if I want to convert this textual representation to the vector, what I have to do, I have to pass this particular token to the convert tokens to IDs, this particular method. Okay, and it is available inside tokenizer object. The tokenizer object we have defined here. Now it will give you the input IDs. Now let me show you this input IDs. I can take different cell and here I can execute. See, this is the input IDs, and this is nothing but your representation of the text. The text actually you have given. I was so not happy with the Barbie movie. Now you can see this is the vector representation of this particular text, and it is using transformer model. Okay, it is using transformer architecture in the backend, and it's like more powerful. Okay, it's like more powerful technique than your bag of word or TF-IDF or what to bake, whatever you have learned. Okay, and going forward we'll be using this particular approach only. Okay, I hope you cleared. But whenever I have to pass this particular vector to my model, I won't be using this particular method. For this, you have to use this particular method. So here there is another function. So here you have to pass your data to the tokenizer. Okay, directly you have to pass to the tokenizer, and tokenizer will give you this output. Let me show you. See, this is the entire output, encoded input. Now see, input IDs, now it is familiar. So this is the input IDs. And here one additional token you can see 101. What is 101? This is the start of the sentence, and start of the sentence represent 101 and end of the sentence represent 102, and in between actually you can see your entire vector, the vector actually you got. Okay, now it is having another actually things called token type IDs. As of now, just try to skip this part, it's not required. And this is the important things, guys. Attention mask. Okay, now I think you remember what is attention mask, that attention mechanism concept. That means whenever, let's say, it will pass this particular data to my model, in which word it will give the more attention. Okay, it is telling. Now see, it is giving the attention to all the word, because every word is 1 you can see. That means this one will get the same attention, this one will give the same attention. Okay, this one will give the same attention. Okay, and how it is getting to know how to give the, let's say, attention, I think I showed you the calculation that I mean one calculation I was discussing in that JLMR blog. Okay, that's how it is calculating the score, and it is able to decide, okay, I have to give the attention to this particular specific word. Okay, I hope it is clear. So these are the actually output you will be getting after doing the tokenization. Now if you want to decode the tokenization, that means if you want to again convert this let's say vector to text representation, you can use decode function for this. Now I'll give my input ID. So whatever input ID I'm I'll pass in the decode function, and decode will give me the previous text. Actually you can see I was not happy with the Barbie movie. Okay, I hope it is clear now. Now if I execute all of them all together, you can see this is the output. This is your tokens, this is input IDs, this is the encoded input, this is the decode output. That means this tokenization will first of all perform the pre-processing, then it will perform the tokenization, then it will convert your, let's say, text to vector representation. Okay, and additionally it will also give you some of the, let's say, number, which is nothing but attention mask. Okay, based on this attention mask, your model will decide in which word it has to give the let's say attention more. So now I think, guys, this tokenizer is clear, like what is tokenizer exactly inside Huggingface, because many people will have this question later on. That's why I just clarified right now, because going forward whatever experiment we'll be doing, we'll be using the tokenizer, okay, from the Huggingface itself. So for this again I kept one example. So here we'll be fine-tuning one dataset called IMDb. Okay, IMDb movie review dataset, and we'll be using one language model, okay, from the Huggingface itself. So for this here we'll be using Huggingface dataset only, because I already told you Huggingface is having dataset. Okay, dataset actually services. So you can also get different datasets, and this is the dataset count, guys. Okay, now you can search any kinds of dataset. Now let's say I want to use something called IMDb dataset. So IMDb. So this dataset is already available. See, this is the IMDb dataset. Okay, so this is a movie reviews dataset. So here you have the movies, and based on that you have the reviews. Okay, whether it's a negative or positive. So here we'll be fine-tuning one text classification model. That means we'll be performing sentiment analysis. Okay, this is our main objective. So if you want to use actually Huggingface dataset, for this you have to install one library called Dataset. Okay, so first of all try to install Dataset, and make sure you also install transformers. Okay, because I already installed transformers, so that's why I'm not going to install again. Now you have to restart the runtime. Now see, it is restarting the runtime. After that we'll load the data, and loading data is very much easy. Only you just need to give the dataset name. Okay, so there is a load dataset function inside dataset. You have to call it, and inside that you have to pass the dataset name. It will automatically download the data from the Huggingface. Okay, now see, this is the dataset name IMDb. Just copy the name and give it here. Okay, it will automatically download. Now if I show you, so not only this data, you can use any kinds of data. Even I think you remember in the previous video I showed you that tokenizer. So in the tokenizer also you can take different model. Okay, different model for the tokenization. So there I was using BART based case model. You can also use any other model. But remember, whatever actually model you are using for the tokenizer, the same model you have to use for the model training as well, for the model inference as well. Okay, this is the idea. Now let me show you. See, my dataset is downloaded. Now if you want to see the dataset metadata, so this is the dataset. Now we are having training data, text and labels we are having, and this is the example. That means 25,000 actually rows we are having inside training example, and test data we are having 25,000, and here we are also having unsupervised data. So here we'll be using this data only, train and test data, okay, for my analysis. Now first of all, let's do the pre-processing task. So for this, I think you remember we have to perform the tokenizer. So here I'm importing auto tokenizer. So again, I'm using this model, BART based case model. Okay. So first of all, I will initialize my tokenizer. Then here I have created a function, tokenize function. Inside that, I'm just tokenizing my example. Now, which example I have to tokenize, guys? I think you remember, if I show you the data, let's say if I show you the first example, you can see this is the text. Okay, this is my reviews. Okay, this is my reviews, and this is the sentiment. So I have to apply on top of the reviews only. Okay, so that's why I'm giving text, example text, because inside example we are having the text. Okay, text keys actually you can see, because it's a dictionary format. Okay, that's the idea. And here I'm adding padding max length. Let's say, what is padding? I think remember. Let's say there is a sentence, this movie is good. Now let's say there is another sentence, I hate this. Okay, now just see the actually input length 1 2 3 4 1 2 3. So this input length actually having one word less. So in case actually what you can do, you can add some padding. Padding means zero value. Okay, so that's why actually we are adding this particular parameter. Padding is equal to max length. That means first of all, it will try to figure out the maximum length sentence. Based on that, it will decide what would be the padding size. Okay, this is the idea. Now here we are applying this particular function. You can see this tokenize function on top of my entire data set. Okay, and for this I'm using map function, and map will apply on top of the entire rows. Okay, this is the idea. Now if I execute, see this tokenizer will apply on top of my entire data set. Then I will get all of my vector. Now previously I only had this many of example. Now after tokenization, you will see you will have some more actually keys, like your attention mask. Then you will also get the input IDs. Okay, these are the things you will be also getting. So guys, as you can see, my tokenization is completed. Now if I show you my tokenized dataset right now, so see, now I am having all of the features like input IDs, token type IDs, and as well as the attention mask. Okay, everything. Now if I want to show you the data, how it will look like. So here you can visualize. Let's say I want to see my training data. Let's say I want to show you the first example. Now you can see the first example. This is the raw text. Okay, and after doing the tokenization, you got the input IDs, and input IDs is nothing but is the vector representation of the entire text. Okay, you can see this is the vector representation, and it will also have something called this one, attention mask. Let me show you. Token type IDs would be there, as well as the attention mask. See, attention mask. Okay, I hope it is clear now. That means we have successfully converted our textual data to vector representation. Now we can start the training, but before that I have to first of all set some of the training argument, and transformer provides actually one function called training arguments. Okay, inside that you can mention training arguments. So these are the default actually arguments you can keep as of now. No need to change anything, because again it's a hyperparameter tuning. Only just change you can do number of epoch. Let's say how many epoch you want to train. Let's say I only want to train only, let's say, one epoch as of now. Okay, only one epoch I want to train. And output directory, so it will create a folder here called output directory. Inside that it will save all the models and everything, right? Now let me set the training arguments. So again, this is kinds of template kinds of code. You don't need to remember anything. All the codes are available in the Huggingface platform. So from there you can refer. Okay, you don't need to remember anything here. Fine. Now see, that many of actually training argument you can set here. Okay, after printing you can see. Okay, but I don't need to set all the training arguments. So we can only set these are the training argument. Fine. Now we can initialize the model. So here to initialize the model, first of all, you have to import to library auto. So here you have to import one library called auto model for sequence classification, because here we are doing text classification. For this, you have to use this particular class. Then you have to also import the trainer. Now, first of all, you have to load the model. You can see this is the model, part based case model. I'm loading. Okay, so if you give it here, it will automatically download. And number of labels I'm giving 2 because we are having only 2 labels, positive and negative. We are doing the sentiment analysis now of the IMDb dataset. And if you see the sentiment, only positive and negative. Fine. If you are having, let's say, 4 sentiment, that time you can give 4. Okay, I hope you're clear. Now simply we can initialize the trainer. Inside trainer, give the model, give the training arguments. Okay, the training arguments we are getting from here. This is the training arguments. Then we have to pass the train data. So this is my train data, tokenized data train. Okay, training sample. And evaluation data, I'm giving my testing data. Fine. Now let me click here. Now see, it will download the model and it will initialize all the trainer. Now see, training has not started yet, because if you want to start the training, you have to call these particular things. Okay, trainer.train. Now see, if I click here, now it will start the training. And after training, it will save all the artifacts in the results folder. Okay, so it will take some time, guys. So let's wait. Once training is completed, I will come back. If you're using free collab, so training will take some time, so you have to wait. Now what you can do, you can also evaluate the model on top of the test data. So just try to execute this code. So again, it will take some time. Let's wait. After this execution, you will see the evaluation metrics. And in between, let me show you the training loss and validation loss you got after training. So this is the training loss and this is the validation loss in only one epoch. So here, if you increase the epoch size, you will see that this loss would be decreased. So try to increase the epoch size whenever you are training your actual model. As of now, I'm only training one epoch because I just wanted to show you. Okay, this is the idea. Now let's see the evaluation metrics. What is the evaluation metrics we get here? So guys, as you can see, this is your evaluation result. So this is the evaluation loss. This is the evaluation runtime. That means that many seconds actually took to execute this entire code. And you can see we only trained one epoch. Okay, so you just only need to see these losses, like how much loss you are getting. So this loss should be close to 0. If it is close to 0, that means your model is performing better that time. Now you can also save the model you have trained. You can also save the model. Even you can also save the tokenizer. Why you have to save the tokenizer? Because let's say in future user will come here and they will be using your model. So they will give some input, right? And input is what? It's a text. So again, you have to convert that particularly into the vector representation. Yes or no, right? So to convert this input to the vector representation, I need to use my tokenizer, my train tokenizer. Okay, not the previous tokenizer. Okay, that's the thing you have to remember. And as well as I also need to save my model. Now let me save both of them. Now you can see in the results folder, we are having all the checkpoints of our model training and all. I think you already know, if you have already learned previously, like how to train computer vision model, TensorFlow model. I think you know what is checkpoints. Okay. Now see, we have successfully saved our model. Now if I refresh, now see this model has been saved here. Now inside this folder, actually we are having different actually files. You can see config.json, then save tensors. Okay, JSON. So this is how actually your Hugging Face saved the model. Okay, it will contain actually multiple files. Inside config.json, so you will have the entire configuration of the model. Okay, this is the main idea. So see, we have successfully saved our model as well as the tokenizer. Now let's see actually one project. Now let's try to do one small project. So here we'll be using this archive actually. So I think you know archive is a website. So here you will get different research paper. Okay, all kinds of research article you will get here. So first of all, we'll install this library because in Python we have this library. With the help of this library, we can actually download all kinds of article, right? We can get all kinds of article data. So now let me import. Now see, if you want to use this particular library archive, first of all, you have to prepare one query. You need AI or artificial intelligence or machine learning related, let's say, paper. Here you are giving the query. Now here you have to search. Okay, you have to search in the archive. Now here you can see I've given the query. Maximum result I need 10, and you have to pass this particular parameter called sorted by. Just try to mention submitted data as of now. Now it will give me different page, and I'm looking through the page and I'm extracting the published date, title, and abstraction and category of the paper. Okay, then whatever data I'm getting, I'm converting to the data frame and I'm just plotting it here. Now let me execute and let me show you. So guys, you can see I got the results. Now this is the published date, this is the title of the paper, and this is the abstraction of the paper. Okay, abstract of the paper, and this is the category. Now let's say I want to create a research paper summarization system. So what I can do in the pipeline, I can mention I want to perform summarization. Okay, and which things I want to summarize? I want to summarize this abstraction. Okay, this abstraction I got. You can see this is the abstraction column. Okay, abstract column. Now that's why I'm passing the abstract column from the data frame. And here I'm using this Facebook BART large CNN model. Okay, and inside that I'm passing my abstraction. Now see, it will give me the summary. So this model actually they train on the summary. Okay, summarization task. You can open it up and you can see the description of the model. They are doing the summarization task. Okay, so execution is completed. Now I got all of my summarization result. Now let's say I only want to see the first one. Okay, first summarization text. Now I can execute this code. You can also print all of them, it's up to you, but I'm only showing the first example. See, this is the summary of the first results. Okay, so I hope guys it is clear how we can perform the, let's say, fine-tuning operation on top of a pre-trained model. And no need to worry, going forward also we'll be exploring lots of model and we'll be doing the fine-tuning operation. We'll be implementing different application. Okay, on top of it we'll be implementing different projects. In this video I will show you how we can generate a Huggingface API key, because I told you sometimes we need this API key. With the help of API key we'll be accessing the model. Okay, so for this we have to learn how we can generate a key. So as of now we'll be generating the key, later on we'll be using that. So for this definitely first of all you have to log in with your Huggingface account. Now click on the profile icon. Now go to the settings. Now left hand side you will see one option called access key. Okay, access token. Now click here. Now see, previously I already created some of the access token, but for you it would be empty. Now if you want to create a new one, just click on create new token. Now you can give the token name. Let's say I will give my new token. Now you can give the permission. Now here you can provide the permission whether you want to create for the read access or whether you want to create for the write access. Okay, so let's say as of now I want to create for the read access. I only want to perform the read operation, and later on I will also show you how you can push your trained model to the Huggingface hub. So that time actually you need the write access. Okay, so as of now let's create my token. This is your token. Just try to copy and save it somewhere. No need to share with anyone, otherwise they will also access your account. Okay, so it should be private. I will delete it after the recording. That's why I'm showing you. Now let me close it. So as of now I showed you the Huggingface demo, like how we can use this Huggingface platform, how we can access different model, even how we can also fine tune those are the model on top of our custom data. So in this video we'll be using the same technique and we'll be implementing one project called text summarization. Okay, so here is the notebook guys I already prepared. So the first thing what you have to do, first thing, just connect the notebook and make sure you change the runtime to the GPU, because here you need the GPU if you want to, let's say, implement this project, because here we'll be fine-tuning one transformer based model. Okay, we'll be fine-tuning one LM model here on top of our custom data. I'll tell you which model we're gonna fine-tune, even on top of which dataset actually we're going to fine-tune. But first of all let me tell you what is text summarization. Text summarization means, let's say you are having a bigger paragraph and you are summarizing that particular paragraph. I think you know, okay, what is the summary, right? What is the text summarization project? So in internet actually you will be getting different summarization actually application. Let's say if I write text summarization online, so there are so many application you will see. This is another application from Quillbot actually. So here actually you can also give any kinds of text and it will give you the summary. So let me show you. If I search for English story, so what I can do, I can copy this text as of now as it is, and here let me paste it. Now if I click on summarize button, you will see that it will give me the summary of the entire text. Now you can also control like how much summary you need. So let's say I need a little bit bigger summary. Now if I again re-summarize, now see this result I'm getting, this is the actually a little bit long than our previous summary. Okay, so that's how actually we're having different application over the internet. So we'll be implementing this kinds of project, but here I'm not going to implement a user interface. User interface wise we'll be implementing later on. So as of now we'll be only doing the experiment on the collab notebook. Okay, we'll be using transformer based model, we'll be using LM model, and we'll be doing this kinds of project. Okay, this is the main objective here. So let me get back to my collab notebook, and first of all let me execute this command. So this command will show you which GPU actually you are using. So here I'm using Tesla T4 GPU because here I'm using free Google Colab. Now the first thing what you have to do, you have to install transformer library. Okay, why? Because here we'll be using Huggingface actually platform, and to use Huggingface platform I already showed you, you have to install transformer library. Apart from that, you need some additional package like sentence pieces. Okay, then you need Scareblue, then Roscore, okay, and Pi7Zer and datasets. Why dataset? Because with the help of datasets, we'll be downloading the dataset from the Hugging Face itself. Okay, that is why. And these are the dependency packages you also need to install here. Fine. So let me install all the packages one by one. So my installation is completed. So the next thing what you have to do, you have to update some of the packages. The first package you have to update called Accelerate. Then you have to uninstall your older version of Transformer and Accelerate, and you have to install the latest one, because what happens actually in Google Colab, sometimes they're using older version of the Transformer package and Accelerate package. Okay, so that's why I'm updating it again. Okay, that's the things you have to do. And what is Accelerate? See, Accelerate will help you actually to access your GPU. That means here you are using the GPU, you are using something called CUDA. Okay, so to use your CUDA actually instance, this Accelerate will help you. So whenever it will do the fine-tune operation, that time actually it will access your GPU, right? So that's why actually this package is required. Now let me update all of them. So as you can see, update is successful. There is no error. That means everything is working fine. Now the next thing, you have to import some of the necessary library to test whether everything is working fine or not. So here you can see I'm importing pipeline. Then I'm also importing load dataset from the dataset. Okay. And apart from that, I'm also importing some additional library. Okay, some extra library also I'm importing here. It is not required, but what the library actually I'm going to use, like later on I'll tell you, okay, why I'm using that one. So as of now, let me import all of them. See, this execution is fine. That means there is no error. We have successfully installed all the packages. Now I think I already imported Torch, so I don't need to import this line. I can delete. Now the first thing what I have to do, I have to check the device, okay, whether it is utilizing my CUDA or whether it is utilizing my CPU. So as I already showed you, I have changed my runtime to the GPU, right? And here you can see it is connected with my T4 GPU. That means it should use my CUDA. So let me check. See, it is utilizing my CUDA. So here I'm using Torch, PyTorch library to check it whether CUDA is available or not. If yes, print CUDA, otherwise print CPU. So you don't need to manually set your machine type. So if you have the GPU installed in your system, and if all the tools and let's say services are already installed, so it will utilize that particular GPU, that means your CUDA. Otherwise it will automatically utilize your CPU. Okay, so if you see any kinds of PyTorch implementation, PyTorch use this particular code snippet, okay, to map with your CUDA or with your CPU. I hope it is clear. Now the first thing what I have to do, I have to load my tokenizer. Okay, tokenizer. And what is tokenizer? I already explained. With the help of tokenizer, we'll be preprocessing our data, and I will be converting my text to vector representation. So for this, I'm going to import auto tokenizer from transformer library, and another class I have imported auto model for sequence to sequence LM, because here we'll be loading one LM model. That means we'll be loading one transformer based model, and to load the transformer based model, actually you have to use this particular class. Fine. Now let me import this package. Now here is the model checkpoint, guys. So here we'll be using one model called Google Pegasus CNN Daily Mail. Okay, so this is the transformer based pre-train model, and this is the model, guys. This is from Google. So Google has trained this model, and this model can perform text summarization. Okay, now if you want to test it, here is the inference API. Now here you can see it will give you the summary. Okay, summary of the entire text. Now you can see what kinds of data set they use to train this model. Every information they have given, okay, about the model. So if you're interested to deep dive, you can check this documentation. You can check this model kit. You will see each and every details. Now if you want to see the model, just click on files and version. You will see the GB of the model. It is around 2.28 GB, and there is another file, it is around 3 GB. Okay, so total I think 5 to 6 GB this particular model. So whenever I will download this model, you will see that, okay, what is the model size as of now. Let's get back. So now let's load the tokenizer, and I already told you the model actually will be using the same model you have to use for the tokenization as well. Fine, this is the idea. Now let me load the tokenizer. So for this, I'm using auto tokenizer from pre-train, and here I'm giving the model checkpoint. It will automatically download from the Hugging Face itself. So fine, I have already downloaded the tokenizer. Now we'll be downloading the model. Okay, so To download the model, I'll be using this class auto model for sequence to sequence LM, this class, and there is a function called from pretrain. You have to give the model checkpoint and to device, like in which device you want to load the model. I want to load the model inside my GPU. Okay, that's why I'm giving GPU to device is equal to my device. Now let me load it. Okay, my model has also loaded. Now we'll be loading the dataset, and dataset wise we'll be using one dataset named Samsung dataset. So this is the dataset, guys. So this dataset is from Samsung actually. So they have published this data, and the Samsung data is nothing but it's a dataset containing about 16k messenger like conversation with summaries. That means it is having actually different conversation. Okay, and in the another column actually it is having the summaries, okay, of that particular, let's say, conversation. So if I show you, let's say this is the conversation. Okay, this side you are having the conversation and this side you are having the summary. So let's say this is the conversation and this is the summary. Okay, again this is the conversation, this is the summary. So that's how they have collected the entire data, and it is having 16k actually messenger like conversation data. Fine. And the dataset name is Samsung data. And if you want to see the dataset is split, so it is having around 14,732 example for the training, validation that many example, and testing that many example. Fine. So again, you can see this documentation if you want to learn more about this data. Now let's download the data. So for this, I'll be using load dataset from my dataset package. Now let me download the data as well. Now I'll give yes and I'll press enter. It should download the data. Okay, now if I show you the dataset metadata. So this is the metadata, guys. So as I already told you, it is having a dialogue and summary, and that many of example you are having for the training, testing, and validation. Fine. Now if you want to see any kinds of, let's say, dialogue, that means your entire, let's say, conversation, you can also visualize. So let me visualize one of the example. So this is the dialogue, guys. You can see Olivia is telling who are you voting for this election. Then Olivia is saying liberal as well, and Olivia, me too. Olivia, great. Okay, so this kinds of conversation it is having, and based on that it is having one summary. So let me also show you the summary. So I'm printing the summary here. You can see, so Olivia and Oliver are voting for the liberals in this election. Okay, so this kinds of actually data set they have prepared. Now this particular code snippet will print the number of example you are having in this data set, as well as the split length and the, let's say, entire dialogue and entire summary. Now let me show you. See, this is the split length, this is the training, validation, and testing, and these are the features it is having, like ID, dialogue, and summary, and this is the entire dialogue you can see. Okay, and this is the summary of the dialogue. So this is the preview of the data. That's why I just printed. I just wanted to show you, okay, what kinds of data they collected. Now let's say you are having some different kinds of data. So what you can do, you can give your, let's say, entire, let's say, paragraph as a dialogue and the summary as a summary. Okay, and you can follow the same approach. Okay, it doesn't matter. Now the next thing what I have to do, guys, I think remember I have to pre-process my data and convert to the vector representation. So for this, what I have to use my tokenizer. Okay, I think you know. And on top of which actually, let's say, column I have to apply my tokenizer on that dialogue, because dialogue is my actually paragraph. And again, if you see the summary is also a text. Okay, so I also need to apply the tokenizer on top of the summary as well. So here I've written a function convert example to features. So it will take the example batches, that means your dialogue and summary, and it will perform the tokenization operation. You can see. So first of all, I'm applying tokenization on top of my dialogue. Then I'm applying tokenization on top of my summary. Then whatever results actually I'm getting, I'm just returning. That means you will get input IDs, attention mask, as well as the labels. I think I showed you. Okay, from that example. Now let me execute. And now let me map this function on top of my entire data set. Okay, so see here I'm doing the map operation. Now first of all, let me convert to vectorization, then I will show you, okay, how it will look like. So see, execution is done. Now if I show you my data set right now, see it is having different features, ID, dialogue, summary, input IDs, attention mask, and labels. Okay, because I converted to the vector representation right now. Now if you want to see the input IDs, so this is nothing but your input IDs. That means this is the vector representation of the first dialogue. Okay, and if you want to see the attention mask, you can also print the attention mask. So this is the attention mask. That means it is giving all the word as the same attention. I already explained this part. Fine. And if you want to print the label as well, that means the summary, you can also print it. Let me show you. So here I will print the labels. So this is the labels. Okay, that means this is the summary of this dialog. Fine. I hope it is clear. Now we'll start the training, but before that, what I have to do, I have to set some training arguments. I think you remember, right? But before that, one thing you have to do, if you're using a large amount of data, so you have to initiate this data collator. Okay, so what data collator will do? Data collator will help you to load your data as a batches in the memory. See, here you are having so many examples I showed you now in the training, validation, and testing. So I don't need to load the entire data in my memory, because here if you see my memory size, I got actually 12 GB RAM. So if you're having huge amount of data, so 12 GB RAM is not enough. So for this, what you can do, you can load your data as a batches. That means some amount of data will be loading. You will be training again. You'll be taking another batches again. You will be training. That's how you can perform the operation. So this data collator will help you to load your data as a batches. And if you want to define the data collator, you have to use this class from transformer, data collator for sequence to sequence. So here you can see I'm passing my tokenizer and model inside the data collator. Fine. Then you have to initialize this data collator object. So let me initialize it right now. Now the same thing, you have to set the training arguments. So as I already told you, just keep all the arguments as same. No need to change anything. Only you can change the number of epoch. Okay, you will be training. So as of now, I'll be showing you only one epoch training because again, it will take time. We are using free Google Colab. Okay, and the output directory I want to create Pegasus Samsung. Okay, so it will create our output directory Pegasus Samsung. Inside that, it will save all the artifacts. Fine. So let me initialize the argument as well. Then I will initialize my trainer object. So it will take the model, your training argument, tokenizer, data collator, and you have to pass the training data. Now see here, one small hack actually I'm doing. See, if you see the training data size, it's very huge. So as I already showed you here. So that many training example, it is having almost 15,000. So if I'm taking 15,000 data for the training, it will take lots of time. And this is my validation and testing. So what I'm doing actually, instead of taking the training data, I used actually test data as my training data, because inside test data, I'm having very less example. So that I want to show you the quick training. But if you are training actually, okay, if you are doing the actual training, that time you just use train data, okay, not the test data. So this is the hack, guys, small hack I'm doing, because if you want to experiment something and you don't have that much of time, so you can take a small amount of data and you can perform the let's experiment. Okay, so that is what actually you can perform. And here you can see evaluation data. I'm giving my validation data. It's completely fine. Okay, now let me initialize my trainer. Now if you want to start the training, you have to call trainer.train. Now it will start the training of the model. So it will take some time. So I will pause the video, and once training is completed, I'll come back. Okay, so my training is completed. Now here you can see my training losses and different metrics that it is giving, but you have to check the training losses. So this loss should be close to 0, guys. Okay, if it is close to 0, that means your model is performing well. Now if you want to evaluate this model on top of the test data, you have to use this function, calculate metrics on test DS. Okay, so here you will be calculating something called row score. Okay, what is row score? See, row score is a metrics for the summarization model, text summarization model. You can search on Google, you will find the row score actual equation. But as of now, I won't suggest, don't deep dive into the equation. Just try to consider it just a evaluation metrics. Like for the classification, actually what evaluation metrics we used to use, like accuracy score, then we used to use confusion metrics, AOC curve, right? And here we are performing something called text summarization, and text summarization uses one metric called row score if you want to evaluate that model. So similar wise, for language translation, we use another kinds of metrics. For let's say name entity recognition, we use another kinds of metrics. For let's say conversational agents, we use another kinds of metrics. Okay, all kinds of tasks is having their different evaluation metrics. Okay, this is the main idea here. Now before that, let me show you the models actually it has trained. Now inside Pegasus Samsung folder, this is the checkpoints. Inside that you can see this is the model actually it has trained. Now we'll be saving this model as well. So just let me first of all show you the evaluation metrics, then I will say tell you how we can save the model. And now you can ask me where I got this function. See, if you just go to the Huggingface that documentation, go to the text summarization task, you will see that they're suggesting this function. Okay, so they're suggesting if you want to perform the evaluation on top of the let's say your text summarization model, you can use this row score function. Okay, this is the idea. Now here we'll be calculating our row score. So here you are having actually 4 kinds of row, like row 1, row 2, row large, and row L sum. Okay, now let me calculate the row score. First of all, I will be loading all the row matrices. I have to give yes. Then I will be calculating the score on top of my testing data. Okay, now let me execute. And again, I'm only taking 10 example, guys, because it is having actually lots of data and it will take time. That's why I have taken only 10 example. But if you are performing actually, so what you can remove this line. That means you are performing on top of the entire data right now. Fine. This is the small hack you can follow if you're doing the experiment only. Now see guys, this is my row score I got. Now guys, you can see I got the row score, and this row score should be close to 1. Okay, if it is close to 1, that means your model is performing better. So as of now, we used our test data for the training and we only trained one epoch. That's why this row score is not good. Okay, but if you're using actual training data and if you train multiple epochs, you will see that you will get a good row score here. Fine. Now let's save the model, my Pegasus model. So I'm using save pretrain function, and here I'm giving the name, so it will save my model. So now if I refresh, you can see my model has saved. So this is my model, Pegasus model, my trained Pegasus model. Then I also need to save my tokenizer, because later on I will be giving my let's say testing data, and if I want to do the let's say summarization task, that time it will also convert that data to the vector representation. Now see, this is my tokenizer. I also saved. Fine. Now if you want to load any kinds of pretrain tokenizer, what you can do, you can use auto tokenizer from pretrain. Now you can give your tokenizer location. Okay, now see, here I'm giving my tokenizer location, not the tokenizer we downloaded from the Huggingface. Okay, now let me load my tokenizer. So this is my custom tokenizer right now. Now this is the prediction code. Okay, now to perform the prediction, first of all you have to generate some arguments. Now you have to set this a length penalty, then number of beams, then max length. So you don't need to change this parameter, just keep it as it is. Only you can change this length penalty. What is length penalty? I think you remember. So here we had one, let's say, interface, like we can generate short output, we can generate long output. Now if this parameter is close to 1, that means it will generate actually long output. If it is close to let's say 0, it will generate short output. Okay, this is the idea. Now here you can see I'm taking a sample text from my test data. I'm taking actually dialog 1, the first dialog. Okay, you can see from the testing data I'm picking up the first dialog. Let me show you. So if I execute it here, so this is the first dialog I'm taking from my test data, and I'm also taking the reference, that means the actual summary of it, because I want to match this summary with my actual prediction of my model. This is the actual summary, right? Then what I'm doing, I'm creating a pipeline. I think you know what is pipeline in Hugging Face. And here I'm telling I want to perform summarization right now, and I want to use my model, the model I trained. So this is the model I trained. I'm giving the name of the model. You can see, okay, Pegasus Samsung model. And here I am passing my tokenizer. The tokenizer actually I loaded here. Fine. Then I'm creating the pipeline. Now here I'm printing my sample text. That means the text actually we have loaded this first dialog as well as the reference. That means my actual summary. Then I'm predicting my model. You can see I'm passing this sample text to my pipe object. Okay, my pipeline. And here I'm giving all the parameter I set here. Okay. Then whatever output I'm getting, I'm only printing the summary text of it. Now let me show you. If I execute this code, see, this is my actual dialog. This is my actual summary. Now my model is predicting, okay, the prediction summary. Let's wait and let's try to match, okay, how much accurate it is. Now see guys, I got the prediction. Now just try to see. Now you can see this is the model summary. That means my model has given me the summary. Now see, it's not very accurate, but still it is close to, because again I told you we only trained one epoch and we used our testing data for the training. Okay, that is why it is actually not, it is not giving actually good performance. Okay, and if you want to increase the performance, what you can do, you can increase the epoch size and you can test, and you have to train on top of the training data. Okay, not on top of the test data. Okay, this is the small modification you can apply. So I hope guys it makes sense right now how we can actually implement different projects with the help of Hugging Face platform now. Okay, that means I showed you how we can use different model, whether it can be LM model, whether it can be LLM model, how we can use different data sets. Okay, and how we can use the Hugging Face pipeline, okay, to create your application. So this was my main objective, the proper use of Hugging Face. Okay, because going forward we'll be utilizing this particular, let's say, technique only to perform all of the, let's say, project. Okay, whatever project we'll be doing, we'll be following this particular approach only. And going forward, I will be also showing you how we can use large language models. So see, now we are using LM model only. Okay, language model only. But going forward, we'll be using large language model. That means we'll be using Llama model. Okay, we'll be using Llama model from Meta. We'll be using, let's say, Mistral model. Okay, we'll be using Falcon model. Different like large language model will be exploring. Okay, so I hope guys this is clear now how we can perform this text summarization project. Now one task I want to give you, see, I already told you now we are having different data sets in the Huggingface. So you can select based on the task. Let's say if I go to the task, let's say I want to perform summarization. I'll click the summarization. Now see, these are the data related summarization. Now what you can do, you can pick up any kinds of data set from here. Okay, and you can perform that text summarization on top of the data. See, here I used Samsung data, but I want you to use some any other data. Okay, so please try to attempt this task, because unless and until you are not doing like a practical from your side, it would be a little bit difficult for you. So if you want to actually generate image from the text, so you have to use something called diffusion model. Okay, diffusion model. And what is diffusion model? Diffusion model is kinds of actually large language model. It is available in the Huggingface. Okay, and if you want to use diffusion model, you have to use one library called diffuser. Okay, diffuser. So this diffuser will help you to actually load these kinds of diffusion model, and you can perform these kinds of text to image generation. So again, it is available inside Huggingface only. So you don't need to go to the any other platform. Okay. So additionally, we just need to install another library called diffuser, and with the help of that, we can easily access that diffusion model. As of now, I don't need the Gradio here. I can remove it. So these are the library actually I have to install here. So as you can see, diffusers is the Huggingface page for using the diffusion model from the Huggingface hub. So here you can see, let me show you the page. Actually, I have already given the link. So see, this diffusers is available inside Huggingface only. So they have already written like how we can install it, okay, and how we can load the diffusion model and all. Every example they have already given here. Fine. So I have followed this documentation, guys, and I prepared one notebook for you. And let me show you how we can perform this text to image generation with the help of different large language model. And here the model actually will be using, guys, this is actually multi-model. That means this model uses both kinds of architecture, your NLP architecture as well as the computer vision architecture, because here you have to give the prompt. That means text is nothing but your prompt, okay, and it will generate the image. That means first of all it will process the text, then it will process that particular image, okay, image output. So that's why it is using something called hybrid architecture. Okay, so it is called actually multi-model. I hope you clear. Now let me install all required packages I need here. Now let me import this stable diffusion pipeline for diffusers. The same way actually we used to load our pipeline. I think you remember from the transformer. So here also we have to load the pipeline for the diffusers. Okay. Now I also need the matplotlib because I want to visualize the image. Then I also need the torch library. Now if you want to see the version of any package, you can execute this command pip show the package name. It will show you the version. Okay. Now here I kept actually two kinds of diffusion model. This is the model ID 1 and this is the model ID 2. You can see the first model. This is the first model. So the model name is Dreamlike Diffusion 1.0. So this is the model, guys, and it is available in the Huggingface hub. Okay. See, whatever models actually you can see in the model section, this is called actually Huggingface hub. That means in the hub also you can upload your own model. It is possible. Let's say if I click on the model now. So inside this model, you can upload your own model. Let's say you fine-tuned one model and you want to share with the community. You can also push your model here. Okay, so that other people can download your model and they can use it. Okay, I'll also tell you how you can push your model to the Huggingface hub. Everything I'll try to show you. Even you can also upload your own data set. Okay, it is also possible here. Now this is the model, guys. You can read about the model and this is the a few results actually. You can see they have given different prompts and these are the results they have generated. Okay. This is one of the amazing model. Even they have also given the code snippet, how we can use it and all, everything they have given. Now another model actually, this one, the model name is Stable Diffusions Excel Base 1.0. This is the model. So this is the model architecture, high level architecture. That means first of all, you have to give the prompt, and with the help of actually transformer model, what they will do, they will just try to understand this prompt and they'll try to perform the tokenization, convert to the vector representation. Okay, that means converting to the embedding. Then they'll be creating one latent dimension 120x cross 120x, and this latent dimension will pass to the unit model. If you don't know, inside stable diffusion actually unit model is used. So unit model will try to generate the image, okay, with respect to the prompt user has given. Okay, you can see last I'm getting the image output. Again, they have already given the paper link and all. If you're interested, you can open it up and you can learn. Okay, see, they have also given the code example. Now let me show you how we can use this model. So what I've done, guys, I'm loading the first model. You can see stable diffusion pipeline from Pretrain. I'm loading the first model, and here you have to give some parameter. Okay, that means torch data type torch.float 64 and use safe tensor is equal to 2. Okay, you have to pass this to parameter. Now I'm loading this model inside my CUDA. That means inside my GPU. Because if you load inside your CPU, it will take lots of time, right? So that's why I'm loading everything inside my GPU. Now let me show you. See, it is downloading the model. Now here I have prepared one prompt, guys. You can see this prompt. Dreamlike art, a grungy woman with rainbow hair, traveling between dimensions, dynamic poses, happy soft eyes and narrow chin. Extreme bouquet, a tiny figure, long hair straight down and tone, quali, shirt and baggy jeans. Okay, so this is my prompt actually I have prepared. Now you can give any kinds of prompt. If you feel like, okay, you have to use this prompt, you can give it here. Now this prompt actually I have to give my pipeline object. That means inside my model, and model will give me the image matrix. Okay, so let me show you. So it is generating this image right now. I think currently in the ChatGPT also, it is having one model called GPT 4.0. Okay, so this model also can generate actually different image. So see, create an image for my presentation. Now if I click here, now see it is utilizing something called GPT 4.0. See, if I click here, see GPT 4.0 they are using. Now it is asking, just try to give any kinds of prompt. Let's say if I give same prompt here, let's see what happens. See, it is generating the image right now. So they're also using this kinds of diffusion model in the backend, multi-model. That means they are understanding the prompt, then they're generating the image. Okay. See, okay, this is the output I got. Now let's see from my model actually, the model actually I'm referring from the Huggingface. See, if I plot this image right now, you can see this is the results I got. Now see the ChatGPT and see my results. Both are pretty good. Now you can also plot with the help of matplotlib. It is also possible. First of all, I'm printing the prompt, then I'm printing the image. Okay. Now let me give another prompt. A girl is sitting on a chair and she is accompanied by her tiger. Make sure to keep it cinematic and color to be golden IDs. Okay. Now let me see the output. The same prompt you can give to the ChatGPT as well. Let's see. So here I think I got the results. Now let me plot the image. See, this is the image I got, and see, this is the image I got from my ChatGPT. So both are good, guys. Now I think you got it, how we can use this kinds of actually multi-model as well. Okay, if I want to, let's say, generate text to image or image to text, okay, everything is possible. Now if I show you, so if you just go to the Huggingface model section, here, if you click on the model, now see, here you are having different tasks. Let's say you want to perform text to image generation. So here is the task, guys. Inside computer vision, you can select it. Now see, you are having different model. So here I was using diffusion model. You can also use any other model. Okay, see, that many of models are available, around 34,000 model. You can use any of the model. Okay, any of the model, and you can try. So this should be your task, guys. I will leave it to you. You can explore any kinds of model from the hub itself. Okay, only select this task, text to image. Okay, now let's see if you want to perform image to text, that time select this one, and you can see the different model. Even if you want to see the example, open it up. They have also given the lots of example here. Okay, code snippet, everything they have given, you can learn from here. So this is the best platform, guys, if you want to deep dive inside Huggingface. Fine. Now we'll be learning some parameters of the diffusion model. Like you can set some of the parameter. Okay, let's say you want actually different dimensional image, you want to, let's say, add some more parameter in that image, you can also do it. For this I created a function generate image, so it will take the pipeline object prompt as well as the parameter, and whatever things actually you will be assigning the parameter, it will set inside pipeline and it will render the image with the help of matplotlib. So let me execute. See, that many of actually parameter you can play with, negative prompting, and now num inference step, height, weight, okay, number of image per prompt. Okay, now let's say this is another prompt I have prepared. As of now, parameter I'm not giving anything, it's empty. Now if I pass these are the thing inside my generate function, so it will give me the image. So this is the prompt. Dreamlike beautiful girl playing the festival of color, wrapped in traditional Indian attire, throwing colors. Okay, this is my prompt. Now you can see based on the prompt it has given me one beautiful image. Okay, see, beautiful image it has generated. Now I can give any kinds of prompt. Let's say number of inference step I have given 100. Now let's see what kinds of input I get. You can see the documentation of the this one diffusers. You will see different actually parameter you're having there. See, this is another example. Now you can see both images are same. I can't see any difference. Now let's see with any other actually parameter. Let's say height. I want to change actually different height and weight. So for this you can pass this height and weight parameter here. Now let me see. So now you can see guys, I got the results and in a different height and width right now. So that's how you can play with different parameter. Now let's see another parameter, number per image prompt. That means if I want to, let's say, generate multiple images, that time I can give image number of images per prompt 2. That means it will give me 2 images right now. So here is the results. Now I'm getting 2 output from my image. Now let's say you want to get 3, you can give 3 here. Now let's also see the negative prompting. So here I have added negative prompt, ugly, destroyed, and low quality. Let's say this is my negative prompt. Now let's see whether it is able to generate or not. So right now you can see these results and these results. I think you can see the difference. This is a little bit low quality, and the prompt I have given ugly, destroyed, and low quality. So it is almost matching, I think. Fine. So yes, that's how we can use this kinds of multi-model, and I can do the text to image generation. Fine. Now I already showed you we are having so many model, guys. Just try to explore from your end some of the model and try to implement any kinds of projects. Fine. So guys, so far what we have learned, so we saw how we can use the existing model from the Huggingface. That means, let's say if you want to use any pre-train model, you can directly use it. So you have to use something called pipeline. Okay, pipeline. For this, inside pipeline you have to mention the task you want to perform. Okay, let's say you want to perform sentiment analysis, you want to perform, let's say, translation, you want to perform, let's say, summarization, you can mention. Or else what you can do, you can also do the fine-tuning operation. Okay, fine-tuning of a pre-trained model. Okay, and I already showed you one fine-tuning example, like I did the text summarization. Okay, text summarization. So there I trained on top of my custom data. Now you can ask me when we have to use pre-trained model and when we have to do the fine-tuning operation. So let's say whenever you are having a problem statement, let's say you want to do text summarization only. Okay, text summarization only. First of all, try to use the existing model. That means the pre-trained model. Okay, pre-trained model. Let's say I showed you one model, Google Pegasus, that CNN Daily Mail model. Try to use that model and try to see whether your model is able to give the correct, let's say, summary or not. Correct summary or not. If it is able to give the correct summary, then why you need to do the fine-tuning? Definitely not. You can use this model as it is, right? But let's say if your data is a little bit different, let's say you are using something called, let's say, banking data. Okay, banking data, banking related, let's say, conversation you are having. And this conversation is not working with that pre-trained model. That time what you can do, you can collect your own data. That means your custom data. Okay, custom data. And based on that, you can fine-tune one. Okay, fine-tune one pre-trained model. That means you are using one pre-trained model. On top of that, you are adding some more knowledge. Then this model will be able to also work with the banking data as well. This is the idea only. Okay, now I think you got it, when you have to use the pre-trained model and when you have to do the fine-tuning operation. It can be for all kinds of, let's say, model. It can be for the multi-model. It can be for the let's say, LLM model. It can be for the LM model. Any kinds of model actually it can be applied. Okay, so the model I showed you right now, this diffusion model, this text image generation model. Let's say if it is not able to generate the image the way actually you are giving the prompt, that time what you can do, you can fine-tune this model. It is also possible you can also fine-tune the diffusion model. And how to fine-tune? Again, they have given all the, let's say, article here, fine tuning, everything they have given. If you just go to their documentation, you will easily learn. Even I will also show you in future, okay, how we can do the fine tuning of the large language model. For this, we'll be using another technique called PEFT. Okay, that means parameter efficient fine tuning. What is PEFT? I will tell you. Parameter efficient fine tuning, because what happens, these kinds of large language model is very huge, and I can't train this kinds of model actually on my this kinds of machine, the Google Colab actually I'm taking, because it's a huge model, huge parameter. For this, we have to follow this parameter efficient fine tuning process. Okay, that time I'll discuss what is the use of that and how we can fine tune those example and all. Okay, everything I'll try to clarify. As of now, I'm only the exploring like the service actually it is having, so that you can get familiar with, okay, that are the things actually we can perform with this particular platform. Like how we can do text to speech generation with the LLM, okay, with the help of this Huggingface platform. So again, I have to install this transformer library, because inside that only I'm having all the, let's say, if I search for Huggingface, so if I go to the model section, so now let's say we'll be working with the audios, that means text to speech. Now if I click on text to speech, see, it is having actually different model. Okay, different model actually it is having, but the model actually I'm going to use this model called Suno Bark small model. So this is one of the transformer based text to audio model created by Suno. Okay, now if you want to read about this, you can go ahead and try to read about this particular model. Even they were also given the example, even though they have also given the Colab notebook, how we can use it. See, this is the Colab notebook they have given. But so many things they have written. So what I have done, I just simplified this notebook, and this notebook I created. Okay, now let me show you how we can perform the text to speech generation. Now for this, first of all, I have to import that pipeline from the transformer, and here is the text, guys. So this text actually I'll be converting to the audio. Now see, Python is a high level general purpose programming language. This is my text. Now in the pipeline, I want to perform text to speech. I have to give, and I have to give the model. So here I'm giving my model ID. This is my model ID, Bark small model. Then device is equal to CUDA, because I want to load my model inside my GPU. Now it will give you the output, and output would be a NumPy array. So let me show you. If I just execute this program, see, now if I print the output would be a NumPy array. Okay, now I have to convert this NumPy array to audio, that is audio frequency. For this, I'll be using one library, IPython display audio. This library will be using, and I have to give this array as well as the sampling rate. Okay, so here you can see I'm passing my audio, that means this array, as well as the sampling rate. Now if I execute, it will automatically convert this array to the audio. Now see, if I play,
Python is a high-level general purpose programming language.
See, I think you heard of, okay, it is speaking that particular text. Now you can give any kinds of text, it will generate the speech for that. Fine. Now you can play with different model, guys. I already showed you it is having different model. You can try with different model. Okay. See, I was using this model, Bark small model. You can also use any other model. Okay, it's up to you. So that's how, guys, you can explore this Huggingface. It's an amazing platform, and it's like very powerful platform, guys, in the field of generative AI or in the field of natural language processing. If you don't know about OpenAI, OpenAI is a platform for the generative AI. So with the help of OpenAI, you can implement any kinds of generative AI application. OpenAI provides lots of commercial large language model like GPT series. I think you already used Huggingface, right? So this is the similar kinds of platform of the Huggingface. So Huggingface provides all the model, all the dataset as free, but OpenAI provides actually everything as a paid. That means you have to take their subscription. So if you're taking their subscription, that time actually you can use their premium model. Apart from that, OpenAI provides some of the model for the free access, so that at least you can do some experiment, okay, with this model. But if you want to build, let's say, production grade application, that time they are suggesting to take their premium model. So guys, through couple of video, we'll be learning about this OpenAI and its platform. So here we'll be learning all the services from the OpenAI, how we can use the entire OpenAI platform. So everything I'll show you here, how we can generate a OpenAI API key, how we can access like different model, okay, and how we can implement different applications. So let's open our OpenAI platform. So guys, if you want to open this OpenAI platform, just search for OpenAI login. So you'll get the first website, OpenAI platform. So make sure you have one account. If you don't have account, you have to first of all create one account. And whenever you are creating an account, it will ask for your card. So try to add your card. So you will get initially actually $5 credit here. Okay. I think $5 credit you will get. Then once you use that $5 credits, then what you have to do, you have to pay for the services. Okay. Whatever services you will be using, whatever model you will be accessing. So based on that, you have to pay. Now you can ask me how much, let's say, money it will take. Okay, I'll tell you how much money actually it will charge. It will charge based on the token size. As of now, just try to see the overview of this OpenAI. Then I'll tell you each and everything. So here you can see, guys, after login, I'm getting two windows. One is like ChatGPT and this is like API. See, ChatGPT is also product of OpenAI. I think you already know, right? So this is my ChatGPT and this is the product of OpenAI. That means it is using GPT model. You can see if I click here, it is using GPT model. Okay, GPT model. So GPT has like different model variant, like GPT-3 is there, 3.5 is there, 4 is there. Even recently one model has published GPT-4o, and this is another like powerful model they have published. Apart from that, it is also having some multi-model, like it can generate text to image, like DALL-E model is also there, right? Then it can also, let's say, generate like text from a audio. That means a Whishper model they are using. So it is having actually different model. I'll tell you what are the model it is available. So first of all, click on the API part. So now see, this is the API interface, but as of now, I'll go to the playground. See, this is the playground. That means if you're opening this OpenAI for the first time, so what you can do, you can test different model here, you can see. But again, I'm telling you guys, you have to first of all create your account and make sure this $5 is let's say credited in your, let's say, account. Okay, otherwise you won't be able to use this playground. Okay, that means you won't be able to access these are the model. So make sure your account is active. Okay, then after that you will be using. So whatever, let's say, chat operation usually perform with the ChatGPT, the same thing you can perform here. Okay, so here you can select different model, you can see. So by default it is GPT 3.5 turbo. You can also take GPT 4o mini, GPT 3.5 turbo 16K. Okay, that's how different model it is available. Okay, so here you can give the prompt and here you can pass the system instruction. So I'll tell you about that, what is system instruction. So whenever, let's say, we are using GPT model, we are having two kinds of, let's say, API. The ChatCompletion API, another is like the completion API. Okay, so both has the difference, I'll tell you. Now here you can also perform the assistant related task. Let's say if you want to create your own assistant, okay, you can also use this service. You can also do the text to speech generation, okay, with the help of this OpenAI. You can also perform the completion operation, that means sentence completion operation. So you can write one sentence, it will complete the entire sentence, or let's say entire story. Okay, so all kinds of model it is available. Even it is also having DALL-E model. Apart from that, actually they are also having something called DALL-E model. DALL-E is a text to image generation model. If you are giving any kinds of prompt, it will generate image for you. Nowadays in the ChatGPT also they integrated this functionality. Let me show you. So this is what I will select, create an image. Now it is asking for a prompt. Okay, it is asking from a prompt. So let's give a prompt. A dog is flying on the sky. Let's see, this is my prompt. Let's see. Now see, it is generating the image. So guys, as you can see, this is the result I got. That means here I pass the text prompt and it is generating the image. Okay, so like that, they also have one model called DALL-E, DALL-E 2. Let me show you. So DALL-E 2. So this is one of the model. I think recently they have also published DALL-E 3. Okay, DALL-E 3 is also there. So this is actually text to image generation model. You can give different prompt. Based on that, actually it will generate an image, right? So guys, you can open this playground and you can test different model, okay, as per your requirement. Now let's go to the dashboard. So let's say you want to create like generative AI application without writing code. So what you can do, you can use their UI interface. So from here, actually you can create different assistant system and all. If you want to fine tune, these are the model, that means GPT model, you can also fine tune from this these services. It is also possible. Then it is also having batches, storage. Storage means it provides one vector database services. So you can also use the vector database services to store your vector representation. And no need to worry. I will also discuss about this vector database, why it is required, and why we'll be using vector database with our large language model. And if you click on the uses, you will see like your uses limit. That means, let's say if you are having $5 credit, so how much you have used here. So everything it will show you here. Now you can also generate the API key. I'll tell you how to generate the API key. So with the help of this API key, actually you will be interacting with our OpenAI platform. Okay, otherwise you can't use those are the model, okay, without this API. See, all the model actually they have hosted in their server, so you don't need to download this model in your system. Everything will be accessing through the API. Okay, this is the best part here. Now this is the documentation, guys. You can see related all the tasks they created the documentation. Let's say if you want to perform any kinds of task, if you want to see the models, like what the model it is having. See, these are the models actually it is having. So GPT-4o, GPT-4o mini, GPT-3.5 turbo, DALL-E. I already told you about DALL-E. TTS, that means text to speech. Whishper. So you can see Whishper is a model. It's general purpose speech recognition model. It is trained on large dataset of diverse audio and is also multitask model that can perform multilingual speech recognition. That means it's a speech model actually. Even it can also work with different languages. Okay. Even it is also having embedding model. With the help of embedding model, we can generate vectors. And why we have to generate the vectors, I think I already told you now in the text preprocessing and text representation session. So first of all, what we have to do, we have to let's say convert our text to embedding representation for our model. Let's say you want to fine tune. Okay, you want to fine tune this OpenAI model. That time what you have to do, you have to use this embeddings, okay, to fine tune. Let's say you want to create any kinds of generative AI application. Definitely you have to first of all generate the embeddings, okay, of that particular text, whatever documents you are having. So that's why embedding models are required. We'll also learning how we can use this embedding model whenever we'll be doing the projects. That time actually we'll be learning. Now it is having also some GPT based model, you can see. So these are the GPT based model. Okay, this is called actually completion model. We can use completion API only, okay, to use this model. I'll tell you how to use them and all. See, everything they have given, okay, everything they have given. Let's say if you want to do the fine tuning, so there is a fine tuning guide they have also given. Okay, so all the information they have given in the documentation, and this is the one of the best resources to learn this OpenAI. If you want to, let's say, learn anything, just go to the documentation. They have the proper explanation with the code sample as well. Okay, great. Now this is the API reference. Now if I click on the API reference, you can see this is the API reference. That means, let's say if I want to use their let's say model and all, how to call call with the help of API, even how to call with the help of Python code. Okay, everything they have given as an example. You can see different example they have given. But you can see there are so many things they have written, but I don't need all the, let's say, concept here. So whatever actually, let's say, concept you need to master this OpenAI. So I will show you each and everything. That means we'll be learning about ChatCompletion API, completion API, and we'll be learning another super important concept, which is nothing but function calling. Okay, OpenAI function calling. So these are the things we have to learn here. So yes, guys, this is the overview and this is the introduction of the OpenAI. I hope you cleared. Now in the next video, we'll be generating one OpenAI API key. Okay. Then after that, actually, we'll be doing some hands-on on this OpenAI. That means we'll be accessing different model with the help of API key. So to generate the OpenAI API key, so first of all, just click on the dashboard. And here left-hand side, you will see one option called API key. Just click here. And now see, I already created one API key previously. That's why it's showing. But for you, it would be completely empty. Now, if you want to create a new API key, just click on create a new secret API key. Now give the name. Let's say I want to give, let's say, test1 or anything you can give. It's up to you. Now, what you can do, you can give the permission, only read only permission, or whether it's restricted. Okay, you can give different permission, but I want to give permission for everything. Let's say I want to read, I want to write, everything I want to do. That's why I will be selecting all. Now I will just simply create the secret key. Now see, this is the secret key, guys. Just try to copy and try to save it somewhere, and don't share the secret key with anyone. Otherwise they will able to access your account. Okay, I'll remove it after the recording. That's why I'm showing you now. Just click on done. Now see, your API has created. That's actually you can create different API key, and with the help of one API key, you can also create multiple projects. So there is no issue with that. So guys, I think you remember I was talking about this playground, and I told you with the help of playground, you can do different tasks, and you can use different model. Okay. Now see, this model is having some of the parameter. Okay, so these are the parameter it is having. So going forward, whenever we'll be accessing these are the model through Python code, we'll be also using these are the parameter, right? So the first parameter you can see called temperature. So what is temperature parameter? See, temperature is a parameter. If you decrease the temperature parameter close to 0, that means you are telling your model, just try to be stick, okay, with the, let's say, prompt, whatever prompt user is giving. No need to take any kinds of risk, and don't generate any kinds of random output. If you are not sure, try to give, I'm not sure, I'm not able to generate, but don't give any kinds of random output. That means you are giving the restriction to the model. Okay, it will only work with a true, okay, true generation. Okay, true data generation. Okay, this is what actually temperature parameter do. That means you can decrease close to 0. That means if you want to get a more stick output, that time you can give close to 0. And if it is close to 1, that means you are telling your model, try to take risk. Okay, whatever response you are generating, it doesn't matter, but try to be more creative here. Okay, this is the idea here. There is another parameter called maximum token. Maximum token means like you are setting the maximum tokens. Let's say whenever you are giving any kinds of prompt to the model, and model is giving any let's say model is giving output, right? And it is also a token. Okay, it is also a token, and you can set the token limit, like how many tokens you want to get as an output. So that time actually you can set this maximum token. Let's say maximum token is 256. It will give you 256 token output. Okay, I'll discuss about these tokens. So there is a token counter inside this OpenAI. With the help of, you can also count the token. Then there is another one called top P. Top P is nothing but like how many, let's say, output you want to generate from the model, how many response you want to generate from the model. Let's say top P is equal to 1, your model will give you only 1 response. Let's say top P is equal to 2, your model will give you 2 response. Okay, and from the 2 response you can select which one is the best. Okay, that's how we can play with these at the parameter. So if you want to learn more about it, you can simply hover. So they will give you the description of this parameter and all. So these are the parameter actually we'll be using frequently. That's why I already told you here. So guys, yes, this is all from this video. So in the next video, we'll be doing the environment setup. Like we'll be doing our local environment setup, like what are the tools and let's say services you need for this generative AI project implementation. We'll be doing all the setup. Then after that, we'll be performing the hands-on, okay, of this OpenAI platform. Let's say sometimes actually we'll be using cloud services, sometimes actually we'll be using local setup. Okay, so that's why for the local setup, what are the tools and technology we need, everything will be making the setup in this video. So the first tools actually you need, which is nothing but Anaconda. Okay, Anaconda distribution. So this will give you actually Python interpreter. So inside that actually we'll be creating the environment, we'll be setting the package, okay, and we'll be implementing our generative AI application. So if you have already Anaconda in your system, it's completely fine. But if you don't have, what you can do, you can simply click on free download and you can download this particular Anaconda in your system. So I already installed Anaconda. So let me show you. So this is my Anaconda, guys. So if you have installed successfully, you will see these kinds of window like Anaconda prompt, Anaconda navigator. If you're getting this kinds of window, that means your installation is completed. And the installation process is very simple. Only just click on next and install the tool, okay, in your system. Now the next thing you need, which is nothing but Visual Code Studio. Why we need the Visual Code Studio? Because see, we'll be writing the code, okay, and to write the code I need a code editor, right? That means IDE, integrated development environment. So either you can use PyCharm, either you can use Visual Code Studio, but personally I prefer Visual Code Studio. That's why I'll be using Visual Code Studio in this particular course. Fine. So again, you can install with respect to your requirement, whatever operating system you're using, you can install this Visual Code Studio in your system. Now the next thing we need, the Git. Okay, Git is nothing but it's a, let's say, client for the GitHub. I think you know, if you have already familiar with GitHub. So if you want to, let's say, commit any kinds of code in the GitHub, what you need this Git client. Okay, and if you install the Git, actually will get one a bash terminal, which is called actually Git bash. Okay, so sometimes actually we need this Git bash because with the help of Git bash actually we'll be executing different Linux command. Because going forward we'll be implementing generative AI end-to-end projects, so there I need this Git bash to execute some of the Linux related command. Okay, so that's why make sure you have this Git bash installed in your system. Fine. And again, you can install from here. Just click on this button and it will download it. Then you can do the next and you can install this Git bash in your system. So as of now, these 3 tools actually I need for your local setup. And once this setup is ready, guys, then I think we can start our implementation. So in the next video, I'll show you the hands-on on this OpenAI. That means we'll be accessing different models. We'll be exploring chat, like completion API will be exploring, or completion API will be exploring function calling of the OpenAI. Okay, everything will be exploring one by one. So as I already told you, OpenAI having 2 kinds of API. That means if you want to use OpenAI model, it is having 2 kinds of model. One is like chat completion model. One is like completion model. So we'll be exploring both of them. So here you can see we are having different models. So these are the model actually related chat completion model. You can see these are the chat completion model. And apart from that, it is also having completion model. So if you go to the base model section, so I think there is an option called base model. Let me find. So here is the base model, guys, GPT base model. And this model is nothing but it's a completion model. Okay, it's a completion API. Now, what is the difference between chat completion model and completion model? I'll tell you. So before that, what I will do, I'll just open up my Visual Code Studio, and there I will do the OpenAI, let's say, package setup, and we'll set our API key and we'll start our implementation. So what I can do, I can open up my local folder, and inside that you can create a folder. Let's say I will create OpenAI. Okay, OpenAI demo. Inside that, I'm going to open up my Visual Code Studio. So this is my Visual Code Studio, guys. Let me zoom. Then I will also open up my terminal. You can also open up your terminal, Git bash. Okay, whatever you are using, you can open it here. See, I have opened up my Git bash. You can also open up your Anaconda prompt, whatever actually you are using, whatever terminal you are using, you can open it here. Okay, so I have integrated my Anaconda with my Git bash. That's why you can see base has been activated. Okay, you can also integrate Anaconda with your, let's say, Git bash. For this, you can simply search on Google. You will see the process. Okay, how we can set your Anaconda with your Git bash. Otherwise, you can also use your Anaconda directly. Okay, it will also work. Okay, anything you can use. I'm using my Git bash here. Fine. Now here the first thing will be setting our OpenAI package. See, if you want to use OpenAI, so you have to install one package actually. So if you go to their documentation, let me show you. So this is the OpenAI. So if you go to the quick start section, so first thing what you have to do, you have to export your OpenAI API key. That means you have to first of all collect your OpenAI API key and you have to add it there. Okay, so we have already collected our OpenAI API key, I think you remember. Then second thing what you have to do, you have to install one package called OpenAI. Okay, with the help of OpenAI package, you can access all the model. That means you can access all the, let's say, ChatCompletion API, completion API, everything you can access here. Okay, now see, you can access different model. Okay, you only need to give the model name and you can access the model. Fine. So let me first of all install this package. So I'll go to my VS Code and here I'll create a file called requirement. Okay, requirements.txt. So the first package actually I'm going to install called OpenAI. So here I'll be installing one specific version of the OpenAI, that's 0.28. Why 0.28? Because this is the stable version. So see, OpenAI has different version. Even currently they have updated their package. So in the updated package, what happens actually, so sometimes actually we'll get the error. So that's why I'm using one specific version. You can also install the latest version, it will also work fine. Now the next package actually I need pandas. Why pandas? Because I want to list down all the, let's say, OpenAI model through my code and I want to show as a data frame. That's why I need this pandas library. Then another library I need called python.env. Why .env? Because I need to manage that secret key. Okay, secret API key, whatever API key you have collected from our OpenAI, right? .env. So with the python.env package, you can easily manage this API. That means we'll be creating a .env folder. Okay, inside that we'll be writing that OpenAI API key. Okay, this is the idea. So here let me paste my OpenAI API key, guys. So this is my OpenAI API key, guys. I have already pasted, and here you have to give this particular key name, and here you have to give this key name OpenAI API key equal to, you have to pass your API key here, whatever API key you have created. Okay, I think you remember, in the double quotation. Now let me save. Fine. Now let's me install this requirement. So guys, before installing, these are the package. First of all, you have to create a virtual environment here. So to create the virtual environment, you can execute this command conda create -n. Give the name of the environment. Let's say I will give OpenAI. Okay, OpenAI demo. This is my environment name. And I have to specify my Python. So here I'll be using Python 3.10 and -y. And why 3.10? Because again 3.10 is the stable version of the Python. Okay, that's why we're using, because it supports all the library. Okay, and -y means I want to create, I am giving the yes permission. Now see, if I execute the command, it will create the 3.10 environment inside my Anaconda. Then after that we'll be activating, then we'll be installing all the requirements there. This is the idea. So guys, as you can see, my environment is created. Now I have to activate it. So to activate, this is the command conda activate OpenAI demo. Okay, it should be activate, sorry. Now see, my environment is activated. Now I'll be installing this package. So I'll just write pip install -r requirement.txt. So it will install all the packets one by one here. So as you can see, my installation is completed. Now let me clear my terminal. Now here, first of all, what I will do, I'll create a Jupyter notebook file. I'll just click on new file and I'll create a file. Let's say OpenAI demo 1.ipynb. Okay, ipynb file is a Jupyter notebook file, and here you need to select the kernel. I'll select my Python environment. So the environment I created called OpenAI demo. So let me refresh. See, OpenAI demo is there. I'll select it. Now if you want to test it, just give the any kinds of, let's say, code here. Let's say print hello, it should execute. Now see guys, it needs this IPy kernel package to run this Jupyter notebook. So let me install. I'll click on install. So it will install all the necessary things. It needs to run this Jupyter notebook. After that, you will see that this code would be executed here. So let's wait. So as you can see, all the necessary package has installed, and now I'm able to execute my code in my Jupyter notebook. Fine. All right. Now we'll be importing some of the library here. So let me import operating system. Then I need my OpenAI. Then I also need .env. So to import the .env, you have to import like that from dot env import load env. Okay, load dot env. Now see, if I execute, it will import all the library. Now if you want to check any version of any package, simply you can write this command. So pip show, let's say I want to see the OpenAI version, I'll give OpenAI here. Now see, it will show you the summary of the OpenAI name, version, summary, okay, homepage, author, everything it will give you. Okay, now the first thing what I have to do, I have to set my OpenAI API key. If you check the documentation, I showed you in the documentation, this one, this documentation. If you check the documentation, so the first thing what you have to do, you have to set the OpenAI API key. Okay, and if you're using Python program, so that time you can set the OpenAI API key like that. So just call your OpenAI package, and inside OpenAI package we have one attribute called OpenAI API key. Okay, API key. So equal to first of all, what I have to do, I have to load my API key. So to load the API key, and to load this API key from the .env folder, what you have to do, you have to take the help from load env package we have imported, right? So just try to write load.env. Okay, now after that, just write this one, os dot get env. Okay, get env. Inside that you have to pass the key name. So key name is nothing but this is my key name, OpenAI API key. I'll pass it here. Okay, and it will give you OpenAI API key. I'll store it here. Now see, if I simply print it, now see, it should load the API key. Now see, it is loading my entire API key. Fine. Now let me comment it as of now. I don't need to show. Now this OpenAI API key, I'll pass it here. Now see, if I execute this code, so it has set my OpenAI API key, okay, inside my environment. Okay, you don't need to do anything. That means OpenAI will automatically load this API key right now from the package itself. Okay, now as I already told you, OpenAI is having different model. So if I click on the model section, you'll see different models is there. So if you want to list down all the models, so what you can do, you can use this code snippet. So OpenAI dot model dot list. Okay, it will give you the entire list of all the model. Now see, if I execute, now see, it is giving me all the list of the model it is having, but I want to only see the data. Okay, so here I'll filter out the data. Now see, these are the model. Now if I want to show as a data frame, what I can do, I can use pd.dataframe. I have to import pandas first of all. So import pandas as pd. Now pd.dataframe. And inside that I'll pass this data, whatever I'm getting. Fine. Now see, if I execute, it will give me as a data frame. Now see, all the model ID, object, created date, as well as the owned by. Okay, see, everything it is showing. Now see, you can see different model. Now, as I already told you, there are two kinds of API you will get. One is like ChatCompletion API, and there is like completion API. So here you can see we are having different model. So if I want to use, these are the model. First of all, we have to know what are the models actually. My ChatCompletion model, and what are the models actually only completion model. That means when I have to use the ChatCompletion API, when I have to use the completion API. So for this, you can simply go to the model section. Now let's say you want to use this GPT 3.5 Turbo. If I click here, now see, this model is a ChatCompletion API model. Okay, if you want to use this model, you have to use the ChatCompletion API. And if I go to the base model section, so this is a completion API. That means you have to use completion API for this model. Okay, now let me show you some example of ChatCompletion and completion API. So first of all, let's try to see the completion API demo. Okay, let's say I want to use this GPT 3.5 Turbo model. GPT 3.5 Turbo model. See, so again, if I go to the documentation, so here is the model, guys, GPT 3.5 Turbo. I have to use ChatCompletion API. And how to use ChatCompletion API? If you click here, that means you have to use chat.completion, okay, .create this particular code snippet. So let me show you. You can also write like that. So here, I'll just call OpenAI dot chat completion. There is directly one function you will get called chat completion. Then you can call this create, okay, create one. And inside that, first of all, you have to give the model name. Let's say model is equal to, I want to use which model? GPT 3.5 Turbo. So this is the model. So you have to give the name like that. Fine. Okay. Now the second parameter, you have to pass the masses. Okay, and message should be a list here. Now see how to write the message. So they have already given the example. That means the first thing what you have to give the role. So role you are giving system. Okay, system, you are a helpful assistant. That means you are giving a system prompt here. I think you know, like large language model is all about prompt. Okay, you have to give the prompt here. Then you are giving the user prompt. That means whatever user want to ask, so user will give it here. So let me show you how we can pass this prompt. So the first thing what I have to do, guys, I already written. So the first thing you have to give the role as a system. That means you are, so here the first role you have to give as a system. That means you are giving the system prompt. And what is the content of the system prompt? You are a helpful assistant. You can give any kinds of prompt here. Let's say you are a helpful assistant, you are a helpful translator, you are a helpful, let's say, chatbot, anything you can give the prompt here. So going forward, we'll be also learning about prompt engineering. There actually I'll try to clarify what are the prompts actually you are having. Okay, different prompt you can set here. Now the second role you are giving as a user. That means whatever user will ask. Okay, whatever user will ask. So if you open the ChatGPT also, in the ChatGPT backend, they have given the system prompt as well as the user prompt. That means as a user, we give our prompt in the ChatGPT, but in the backend, they have given the system prompt. Okay, in the ChatGPT, that is the idea. Fine. Now let's give one prompt as a user here. So let's say prompt is equal to, I'll give, let's say, hello, how are you? So this prompt, here it will come, okay, as a user prompt. Now it will give me one response. And that response I'll print here simply. Okay, now see if I execute the program. So it will give me the response. So it is giving invalid request added. Missing required parameter message. You provide message. Okay, so let me check. So it should be messages. Okay, not messages. Now see, it should work. Now see, it is giving me the response right now. And here is the response, guys. Okay, if I show you. So here is the response. Hello, I am here ready to assist you. How I can help you today? If I want to extract this content only, that means this, let's say response only, what I can do. So simply I can copy this example as it is. And here, let me paste. So here you can see, first of all, I have to go to the choices. Okay, because it's a dictionary, I have to take the choices. So let's take choice. First of all, I'll take the choice. Now choice is nothing but it's a list. So I will take the first, let's say, item of the list. Now I have to go inside the message. Now I need the content only. Now see, it will give me the content only. Okay, hello, I'm just a computer program, so I don't have any feelings, but I am here to ready to help you. How I can assist you? Because every time whenever you will execute this program, it will give you different response. Okay, it will generate different response for you. This is the idea. Fine. Now what is the main benefit to use this ChatCompletion API? That means ChatCompletion model. See, in the ChatCompletion model, you can pass multiple prompt. Okay, here you can pass multiple prompt. So how? Let me show you. So here I have given one example. So this is the example, guys. See, here I have created actually 3 prompt. Hello, how are you? Second prompt, I am 25 years old. I'm a programmer. Now third prompt I have given, tell me about me. That means in the prompt itself, I have given my data and I'm asking, tell me about me. Now see, the same way I have created my ChatCompletion API. I have initialized my model, and in the message section right now, you can see the first role actually I have given the system role. That means you are a helpful assistant. Second role I have given my first prompt. Third role I have given my second prompt, and fourth role I have given my prompt 3. Okay, that means you can pass multiple prompt here. This is the main benefit to use this ChatCompletion API. That means in the ChatGPT also. So if I go to my ChatGPT, let's say here I give my data. Hey, I am. Let's say I'll give the same prompt here. This is the prompt I want to give. I'm 25 years old. I'm a programmer. Now you can see memory updated. It has memory updated, right? Now if I give this prompt, tell me about me. Now it is telling you are 25 years old programmer who created courses and playlist. Okay, see, Now it is giving me the answer related my information, because it has remembered. Okay, it has remembered my previous prompt. So this is what actually they're using, something called ChatCompletion model. That means it can understand multiple prompt. Okay, not one prompt, it can understand multiple prompting. So here you can see I have given one demo. So I'm giving the same thing. Hello, how are you? I'm 25 years old, I'm a programmer, tell me about me. Now see, if I execute the program right now, it will able to give me the answer. See, based on the information you provided, you are 25 years old programmer. Is there anything specific you would like to know or discuss? I hope it is clear now. What is the use of ChatCompletion API, and what is the benefit to use the ChatCompletion API model? That means ChatCompletion model. Got it? Great. Now we'll be tweaking some of the parameter here. So the first parameter will be tweaking, which is nothing but max token. Okay. So what I'll do, I'll copy the same example, my previous example. Now instead of asking this question, I'll write what is Python. Let's say this is my question. Okay. Now there is a parameter you can set called max token, max underscore token. Let's say I want to generate only 25 tokens. Okay, 25 tokens. Now see, if I execute the program right now, it will only give me 25 tokens output. Now if you want to see that, you can copy and you can go to the OpenAI token. Okay, tokenizer. Now go to the first website. Now here you can simply give it this particular, let's say, a response you have copied. Now you can see maximum token 25. That means whatever token limit you have set, so it will give you that particular token output only. Now if you want to see the detailed information, you can simply print the response instead of printing the content. Now see, so now if I execute this program, you'll see that my completion token 25. Fine. Now it will charge you based on the token limit. So if you can go to the OpenAI pricing, so in the pricing section they have given how it will charge you. So guys, as you can see, this is the OpenAI pricing page. So here they have given the pricing as per the token limit. You can see this is the input token, this is the output token. That means if your input token is that much, that means 1 million, and if your output token is, let's say, 1 million, so you will charge that many of dollar. Okay, that much of dollar. So you can see this different examples. So this is GPT-4o mini. This is the embedding model. You can see if your input token limit is 1 million token, and if your output token is, also 1 million tokens, so he will get 0.020, okay, $20 only. It's like very less amount. Now see, different model with respect to their different price. Okay, so you can check all the models, see audio model as well as the image model, assistant API. Okay, see whatever assistant API actually you will be using, and vector source. Okay, every model they have given the pricing. Okay, every model they have given the pricing. So that means it will charge based on the token limits. Let's say whatever token it is giving you the output, as well as the whatever tokens actually it is receiving as an input, it will first of all do the count operation. How it will do the count operation? So with the help of this tokenizer. So they have one inbuilt tokenizer inside that, it will automatically make the count. Now you can see I'm having total 141 character. Now you can see like how many character they are considering to calculate only one token. I think 4 to 5. Okay, 4 to 5 character they are considering to count one token here. Okay, this is the idea. So here they have written, you can see a helpful rule of thumb is that one token generally correspond to 4 characters. Okay, whether it's a 4 character or sometimes it would be more than 4 character of text for the common English text. Okay, this is called actually one token. So they have given each and everything you can explore here. Now let's get back to my code editor. Now I think this parameter is clear. Okay, what is max tokens here? Now I think you remember in the playground also I showed you this parameter. So if I go to the playground, see in the playground also I showed you this parameter max token. Okay, now it is, I think it is clear. Now I'll show you the next parameter right now. So the next parameter is nothing but our temperature parameter. So you can see I've given the same example, but one parameter I'm using called temperature. And I already told you what is temperature parameter means. It will give the randomness, okay, randomness to the response, like how much randomness you need. Let's say if it is close to 0, your model will be more stick to the, let's say, prompt you have given. And if it is close to 1, that means it will try to take some risk, and it will generate some random output as well. Now let's say here I've given 0.6. That means I'm telling my model try to be actually balanced, okay, balanced with the prompt user is giving. Try to give some creativity somehow, even also try to be strict with the prompt user has given. Now see, if I execute the program, now see, now the response actually I'm getting, this is the this little bit different response from the previous response, you can see. So here is the response I was getting. Python is a high level internet programming language, simplicity and reusability. It supports multiple paradigms. Okay. Now see, this is the another response actually I'm getting. Okay. That's how you can increase and decrease this parameter size. But what I saw, like people are using this parameter around 0.5 to 0.6 to 7 like that. Okay. No need to decrease and no need to increase much. But if you sometimes need it, you can increase. Otherwise you can decrease. Okay. It's up to you. Now there is another one, that n parameter. N parameter means it will give you like how many response you need from the model. Let's say if n is equal to 2, it will give me 2 response. Now if I execute the program, see, it has given me 2 response. So this is 1 response and this is another response. Now if it is 3, it will give you 3 response. See, 1 response, 2 response, and if I open in a text editor, 2 response, this is 1, this is 2, and this is 3. Okay, that's how you can get multiple response if you want. So this is called actually n parameter, like number of response you want to get here. Great. So yes, these are the parameter you can play with, guys, because these are the parameter we'll be using frequently. Now see, with the help of ChatCompletion model, you can perform different tasks. So let me show you. So you can give different prompt. So let's say here I have given a prompt, give me a sentiment of this sentence. Okay, this movie is amazing. Now I think you know this sentiment would be positive. Now let's see whether my model is giving me right answer or not. Now see, this sentiment of the sentence, this movie is amazing, it's a positive. That means it's working fine. Now apart from that, you can also give any other prompt. Let's say I'm given, give me the Hindi translation of this sentence, this movie is amazing. Now see, it should give me the Hindi translation. See, so whatever things we use to perform in the ChatGPT, na? Okay, that means we can perform multiple tasks. I want to do language translation, then sentiment analysis, anything I can perform here. The same thing you can also do here. Okay, because it is using the same model only. Okay, and we're able to access those model with the help of API key. That means whenever you are sending this request, it is first of all calling that API, and API is actually hitting the model, and model is giving me the response, and this response actually we are able to see. This is the idea only. I hope you clear. Now let me show you another prompt. Let's say detect the language of this sentence. This movie is amazing. So the language should be English. See, it is an English language. Okay. Now you can also generate code. Okay, you can also generate code with, these are the model. So I've given a prompt, give me a Python code to add 2 numbers. Now let me see. See, this is the code I have given to add. So here I got the code to add 2 numbers in Python. Okay, so that's how actually we can create different application with these are the large language model. Fine. So yes, guys, this is all about our ChatCompletion API. Now let's try to export the completion API as well. So as I already told you, so here is the definition of completion API, guys. You can see hooks you up with text completion from a single prompt. That means it can only support single prompt. You can only pass 1 prompt here. In the other hand, actually in the ChatCompletion, you can give multiple prompt to keep the conversation flow intact. Okay, as I already told you, you can give multiple prompt, and that prompt actually this model can remember. But in the completion API, you can only pass the 1 prompt here. Okay, this is the idea. In completion API, you can pass only 1 prompt. Now, if I show you some completion model section, and let's say this is the GPT base. So this is use actually completion API, and these are the model are available related completion API. Okay. Now let me use this Babbage 002 model, and let me show you one example. See, if you want to use completion API, that time you have to call this completion OpenAI dot completion. Okay, OpenAI dot completion dot create, not chat completion. You have to call completion only, and inside that you have to give the model first of all, which model you want to use. Let's say I want to use this Babbage model, that Babbage model. Okay, and it will take the prompt. So let me define a prompt here. Let's say this is the prompt. Okay, what is Python? This prompt I'll pass it here. Now I'll print the response. Okay, now if I execute, now see, it is giving you the response. Okay, it is giving you the response. So that's how actually you can give actually only single prompt here. And whatever, let's say parameter you saw, temperature, then maximum token, then n parameter, you can also give the same parameter in the completion API as well. Okay, it will also work. But see, we'll be using the ChatCompletion API a lot. We'll be using ChatCompletion model a lot going forward. Okay, because I have seen like people are using this ChatCompletion model a lot instead of completion API, because here we can pass multiple prompt. Okay, this is the main advantage. Okay, I hope it is clear. So yes guys, this is all about our ChatCompletion API as well as the completion API, and this is all about a hands-on part on the OpenAI platform. Okay, because see, going forward we'll be using these are the concept only to implement any kinds of project. Even I will also implement some of the project. I'll tell you how we can implement different projects with the help of OpenAI. That time also you'll see I'll be using these are the concept only. Okay, now in the next video we'll be learning about another super important concept inside OpenAI called function calling. Okay, again it's the very powerful concept inside OpenAI. So we'll be learning that function calling. See, first of all, you have to understand what is function calling and what is the use of the function calling. So for this, I will go to my Blackboard and there I'll try to clarify. Okay. See, function calling helps the OpenAI model to interact with different third-party API. Let's say here you are having one API. Let's say here you are having one API. Okay. Let's say you are using one databases. Okay, databases. So let's say with the help of API, you are hitting the database, and database is giving you some kinds of response, which is nothing but a JSON response. Because most of the time, whenever you will use API, right? API to hit any kinds of website or database, you will get the JSON output. Let's say this is a weather. Okay, weather data database. And with the help of weather API, you are hitting this website and it is giving you the JSON response. That means weather related data. Now what you can do with the help of function calling. Okay, with the help of function calling inside OpenAI, you can use OpenAI API, okay, to interact with this model. Because let's say this is my large language model, okay, OpenAI model. Now with the help of OpenAI API key, what I can do, I can interact with this model. That means with the help of function calling, what it can perform, okay, it can perform the communication with this data. Communication with this data. That means this model can directly communicate with this data. That means whatever response you are getting from this database or let's say API, you can directly communicate. Okay, you can directly communicate with the help of your large language model. Okay, this is the main power actually this function calling will provides. Okay, that means you don't need to manually extract this information and manually let's say feed inside your model. You don't need to do like that. You'll be using function calling, and what your model will try to do, it will directly let's say communicate with this particular response. Whatever JSON, whatever response you are getting, it will directly do the communication. Okay, so that's why with the function calling, my large language model will be capable enough to communicate with any kinds of third-party API. Okay, third-party API. This is the main benefit to use this one. And without this function calling, what you have to do, you have to manually extract the data and you have to manually fine-tune this model. Okay, manually fine-tune this model, and again it's a very hectic task, right? Because again it's a large language model and you can't do the fine-tune easily. Okay, and again it is having lots of cost involvement. So that's why this function calling helps us to do this communication. That means instead of like feeding the data in my model directly, function calling will try to make the communication between my response of like API response I'm getting and this particular model. Okay, this model will try to communicate with my output. Okay, it can be any kinds of API. It can be not only weather API, it can be any kinds of API, any third-party data. Okay, so that's why OpenAI supports actually different third-party actually integration. You can connect like different platform. You can connect let's say Slack. You can connect let's say different website. You can connect different database. Okay, directly you can connect, and it can directly do the communication with the help of function calling. Okay, now let me show you one example. I think then this part would be more clear. So what I'll do, I'll go to my code editor, and here I already created one file. You can see now we'll be exploring the function calling here. Again, what I will do, I'll import all of the library. Then I'll select my kernel and I'll set my environment variable. Now I can use the same example from here just to test whether everything is working fine or not. I can copy See, everything is working fine. Okay, there is no issue. Instead of printing all the response, I can only print the content. So as I already told you, it can actually communicate with any kinds of third-party API. So as a third-party API, what I will do, I will use one API here. So called Rapid API, okay? Rapid API. So inside Rapid API, you are having different API, whether it's a weather API, okay, any kinds of API, it is available. So this is the link. So let me open this link, guys. I will search on Google. So this is the rapidopenai.com, and make sure you have created one account. So for me, I already created one account, okay? For you also, you have to create one account. Now here, what you have to do, you have to search for the API. Now simply left-hand side, you can click on View All Categories. Now I need actually weather API, so I'll simply search here. Weather. Now see, different weather API is coming, but I need this AI weather by Metro Source. Okay, this one, I'll click here. Now see, initially if you're doing it for the first time, you will see one button here, subscribe. Okay, subscribe to the API. You have to do the subscription. That means you have to take the basic plan, that free plan. Okay, you can also take the premium subscription, but you can take the free plan. Free plan actually will give you some of the API request you can hit, right? Now I already do the subscription, that's why it's showing me test endpoint. Now simply what you need to do, you need to copy this code snippet. Copy this code snippet, and with the help of that, I have written a function. Let me show you. So this is the function I have written. So the function name is get current weather. Okay, so it will take the location and it will return you the current weather in that particular location. Okay, see, this is the UI. That means the same code, na? Here, see, the same code actually I've copy pasted. Same code I've copy pasted. You can see the same code I've copy pasted, and this is my API key, Rapid API key, and this is my Rapid API host. And don't share with anyone, otherwise they will also able to access your account. Okay, I'll delete it after the recording. Now with the help of request package, I'm sending the request and it will give you the response, and that response actually I'm doing the returning, and as a JSON format, because I already told you, na, that's any kinds of API will give you as a JSON response, and that particular JSON response I want to do the communication with my large language model. Okay, this is the idea. Now I think, yeah, everything is fine. Now let me execute this function. Now if you want to test what I can do, I can call this function. Inside that I can give any location. Let's say I will give Delhi, and it will give me response. Now see, Delhi place ID, area, India, latitude, longitude. Okay, see all the information it is giving me. Okay, all the information it is giving me related Delhi. You can give any kinds of place. Okay, it's up to you. You can give Bangalore, Delhi, Mumbai. Okay, anything you can pass here. Now if I show you the response, so this is the response. Okay, so this is the response I'm getting as a JSON. Fine. Now what I will do, I'll just connect my large language model with this response. Okay, with the help of function calling. For this you need to create a functions. See, this is the function format you have to follow. It's actually, you can see again, it's a kinds of JSON format only. So you can see I have written a list. Inside that I have mentioned a dictionary only. Okay, so this is called actually function. Again, if you go to the documentation, if I go to the documentation, let's say documentation, so they have one function calling. You can also search here, function calling. See, whatever things I explained, they have written here also. Now see, this is the format you have to follow. Okay, this is the format you have to follow. That's how you can write the function calling here. So I already simplified this thing and I written a function. Okay, so similar like format you can also follow. Now first thing you have to give the name. So current, get current weather. So I've written my function name here. You can see is the function name, get current weather. That means this will hit that particular function because this is my third-party API. Okay, you can also consider database here, but as of now I'm considering the function. Now this is the description, get the current weather in given location, parameter, object, properties, location, string, and the final thing, required location. That means it needs the location. Okay, if it needs to give any kinds of output, first of all it needs the location because my function takes the location out input. Okay, I hope it is clear. Now let me initialize my functions. Now I think remember whenever I was using this ChatCompletion API, okay, ChatCompletion model, that means I can give multiple prompt. I can add multiple prompt. Okay, in that particular, let's say message section. So that concept actually will try to utilize here. See, here I have given an example. Let's say this is here I'm using ChatCompletion model, and I have to prepare the message function. I think remember this message function. Inside that I can give multiple role, right? That means multiple prompt. So what I'm doing here, I'm appending one prompt here. You can see user message masses dot append, because it's a list, I can append role, user, content, user, masses. Okay, now it will add this particular prompt inside my masses. Now see, if I execute, now if I show you the, now see, if you want to see the output, see, this is the output, hello, how I can assist you. Now if you want to see the masses only, now see, in the masses, one prompt has been added. Okay, this is the user prompt has been added. That's how I can also add multiple prompt. Again, what I can do the append operation. See, again, I have taken another user message. What is the temperature of Delhi? Now I'm appending in the message. Now role, user, content, user, because this is a user. Okay, user message only. Now again, I'm adding the message, and I'm also adding the function calling I have defined now here, this particular function calling. So with the help of this function, it will try to understand, okay, I need to execute this get current weather, okay, this particular function, and this particular function will return the JSON output, that means the data related weather, and it will automatically connect the large language model in that particular data. See, the same diagram I showed you now here, it will give you the response, and my large language model will connect through function calling. Okay, now so let me show you. So if I execute it, now if I show you the masses, now see, 2 masses has been added, 2 prompt has been added. Hi there. Now second prompt, what is the temperature of Delhi? You can also ignore this prompt. I've just only given because I just wanted to show you, okay, whether you can add any new prompt or not. Okay, this is the idea. Now if you see the completion, that means the response. See, this is the response you got. See, as of now, it is only calling the function. You can see it is only calling the get weather function. Okay, and here you have given the location of Delhi. You can see it is automatically extracting the location from your prompt. Okay, you can see location Delhi you have given. Okay, now if you want to get the information, what you can do, now if you want to get the actual information, what you can do, let me show you. Let's say you want to see the masses, you can also see the masses. This is the masses, it is calling my function, and this is my location. Now this is the response. Okay, this is the response. Now if you only want to extract, let's say, the function name, what you can do, you can extract like that. So it is inside function call name. Okay, and it is my get current weather function. And if you want to see the location, so what you can do, inside function call, inside argument location, you can see argument location, I'm extracting the Delhi here. See, this is my location. Okay, now this response actually I'm getting, I need to pass to my large language model. For this, you can execute this code. Message.append response. The response actually I'm getting, I'm again adding to the masses. That means as a prompt. Okay, as a prompt actually I'm adding. I think remember here now. Here I showed you. You can give multiple prompt. This prompt, this prompt. That means I was providing the data, based on data I was asking the question. The similar things I'm doing. The response actually I'm getting, this response, entire response I'm getting now. This is I'm passing as a prompt. Okay, as a prompt data. And on top of this prompt, I'll be asking the question, okay, with the help of function calling. See, the same thing I'm doing, appending the response, message.append. Now I'm appending the role as a function, name function, content, location. Okay, this thing actually I'm passing one by one. If I show you the entire masses, see, this is my entire masses right now. Now I can initialize my GPT 3.5 turbo model. Inside that, I'm passing my message as well as the function calling. Now it will give you the accurate response. See, the prompt you have given, the current here is the prompt you have given, I think, remember. What is the temperature of Delhi? Now see, this is the temperature of Delhi right now. Okay, and it is coming like that because it's a 32 degrees Celsius. So degree is a special character, that's why it's coming like that. Okay, you can convert to special, see, you can convert this Unicode to special character. Okay, it is also possible. Now see, here I have executed actually line by line. That's why you can see, you can also execute as a snippet of the code. It will give you the complete response. Now see, instead of giving Delhi, I can give, let's say, Mumbai. Now let's see the Mumbai temperature. See, it is not able to fetching the Mumbai temperature currently. So what I can do, I can give any other location. Let's say I'll give, as of now, I can comment this to line. It's not required. I'll give, let's say, Bangalore. Now see, this is the current temperature of the Bangalore. Okay, so that's how actually you can give any kinds of information. any kinds of API you can connect with your large language model with the help of this function calling technique. And it's like very powerful technique, guys. Trust me, it's like very powerful technique. Okay, if you're interested learning more about it, like what are the things you can connect, you can go to their documentation. Okay, they have written each and everything. What are the things you can connect with it here, right? Okay, so yes, guys, this is all about from this video. I hope you liked it. Now in the next video, we'll be implementing one projects, whatever concept we have learned so far. The project name is Telegram bot. Okay, Telegram bot with the help of OpenAI. That means we'll be creating a chat bot and we'll be integrating with the Telegram. Okay, so all the fundamentals we have already discussed. Now it's time to implement one projects with the help of OpenAI. So in this video, I'll show you how we can implement one Telegram chatbot with the help of OpenAI. That means here we'll be using one ChatCompletion model. That means one large language model we'll be using called GPT 3.5. And with the help of that, actually we'll be implementing one chatbot and we'll be integrating this chatbot with the Telegram platform. Okay, so make sure you have the Telegram, guys. It can be a smartphone Telegram application or it can be your desktop application as well. Anything you can keep, both will work. Okay, so here I'm going to use my desktop Telegram. You can also use your smartphone Telegram. It will also work fine. So before starting the implementation, guys, first of all, let me show you the architecture diagram, like how we'll be implementing the entire projects. Then after that, we'll be doing the setup and we'll be starting the implementation. So guys, let's say this is the user, that means you. So you will be asking one query. Okay, you'll be asking one query and this query will go to the front end. Okay, front end of our application. So here front end wise we'll be using something called Telegram. Fine. Then what will happen? This query will go to the backend. Backend means our OpenAI. OpenAI API. Okay, OpenAI API. Then this API will access the large language model. That means here we'll be using GPT 3.5. Okay, you can also use any other model like GPT 4. You can also use GPT 4o. It's up to you. Okay, I think I showed you how to like select different model. There is a model list. So if you click there, you will see the model ID. So that particular ID you have to write there. Okay, and this model is, I think you already know, this is a ChatCompletion model. Okay, why ChatCompletion model? Because it can take the instruction. That means multiple instruction you can give, multiple prompt you can give. Okay, you can also create with the help of completion model like the Babbage one. Okay, I already showed you. Which will also work, but what I feel like this ChatCompletion model will be more powerful. Okay, this is the idea here. Now what will happen? This large language model will give the response. So where it will give the response? It will give the response to the backend API. That means your OpenAI API, and OpenAI API will send the let's say response to the front end. Okay, front end means our Telegram. Okay, and from Telegram actually user will again get the response. Okay, response. Let's say this is the response and this is the question. Okay, so that's actually we'll be implementing the entire projects. Okay, this is our actually high level architecture of our project. Now what I will do, first of all, I just need to get my OpenAI API key. And I already told you how to get the OpenAI API key. So make sure you already created your OpenAI API key and you keep it with you. Now in my computer, I'll just create a folder here and I'm going to name it as Telegram chatbot. Okay, Telegram chatbot. And inside that, I'm going to open up my Visual Code Studio. Then I'm also going to open up my terminal here. You can also open up your command prompt. Then you can also open up your Anaconda prompt. It's up to you. Now here, the first thing what I have to do, I have to create one virtual environment. So to create the virtual environment, just write conda create -n. Give the name of the environment. Let's say this is my Telegram. So I'll just write telebot. specify the Python version. Let's say Python is equal to 3 point, let's say 8. Okay, I'll use 3.8. You can also use 3.9, but let's use 3.8, then -y. Yeah, now let's get the environment. So my environment is created. Now let me activate. Just write conda activate teleport. Now let me clear. Now what I will do, I'll just create a requirement.txt file. Requirements.txt. So inside that, I need to mention all the, let's say, library I need to implement this project. So here you can see front-end wise, actually, I'll be using Telegram. Okay. And to integrate my chatbot with my Telegram, I need a Python package. That means this package will communicate with my Telegram. So inside Telegram, we'll be generating one, let's say, API token. So with the help of API token, we'll be communicating with our Telegram app, right? So for this, actually, we need one Python package. So let me show you this package, actually. The package, actually, I'm going to use. So guys, as you can see, this is the package, actually, we'll be using. The package name is AIOgram. So as you can see, AIOgram is a modern and fully asynchronous framework for Telegram bot API. And this is the complete documentation of this AIOgram. Even they have also given the sample code, like how we can connect with the AIOgram and all. Okay, they have discussed each and everything. But you can see they have written actually too much line of code, but that many line of code actually is not required. So what I've done, I just made it like simple. And I created one basics template for you if you want to connect with your Telegram. Okay, so how you can connect for this, what kinds of code you have to use, I already prepared one code snippet. Okay, I'll share with you. So first of all, let me mention this package name inside my requirement. So the first package I'm going to add called AIOgram. Fine. Now the second package I need OpenAI, and I'm going to use the same version of the OpenAI I already used in my OpenAI demo. Then I need another package called Python .env. Why Python.env? Because I already showed you, if you want to manage the secret key, so you can use this Python.env to load that secret key from the environment. That means .env file. Okay, this is the idea. Now let me save. Now what I will do, simply I'll install everything in my environment. So for this, just write this command. So pip install -add requirement.txt. So guys, as you can see, my installation is completed. Now let me clear my terminal. And now, first of all, we'll be testing our this one Telegram, whether we are able to make the connection without Telegram or not. So for this, I'm going to create a folder here called research. Inside that, I'm going to create a file. I'm going to name it as ecobot, eco_bot. So here we'll be creating one eco functionality. That means if you're sending any messages, okay, to the, let's say, chatbot, that means to your Telegram chatbot, it will give you the same message. Okay, this is called actually ecobot. That means whatever message actually will be giving as an input, that message actually will be getting as an output. Okay, so that means I just wanted to experiment whether I'm able to successfully connect with my Telegram or not. Okay, this is the idea here. But before that, I just need to create this .env file. Now inside that, first of all, you have to write your OpenAI API key. So let me just write my OpenAI API key. So this is my OpenAI API key. I think you remember I already created this API key. Okay, now let me save. Now just open up your Telegram app. So here I'm using my desktop Telegram. So you can see this is my desktop Telegram. To search for bot father. So after searching bot father, you will see different bot father, but you have to take the verified one. You can see this is the verified one. Now just try to open it up. See, I've already opened. Now see, previously I already created some of the bot with the help of bot father. That's why it's coming. That's why here you can see some of the like older messages. But if you are opening for the first time, you won't be seeing any kinds of messages. Okay, you will see a start button. You just click on the start button. Okay, then it will give you the suggestion. Okay, what do you want to do here? So here I want to create a, okay, I think my screen is visible. Okay, so here I want to, let's say, create a new, actually Telegram bot. So for this, what you can do, you can write this command new /new, okay, new bot. So for this, what you can do, you can write this command new /new, okay, new bot. So for this, what you can do, you can write this command new /new, okay, new bot. So for this, what you can do, you can write this command new /new, okay, new bot. So for this, what you can do, you can write this command new /new, okay, new bot. You can see new bot. Just select this one. Now see, now it will ask you, all right, a new bot, how are we going to call? Okay, please choose a name for your bot. Now you can give any kinds of name here. So let's say I will give my live. Okay, my live bot. Let's say 24. Let's say this is my bot name I want to give. Now if I hit enter, see, it's telling good. Now let's choose a username for your bot. It must end with bot, like this is example, Terry's bot or Terry's underscore bot. Okay, so you have to give a username, and that username should contain underscore bot, okay, at the last. So I'll give the same name. Let's say my live bot, okay, 24 underscore bot. Now if I hit enter, now see, my bot is created. Now it is telling congratulations on your new bot. You will find your bot here. But before that, what you have to do, you have to collect this user, you can see use token. So let me collect this user token. I'll copy. Okay, and I'll open up my Visual Code Studio inside environment. What I will do. So here I'm going to paste it as of now. And you need to also give the key name. That means this is my Telegram bot token. Okay, now I'll be mentioning inside my string. So here we have collected two secret key. One is my OpenAI API key, another one is your Telegram bot token. So with the help of Telegram bot token, we'll be authenticating with our bot actually we have created here. You can see this is my bot. If I click on the URL right now, see, this is my bot. Now if I click on the start, now see, there you won't be seeing anything because this is not connected yet. Now see, if I send any message here, so you won't be getting any kinds of response because as of now we haven't made the connection. So here first of all we have to make the connection, and how to make the connection with the help of this Telegram bot token. Okay, and this OpenAI API key we need to access our GPT model, because this is my main large language model, right? With the help of that actually we'll be getting the actual response. This is the idea here. Fine. Now in the EcoBot, I'll be writing some of the code to connect with my Telegram. Okay, so as I already showed you, so this is the AIogram documentation, and they have given the code snippet you can use to connect with the Telegram, right? But I already told you this that much of actually code is not required. So I just created a basics template. Let me show you. So here first of all, let me import some required library. So you can see I have imported some required library, but here it is coming this YOLO mark because I haven't selected my current environment. So right hand side below you can see there is one option. So my base environment is selected. Now I have to select my own environment, which is nothing but Telegram bot. Okay, now see, this error will be disappeared. Now see, these are the packages you have to import, like login, AIogram. From AIogram you have to import bot, dispatcher, executor, and types. Okay, if you see the documentation also, they are importing the same thing. See, they're importing the same thing as well. Fine. But as I told you, they have written so many line of code. I just simplified the code. Okay, that's why my code might be a little bit different. Okay, from the documentation. This is the idea. Now .env I'm loading because with the help of .env I'm going to load by .env. Okay, that means my secret. Okay, inside my environment. Now operating system I need, because with the help of operating system I'll be loading. Now os.get.env, I think you remember previously you also did the same thing. And why logging is required? Because if you see the AIogram, they are also using login. Okay, so you have to write the login. Okay, login here. See, basic config login. So by default it will take the log because it will, let's say, log all the information in the backend. Okay, because see, this is their implementation. They are suggesting to use, these are the, let's say, code snippet. Okay, that's why I'm using. It's not my implementation. So whenever you are using any kinds of, let's say, framework or library, first of all, try to check their documentation, whatever things they are suggesting. Based on that, you have to write the code. Okay, no need to do any modification at the very first. If you understand their implementation, then you can do the modification. But the core implementation you have to always keep as same. Okay, this is the idea here. Now the first thing what I have to do, guys, I have to load my API key, right? So for this I can use this load env. Now simply os.get env, and inside that I can pass my key name. Let's say I want to load my Telegram bot token. I'll pass the key name here. Fine, so it will return me my Telegram bot token. Now if I print this one, my Telegram bot token, now see, if I execute the file right now, it will print the bot token. So let me show you. So Python, let's say it is inside my resource folder, resource. I want to execute this ecobot. Okay, sorry, ecobot.py. So guys, you can see it is throwing me one error. It is telling from AIogram import bot, dispatcher, executor types. import error cannot import the executor from AIgram. Okay, so it is throwing me one error. So to solve this error, what you have to do, so you have to create actually Python let's say interpreter 3.7. That means Python environment you need 3.7. So let's create one another environment. So I'll just write conda create -n. Let's give the name, let's say my bot Python is equal to 3.7. Actually I want to use -y. Okay, now let me activate conda activate my bot. Now let me clear and let me install the requirements right now. So pip install -r requirement.txt. See, it has installed all the packages in my environment. Okay, so I already installed, that's why it's telling requirement is already satisfied. But for you, it will take some time. Okay, so once it is done, now let's clear my terminal. And now if you execute the command, this command python research /ecobot.py, that means if you execute this ecobot right now, now see, it should work. Now see, it is printing my API token. Okay, it is printing my API token right now, Telegram bot token. Fine, that means it is working now. Now let me comment this line, it's not required. Now what you have to do, you have to first of all initialize the login. So that's how actually you can initialize the login. So you just need to write logging.basic-config label is equal to logging.info. Okay, because if you check the documentation, they are suggesting like that. Okay, you have to configure the logging like that. Okay, after that you have to initialize the bot and dispatcher. So this is the bot and dispatcher. So inside that you have to pass the API token. Okay, now see what will happen. You can see from AIgram I imported bot, right? Because I want to connect with my Telegram bot. The bot actually I have created. Now if I want to connect, what I need the API token, Telegram bot API token, yes or no, right? So here you can see I'm passing this bot token inside a token actually attribute. So what will happen? This bot will be initialized. That means it will authenticate with my credential. If the authentication is correct, that means this statement would be true. Okay, if it is true, that means my dispatcher would be connected. Okay, dispatcher means, let's say the synchronization, that means whatever message I want to pass, okay, so it will go to my Telegram bot. Okay, this is called actually synchronization. So it will be connected. Okay, it will be connected. That means this is the authentication code, okay, with your Telegram. I hope it is clear now. Fine. Then after that, I think you saw they have written different function with the help of async and await keyword. Okay, async and await keyword. So what is the use of async and await? See, this is the concept of Python. If you don't know about Python, so what you can do, you can check out our YouTube channel. Okay, so there actually I already let me show you. So guys, you can see this is our YouTube channel. So there I already created like a Python playlist. So there I already covered each and every topic. Okay, you need to master inside Python. So there I already explained what is async and await. Okay, so you can check those video. So let me tell you as a high level what is async and await. See what this async and await will do. It will keep on syncing. Okay, it will keep on syncing your update. That means if you update anything, okay, if you update anything in the code base, it will automatically get that update. Okay, that means what happens actually, let's say whenever you update anything in your code, so you don't need to send the request. Okay, you don't need to save and send the request. It will automatically sync that. It will automatically sync that and it will send the update. Okay, so this is the work of async and await. And if you want to use AIgram, you have to use this particular keyword. Okay, async and await with a function. So I already created two functions. Let me show you. So I'll tell you what this function will do. So this is the first function, guys. So the function name I have given command start handler. Okay, I think you saw whenever I started my Telegram bot. Okay, whenever I started my Telegram bot, so there was a start button. See, I given /start. Whenever I will give the /start, my bot will start. Okay, my bot will start. See, if I show you the bot further, if I give /start, see, bot further started and it has given me all the suggestion actually I can perform here. So these kinds of functionality I want to implement. And if I want to implement, so for this I have to create a function, and with the help of async and await keyword I have to give here inside the function. Now you have to create a decorator, your dispatcher decorator. Now inside that there is a function called message handler. Inside that you have to pass the command, like what kinds of command you want to pass. Let's see if I give /help as well in my bot further /help. So it will give me the menu. Okay, what are the things I can perform with the help of bot further. That means if anyone is using my bot for the first time, they can get the information with the help of start and help. Okay, slash help. So I want to give two commands, slash start and slash help. If you are passing this one, so what your bot will do? So what your bot will do, your bot will reply, hi, I'm a echo bot powered by AIogram. So this message actually it will give. Now here you can give any kinds of messages. Okay, you can give any kinds of messages. I have given this message. Now let me show you how it will work. So for this, what I have to do, I have to start my bot. So for this is the syntax you have to write. So inside this keyword, you have to write executor start pooling. Then you have to give the dispatcher object, and as well as you have to give one parameter called skip updates is equal to true. What is skip update is equal to true? I'll tell you later on. As of now, just try to remember this parameter you have to give. Okay, if you check the documentation, they are also giving the same thing. Now let me save, and now see if I execute my program, my EcoBot. See, so it has connected. Now see, it has start pulling. Now if I go to my bot, let's say this is my bot. Now see, if I give, let's say slash start here. So it has given me, hi, I'm EcoBot powered by AIogram. Now if I give, let's say slash help, it will give you the same thing, because you have mentioned two command there. I think, remember, you have mentioned two command. Now apart from that, if you give any command, let's say slash hello, it's not working. If you give any other message also, it's not working. Okay, that means it will only work whenever it will get these two command. And here you can pass any kinds of messages. Okay, I have given powered by AIogram or anything you can. Let's say powered by Bappy. Here you can give my name. So once you changed anything, just try to re-execute the code. So I'll just stop the execution with the help of Ctrl+C. Now if I re-execute, now again I will go to my Telegram, and now if I give, let's say slash help, now see, it will give me, hi, I'm EcoBot powered by Bappy. Okay, I hope it is clear now. But see, it is not able to handle my casual response. Okay, let's say if I'm giving any other message, let's say hi, hello, okay, hi, hello, whatever, it's not giving me the response because I have to create another function for this. Let me show you. So here I will create a function called echo. That means it will give me the same message again and again. Okay, so this is the echo function, and see, I'm using the same syntax only, message handler. Now see, here I'm not providing any kinds of command. I'm not providing any kinds of command, because see, whenever I'm giving my casual message, this is not a command. Okay, so that's why you don't need to mention the command. That means whatever message user will give, that message actually it will send. Okay, it will show you as an output. You can see with the help of await. Now let me save, and again I have to re-execute. Let me stop the execution. Now re-execute my code. Now if I go to my Telegram, now let's say if I just write hi, it will give me hi. If I write hello, it will give me hello. If I write, let's say I am Bappy, it will also give me I am Bappy, because it's an echo bot we have created. That means I'm successfully able to connect with my bot. The bot actually I have created in my Telegram. That means Telegram connection is completed. Okay, Telegram connection is completed. There is no issue. That means we are able to communicate with the front end. Now we have to make another functionality, that means backend API. That means we will be using OpenAI API to let's say process the response, process the question whatever user is asking. We'll be taking the help from the LLM. LLM will give the response, and this response I will be sending to the front end again. Okay, so now let's create our actual application. So what I will do, outside of research, I'll create a file. I'll name it as, let's say, main.py. Okay, main.py. Inside that, I'll be writing all the code. So what I can do, I can import all the necessary library. Again, you can see I have imported all the library. Even I also imported here as well. Okay. Apart from that, I'm also importing OpenAI as well as the system package. Okay, this is the idea. Now see, this application I'll be creating a little bit advanced, because if I show you my ChatGPT now, so let's say this is my ChatGPT. Let's say if I give any message to the ChatGPT, let's say I need a Python code to add 2 numbers. Sorry, I think my prompt is incorrect. It should be add. Again, I can give the prompt. I need a Python code to add 2 numbers. Okay, now I think it is perfect. Now see, it is giving me the code. Okay, but see, it is giving me with the function, but I don't need the function. What I can give without functions. Okay, now see, I just given without function, it will automatically remember I'm asking this particular response. Okay, it has remembered. Okay, it has remembered my previous input. So this is actually using one memory. Okay, temporary memory. So I also want to implement this kinds of temporary memory inside my chatbot. So for this, what I will do, I'll just write a class here. I'll just name it as reference. Okay, reference. So inside that, what I will do, I'll just write a constructor, and this will, and it will return actually none. Okay, so inside that, I'll just write self dot response, and it should be empty initially. Okay, that means as of now, let's consider this is my empty memory. Okay, this is my empty memory. That means whatever question I'll be asking as a as a temporary memory, that question actually I'll be saving here, so that if I want to ask any new question, my previous question my model will try to understand. Okay, it will try to remember. Now here you can also pass the doc string. So let's say this is my class I have written to store previously response from the ChatGPT API. Okay, you can also give OpenAI API. OpenAI API. Okay, this is the idea. Now let me load my OpenAI API key as well as my Telegram bot token. So first of all, I will load my OpenAI API key, and I'm setting my OpenAI API key. Then I will also load the Telegram bot token. Okay, this is my Telegram bot token. Fine. Then let's initialize this reference class. So here I can initialize. I'll just write reference is equal to my reference. Then I'm going to define my model name. That's which model I want to use. So model underscore name is equal to, let's say I want to use GPT 3.5 turbo model. If you go to the OpenAI platform, okay, if you go to the OpenAI models, see here is the different model, and I want to use this 3.5 series actually, C turbo model. Okay, this model actually I'm using right now. Fine. Now same way I have to initialize my dispatcher as well as the bot, because it will authenticate with my Telegram. The same code, guys, from my previous let's say file I'm copy pasting. Okay, I think you remember. So we are initializing our bot and dispatcher. So here the first thing I want to create a function. So this function actually will do the welcome. Okay, so if you give, let's say, start command, it will welcome you. So this is the function I've written, guys. You can see simple function using the same concept. Okay, same concept. So this is the function dispatcher message handler, and here is the command only start. Okay, if you give start command, it will give you, hi, I am a telebot created by Bappy, how I can assist you. Okay, this is the message actually it will show you. That's it. Now if you want to execute, you can simply copy this line and here you can paste it. That's it. Okay, now it's a dispatcher object, DP. Previously I written as a short form, but now what I did, I just written full name. Okay, this is the idea. Now let me execute and let me show you. So I'll open up my terminal. Let me stop the execution. Now let's say if I execute the file right now, I need to execute my main.py file. So clear Python main.py. Now see, if I open up my bot and if I give /start right now, so it is giving, hi, I'm a telebot created by Bappy, how I can assist you. That means it is working fine. Now let me stop the execution. Great. Now I also want to create a helper function. That means I showed you now, if I go to my bot further and if I give /help, so it will give me all the menu actually I want to perform here. So I also want to give one menu function in my bot. So for this I have created a function and I named it as a helper. See, this is the function. So it will take the help command. After that it will show you this message, hi there, I'm a ChatGPT Telegram, or I can write, I'm a Telegram bot, okay, created by Bappy, please follow this command. Start to start the conversation, clear to clear the past conversation, and help to get the help menu. Okay, I hope this helps. Now it will give you this this actually menu. Okay, now see here I've written clear /clear to clear the previous conversation. Now let's say if you're saving any conversation and if you want to clear it, so you can use the clear function for this. So what I will do, I'll just write a function named clear. So here I can write, so it will just do the clear operation on the previous conversation. See, I think you remember we initialized our reference here. So inside reference we're having one variable, class variable called reference. So here I'm doing the clear operation. See, reference.reference I'm making as empty. That means whenever I will save something, okay, inside the variable, and if I call the clear past function, it will clear that particular response. Okay, this is the idea. If you go to the ChatGPT as well, and if you write forget my past prompt, it will forget that. Okay, it will remove that memory. So same way, I'm creating the same functionality here. And to execute this clear past, so I will pass one command. So I'll just write clear, this command clear. So it will automatically do the clear operation. So for this, I will be writing another function here. So function name is clear, and it will take the clear command and it will call this particular function. You can see clear past. Okay, then it will give you message, I have cleared the past conversation as the context. Okay, this is the idea. Now I have to write my main code. That means my main brain functionality of my application. So for this, I already prepared the OpenAI code. See, this is the OpenAI code, and this is nothing new, guys. This is nothing new. Just try to see. Here I'm using ChatCompletion API. Okay, now let me check everything is fine or not. Now you can see, guys, everything is fine. So I'm creating the ChatCompletion API, and role assistant content I'm giving, because you can see reference.response. First of all, it will check this response. Okay, this response, if there is any response or not. Okay, if not, that means it will act like you are using for the first time. That means there is no previous context. But if you are starting for the second time, let's say, I think you remember here in the ChatGPT, I have given a prompt, I need a Python code to add 2 numbers. That means one response it will remember, and whenever I'm asking the second question, it will refer my previous, let's say, question I have asked. Okay, the same thing actually happening here. That means it will first of all check whether you are having previous response or not. If not, that means it's a completely new role. Otherwise, it will refer my previous, let's say, response. Okay, now this is the user message, then it will give you the response. This response actually I'm only getting the content, and I'm printing in the terminal, and I'm also printing in my user interface. That means in my Telegram, and it is also updating the response. Okay, you can see this reference response is also getting updated. Okay, now if you will call this clear past, it will also do the clear operation. It's a simple code I have written. Now let me show you how it will work. So I'll open up my terminal. Now let me execute my app. Now if I open my bot, let's say if I just write /start, I think this command I already showed you, na? /start /help. It is working fine. Sorry, /start. Okay, now see, if I give any casual message, let's say hi. See, it is giving me hello, how I can assist you. Let's say if I give hello, how are you doing today? Let's say I'll ask, what is Python? So it is telling Python is a high level programming language. Okay, now I can also give the same prompt. Let's say give me a Python code to add, code to add 2 numbers. See, this is the code I got. Now I'll ask, give me as a function. Now see, that means it is remembering my previous context. Now if I give /clear, I have cleared all the past conversation. Okay, now if I give the same message, give me as a function. Now see, here it is giving me the function. Okay, it is giving me the function, but not these kinds of function. That means my previous, let's say, question function. Okay, that's why I've created this clear. Okay, clear functionality as well. Okay, now you can ask any kinds of question. Okay, whatever question you can ask in your ChatGPT, the same question you can also ask here. Okay, there is no issue. So that means we have created one beautiful application. Now one thing I want to show you, this is keep update is equal to true. Let's say if it is true, what will happen? Let's say if my application is offline right now, let's say I'll stop the execution. Let's say it is offline. Now if I give any message, let's say hello. Now see, it is offline. Okay, it's not giving you any response. But if it is online, let's say if I execute the program right now, let's say my application is online. Okay, now see, still it is not giving me the response. Still it is not giving me the response, because let's say sometimes it's possible your application will go offline, and if user is giving any question, when it is online again, it should return the answer, right? But it's not giving. So for this, what I can do, I can stop the execution, and this parameter I can make it as false. Okay, now let's say if my application is offline, let's say hello. Now if I re-execute my program, see, it will automatically take the hello, okay, hello message, whatever you asked during offline. Now see, it is giving you the response. Okay, so this is one of the amazing parameter you can play with if you want to, let's say, keep your application offline, but if you want to reply it, okay, when you are online, you can update this particular parameter. Fine. So yes guys, this is the like chatbot we have implemented. You can also share this bot with your friends and family. So what you need to do, you just only need to give the username. Let's say this is your username of your bot. Now if they search with this username, they will be able to access your bot. Okay, and if they're asking any question, they will also get the response. Okay, that's how. Just try to ask your friend to use your chatbot, okay, you have developed with the help of OpenAI. So in this video, actually, I will show you like how you can fine tune your GPT-3 model, okay, with your custom data. So basically what I'm gonna do here, so basically here we'll be fine tuning ADA classifier, okay, to distinguish between two sports like baseball and hockey. So basically we are gonna perform one classification task here. Okay, so here I will like take one sports data, and with the sport data, okay, I will train my GPT-3 model, which is nothing but ADA. Okay, ADA classifier, I think you already know it has various model. Okay, if you click on the model, so ADA is one of them. Okay, so let's install first of all OpenAI. And here you don't have to worry about your system configuration, because here you are using OpenAI API. Okay, so all the training and all the, you can say, computation, everything will be performed on their website itself. Okay, on their you can say engine itself. Okay, so you don't have to worry about. So you just need the API key and just try to open up your Google Colab. Okay, and try to start the training. That's it. So because see, it has like millions of parameters, so it's not possible to train in our system. Okay, so that's why they have proposed a API, okay, GPT-3 API, instead of giving the raw model to us. Okay, then this command, actually you can actually upgrade your OpenAI. So let's upgrade it also. And here I will import my data. So this data actually is already available inside scikit-learn dataset. Okay, like 20 news group dataset, the name of the dataset is. Okay, so here you have two categories, one is like baseball and hockey. Now if you want to see the example, the first example, so this is the data. Basically it kinds of email. Okay, and here you have the news sports data. Okay, now if you want to see the label target, so you have sports, baseball and hockey. Okay, now if you want to see the first one, see the first example I shown here, first data set, with respect to that I'm showing my first target. Okay, which is nothing but it's a baseball. Okay, now if you want to also see the count, so you have total example 1197. Baseball has 597. Okay, example, and hockey has 600. So basically this data is not imbalanced. Okay, it's fine. Now inside data preparation, first of all we need to prepare the data. So what kinds of preparation we need to do here? If you see, if I show you the target, so it has actually rec.sport.baseball. Okay, so this is the additional information I don't need. Okay, so I need to suppress that. So if you just run this code, so basically what it will do, it will take all the data. Okay, and it will create two columns, one is like prompt and completion. Okay, so why I'm creating prompt and completion, because if you go to the documentation of OpenAI, so here is a section called fine tunes. Okay, just click on fine tunes. So they have given like how you can fine tunes, okay, GPT-3 model. So here one thing they have mentioned, data preparation. I think here fine tune guide, and if you just go below, prepare your dataset. Okay, so if you just read it, okay, if you just read this okay, entirely, so you will get to know you need prompt and completion. Okay, so that's why I have given this name, prompt and completion. So prompt is nothing but your data, okay, your input data, and completion is nothing but your level. Okay, so that's actually you need to prepare the data. So once it is done, now you need to convert them a file format called JSONL. Okay, so this is the command, just run it. Okay, now let me show you what is JSONL. Okay, so if you just refresh here and let me download it. Now if I open it, Okay, so this is the same data format. Okay, like this is your prompt, and at the last you have the completion. See, this is the completion. Okay, and if you see, this is the same format. If I come here, this is the same format. Okay, so that is why you need to you can say convert your entire data frame to JSON-L format. Okay, is done. Now OpenAI has a data preparation tool. So if you just call OpenAI, and from tool itself you just call prepared data. Okay, so it will actually prepare your data. First of all, it will take this JSON-L. Okay, see, I'm just passing sports to JSON-L hyphen q. It will take this one and will do some analyzing. Okay, if something is okay wrong with your data set, it will throw error. Otherwise it will actually fix it. Okay, so see, I have run this command, so it has generated two file, which is nothing but supposed to prepare train JSON, validation JSON. Okay, so it will also do like train test split. Okay, you don't have to do it separately. Okay, so this thing actually you need to run, and here also they have written, okay, they have their own data preparation tool you need to execute. So whenever it is done, now this is the section actually you can execute, okay, to fine tune your you can say model. Okay, this is the training command actually. So here you need to change this API key because this is my older API key. So what I will do, I will change it with the newer one. You can also read it from secret. Okay, but I will give it here just for simplicity. Now here API fine tunes great. Okay, now here actually you need to give your data path. Okay, so this is my train data path and this is my validation data path. But here one issue actually I was having. So I was trying to actually execute this command, because here if you see, if I show you my model, okay, so fine tunes, here I have like already trained two models, okay, with the same data. So here actually you can't give the same ID again and again. Okay, if you give this same name, so it will create the same ID again and again. Okay, and it will give you error like just give a new ID. Okay, so that's why if you have done training one time, okay, you just change the data name. Otherwise it's fine. Okay, if you're doing it for first time, it's fine, just keep it as it is. Otherwise what you can do, just rename this name with a unique name. So I'll just rename, so I'll just give sports 222. Okay, because this name is already present in my model, so I'll that's why I'm changing the name sports 222. Okay, similar wise, just change it also here, sports 22. This is your validation. Okay, and competition and metrics. Okay, everything you're providing, and at the last you're selecting the ADA model. Okay, epochs is not required, so it will basically okay, automatically observe whenever your loss is not decreasing or accuracy is not increasing, it will stop the execution. Okay, so now everything is prepared. Now just click on this one, so it will take the data and it will start, you can say, training your, okay, it's telling, okay, it's telling this data is missing. So let me do ls. Okay, so here one mistake I have done. Here I have given one. Okay, one won't be there. So just remove the one. And now I think everything is fine. Now let me execute again. So guys, actually training takes a lots of time. So what I'm gonna do, I'm gonna show you my previous notebook. Okay, I did the training. So basically whenever you will click on the command, so actually it will start the training and it will start the epochs. Okay, see, this is the epochs, actually it will be running. Okay, and once your training is completed, it will save your model. Okay, it will save your model. So where you will get the model, just come here. Okay, come here, and here you need to refresh this page. Okay, so if you just refresh this page, now if you just click on the model, and at the last there would be a section called fine tunes. Okay, inside fine tunes actually will get your model. Okay, see, I trained add a model. Okay, and this is the ID. Okay, it is the ID, and basically this is the date actually when I trained this model. Okay, so this model actually you have to use, okay, whenever you'll be doing the inferencing. So now how you can do the inferencing, so this is the code. So basically you can also see the evaluation metrics. Okay, performance metrics actually you can see. Okay, you can also save it as a result.csv. Okay, and here you can also plot this accuracy score. Okay, this is the accuracy score, and this is my data. Okay, this data set actually I'm like taking one prompt. Okay, and here actually I'm doing the generation. Okay, basically I'm loading my model. So why do you need to give your model? So let me show you. Yeah, so here actually you need to provide your model name. Okay, the model name actually you will be training. Okay, here see I have took this model. Okay, so this name actually you need to copy and you need to paste it here. Okay, and it will load the model from the OpenAI itself. Okay, and it will do the inferencing. See, this is the score of your hockey and baseball, and after that if you want to see, okay, this is the baseball and hockey. So that's actually you can see the example. Okay, do the inferencing. So yes guys, I think you got it, like how you can fine tune your OpenAI like GPT-3 model. Okay, with your custom dataset. And if you want to learn more about fine tuning, I will suggest just try to explore this documentation. It is pretty good documentation. Just try to read everything, not only like classification, you can also do it from summarization and other tasks. Okay, for that actually you need to prepare the data, like you need to learn how to prepare the data. Okay, so yes guys, I think you got it. This was all about from this video. And yeah, that's it. Actually you need to learn about OpenAI and like GPT-3. Okay, so once you are comfortable with this API, I think you can do anything. Okay, so as I already showed you the OpenAI platform, even I already use different model. Even in our previous video, we also implemented one project called Telegram chatbot. So here we'll be exporting another actually variant of the model. So the model name is Whishper. So I think I showed you the Whishper, let's say introduction. What is this Whishper model? So let me show you again. So if I go back to my, let's say OpenAI platform. So here, if you go to the model section, and if you just go below, this is the Whishper model guys. So let me open it up. So you can see Whishper is a general purpose speech recognition model. It is trained on a large dataset of diverse audio, and it is also multitask model that can perform multilingual speech recognition as well as the speech translation and language identification. Okay, so this is actually a speech based model. That means you can give any kinds of speech or audio, so it will give you the transcript of that particular audio. So here what we'll be doing, let me show you the entire diagram. See, here we'll be implementing one audio transcript translation. Let's say here I will pass one audio file. Okay, it can be MP3 or any other format you can pass. I will pass to the Whishper model. Okay, and Whishper model will return a transcript of this audio. Okay, transcript, that means it is a text. The entire audio text actually it will return. Then what I will do, I will use one actually ChatCompletion model. That means here I can use any kinds of model. Let's say here you will be using GPT. Okay, GPT-3. So I'll pass this transcript to the GPT-3, and here I will provide a prompt, translate. Okay, translate. So here as an input you will pass one language. Okay, you will pass one language and it will give you that like translated text. Okay, translated text. Okay, so this is the entire actually high level diagram. So for this I will open up my local folder, and here I'm going to open up my Visual Code Studio. So this is my Visual Code Studio. Then I'm also going to open up my terminal here. Okay, I think you remember previously we created one environment like OpenAI demo. So let me activate the environment instead of creating again and again. So what I can do, I can just write conda activate OpenAI demo. Okay, so this environment I'm going to use because inside that OpenAI is already installed there, right? Fine. Now here I'm going to create a requirement file. So here the first requirement, you need the OpenAI. I think OpenAI is already installed, but here I'm adding because I want to share this material with you. So later on, whenever you want to install it, you can check the requirement.txt file. Then I also need python.env. I think you know why python.env, because we'll be managing the credential, right? That means we'll be creating a .env file And inside that, I'm going to mention my OpenAI API key. I think you remember we already created one OpenAI API key. So this is my OpenAI API key. Okay. Let me save it here. Fine. Now see here, I'm going to create a user interface. That means see this audio file, user can upload this audio file. For this, I need a web interface. Okay. Web application. So to create the web application, I'm going to use one framework called Flask. So Flask is a framework inside Python. With the help of that, you can create a web application. Okay. So let me also install the Flask here. Okay, Flask. Now simply what you have to do, open up your terminal and write this command, pip install -r requirement.txt. For me, it is already satisfied, but for you, it will take some time to install all the package. Fine. Now, the first thing, I'll show you the demo, like how we can use the Whishper model. So first of all, let me import OpenAI, and it is showing this warning because I have to select my environment. I have created OpenAI demo. Then I also need to import operating system because I want to load my env. Then .env as well. So from .env import load env. Fine. First of all, I'll load my env. So here is my OpenAI API key. os.getEnv. Then I need to add this API key inside my OpenAI API key. So OpenAI.API key is equal to my OpenAI API key. Fine. I think my authentication is completed. Now what I will do, I'll just open up one audio file. So let me show you. I have one audio file with me. So this is the audio file, guys. Let me play. So this audio actually I have recorded. Python is a high-level interpreted general-purpose programming language. It is very easy to learn, and you can use Python programming in data science. Fine. So this is the audio file actually I have recorded. So I just need to open this file. So to open this file, I think you can use this open, and inside that you can pass this name. So recording dot mp3. Okay, mp3, and again it's a binary file, so you have to give the mode rb, read binary. Fine. So it will give you one object, let's say audio underscore file. Okay, so I have successfully loaded this file. Now if you want to get the transcripts, what you can do, you can use this OpenAI Whishper model. So I'll just write OpenAI dot audio. This is audio model, I think I told you. So you have to call one function called translate. Okay, translate, and inside that, first of all, you have to mention the model name. So I want to use Whishper 1 model. So it is having different model. I want to use Whishper 1 model. Then you have to pass the audio file. So audio file. Now here, it will give me the output. Now let me print the output. Now let me show you. So guys, here is the text I am getting. Python is a high-level interpreted general-purpose programming language. It is very easy to learn, and you can use Python programming in data science. That means whatever things you can actually hear in the audio, the same thing you can see as a text. So it is like very powerful model. It will give you the accurate result always. Okay, you can try with different audio. I think you will get it. Now what I have to do, I have to translate. Okay, I have to translate this transcript in a different language. Okay, for this I'll be using GPT-3 or GPT-4 model, whatever you can use here. Okay, and we'll be creating one user application so that user can upload this audio there. Okay, this is what actually we'll be implementing. So for this, what I can do, I can create another file here. I'll just name it as app.py. Now I'll copy paste the same code. This code actually I'll just try to copy paste here, because here we are authenticating with our OpenAI only. Fine. Now apart from that, I also need to import another package called Flask. Okay, because with the help of Flask, we'll be creating this user application. Okay, that is why I'm importing Flask. So you can see from Flask, I'm importing Flask request. So redirect URL, this is not required as of now. JSONify render template. Okay, so with the help of that, actually, we'll be rendering our web page. For this, you need a basic HTML file. I'll tell you how we can create a HTML file. You can also get different template. You can also use that one. Fine. Now this next thing, I'll be initializing my Flask. To initialize the Flask, just write this code. This is the code, guys. Flask. In the parenthesis, you have to give _ name. Now you can ask me how to initialize the Flask. Go to the Flask documentation. You can see that. Okay, we can see the code snippet, the basic template they have already given. So first of all, here I'll just add one configuration. So app.config. That means whatever audio actually user will upload. So this will save. So this will save actually. First of all, let me just write upload _ folder. This will save inside a folder name static. Okay, now let's create this folder. Left hand side, I'll create a folder name static. Okay, inside that this audio will be saved. Fine, this is the idea. Now let me create a route. So I'll just give @app.route. So as you can see, this is my route. So it will look for actually two kinds of, let's say, request. One is the get request and there is like post request. Okay, if it is matching, what will happen? This will execute this function. So here I'm going to create a function called main. Okay, so this will execute this main function. So inside main function, the first thing I have to check whether it's a post request or not. So if request, okay, if request.method is equal to if it is post. Okay, if it is a post request, that means if you upload one audio file and if you click on the button, that means it would be a post request. Okay, that is the idea. If it is a post request, so what I will do, first of all, I will get the language. Okay, I'll get the language. That means user will also pass the language, like in which language he or she wants to translate this, let's say, transcript. Okay, that's why I also need to take the language input. So here I will take the input. I'll just write request.form. So from the form itself, I'll take the language. Now, how I'll get the language? Because for this, I'm going to create a HTML file. So let me create a folder here. First of all, if you're using Flask, you need to create this folder, guys, called templates. Okay, templates. Inside that, I will be creating a, sorry, it should be templates, not spelling is not correct. Now it is fine. Now inside that, I'm going to create a HTML file called index.html. Okay. Now here I have written one very simple HTML code. It will only accept the audio file. See, here I've given the title, and this is like very basic CSS code I have added here, just to like show my front end a little bit actually beautiful. That's why. Now see, it will user can upload one audio file. Okay, you can see user can upload one audio file. Input type is file, and user will also able to give the language input. That means in which language he or she wants to translate that transcript. Okay, then there would be a button called upload. So whenever they will upload, so what will happen? It will hit the post request. Okay, it will hit the post request, and that time you can see method is equal to post. That time it will hit this route. Okay, it will hit this route, and I will be able to get the language, and whatever audio actually he is submitting, everything I will get. Okay, from the backend. This is the idea only. Fine. So this is a simple HTML code. And now you can ask me why to get these kinds of HTML code. There is a one beautiful website you can follow called Bootstrap. Okay, Bootstrap. So here you will get all kinds of free HTML CSS template. You can go to the example section and see different actually template you are having. You can get their HTML and CSS code. Even you can also search. Let's say you need a file uploader button. Okay, file upload. See, different code snippet they have already given. Okay, that's how actually you can also get the code. Okay, so I just referred this website, and I actually, let's say, collected this HTML and CSS code, and I modified, okay, with respect to my requirement. This is the idea. Now I think everything is fine. Now what I will do, I'll go back to my app.py, and I'm getting the language. Then I also need the file. Okay, so to get the file, I'll store inside a file, and I'll just write request.form. Request.notForm.files actually, because it's a file type input, right? So it should be a file. You can see here I have mentioned it should be a file. Okay, it should be a file type, should be a file. Now once I get the file, first of all I will check whether this file is available or not. If file is equal to true. Okay, if this is not false, that means user has uploaded the file. That time what I will do, I'll just simply save this file. Where I will save? I'll save inside my static folder. So this is the code. I think you remember we set the configuration. Okay, static. Okay, upload file static. So it will save the inside static folder. And to save this file, I need a file name. So let's create a file name here. I'll just write file name is equal to file.filename. Okay, it will give you the file name. Now after that, you can easily save this file inside the static folder. Then I will load my audio. So to load the audio, I think remember I was using this code snippet. So I can use the same code here. Now see, this recording.mp3 would be available inside the static folder. So I need to also give the path of the static. Okay, static / recording.mp3. Now the same code I'll be writing here. I'll copy and here I'm going to paste it. So this will give me the output, that means the transcript. Here I can mention it as transcript. Okay, transcript. Now what I have to do, I have to translate this transcript to the another language. For this, I already told you here we'll be using something called GPT-3 or 4 model. Okay, so let me initialize my GPT model. So I think remember how we can initialize it. We can use ChatCompletion API. So here is the code snippet, guys. So here I'm using ChatCompletion API. Inside that I'm mentioning I want to use GPT-4 model. Okay, GPT-4 model. And this is the message I have given, role. You can see role, system, content. You will be provided with a sentence in English, and your task is to translate it to language. That means whatever language user is giving that in that particular language, then the role. So let me bring it here. I can see role, user, content, transcript.text. That means whatever text actually I'm getting after doing the, let's say, audio to text, I'm just passing it here. And here is my prompt. Okay, here is my prompt I have given to my large language model. And this is the temperature parameter, and this is the max tokens. Okay, I already explained this parameter. Okay, why it is required. Now simply what I will do, I'll just try to return this response, but I'll just try to return with the JSONify. Why JSONify? Because whatever, let's say, response you want to render in the HTML page, it should be JSON format. Okay, that's why I have to do the JSONify. So inside that I will be passing my response. Okay, and JSONify I already imported, I think you remember from here. Then if it is not a post request, okay, if it is not a post request, that means if it is a get request, what will happen? It will only render, okay, it will only render my index.html. Okay, this index.html, that means my web app. Okay, my web app menu, it will open in front of the user. This is the idea. And to render it, I'm using render template function. You can see I've already imported it here. Now if I want to execute my application, so you can execute it here. For this, you have to give the app host and app port. See, app.run host 000. That means I want to run in my local host, and debug is equal to true. That means if you change anything, it will automatically update the changes. And this is the port number 8080. Now let me execute and show you this application. So I'll open up my terminal. And now if I execute, let's say Python app.py. Now see, it is running on my local host. Now let's go to the Google and search for localhost port number 8080. Now see if I search. So guys, you can see this is my interface. Okay, interface of my application. Now here you can upload any kinds of audio file. Now let's upload. So let's say I want to upload this audio. Now language, let's say I want to translate in a Hindi. Okay, Hindi. Now let's upload it. Now see guys, this is the response I got. And this is my response. You can see this is the Hindi translation. Okay, this is the Hindi translation. Whatever actually I had in my audio. Now you can also give any other language. Let's say again I will pass my audio. Let's say I want to translate let's say I want to translate in Bangla. Okay, Bengali. Now I'll upload. See, this is the Bengali translation I'm getting. Okay. Now you can also extract the content only. Instead of let's say getting all the response, but I have printed all the response. I just wanted to show you each and everything, whatever things it is returning. Okay, I already showed you how we can extract out this content. Okay, from my previous session, remember. Fine. So yes guys, that's how actually we can implement this project, and we can use the Whishper model. Okay, now what you can do, you can improve this project. You can add some more functionality. Let's say you want to again convert this text to audio, you can also do it. For this, just go to the Whishper documentation and try to check there. Okay, so I hope guys you like this project. So if you have liked this project guys, so please try to subscribe to the channel and share this video with your friends and family. So I already showed you OpenAI is having different actually large language model, like different kinds of large language model, like language model, multi-model, okay, image model, like different model actually it is having. So we'll be using another model. This is called actually DALL-E. So DALL-E is having different like version, like DALL-E 2 is there, DALL-E 3 is there. So we can use OpenAI API to access this model. Okay, so let me show you this DALL-E model. So guys, if you go to the OpenAI documentation, so here you will see this DALL-E model. Let me show you. So this is the DALL-E model. So as you can see, DALL-E is having different kinds of let's say version, like DALL-E 3, then DALL-E 2. Okay, so different version it is having, and DALL-E is one of the model. Actually it can create actually realistic image from a prompt. Let's say here you will be passing one like text prompt, and with the help of this prompt actually it will generate the image. Okay, the prompt you will be asking the same kinds of image actually it will try to generate, and this would be realistic image. Okay, now let's see how we can use OpenAI API to access this DALL-E model, and let's build one image generator application. So what I will do, guys, I have used the same template as I already used in my previous project implementation. I think you remember we are using Flask there. So I used the same template and I just did little bit modification here. So the modification I have done, the entire HTML code. Okay, I've done the modification. So let me show you the application, like how it will look like. Let me clear. Now if I open up my app.py again, so let me go to Google and localhost port number 8080. So guys, you can see this is the interface of my application. So to build this interface, I have actually collected this HTML and CSS code from the Bootstrap website. I think I showed you that Bootstrap website, right? So you don't need to do anything. Only you can change the title and all. Okay, everything you can keep it as default, because you can use this HTML and CSS code as a template. Okay, let's say you want to build any other application with the same template, you can use this code as it is. Okay, if you're not familiar with HTML and CSS code, it's completely fine. You can copy paste from different website. Okay, now the second changes I have done, I've created two route. One is my default route. That means if user is hitting my let's say default route, that means port number 8080, so he will get this kinds of landing page. Okay, and to render the landing page, actually I'm using render template index.html. Okay, and whenever user is giving any kinds of prompt and they're submitting, okay, submitting button, so it will hit this route and it will generate and it will execute this function, and this function will take the prompt, whatever prompt actually user is giving here. I think you can see. Okay, and this prompt will go to the OpenAI DALL-E model. You can see to use the OpenAI DALL-E model, you have to use this code snippet OpenAI.image.create. Okay, now inside that, just try to mention the prompt, number of images you want to generate, just give the number of images and the size of the image. Okay, everything you can set here. Now I'm printing the response as well as the, and here you can see I'm also rendering on my user interface. Okay, and again I'm running on localhost and port number 8080, and debug is equal to true, means if you are changing anything, this will reflect automatically. Fine. So this is the simple modification I have done, guys. Otherwise everything I kept default. Okay, everything I kept default, whatever things we have implemented in our previous project. So yes guys, I think you got it. Using OpenAI is like very easy. Only you just need to know how we can access different model. Rest of the things you can take care. Okay, let's say if you want to create any kinds of application, you have to design how you'll be creating. Okay, otherwise the fundamental will remain same. Now let me show you the demo, guys. So what I can do, I can give a prompt here. Let's say I'll give a dog is flying and smoking. Let's say this is my prompt I have given. Let's see whether it is able to generate the image or not. You can give the same prompt in the ChatGPT also. Let me show you. ChatGPT is also using this kinds of image model. Recently they have published one model called GPT-4o. Okay, GPT-4o. So this model is able to actually create this kinds of image. Okay, from your prompt. Now let me pass this prompt. A dog is flying and smoking. See, it is generating two response. And let me see this one. Actually it has generated. Okay, this is a cartoon version. Even you can also generate the realistic one. Let me show you another prompt. So guys, this is the prompt I have prepared. You can see dream like a beautiful girl playing the festival of color, draped in the traditional Indian, throwing the colors. Okay, now let me send and let me see the response. And if I go to the ChatGPT, see, this is the ChatGPT response. Fine. See, this is the output actually we got. Okay, it's amazing. You can see. So you can give different prompt like that, and you can generate image, and you can also control like how many images you need. So here I mentioned, I think you saw only 5 images. That's why it's giving 5 images. Okay, and you can also mention the size, everything you can mention. So yes guys, this is the application we have developed. I hope you liked it. And now what you can do, you can improve this application. You can add some more functionality. See, I think the previous application we created, that Whishper model, what you can do, you can integrate like both application in one place. Okay, and you can create a complete platform. Okay, that thing I think you can perform. Okay, this would be a good project for you. So yes guys, this is all about from my side. Please subscribe to the channel and share this video with your friends and family, and please support the channel, guys. If you support the channel, so definitely we'll be bringing up these kinds of content, okay, for you, and you can let us know what kinds of content you want, okay, from my end. I'll try to provide. So I think as of now, we have worked with large language model. I have showed you the Hugging Face platform. Even we have also worked with the OpenAI platform. There we use different large language model. And whenever I was using these kinds of large language model, I think you noticed I was passing the prompt. Okay. Again, if I'm talking about ChatGPT, Google, but whatever application you can see in the field of generative AI, all the application takes the prompt as an input. Okay, based on the prompt, it will decide what kinds of output it should generate. Okay, that means prompt is everything inside large language model. Okay, whatever, let's say, large language model you are using, whatever generative model you are using, prompt is everything here. Okay, you have to give a proper prompt to get a proper answer. Otherwise, you will be getting random kinds of answer from your large language model. Okay, so that's why there is a separate concept inside generative AI called prompt engineering. Why prompt engineering? Because whenever you are writing these kinds of prompt, you have to know some technique. Okay, how we can design this prompt efficiently so that I can get the output, I can get the effective output, I can get the, let's say, useful output from my large language model. Okay, otherwise what is the use of large language model if it is giving you, let's say, random kinds of output? Fine. So that's why we'll be learning about this prompt engineering. And make sure you are watching this video till the end, because in this video we'll be covering each and everything you need to master about prompt engineering. So guys, as you can see, what is prompt engineering? Prompt engineering is nothing but, prompt engineering is the process of structuring an instruction that can be interpreted and understood by a generative AI model. That means I already told you na, inside generative AI, prompt is everything, and whatever prompt actually you are giving to the generative AI model or your large language model, okay, this should be well structured. Okay, this should be well structured and well organized. Okay, otherwise what will happen? Your model will give random kinds of output. Okay, that is why here I have written the definition what is prompt engineering exactly. Okay, I hope it is clear now. Now, as a generative AI engineer, you should have some responsibility whenever you will be working with the large language model, whenever you will be preparing the prompt and all. See, here I have listed down some of the points. Write, refine and optimize prompts. Perfect the interaction between humans and AI. That means you always need to make sure whether your prompt is perfect or not. Okay, to communicate between human and AI. That means you will be communicating with your AI assistant. Let's say whatever, let's say, application you are having with the help of large language model. Okay, there is a good interaction or not. Okay, the prompt actually you have given, you have to always make sure. Continuously monitor those prompts. You have to continuously monitor those prompts whether this prompt is perfect or not, and is there any change in the model or not. Then maintain and up to date the prompt. That means if, let's say, model got updated, let's say they again did the fine tune that particular model, and if, let's say, previous prompt is not working better, in that case what you can do, you can maintain and update that particular prompt for that large language model. So these are the key responsibility you should have as a generative AI engineer. Now let's try to understand why prompt engineering. Okay, so for this I'm going to show you one demo. I think this demo will give you the clear-cut idea why prompt engineering is super important if you want to work with the generative AI. So here you can see I have written a prompt. You can see this is a prompt I have written. Correct my paragraph. Today was the great day in the world for me. I went Disneyland with my mom. It could have been better if it wasn't raining. You can see some of the spelling mistake is there. That means grammatical mistakes are there in this paragraph I have written. So what I'll do, I'll give this prompt to my, let's say, large language model. So large language model wise, here I'm going to use ChatGPT. Okay, you can also use Google Bard or any other, actually, let's say, model. It's completely fine. But just to show you the demo, actually, I'm going to use the ChatGPT platform. Later on, whenever, let's say, we'll be implementing different, let's say, application with the help of large language model, that time actually we'll be using this prompt with the help of Python code. Okay, as of now, just to show you the demo, I'm going to use the ChatGPT application. So guys, as you can see, I'm inside my ChatGPT. Now, let's say if I give this prompt to my ChatGPT, now let's say if I send it here, see what will happen. See, it has given me straightforward results without, let's say, explaining this like paragraph I have given, without, let's say, asking me any kinds of question. It has given me straightforward answer. So here is my paragraph, and here is the correct of my paragraph, correct version of my paragraph. Today was a great day for me. I went to Disneyland with my mom, and it could have been better if it wasn't raining. Okay, you can see. So here you can see this grammatical mistake I did. It is resolved, okay, by my large language model. Now let's say you are learning about English language, you are learning about grammar, you are learning about, let's say, spelling and everything. Like that means the complete, let's say, English guidance you want, okay, from your mentor. But as a mentor wise, what you want to use the ChatGPT, let's say, your large language model. That time, instead of giving this kinds of prompt to the large language model, what you can give? So instead of giving the prompt like that, you can design your own prompt in an effective way. So let me show you another example. So guys, as you can see, this is the next prompt I have designed. So here is the prompt, guys. I want you to act as a spoken English teacher. I will speak to you in English and you will also reply to me in English to practice my spoken English. I want you to keep your reply neat, limiting the reply to 100 words. I want you to strictly correct my grammar mistakes and typos. I want you to ask me questions in your reply. Now let's start practicing. You could ask me a question first. Remember, I want you to strictly correct my grammar and mistakes, typos and factual errors. Okay, so this is the prompt I have designed. Okay, see, previously the prompt I have given, it was like very straightforward prompt I had given, right? But now what I did, I just designed one very powerful prompt here. Now see, what should be the response from my large language model right now? So let me give this prompt to my large language model. This is the prompt, guys, the same prompt I have given. Now let me send. Now see, it is giving me great. Let's start with a question. What is the most interesting place you have ever visited, and why did you find it so fascinating? Okay, now let me give the answer. Let's say the most interesting place I visited, India, because I loved Indian food. Okay, now you can also do some grammatical mistake. Let's say here I'll just write like that. Okay, now let's say this is my response I have given to my model right now. See, my model will try to correct. First of all, you can see here is the correct version. The most interesting place I have visited in India because I loved the Indian food. Now see the reply you have given. So there actually lots of spelling mistakes were there. There are lots of actually grammatical mistakes were there. Now it has corrected everything. Now as I learned that, you can easily get to know, okay, so that's how actually you have to write this particular sentence. Okay, now you don't need any kinds of actual actually English teacher. Okay, with the help of these kinds of large language model, you can easily learn these kinds of syntax. Yes or no? Fine. Now again, it is, you can see it is asking me one question. Can you tell me more about your favorite Indian dish? That means now this conversation is like more interactive. It's not like straightforward answer it is giving me. It is like more interactive. The way actually human communicate with each other. Yes or no? Now, yes, I can give another response. So here I can give, I loved chole bhature. Okay. Now let's see the output. So here is the correct version. I love chole bhature. What do you like most about chole bhature? Okay. So here I can write the puri. Now see, this is the correct version. I like the puri. What do you enjoy about the puri? Okay, now see, this conversation is more interactive. Now you can just keep on replying to the question actually this model is asking. That's actually you'll be learning about the correct, let's say grammar, correct, let's say spelling and all. Yes or no? Now see, with the help of just only one simple prompt design, I got like very interactive output from my large language model. Okay, this is called actually prompt engineering, and that's why it's useful. Okay, that's why it is important, because sometimes whenever you'll be creating any kinds of application, any kinds of LLM powered application, that time you have to design the prompt in such a way so that it can give the correct answer to the audience. Even it can be more interactive to the audience. That means those who are using your application, so they should enjoy your application. Yes or no? So guys, that is why it's like very interesting concept, and it's like very important concept inside generative AI you have to master. Now see, to master the prompt engineering, the first thing you should know about the linguistics. Okay, what is linguistics? Linguistics is nothing but it's a study of language. That means whenever, let's say, you are studying any kinds of language, let's say English language, inside English language you are having some kinds of let's say linguistics. Okay, what kinds of linguistics? You can see phonetics is there. So phonetics means the study of how speech sounds are produced and perceived. Okay, then there is another one called phonology, the study of sounds pattern and changes. That means whenever we are speaking any kinds of, let's say, language, like how this sounds look like. Okay, how this sounds look like, how you are pronouncing this particular word and all, this is called actually phonetics and phonology. Got it? Then there is another one called morphology, the study of word structure. Then there is another one called syntax, that means the study of the sentence structure. That means whatever grammar you usually learn inside English. Then you have also having the semantics, that means the study of the linguistic meaning. Then the next one is pragmatics, the study of how language is used in the context. Then historical, the study of language change. then so on. Okay, you can see these are the actually linguistics are available to study about the language. Okay, and if you have good knowledge, on these kinds of, let's say, linguistics, definitely you can design a very good prompt for the large language model. So that's why I have written here, linguistics are the key to the prompt engineering. That means if you are having good knowledge about linguistic, definitely you can design a good prompt for the large language model. Now we have already studied about like large language model or our generative AI model, right? So there are different kinds of generative AI models are available, like GPT, BART, then Lambda, Palm, Bloom, Llama, Cloudy, okay, then Nemo LLM, okay, Generate. So these are the actually, apart from that, like there are so many large language models are available. I think I showed you one GitHub, right? I think remember Open LLM GitHub. There I think you saw thousands of large language models were there. And these are the provider and vendor, okay, like those who are created this, these are the actually large language model. See, on kinds of large language model over the internet, all the large language model accept this prompt. Okay, that means you have to give the prompt there if you want to use this kinds of large language model. Okay, because this large language model is already trained with huge amount of data, huge amount of unstructured data. Even they also did something called supervised fine tuning. They also applied something called reinforcement learning technique to improve the quality of the model. That means this model is also trained with the instruction, lots of instruction. That means they did the chat operation with this model. I think I showed you one in one video, one of my video, I already explained how ChatGPT were trained. Okay, so that's why whenever they trained with this kinds of instruction data, that means they are passing the prompt. And whenever you want to use this particular model, you also need to provide the prompt. I think now it is clear why this prompt engineering is super important. And whenever you want to use any kinds of large language model, why you have to use the prompt engineering technique. That means why you have to give the correct prompt always to the large language model. Now let's learn about some best practices to design a prompt. See, if you want to design some best prompt for the large language model, you have to keep some of the point in your mind. Let's say the first thing, clear instruction. Definitely you have to give the clear instruction to the large language model. Then adopt a persona. Then specify the format, avoid leading the answer, and limit the scope. Okay, so these are the things actually you have to always remember. Now let's open our ChatGPT and let's try to see some of the best practices. Okay, we can perform whenever we're giving any kinds of prompt to the large language model. So guys, let's say if I give a prompt here, let's say I'll give when is the election. Okay, when is the election? Let's say this is my prompt. Okay, now see, if I pass this prompt to my large language model, let's see the output. It depends on which election you are referring. See, election can be vary by the country, definitely, because it's the correct one. Now you are asking what is the election, but you are not clarifying. Okay, you are not clarifying in which country you are referring. Okay, that means you have to always pass a clear prompt. Okay, clear instruction to the large language model. Now see, I can give this prompt like that: when is the next president election in USA. Okay, now see, this prompt is clear and it is like well organized for my large language model. Now see, if I pass, now see, this is the answer. The next US president election is scheduled for the November 5th 2024. Okay, now I'm getting the correct answer from my large language model. But whenever you are not giving any kinds of clear, let's say clear let's instruction to the model, it will give you unnecessary output. And again, it's a chargeable, because whenever you are using ChatGPT or let's say any kinds of let's say commercial large language model, it is charging based on the token, input and output token. I already showed you, okay, how it will count the token and how it will charge. So whenever you are getting these kinds of unnecessary output, that means unnecessary you are spending your money, yes or no? Okay, so that's why whenever you are using these kinds of commercial large language model, make sure you have the proper prompt, so that in just one prompt you will get the actual output you are looking for. Okay, this is what actually you have to always remember. Now let me give you another example. I'll just write a code to filter out the ages from data. So let's say this is my prompt I've given. Now see, my LLM model has given me this is the output. But let's say you are looking for Java code. You are looking for Java code, but it has given you the Python code. Again, what you have given? You have given actually uncleared instruction to the model, yes or no, right? So you have to give the clear instruction always. Now you can write this prompt like that. Write a Java code okay, to filter out edges from the data. Now see, now it is the clear instruction to my large language model. Now I will get the Java code. Now let's see the next one, like the adopt the persona. Okay, like what is the persona exactly? Whenever you are giving any kinds of, let's say, instruction to the model, what kinds of persona you have to adapt there. Let's say this is one prompt I'm giving to my large language model. Write a poem for a sister's high school graduation that will be read out to the to family and close friends. Okay, let's say this is my instruction I have given to my large language model. Now see, here is the response I will get. So here is the response I got. That means this is my poem. Now if you read this poem, actually this is not actually much interesting, the poem actually I was looking for. Now what you can do, you can actually give the persona. Okay, you can give the persona whenever you are giving the prompt. So now let me show you another prompt I have designed for this. So this is the prompt, guys. Now here I am writing, write a poem as Helena. Helena is a 25 years old and amazing writer. Her writing style similar to the famous 21st century poet Rupi Kaur. So I think you know about Rupi Kaur. You can also search about Rupi Kaur. See, she is actually a Canadian poet and illustrator. Okay, you can read about her. Now see, writing as a Helena, write a poem for her 18 years old sister to celebrate her sister's high school graduation. This will be read out to the friends and family at the gathering. Okay, now see, this is the prompt actually I've given. Now see, if I send it, if I send this prompt right now, now see the response actually I got here. Now if you read this poem, actually it is too good. It is too good than my previous response I got. Okay, so that's how actually you have to adapt the persona always. You have to adapt the persona, what kinds of things you are looking for. Now see, this large language model is already know about Rupi Kaur. Okay, because it is already trained. It is already trained, let's say around 2022 data. Okay, till 2022 data it has already trained, and in that data actually Rupi Kaur poem was there. Okay, that's why you all that's why this model is already known about Rupi Kaur, and it is trying to get the similar kinds of, let's say, poetry. Okay, whatever, let's say, poem actually Rupi Kaur used to write. Okay, the same actually syntax context actually it is trying to, let's say, gain. Now the next thing, you can also specify the format. Let's say what kinds of format you want as a output. Let's say what I will do, I will give you one example for the summarization. Let's copy one English story here. So let's say this is one English story. I'll just try to copy the entire story. And here I'll go to my ChatGPT and I'll just write, please summarize this story. Okay, summarize this story. Now I can pass the entire story here. Now see, I can send it. Now see, it is giving me the summary, but see, this summary again, it's a paragraph. Okay, it's a paragraph. Now I can also specify the format. Let's say I'll give, I want, I think I can copy the same instruction. Now here, just try to modify. Please summarize this story in bullet point. Okay, bullet point. Now see, I'm specifying the format. Now see, if I pass this, now see, it will give me inside a bullet point. Okay, now see, it's like more readable. Nah, it's more readable. It is giving me some actually important actually summary of this entire story. It is trying to return me. Okay, so that's how you can provide any kinds of format you need. Let's say you need a data and you need a JSON format data. You can also provide, I need a JSON format data. Okay, you can pass the prompt and it will give you that. So that's how actually whenever you are designing your prompt, you have to always keep these are the point in your mind. Okay, the point actually I listed down in my presentation. I think you saw that, right? Now there are some types of prompt are available. So the first type you can consider zero shot prompting, and the second type actually few shot prompting. Apart from that, actually there are like some types of prompts are available like emotional prompting and all, right? But this is not actually required. But if you want to create any large language powered application, so this two prompt actually very famous. So I have seen like people are using this to prompt a lot, like few shot prompting and zero shot prompting. So let's explore this zero shot and few shot prompting in the example. So again, I will go to my ChatGPT. Now, first of all, let's write the zero shot prompting. Zero shot prompting means you are only asking the instruction, because see, this ChatGPT is already trained with huge amount of data. So this ChatGPT has already like lots of knowledge about, let's say, the data over the whatever data they have trained. Now let's say I will ask one question: when is the Christmas in America? Now see, Christmas in United States celebrated on December 25th each year. Okay, now it is giving me the answer. So this is called actually zero shot prompting. That means you have only give one prompt. Okay, one prompt, that means the instruction you have given, the question you have given. Okay, but let's say if I ask these kinds of question, now let's say if I ask this kinds of question, what is Bappy's favorite types of food? Okay, let's say this is the question I have given. Now see, it will give you, I don't have the information about Bappy favorite types of food. Could you please provide more details, clarify to who is Bappy? Okay, now see here actually zero shot prompting is not working. So here you have to pass the few shot prompting that time. Okay, now see here I'll give a prompt. Now I'll just write Bappy is a data scientist and his favorite types of food are, or you can write food includes, let's say, burgers, pizza, okay, and chicken. Now I can pass this prompt to my large language model. Now it will learn about me, okay, because I have given a few short prompt here. Okay, now see, got it. Bappy favorite types of foods are burger, pizza, chicken. And if you need any more details or have a questions, just let me know. Now here I can give another prompt. What is the, or I can write what restaurant. Now let's say this is the prompt I have given. What restaurant should I take Bappy to in Dubai this weekend? Okay, now see if I pass. Now see, it will suggest me some restaurant. Dubai has fantastic range of restaurant that caters a variety of tastes, since Bappy like burgers, pizza and chicken. Here is the few recommendations. So here is the restaurant. Now see, this is called actually few shot prompting. That means you are also giving some few shot prompt. That means some let's say information about the question you are asking. Okay, this is called actually few shot prompting. So these are the thing, guys, you have to master. So see, this prompt engineering will come automatically whenever you will be writing this kinds of prompt. So unless and until you are not writing, you are not experimenting, you won't be able to understand, okay, which prompt will give you what kinds of output. So try to practice a lot. Okay, you have the ChatGPT, you can give different prompts and you can get the response from the ChatGPT. And the prompt actually you are giving to the ChatGPT, the same prompt you can use to any kinds of large language model. Okay, in future you will be using, whether it's a let's say Gemini, whether it's a, let's say, Mistral, Falcon, whatever, let's say, your model you are using, you can use it as it is. Fine. Now there is another concept inside actually generative AI model called AI hallucination. Now what is an AI hallucination? See, AI hallucination is when a large language model generates false information. That means, let's say you are giving a prompt and that model is giving you the false information. Okay, so this is called actually AI hallucination. That means the prompt you are asking, the information you are asking, this information is not available to the large language model. Okay, so that time what we have to do, if we are getting this kinds of hallucination, so that time we can use something called RAG concept. That means retrieval augmented generation. That means we can connect our external data source to my large language model. Okay, and from that data sources my model can learn, okay, this is the information you are looking for. And if RAG is not working, that time what we can perform, something called fine tuning of a large language model. I think I showed you. Now we can perform fine tuning with the help of Huggingface. Okay, so I'll also show you how we can fine tune different kinds of large language model on top of our custom data. We can also perform fine tune operation. But fine tune is a costly task because here you need a good system, like lots of data. Okay, so again it's like very costly task. But RAG application is a very easy kinds of task. See, here you don't need lots of cost, here you don't need lots of computational power. Okay, so both will be exploring one by one, like what is RAG concept and what is, let's say, fine tuning concept, everything will be exploring. Okay, so yes guys, this is all about our prompt engineering. Now I think you got it why prompt engineering is super important and how you can master this kinds of prompt engineering technique. Okay, it's nothing but it's just a way of, let's say, communicating with your large language model. The input you are giving to the large language model, this is called actually prompt. Okay, and the way you are designing this particular prompt, this is called prompt engineering. Okay, I hope it is clear now. See, if you want to learn, if you want to master generative AI, if you want to work with the large language model, so this is super important concept you have to first of all master. And this is called actually vector database, because see, whatever, let's say, data you will be using, whatever documents you will be using, let's say, to work with your large language model. So first of all, what you have to do, you have to convert the documents to the embedding representation. I think I already explained like what is embeddings, right? So my model can't take the English input directly. So for this, I have to create some number. Okay, that means I have to generate the embeddings, I have to generate some vector. And after generating these kinds of embedding and vector, we have to store these are the vector to a databases, because I have to connect my large language model with these kinds of databases. Okay, so this is called actually vector databases. Okay, I hope it is clear now. So no need to worry, I will give you the entire idea of this vector database, like what vector database is. Even I will also show you the different practical with different vector databases. So here we'll be covering almost all the famous vector databases, whatever let's say people are using broadly in the market. We'll be covering all of them, no need to worry. And guys, to show you this vector database demo, I'll be using one framework called Langchain. So Langchain is a generative AI framework. With the help of Langchain, actually we can build different generative AI based application, because inside Langchain actually all kinds of vector database functionality are already available. Okay, so that's why I'm going to use Langchain throughout the entire, let's say, a series of this vector database. But if you're not familiar with Langchain, no need to worry, go through this tutorial and try to implement whatever things I'm implementing. So after this vector database series, I will start the complete Langchain series as well. So there actually will be starting from very basics of the Langchain, even we'll be covering till advanced part of the Langchain. Okay, we'll be learning each and everything. As of now, let's say as a code wise, just try to understand, okay, what are the functionality actually I'm using from the Langchain and try to implement with me. And make sure whenever I'll be installing any kinds of package on my Collab notebook, try to see the version. Okay, try to see the version of that package, because today actually I'm creating the video. I know that because this is a completely research field. So some of the functionality they will change in their package, and then you will get some issue. Okay, you might get some issue, you might get some error. So make sure whatever, let's say, version I'm installing on my notebook, try to also install the same version. And if I'm not mentioning the version, okay, with the package, what you can do, so whenever I will show you the installation, below in the console you will see the version. Okay, like what is the Langchain version, what is the OpenAI version, what is the, let's say, vector database version. Okay, just try to see the version, try to just note it down and try to install the same version. It will work, because see, it's a completely research field. Every day they are updating their package and all. So I know that if you're learning something today, so tomorrow actually they will update that package and you might get some issue. Okay, so that's why I'm telling you guys, always try to use one specific version. Okay, if you're using a specific version, so you won't be having any kinds of issue, because you know that this version will work fine. Okay, the code you have implemented. So that's why just try to see the version, whatever version I'm installing. See the console of that Collab notebook. There actually will see all the version has been written. Okay, for all the package. So note it down and try to install the same version. Now let's try to see what are the topic actually we'll be covering through this vector database series. So guys, as you can see here, first of all, we'll be learning about vector database, like the in detail explanation of the vector database, what is vector database, how it is work and all, everything we'll be learning. Then we'll see that why we need the vector database, how vector database works, use cases of the vector database, then some widely used vector database we'll be also learning. Then at the last of the series, actually we'll be also doing the practical demo with the help of Python and Langchain. As I already told you, we'll be using Langchain framework to work with the vector database. Okay, now let's try to see what is vector database is. See, vector database is nothing but a vector database is a database used for storing high dimensional vectors such as word embeddings or image embeddings. So I think you already know that we are having lots of unstructured data and higher dimensional data like documents, image, PDF. Okay, then we are also having audios, videos and so on, right? So this is called actually unstructured high dimensional data. So what we have to do inside vector database concept, we just need to first of all convert these are the higher dimensional documents to the higher dimensional vector. You can see we are converting these documents to a vector representation, and this vector actually we are storing to the database, and this is called actually vector database. Okay, that is why here I have written a vector database is a database used for storing high dimensional vectors such as word embeddings as well as the image embeddings, because I think you already know that inside generative AI we are having textual data as well as the image kinds of data, that means video data, audio data and so on, right? So that is why you can consider any kinds of data, and whenever you're considering any kinds of data, it will have some embeddings, and that particular embedding you have to save to the vector database. So this is the introduction of vector database. I think it is clear. Now you can ask me like why we need this kinds of vector database, because we have lots of existing database are available in the market. Now to give you the answer, actually I want to show you one example. So first of all, let's see like why we need this kinds of vector database. Because if you see over like 80 to 85% data out there is unstructured data. Like we have images, we have videos, we have text and we have audios. Okay, so these are the data actually unstructured data. So we can't easily store these kinds of unstructured data to the relational database, or let's say our traditional database. Like we have MySQL, then we have PostgreSQL, then we have SQLite. So these are actually relational database, and these are actually traditional database. So we can't directly store, these are the data. So we can directly store our unstructured data to these kinds of relational or traditional database. Okay, why we can't store? I will show you one example. It would be very much clear. So guys, to give you one example, let's take one image data as an example. So let's say I want to store these kinds of dog images to our relational or our traditional database. So if I want to store it, I can't directly store these are the data to our relational database. Okay. So if I want to store it, so what I need to do, I need to create some of the schema. Let's say I have some schema here. I have some table. So in this table, let's say I have one column called animal. Okay, animal. Then I have another column called color. Okay, then I have another column called tags. So basically you need to manually label them to store these are the images. Okay, if you want to identify similar kinds of images, if you want to apply the query on top of that, then you need to create these kinds of schema manually. Now here you just need to set those parameter manually. Let's say animal wise it's a dog. Okay, it's a dog. Then color wise, let's say it's black, or let's say I can, and color wise you can give any color, let's say golden. Okay, this is the golden dog, golden dog. Then we have, let's say, black dog as well. Okay, black dog, you can give anything based on your image actually you are trying to store. Then you also need to assign some of the tags. Let's say this is very cute. Let's say this dog has black eyes. Okay, black eyes. So these are the tags actually we'll be assigning manually. So what happens actually, so whenever you assign these kinds of schema manually, so what happens, let's say you want to query the similar images, okay, from the database. So you just give these are the parameters, so it will return these are the image for you, okay, based on the tags actually you have written, based on the schema you have prepared, right? But again, it's a manual thing. Okay, it's not an efficient way to store our data, and it's not an efficient way to like query out our data, because let's say I want similar kinds of image, so I need to assign these are the labels manually, and it's like very hard task for us, right? So that's why actually we can't use our traditional, or let's say relational database for these kinds of unstructured data. We can easily use these kinds of relational database for the structured data. Let's say we have CSV data, we have Excel data, but for these kinds of unstructured data, it's like very much difficult to store these kinds of data, right? You can store them, there is no issue, but the thing is, like, whenever you will be querying out from your database, let's say you want similar kinds of dog images, at the time it would be very much difficult, because if I, let's say, convert this image to base64 string, so using base64 string I can easily store the data to the relational database. But I'm talking about whenever, let's say, you are applying query on top of that, let's say you want similar kinds of dog images from this database, at that time it would be very much difficult for you to querying out, because it doesn't know like whether this base64 string is a dog image, or let's say it's a cat image, or let's say it's a horse image. Okay, it doesn't know. So there is only one option to filter out these kinds of images. The thing is, like, you need to create one manual schema, like these kinds of tags you need to generate, you need to label out these are the images. Using that actually you can filter out these kinds of data, but again it would be very hard approach, as I already told you, because you need to apply manual observation here. Now guys, I think you already got the idea like why it is difficult to store these kinds of unstructured data to the relational database, because as you can see, image is nothing but it's a pixel, and your relational database doesn't ever know like how to query out similar kinds of images using these kinds of pixel, right? So guys, this is the one major problem with these kinds of relational database whenever we are using unstructured kinds of data. So guys, whenever I'm talking about unstructured data, it is not only image data. So it can be video data, it can be text data, and it can be audio data as well. So guys, to overcome this issue, there is a concept introduced called vector embedding. So let's say we have unstructured data. Let's say we have image, we have text, and we have audios, and it can be also videos. So first of all, what we need to do, we need to apply something called embedding model. Okay, so embedding model is nothing but it's a neural network based model. It's a deep learning model. So using this embedding model, first of all, you will be generating some of the embeddings, or let's say vectors. Okay, let's say this is my image. We have applied embedding model. Embedding model will give you vectors. Okay, like this is the representation of the image. Okay, this is the numerical representation of this image. It can be also applied to the text data. So you see here I'm giving the text data, and this is my embedding model, and it is returning this kinds of vector. Again, you can also put audio data, so it will convert to the numerical representation, and this is the representation of the audio. So here if you see, embedding model is nothing but it's a neural network based model. Here you can use any kinds of embedding model. Let's say we have what to wake, then we have transformer based embedding model as well, right? So these are the things actually you can use. So if you're already familiar with NLP, that means natural language processing, I think you have heard of like what to wake, then you have heard of like transformer embeddings. Okay, and nowadays actually we have large language model based embeddings, like we have OpenAI embeddings, we have lots of open source LLM based embeddings as well. We have Huggingface embeddings as well. So using these kinds of embedding model, we can easily generate these kinds of vectors and we can store them in a vector database. So guys, this is the entire idea on top of this unstructured data, like how we can store these kinds of unstructured data to the vector database. So first of all, what we are doing, we are just trying to convert these are the unstructured data to the vectors, vector representation. Then we are storing these are the vectors, okay, to the vector database. So guys, here is an example you can see. So let's say we have text unstructured data, and here you can use any kinds of embedding model. So in this case, actually, I have referred this OpenAI embedding model. So it is already trained on GPT model, okay, GPT-3 and 4 model. And if you put these kinds of unstructured data to the embedding model, it will give you these kinds of vector, okay, these kinds of vector representation of all the text actually you have in the documents. Then once you got this vector, actually this vector embedding, then you will be using some vector database. It can be anything, any database you can use. So here you can store one by one, these are the data, okay. So this is the complete idea of this vector database. Like instead of directly storing our text data to the database, first of all, what we are doing, we are taking help from the embedding model, and using the embedding model, we are trying to generating these kinds of vector embeddings. Then we are storing these kinds of vector embeddings to the vector database. And guys, this kinds of vector database has one beautiful function called similarity search. So using this similarity search functionality, it can return you similar kinds of vector represented in the vector database. Okay, I will show you this similarity search as an example, like how it is doing actually similarity search. Now guys, you got to know like what is embedding, but you don't know like how these embeddings are generated. So to give you one example, I will open my whiteboard and there I will try to make you understand. So guys, I'm inside my whiteboard, and here first of all what I will do, I will take one pen, and here I'll be using unstructured data, unstructured data as text data. Here I'll be using text data to give you the example. So first of all, what I will do, let's create one table here. So let me create one table. So guys, let's say I have taken one table here. So here we are using one embedding model. So let's say we are using one embedding model to convert our text to numbers. So here you can use any kinds of embedding model. You can use OpenAI based, you can use what2vec, you can use large language model based, you can use anything here, okay. Now whenever let's say I have some words here. So let's say I have something called king, then I have something called queen, then I have something called man, and I have something called woman, then I have some let's say monkey. So let's say I have 5 words here. Now what this embedding model will do, it will try to generate some of the features on top of the words, okay. Let's say this is my features column, okay. So what kinds of features actually it will generate? Let's say it can generate anything. Let's say it can generate gender, it can generate wealth, it can generate power. Because this is a neural network based model, we can't say like what are the features actually it will generate, because it will generate these are the features based on the back propagation. So it will calculate the loss and all. Based on that, actually it will try to find out the best possible features, okay, for these kinds of work. So here I'm just giving one example, that's why I'm taking these are the features, okay. But it might not like generate these are the features, but to give you one example, I will be using these are the features. Now let's say it will generate weight, and it can also generate something called speak, okay. Now what happens actually, based on the features, actually it will assign some of the value. Let's say here my first word is king, okay. Now king has gender or not? Yeah, king has gender, and the gender is like male, so it would be 1. And for queen, yeah, queen has also gender, so it would be 0 because queen is a female. So similar wise, man has a gender, so it will have 1. And woman also has gender, so it would be 0 because it's a female. And monkey, let's say it's a male monkey, so I'll assign it 1, okay. Now it will come to the next features called wealth, okay. Now here you can see king has wealth, right, because he's the king and he has lots of wealth, so it would be, let's say 1. I'll assign it as 1. Queen will also have wealth because queen is also part of king. And man will also have wealth, but it would be less than king and queen, so let's assign as 0.5, and women will have also wealth but less than man, so here I can give 0.3. Monkey doesn't have any wealth, so I'll give as 0. Okay, now king has power, so I'll give 1. Queen has also power but less than king, so I'll give 0.7. Man has also power, let's say man has power but it's less than king, so I'll give as 0.5. Woman has also power but it's less than man, so it would be 0.2. And monkey doesn't have any power, so I'll give as 0. Now weight, yeah, king has also weight, so I'll give 0.8. And let's say king is a little bit obese. Queen has also weight, so I'll give as 0.5 because let's say queen is slim and all. Man has also weight, so I'll give it as 0.7. Women has also wealth, I'll give 0.5. Weight is fine, I think. Monkey also has weight, let's say 0.3. Now king can speak, so I'll give 1. Queen can also speak, I'll give 1. Man can also speak, I will give 1. Women can also speak, I'll give 1. And monkey doesn't speak, okay, so I'll give as 0. Okay, now see guys, beautifully it has generated, these are the vectors. Okay, by generating these are the features. Now let's say if I want to represent king, okay, if I want to represent king, so what would be my king vector? So here this is your king vector, so king vector is nothing but 1 1 1 0.8 1. So this is the king vector. Now if I want to represent queen, so this is my queen vector. So queen vector would be 0 1, then 0.7 0.5 and 1. Okay, now if I want to represent man, so this is the man vector, so 1 0.5 0.7 and 1. Okay, now let's say if I want to represent women, okay, I think you are getting it, like how we have generated, these are the vector. Now this is the vector of the women, so 0 0.3 0 0.3 and 0.2 0.5 and 1. Okay, now let's take one 2D dimension, okay, and plot these are the vector and try to understand like what will happen. So let's say here I will take one 2-dimensional space. So let's say this is my 2-dimensional space. Okay, so this is my x and this is my y. So if you plot all the vector here, okay, if you plot all the vector here, you will see king and queen, king and queen will appear to the similar. So here let's say this is my king and this is my queen. Okay, so what will happen whenever you will plot these are the vector to the 2-dimensional space, or let's say 3-dimensional or any dimension, okay, you will see king and queen will appear like very close together, because if you see here, okay, if you see here, as per the features, if you calculate the number, if you calculate a distance between these are the vector, you will see this distance would be like very less. Okay, that's why king and queen would be appearing very closely together. And here man and women, let's say this is my man vector and this is my woman. Okay, this is my woman. So these two vector would be appearing closely. And here if you see here, there is another vector called monkey. Okay, monkey will appear completely different from these are the vector, because monkey is a different entity here. So let's say this is my monkey. Okay, now if I show you, see, so it has built one cluster. So this is one cluster, this is another cluster, and this is another cluster. Okay, now if you see here, using this concept called vector embeddings, we are easily getting these are the similarity score. Okay, similarity vector. So now if I want to extract any kinds of vector, okay, let's say I want queen. Okay, I want queen, so it will go to this cluster and will return this vector. And let's say not only queen, let's say it would be, let's say I want something called princess. Okay, I want something called princess vector. So what will happen, it will come in this cluster, because if you calculate the vectors, okay, of the princess, you will see it will have these are the features. Okay, it will have these are the features related to the king and queen. Okay, so now this princess will appear here. So that's how actually this embedding model works actually. So it will first of all assign some of the features. Based on that, it will generate these are the vectors, and it will plot these are the vectors to the higher dimensional space. So here in this case I have taken 2-dimensional space, but it might be 3, 4, 5 and so on, okay, based on your dimension of the data. So whenever I'm using unstructured data, whenever I'm using real world data, so dimension might be vary, okay, it might be millions dimension, it might be 1,000 dimension. We can't say like what are the dimension it will have, but as a visualization we can only show 2D space here, okay. So this is the complete idea, guys. I think you got it, like how these embeddings model are working, okay, and how it is generating these kinds of vector, okay. Now here in this case actually you have lots of embedding models. So we have OpenAI embedding model, and this model is trained on GPT, okay, GPT model. I think you have heard of GPT model. Then we have something called Huggingface embedding as well, okay, Huggingface embedding. So it is already trained on, let's say, lots of open source LLM, okay, that means large language model. Then we also have something called llama, okay, llama 2 embedding. I'll be discussing like what is llama 2 and all, okay, as a open source model. Then we have something called Google Palm embedding. So these are the open source embedding you can directly use. So this is from Facebook research, okay, and this is from Google research, okay. And this one is paid, because if you are using OpenAI embedding and OpenAI model, so you need to pay. This is completely paid, and these are the things are free, okay, these are the things are open source and free. But to get the llama 2 access, actually you need to like send some information, then they will give you the access. I'll tell you like how to take this llama 2 access and all, okay, everything I'll be discussing about. Don't worry about, like, just try to stay with the video. I'll be discussing each and everything. So guys, I hope you got the entire idea, like how these embeddings models works, okay, and how it generate these kinds of embeddings as a vector, right? So guys, here I kept another example. If you just see this example, your concept will be very much clear. See here, I have these kinds of words, okay, and we are using these kinds of embedding model, and we are generating these kinds of vectors. And if we plot these are the vectors to the 2D dimension, so it will look like that. So let's say we have this 3 word, we have this 3 word, and we have this 3 word, and we are getting different vector. And this is the cluster, okay, this is the cluster of each of the words. If you see here, king, man, women, it's appearing in the same cluster. Then apple, banana, orange is appearing to the another cluster, and football, golf and tennis, it's appearing in the another cluster, because this is related to a person, okay, person, and this is related to fruits, and this is related to sports, okay. That's why this cluster is different. Now I think you got it, them vector embeddings, like how this vector embeddings looks like and how it is generating, okay. I have given you the entire idea. But one issue actually with this vector embeddings, which is nothing but whenever you are getting any similar kinds of vector, it is applying something called distance formula. I think you have heard of like distance formula. We have Euclidean distance, okay, we have Manhattan distance, or let's say we have something called cosine similarity score as well, okay. So using these are the equation, actually it try to calculate the similar kinds of vector. But again, if you see here, it would be very much time taking, because it will calculate with respect to one by one all the vector, then it will give you the similar kinds of vector. So the main problem is like the time. If you are using this thing directly, so it will take lots of time to give you the similar kinds of vector. So to overcome this issue, actually they propose something called indexes in the vector database, okay, like we call it as vector indexes. So what is vector indexes? So let's say whenever we are having these kinds of unstructured data, we are applying these kinds of embedding model, and it is generating these kinds of embedding, okay. So on top of this embedding, where what is trying to do, it is trying to add some kinds of indexes, okay. So this indexes is nothing but it's a data structure. It's one kinds of data structure actually. So what it will do, it will find out similar kinds of vector, and it will assign some of the indexes, okay, and it will make some cluster kinds of thing. So whenever, let's say, you have any new data, first of all it will see like which indexes actually lies this data. So in that index only, it will search that query. So to understand this, let's say this is my example. So first of all, let's say it has assigned these kinds of indexes. Now you have one new data. Now first of all, it will see like which cluster actually this is lies, okay. So it will go to that cluster, then it will return the similar kinds of vector with respect to the new data you are giving, okay, instead of searching to all of the clusters. So this is the idea of these indexes in this vector database. Now using these indexes to our vector database, it's like very fast. Now whenever you are asking any kinds of query to the vector database and it is returning any kinds of vector, so this process time would be very fast. Now guys, I hope you got the entire idea like what is a vector database and all about, and what is embeddings and all about. Now you can tell a vector database indexes and store vector embeddings for faster retrieval and similarity search. So we used to use our traditional database to directly store our data, but in the vector database, first of all, we try to convert as vector, then we try to store them to the vector database. Okay, this is the complete idea. Now guys, let's discuss some use cases like why this vector database is useful, like what are the use cases are there. So as you can see, it will help you the long term memory for the large language model, because it is storing all of the data as a vector to the vector database. So whenever you are connecting this kinds of large language model to the vector database, so it can be used as a memory, okay, memory of your large language model, like long term memory. And it can also perform something called semantic search. I already told you how to perform the semantic search using the formula and using the indexes and all. So search based on the meaning of the context. Let's say if you're giving something called, let's say, king and queen, so it will not only consider the text you are giving, it will also consider the context, like what is king, what are the features of king, what is the features of queen. Based on that, it will give you the similar kinds of vector, okay, as a output. Then it can also perform something called similarity search, as I already told you, like on the text data, image data, video data, or let's say audio data. Let's say I have one image, let's say dog image. I will tell hey, just give me some dog images, okay, similar kinds of dog images. So it will first of all try to see the vector, okay, similar kinds of vector, and it will return the similar kinds of representation of the dog to you, okay. So we call it as similarity search. Then it can be also used in the field of recommendation system, because as you already saw, like if you are having these kinds of vector together, and it can perform similarity search. Let's say I want to build something called recommendation system. So let's say I'm asking for like food related content, so it will suggest me food related content only, okay, using these kinds of similarity search and all. So guys, this is the entire idea of this vector database, and these are the use cases actually you can consider, okay, inside this vector database. So guys, I think so far everything is clear. Now let's try to see some widely used vector database. So you can see we are having ChromaDB, Weaviate, then Fias. So Fias is implemented by Facebook AI. Then we are also having Pinecone, then Neo4j. Neo4j is a graph-based vector database. Okay, so these are the actually very common vector database people are using in the market, and it's like very famous vector database, okay, in the market right now. So here we'll be exploring all of them one by one. So in the next video, we'll try to see how we can use ChromaDB, and ChromaDB is a local vector database, and this Pinecone, Weaviate, Neo4j, it's a cloud-based vector database, okay. And here is another vector database. You can see Fias. Fias is also a local vector database. That means if you want to, let's say, store your data as a locally, so what you can use ChromaDB or Fias. And if you want to store them in the cloud, you can use Pinecone, Weaviate, or Neo4j. Okay. So now in this video, actually, we'll start with one practical demo. That means we'll be learning one amazing vector database, local vector database called ChromaDB. You can see ChromaDB is a local vector database. So they're also bringing the hosted version of the ChromaDB. So you can see it is still under development. So once it is done, you will be also able to, let's say, use this ChromaDB in the cloud server as well. So as of now, if you want to store your, let's say, embeddings in the local, okay, that means if you want to set up everything in the local, you can use ChromaDB vector database for this. So this is the documentation of ChromaDB, guys. You can see this is the official documentation. So they have given each and every guideline, so you can follow this documentation, like how we can set up and all, okay. So what I will show you guys, I will show you one complete practical. That means we'll be experimenting this ChromaDB on the Colab notebook, okay. So guys, let's open up my Colab notebook and let's see how we can use this ChromaDB vector database. So guys, as you can see, my notebook is connected. Now, if you want to test it, whether it's working or not, just write one message here. So I'll just write print. Okay. So it should, yeah. So it's working fine. Okay. So now the first thing, I'll be installing some of the like required packages. Like I need to install the ChromaDB and all. So there is the guide actually. They have given like you need to use pip to install the ChromaDB, and how to like set the client and all, everything they have given, okay. So first of all, what I will do, I will just set up this ChromaDB. So to set up the ChromaDB, you will need some more required package, okay, some more dependency. I'll tell you like what are things you need. So just write pip -q install. First of all, I need something called ChromaDB. So I'll copy the name from here. ChromaDB. Then I need something called OpenAI, because I'm going to use OpenAI embeddings and OpenAI, like you can say LLM model. Okay, that means GPT 3.5 turbo model. So that's why I need OpenAI. And I also need something called Langchain, because I told you I'll be using Langchain here. Langchain, and there is another dependency you need, something called tick token. Okay, tick token. So if you are using OpenAI embedding, so you need this package actually, tick token. Now, yeah, I think these are the things actually I need. Now let me install it. And guys, you need OpenAI account for this video actually. So just try to create an account here. Otherwise, you won't be able to do it, because you need the OpenAI API key, okay, to run this, like you can say, notebook. So guys, installation is done. Now, if you want to see, let's say, any version of any package, so what you can do, let's say I want to see the ChromaDB version. So I'll just copy the name, and here you can just write pip show, pip show, and just give the name of the package. Now if you execute, it will show you the version and every information about this package. See guys, name is ChromaDB, and this is the specific version, and this is the entire summary of your like ChromaDB package. Okay, so that's how you can see for all the packages, okay, you have installed. Now here, first of all, I need to download some data, because here I'm showing you vector database example, and there actually I need the data, okay, to show you like how to store and all. So for this, actually what I will do, so there is a actually this Dropbox links, actually you can see this is the Dropbox links, and inside that actually you have some article data. If you see, Google article is there, then you have some AI startup article, Amazon article, then you have Databricks article, ChatGPT article. So we have different articles here, okay, and this is a txt data, txt format data. Now if I open any kinds of txt file, see, this is the article related to this default, okay, generative AI. So they have written all the article and all, okay. So I'll be using these kinds of data. You can use any kinds of data, it's up to you, but this is the open source data actually I got from the internet, and this is the link of the data. So to download this data, first of all I will copy this link, and here I'll be using something called wget to download this data. So I'll just write wget. So wget is a Linux command, and here we are using Google Colab, and Google Colab is running on the Linux operating system. Okay, so it is running on the Linux kernel. So that's why you can execute any kinds of Linux command here. So here I'll just write wget -q, and here I'll just paste this link. Okay, I'll paste this entire link. Now once it will download, let me show you how it will download. So if I execute this cell, left hand side you will see it will download that zip file. Okay, see, new article.zip file, this zip file has been downloaded. Now I also need to unzip this zip file, so I'll just write unzip -q, and this is the name. I'll just copy the name. I'll just copy the name, and here I'll just tell the directory like where you need to I mean unzip it. So I'll give the same name. So this is the name, new underscore articles. Okay, so it will create one folder, new underscore articles, and inside that it will unzip everything. Okay, now if I show you, it's done. Now if I refresh the page, I think inside new articles, now see guys, all the articles are present. Okay, now let's see, if you want to open it, you can also open and see. So this is the article and all about. So now let me close this thing. So we have successfully downloaded our data. Now what I need to do, I need to first of all create one OpenAI API key, and I'll be setting up my environment. Okay, so for this, actually what I need to do, I'll first of all open up my OpenAI account. So you just also open up your OpenAI account. Just size just search like openai.com, and here just try to log in with your account. So let me quickly log in with my account. So guys, as you can see, this is my account. Now here I'll just click on this personal, my this is my profile. I'll click here, and here you will get one option called view API keys. Okay, now I'll click here, and here you will see API keys option. Okay, now see, previously I created some of the API keys, that's why you can see here, but for you it might be completely empty. It's completely fine. So you'll get one option called create a new secret key. Okay, just click here and just give the name. So in this case, I'm using vector db. So vector db, I'll just name it. Okay, you can give any name. I'm just giving vector db and create the keys. Now you need to solve one puzzle here. It will verify whether it's whether you are a human or not. Okay, so I'll just click here. Now it's telling just try to move this object with respect to this hand direction. So let me move it and submit. I think yeah, attempt is complete. Now I will get my secret key. Yeah, now I'll copy this key and here I'll paste it. Okay, as of now I'll paste it and I'll just give a comment here. Setting up setting up environment. And don't share this key with anyone, guys, otherwise they will also able to access your like you can say OpenAI account. I will be removing these keys after this recording, so that's why I'm showing. Now here, first of all, I will import operating system package called OS, and here I'll set the environment. So I'll just write OS dot environment environ. Okay, and here you just need to give the keys, like which name you need to save it. So I'll just give OpenAI underscore API underscore key and equal to, I'll set my API key here. So this is my API key. I'll copy or I'll cut it and here I'll set it. Yeah, that's it. Okay, now I can remove this cell. Now let me execute. Done. Now I need to import some of the necessary library. So import. So first of all, I need to import something called Chroma. Okay. So if you're using Langchain, so Langchain already has this Chroma API, because I already told you the integration. So it is the integration with the Langchain as well as the LlamaIndex. So instead of like importing directly, like import Chroma, okay, import Chroma, we have to import it like from the Langchain itself, because here I'm going to use Langchain framework, okay, to build my application. That's why I need to call it from the Langchain. But let's say if you're using it for any other like task purpose, let's say you are not creating any generative AI application, let's say you are doing some different thing, okay, different application, at that time you can directly import it and all the functionality will remain same only, all the code will remain same only, you just need to change the import, okay, at that time. So here I'll be using Langchain, so I need to import it from the Langchain itself. So how to import it? So just write from Langchain dot vector store. So there is a function you will get called vector stores import. So I'll import my Chroma. So I'll just write Chroma. Then I also need to import uh, OpenAI embedding, because I think you remember. Let me open my board. I think you remember. First of all, what I need to do. Let's say I have my unstructured data. So let's say this is my data. So the first place what I need to do, I need to use something called embedding model. Embedding model. So this model might be anything. So in this case, I'm going to use OpenAI embedding model. OpenAI embedding model I'll be using. So you can use any model here. Okay. Then after that, it will return me my vector embedding. Vector embeddings. Okay. And that vector embeddings I will store inside my vector database. Okay. Vector DB. So in this case, I will be using something called ChromaDB. Okay, so this is the complete idea. So first of all, I need to import this embedding model as well. So here I'm going to use OpenAI embedding, so I can directly import OpenAI embedding. So let me do it. So here I'll just write from Langchain dot embeddings import OpenAI embeddings. Okay. Then I also need to import OpenAI because I'm going to use OpenAI large language model. So again, I'll just write from Langchain dot LLMs. That means large language model. I need OpenAI. Then I need to load my data. As you can see, this is my data and it is present inside a directory. Okay. And again, this data format is a TXT data. Okay. If you see, it's a TXT data. So for this, I again need two libraries. So I'll just write from Langchain. So guys, I'm expecting you are already familiar with this Langchain because if you check our YouTube channel, so we have already covered this Langchain tutorial and all. Okay. So you can go with that tutorial and you can learn the Langchain. So here from Langchain, there is a class called document loader. So just write document loaders. Okay. So first of all, I'll be import something called directory loader. Okay. Directory loader, because my data set is present inside the directory. That's why I need this directory loader. Then I also need to load my text loader because it's a TXT data, right? So I'll import the same thing only. Sorry, it should be data loader, I think. Document loader. Document. It's a document loader. Okay. Now it should be text loader. Text loader. Okay. Yes. So as of now, I need these are the libraries, and if I need anything, I will be importing later on. So let me just quickly import them. Now we'll be loading the documents. So load data. So guys, to load the data, just write directory loader, and inside that you just need to mention the directory. So here this is the directory. I'll just copy the name, copy path, and I can give it here. So this is the directory, and inside that actually I have txt data. Okay, I have, if you see, I have txt data. So I only want to load the txt file. So if I, let's say I have some any other file, okay, I will be ignoring. So for this, there is a parameter you can give called globe. Okay, just write globe equal to, so it should be txt file. So all the file just load. Star means all the file. Okay, it should be dot txt. Then you also need to define the loader class. Okay, so just write loader class, and it should be my text loader because all the file are txt format. Okay, that's why you need to give this text loader. Okay, now it will load up your data, and I'll be storing this data inside a variable called loader. So this is my object of my data loader. Now let me execute it. Now to load the data, you need to call one function called loader.load. Okay, if you call this function, it will load the data, and this data will store it in a variable called document. Okay, and see guys, it will load all the data inside this document. See guys, this is the all of the text actually you can see here. So it has loaded all the txt file one by one, and it has extracted the data, and this is your entire data, as you can see. So let me show you. See guys, and this is a document object. Okay, this is a document object. Now we have successfully loaded our data. Now guys, before converting this dataset to the embedding and storing it to my ChromaDB, first of all, I need to apply something called text splitter on top of it. Basically, I need to convert my entire data as a chunks, because as you can see, this is my complete corpus. Okay, see, this is my complete corpus. If I show you, so if I show you the data, see, this is the complete data. Okay, this is the complete data corpus. But this data set is like very huge. Okay, I can't like you can say directly convert it to vector. Okay, so if I'm converting, so what will happen? Okay, let me explain. So what is the use of this chunks? Okay, so see, so whenever you are using any LLM model, okay, whenever you are using any LLM model, so it has one input size. Okay, it has one input size, as well as it has one output size. Okay, output size. So whenever you are giving something as an input to the LLM, okay, you need to always take care about the input. Okay, so I'll tell you like where you need to check the input size and all. So in this case, let's say I'm using OpenAI LLM. Okay, OpenAI LLM. So OpenAI LLM wise, I'll be using something called GPT 3.5 Turbo. So there is a model you will get from OpenAI called GPT 3.5 Turbo, and it has actually one specific input length. So that input length actually you need to see. So if you want to check the input length, just search like OpenAI model, OpenAI models. So this is the link, just open it up. And here you will see all the models are available inside OpenAI. So we have GPT-4, GPT 3.5, GPT based DALL-E, okay, GPT-3 legacy. So these are the model actually. And here I'm going to use this GPT 3.5 series. So I'll just click here. Now here if you see, the first model is GPT 3.5 Turbo. And this is the description about the model, okay, like what are the things they are doing and all. And this is the max token length, as you can see. So it can take an input around 4,097 tokens, okay, at a time. And this is the training data, okay, like up to September 2021 they have trained the data, okay. So this is the input length, okay. But if you check your input here, if I open my data, if you see, this input length actually will be more than this 4,000 token, because here if you see, I have loaded the entire documents, all the articles I have loaded, okay. So there is a possibility this input size would be more than 4,000 tokens, okay. And if I'm converting all the corpus as my vector embeddings and I'm storing to the vector database, so it will create issue, okay. So again, during storing it will create issue, and whenever you will be giving this data to your LLM model, again it will be creating issue, and you will also get some memory error and all, okay. So it's better to split our data as chunks, okay. Now what is chunks? So let me first of all tell you, chunks is nothing but, here I have already written, chunks is a size of the maximum number of the character that a chunks can contain, okay. And there is another concept called chunks overlap, okay. So chunks overlap is nothing but this is the number of character that should be overlap between two adjacent chunks, okay. So let's say, so to explain this one, let's say I will take one text here. So let's say this is my entire corpus, okay. Now first of all I need to convert it to chunks, okay. Chunks means I'll be taking some of the chunk size, okay. Let's say if I am writing chunk size is equal to, let's say, 500, so it will take let's say I'll take a new color. So it will start from here and it will go and it will count like 500 character, okay. It will count 500 character. So let's say this is this will end here, okay. This will end here, and this should be one chunks, okay. This should be one chunks, okay. So again it will start from here, again it will count, let's say, 500 word 500 character, and we call it as a token, okay. So let's say this is the here it will end. So this should be another chunks, okay. So let's say this is another chunks, this is another chunks. Now again let's say it will start from here, it will start from here, again it will count, let's say it will end here, this is another chunks. Let's say again it will start from here and let's say it will end here, okay. I'm taking it randomly, just try to consider. So this is another chunks and it will start from here, it will end here, okay. Now how many chunks we have got? So one chunks, two chunks, 3, 4 and 5, okay. So here I got 5 chunks, okay. 5 chunks, 5 chunks of the data. See, now if you count this input length, okay, now it should be less than my 4,000. I think what is the number? It should be 4,097, okay. 4,097, okay. Now my input size is less than 4,097, okay. So this is the idea of creating these chunks, okay. Instead of converting my entire corpus to the vector, first of all I need to create as the chunks, okay. Then I need to convert it to vector embedding, then I will be storing, and that embedding I will feed my LLM model, okay. And there is another concept called chunks overlap, okay. So what is chunks overlap? So if you set this chunks overlap, let's say I will set this chunks overlap, chunks underscore overlap, let's say I have set as 20. So what it will do, so whenever first of all I will wrap, these are the chunks, okay. Now let's create a new chunks again. So let's say whenever it will create a chunks, let's say it will start from here and chunk size is 500. So let's say it will end here. Now you have mentioned chunks overlap is equal to 20. Now what it will do, instead of starting from here, it will go back and it will count 20 character. Okay, it will count 20 character. Let's say this is my 20 character. Okay, now it will create the chunks from here. Now again it will count, and let's say your 500 character will end here. So this is my another chunks. Okay, so basically chunks overlap means like how much overlapping you are needed from your previous chunks. Okay, so that is called chunks overlap. So it helps you like to understand your context of the text. Okay, uh, instead of using only chunk size, you can also use chunks overlap, so that it can also got to know like what was the previous context. Okay, whenever it will, let's say, see, I'm giving this chunks by chunks. Let's say this is my chunk 1, the chunk 2, and chunk 3. So okay, so instead of giving directly the chunks, if I'm also mentioning chunks overlap, so what will happen, your LLM model automatically will get to know, okay, so this is the context actually. So this sentence, okay, this sentence and this sentence, so after this sentence actually this sentence is coming. Okay, so that's why this chunk size, this chunks overlaps actually helps us. Okay, this chunks overlaps actually help us to understand the context of the entire story. Okay, so that's why we'll be using these two concepts called chunk size and chunks overlap. Okay, now I think this thing is clear. Now let me show you how to do it using code. So I'll come here. Now here, first of all, you need to import something called recursive character text splitter. Okay, so from Langchain dot text splitter, text underscore splitter, import recursive. So recursive character text splitter. Okay, so this is the class actually we'll be using to convert my entire corpus as a chunks. Okay, now I'll just call this class, and inside that you need to mention two parameter. I think I already explained. One is your chunk underscore size. Okay, chunk size. So let's define as 1000. Okay, I am considering 1000 character as my one chunk. Okay, you can give any number, so it's a hyperparameter tuning. You can set any number here, but I saw like people are starting with 1000 here. Okay, and there is another parameter you will give called chunk underscore overlap. So chunk overlap, I'll give, let's say, 200. Okay, so again it's a hyperparameter tuning. Now guys, I have created this object. Now I will save this object. So I'll just create a variable called text splitter. Now guys, finally I will convert my entire corpus to my chunks. So I'll just call this object, and here you need to call split dot split underscore documents, and this is my entire documents. Okay, this is my raw documents, so I'll give it here, and I'll store in a document variable. Okay, or I can store it, I think, in a text variable. I think it should be fine. So let's make it as separate. Now let me execute. It's done. Now if I show you my text, guys, so you will be able to see it has converted to chunks, and how many chunks it has converted I will also show you. See guys, so if I just go up, so guys, see, this is my first chunks. Okay, and it is ending here. Then again it is another chunks. Okay, then it is ending here. Then again this is another chunks, and it is ending here. And from and if you see, in each chunks actually you have 1000 character. Okay, 1000 character. And here if you see the chunks overlap, so if you read this text carefully, so you will see some of the sentence are coming, okay, in these new chunks as well. Okay, because we have set this chunks overlap as 200. Okay, so see, this is my entire chunks. Now if you want to see the length, like how many chunks it has created, so just print the length. So I'll just read as my text. So it has created 233 chunks, okay, altogether. Now it's fine. Now if you want to see any chunks, specific chunks, you just give the index. Let's say I want to see the number 1 chunks. This is the number 1 chunks, and I can also print number 2. Now we have successfully converted our like corpus to chunks. Now what I will do, I will create my DB object, okay, like vector DB object. So just write the comment here, creating DB object. So as I already told you, ChromaDB is nothing but it's a local database. So first of all, you need to create a local like DB here, okay, local DB. So you need to specify the name. So here I already prepared this code. So here you need to first of all create one persist directory, and the name can be anything. So here in this case I'm giving as DB, that means database, and you need to specify the embedding first of all, okay, like I think you know why we need the embedding, because first of all, I need to convert my text to embeddings. Okay, that means vector. Then I will store this vector, okay, to my vector database, which is nothing but my ChromaDB. So in this case, I'm using something called OpenAI embedding. I think you remember. Here we imported. So OpenAI embedding. So I'll just call it OpenAI embeddings. And by default, if you execute this code, so let me show you which embeddings model it is using. So it is using something called text embedding ADA model. Okay, 002. This is the model. Now you can search also here. So if you check here, so it has this model called text embedding ADA 002. Okay, so this is the model. It has also another version, text ADA 001. Okay. Now we have successfully loaded our embedding model. Now what I need to do, I need to create my vector instance. Okay. I need to like create my vector database instance. So to create it, so this is the code for it. It's a simple code only. So first of all, I have created one variable called vector db, and here I'm just calling my chroma. I think you remember we imported chroma from my Langchain. I'm just calling this chroma. So inside chroma, you have one function called from documents. Okay, from documents. Now here you just need to give the data, like you just need to give your text, like you just need to give your chunks, like which chunks actually you want to convert as a vector. So in this case, this is my chunks called text. As you can see, this is my text. I'll just copy the name, and here I'll just name it text. Okay, and it will also take the embedding model. Okay, so this is the embedding model I want to use. So in this case, you can use any embedding model. You just need to import it here. Okay, so here I'm using OpenAI based embedding model, so that's why I have initialized it here. So here I'm giving the embedding model, and here you also need to give the persist directory, like where it will save after, let's say, converting to vectors, where it will save. So it will save inside this db folder. Okay, so here I'm giving the directory. So these three parameters you just only need to give here. Okay, that's it. And if you're not giving any embedding model inside ChromaDB, it will automatically take OpenAI embedding model. Okay, I think they have already written here. If you see here embeddings, so they're automatically, I think, taking some embedding model using OpenAI API key and all. Okay, so they have already mentioned here, like it will automatically load, but it's better practice to mention. Okay, always better practice to mention here. That's it. Now if I execute it, so first of all, what you will do, I'll just remove this directory. Now see, it is converting everything to the vectors. Okay, all the text has been converted to vectors. Now I need to save it to my disk. Okay, now see, it has converted everything to the vector. Now I need to save it to the database. Okay, now this is the code for it. Just write vector db persist and vector db is equal to none. Now if I execute it, now you'll see it will create one db here, local db. Now if I refresh, see guys, db has been created. Now inside that, it has saved all the vector. Now see, it's a binary format. You can't see the vector here, so that is the issue with this local db. But whenever I will be showing you like Pinecone and Weaviate, you will able to see the vector, like how it has generated the vector. Okay, how it has generated the embedding, everything you can see in the cloud. Okay, you can like see all the list of the vector there. Okay, so that was the beauty of this cloud vector database, but again it's a local one. Okay, so that's why it's a binary representation here. So yes guys, we are successfully able to save our vector here. Okay, now let's say you want to load it. So how to load it? So this is the code for it. So here you just need to mention chroma. Okay, just call the chroma, and here you just to mention the directory you have your data. So this is my database db. So here I'm giving the persist directory, which is nothing but db in this case. And here you also need to give the embedding. Okay, so this is the embedding I'm using. Now here I'm giving my persist directory. So in this case, it's db. Okay, now it will automatically load this vector and everything. Okay, from this db itself, because it's a binary representation. I already told you. Okay, and as well as I'm also giving my embedding model. Now let me load it. Now I think you remember I told you something called similarity search. Okay, now once we have loaded this vector to my vector database, now you can apply similarity search on top of it. Okay, we call it as retriever. Okay, retriever. So now let's show you the demo of the retriever. So I'll just comment it out, make retriever. Okay, so to retrieve any specific information with respect to the question you are asking, you need to set this parameter called vector as retriever. Okay, vector db. So this is my object, vector db as retriever, and this is my retriever object. Now let me execute. Now here I'll just call this retriever object, And here there is a parameter called get retrieve documents. Okay, that means I'm trying to tell my vector database whatever question I'm asking, try to give the similar kinds of you can say data, okay, with respect to the question I'm asking. So here I'll ask one question. Let's say here I have Microsoft articles as well. I think if you see here, I think Microsoft articles is also there. So I can ask one question, just like how much how much money did Microsoft raise? Okay, so let's say this is my question. Now by default, uh, I'll store it in a docs. So by default it will return for a relevant answer. Okay, for relevant answer, if I print it, see, it will return you for similarity answer. Okay, for most similar answer. Okay, like whatever a vector are closed, I think I was explaining in the theory. So it is the most relevant and most similar answer. Okay, for most similar answer. So if I show you the length, so you can also set this parameter like how many relevant information you want. See, it is returning me 4. So let's say you only want, let's say, 2 relevant answer. Okay, so in this case you can set this parameter vector db as retrieve, search keyword as k2. Okay, k means like how many answer you want. Okay, so let's say I have given 2. Now if I execute it, okay, done. Now if you want to see like search type, so it's a similarity matrix. I think they're using similarity equation, they're using cosine similarity to calculate this answer. Okay, like the question you are asking, basically it will match with the vector, like what are the closest vector, okay, it will come, so it will return you. So they're considering this similarity cosine similarity matrix, I think there. Okay, so cosine similarity equation, and this parameter will give you like number of return actually it will provide. So it will only provide 2 answer. Okay, 2 answer. Now if I again execute this code, now see guys, now length is 2. Okay, it is only returning 2 answer. Okay, so using this parameter you can set like how many like answer or how many similar answer you want, okay, from your database. Okay, now see guys, it has returned 2 or let's say 4 similar answer, but I want a specific output. Let's say the question I asked, okay, let's say if I print my document, so it's a different kinds of answer actually it will return. Okay, but it's not understandable actually. It's like it is giving like lots of answer and all. Okay, it's giving lots of text, but I want like a relevant answer. Like I just asked like how much money did Microsoft raise, so it should give me like that is the money Microsoft raised. Okay, so it should give me that kinds of answer, but it is returning this kinds of document. Okay, these kinds of chunks. So to get a specific output, okay, from your data, you can take a help from the LLM. So what you can do, let me show you the diagram. So let's say this is my vector db. Okay, now we have stored our vector embedding here. Vector embedding we have stored here. Okay, now you are giving any kinds of query. Let's say this is your query. So here in this case, let's say you asked like how much money Microsoft raise, right? So this is your question. So it is returning, let's say 4 or let's say 2 output documents. Okay, but this 4 or 2 output documents is not readable. Okay, I am not getting my specific answer. So what I can do, I can integrate LLM model. So let's say I will initialize my large language model here, which is nothing but GPT 3.5 turbo in this case. Okay, turbo. So I'll give this answer to my LLM model. Okay, I'll give this answer to my LLM model, and LLM model will analyze this answer. It will also analyze this query. Okay, it will also analyze this query. With respect to that, it will give me the authentic output. Okay, the correct output, correct meaningful output. Okay, that is the power of LLM. I think you know why it is powerful and all. Okay, because it has trained with huge amount of unstructured data, so it can perform all kinds of tasks. Okay, that's why uh, we will be using LLM, okay, to retrieve our specific answer with respect to the specific question I'm asking. Okay, so this is the idea. So now to do it, actually, first of all, I need to make one chain. Okay, so let me just comment it out. I think you know what is chain in Langchain. Okay, so I'm not going to explain because I think you already learned this chain in Langchain. Okay, why we use chain and all. So first of all, I need to import something called retrieval QA chain. Okay, so I'll just write from Langchain dot chains import retrieval. So whenever you are using vector database, okay, it is returning retrieval output, right? Like related output. So you need to use this retrieval QA. That means retrieval question answering chain. Okay, so it will help you to uh, ask the question, okay, to the data actually you have stored in your DB. Okay, so that's why this chain is required. Retrieval question answering. So I'll import this chain. Now here, first of all, you need to make one chain. So I have already made one chain here. So this is the chain. So I'm just calling retrieval QA chain, and there is a function called from chain type. So here you need to specify the LLM model. So here in this case, I'm using OpenAI LLM model. Okay. So let me show you how it will give you the model. So if you just run it in a new cell, now if you print this LLM, so this is nothing but your GPT 3.5 turbo. Yeah, so it's not giving the name, but if you see the documentation by default, whenever you call OpenAI, so it will give you something called GPT 3.5 turbo. Okay, this model actually, if I GPT 3.5, so this model actually it will return. Okay, so I'll be using this LLM, and here I'm giving this LLM model, and chain type is stuff. Okay, I think you already know what is chain type and all. And retriever, so you need to give the retriever object here. Okay, this is the retriever object. So basically, whatever question you are asking, okay, whatever question you are asking, it will return you from this retriever, right? Because you have given this retriever here. Okay, so that's why you need to give this retriever object here, and you also need to give the return source documents. Okay, return source documents means it will return the source also. Like, see, we have lots of data here. If I show you, we have lots of article here. Okay, now which article it is referring to give the answer. Okay, it will also give you as a reference that article. Okay, so this is the idea of this. Now if I execute, now let's ask one question and print this response. Okay, so here I'm calling my QHN, and this is the query. Same query I'm asking, how much did Microsoft raise the money. Okay, so this is the query I'm giving my inside my chain, and this is the response of the LLM. Now if I print this, see guys, this is the query. Now it's telling around $10 billion. Okay, raised like this Microsoft, and this is the source document. Okay, but it's not readable. So what you can do actually, you can write one function here, process LLM output or process LLM response. So this is the function you can write. So whatever response it will give, it will process only, like it will give it the result, source, and the answer. Okay, now if I execute, now if I call this function here, now I'll just remove this response here. Okay, now I think it should give me the yeah. So now you can see this is the clear output. Now around $10 billion, and these are the source. Actually, it has referred this to file as a source. Now see guys, we are able to successfully store our vector to the vector database, and we are also able to make the query on top of that. And we also saw that like how we can found the similar kinds of you can say output. Okay, using this retrieve. Okay, using this retrieve option. Okay, so you can ask any different question also. So let's say I will ask another question here. So what is the news about Pando? So there is again another Pando articles you will see inside the data. Now again I'm giving inside my chain, and it is giving the response, and I'm just processing the response. Now see, Pando is a startup that has raised $30 billion in a Series B round, and bringing its total raised. Okay, so this is the complete answer, and this is the source it is giving. Okay, I think I don't need to print this. Yeah, so this is the source. So yes guys, that's how actually you can do it. And one thing I also want to show you, like how to, let's say you want to delete this database, so how to do it. So deleting DB, so it's like very easy. First of all, you can make a zip file, okay, of your existing DB, so that Later on, if you want to retrieve it, you can retrieve it. Okay, so first of all, I'm making it a zip file, then I'll be deleting it. So first of all, I'll make a zip file. Now see guys, if I refresh, so first of all, it will make a zip file of this DB. Okay, now I'll be deleting. So this is the deleting code. So it will clean up everything. Now if I refresh, now see database has been deleted. Okay, now let's say you want to get your previous DB. Okay, like you had, let's say, some specific or let's say important vector there, you want to get back. So what you can do, you can unzip that zip file. Okay, so this is the zip file, you can unzip. Now again your database will come. Now what you need to do, you need to restart the runtime. Okay, so just click here and there is option called restart the runtime. If you restart the runtime, again you can able to use your DB same wise. Okay, like we already imported our DB right here. So here, that's how we can load your DB again. Okay, so this is the functionality actually ChromaDB provides. Okay, if you see the documentation, they have written everything. Even they have also given the starter notebook and all. Okay, so guys, I think as of now you got the entire idea about the ChromaDB, like how we can use ChromaDB vector database and how we can connect the large language model and how we can perform this let's say vector search operation, right? So one thing I just wanted to show you, see, if you click on the integration, see, this ChromaDB is having like different integration. That means you can use ChromaDB with OpenAI, Google Gemini, Cohere, Huggingface, okay, Instructor, Huggingface embedding server, GenAI, RoboFlow, okay, Ollama embeddings, everything you can use. Okay, everything you can use with this ChromaDB. Now we can see some framework integration, like it can also support Langchain, LlamaIndex, then BrainTrust, LLM tree, okay, then Streamlit, HighStack, OpenLead. So these are the framework also you can connect. Okay, that means it has actually all the integration. If you are using different framework, different let's say large language model, different platform, everything it can support. Okay, so as of now we saw like how we can use with the help of Langchain. Going forward, we'll be also learning how we can use with the help of LlamaIndex and so on, right? So yes guys, this is all about from this video. In the next video, we'll be learning another amazing vector database called Pinecone, and Pinecone is a cloud-based vector database. That means we can store our embeddings in the cloud platform. As I already told you, Pinecone is a cloud-based vector DB. That means you can store your embeddings to the cloud. So if you want to use Pinecone, so search for actually Pinecone in the Google. So Pinecone. So you will get the first website. Just try to open it up and make sure you create one account. Okay, you just need to create one account inside this website. So for this, you just do the sign up operation. So with the help of your Google account, you can create one account. So once you have the account, just try to do the login. So I already have the account, so I'll just try to do the login here. So once you have logged in, guys, you will get this kinds of dashboard. So guys, now let's try to see how we can use this Pinecone vector database to store our embeddings. So guys, what I've done, I already recorded one video previously on this Pinecone, the detailed video, how to use this Pinecone and all. So I'll add this video here. So this video will give you the entire idea how we can use this Pinecone with the Langchain and all. So guys, as you can see, recently they have updated their dashboard, but previously it was actually different kinds of dashboard. But see, functionality wise, it is same. You have to use as it is. But somehow actually they have updated some kinds of actually dashboard. You can see previously this index was like out. That means there was a option called index, directly create index option was there. But they have actually created this index now inside databases. Okay, see inside databases now there is an index option. So guys, this Pinecone is not a free vector database. For this actually you have to take the subscription. But if you are creating, let's say, new account for the first time, here you will get actually a free actually some storage. That means 2 GB storage you will get. That means you can only create one index there. That means one cluster you can create. So if I click on the create index, you will see I can only create one index. And whenever you are creating free index, make sure you are selecting Google Cloud, okay, not any other cloud. Otherwise actually it will ask for the charge. See, I already occupied my, let's say, free plan. Now if I click here, see, it will ask for the upgrade. That means I have to upgrade with their, let's say, subscription. I already utilized the free plan, but for you actually will see the free plan option is there because you have created the new account. But for me, I already use this account. Okay, that's why it is showing I don't have any free plan right now. Fine. So make sure guys, you just try to create a new account and try to use this Pinecone. And to create the API key, guys, just click on the API key and here you can create the API key. Okay, and this API key will help you to connect with your this Pinecone server. Okay, from your Python code. Now let's try to see how we can use this Pinecone vector database without Langchain. And guys, one thing, whenever you're installing Pinecone client, make sure you're installing 2.2.4. okay, this particular version, because whenever I was using this Pinecone, that time actually this version was the stable version. And try to use this version, guys, because this version will help you a lot, because it is having like very easy syntax to store the embeddings to the Pinecone server. So make sure you're installing this 2.2.4 version. So let's try to see how we can use this Pinecone right now. First of all, you need to install some required packages. So just let me write down the comments here. So I'll be installing, these are the packages. So I'll be installing something called Langchain, then Pinecone client. Okay, so if you want to use this Pinecone vector DB, so you need to install this package called Pinecone client, and this is the Python package, and it will help you to connect with this Pinecone. Okay, then I also need PyPDF library, because here I'm going to load PDF data. So previously I showed like how to load TXT data. Now I will show you like how to load PDF data. So I'll show you like all kinds of data, like how to load and all. Okay, so that's why I need to install. These are the packages. So let me install. So guys, as you can see, my installation is done. Now I'll take some new cell, and here I also need OpenAI and tick token. Okay, I think you already saw from my previous demo. So OpenAI is also needed because I'm going to use OpenAI embedding, and as well as this tick token because I'm going to use OpenAI embedding. So tick token is the dependency there. Now installation is done. Now let's import some of the libraries here. So here I'm going to import, these are the libraries, and I think you are already familiar with these are the libraries, why I'm loading and all. I also need something called operating system. So I need this PyPDF reader loader, because here I'm going to read like PDF data. So for this, actually, I need to load this one from documents loader. But previously I was loading like text loader. Okay, so this is the difference. Then recursive character text splitter means like you want to make your data as a chunks, because I told you why this chunks is required and all. So that's why this is needed. And OpenAI embedding I will be using, and OpenAI LLM model, that means GPT 3.5 turbo. So for this, actually I'm using this OpenAI LLM. Then from Langchain I'm also going and here from Langchain I'm also importing like vector store, which is nothing but my Pinecone, but previously I was loading my ChromaDB. And retrieval QA means like you can also make some question answer, okay, on top of your data you have stored in the vector database, I think I was discussing, okay, with the help of this chain. Then you can also import something called prompt template. Basically you can give your custom prompt here, so this is also possible. Okay, I'll show you one demo here. So let's import these at the library. So first of all, here what I will do, I will create one folder. So let me first of all give one title like load data. So first of all, I'm going to create one folder here called PDFs. So inside that, I will download some of the PDFs I have in my Google Drive. So this is the code to download anything from the Google Drive. So here, if you see in Google Drive, you will see this ID, okay, of any kinds of file. Otherwise, you can download it and manually upload it inside. Okay, it is also fine, but I'm just downloading. So I have one yellow V7 paper in my Google Drive, and also I downloaded one resume. Okay, like from Google itself, I've downloaded one resume. So the name of the resume is like Rachel Gree CV. Okay, so this is the resume I've downloaded. So these two files I'm going to download inside my PDF folder. And with the help of this gdown package, you can download anything from the Google Drive. Now if I refresh and if I show you my PDF, so see, these are my data are available inside that. Okay, now what I will do, first of all, I need to extract the text from the PDF. So for this, let me give one title here. So how to extract the text from the PDF. So this is the code. You need to take the help from PyPDF directory loader. And here you just need to provide the path of the PDF file you have. So this is my path like PDF. So here I'm giving the path. And once you have given the path, you just need to call this load function and it will automatically load the data. So let me show you. So it has loaded my data. Now if I print my data, you will be able to see my data. See guys, all of the data has been extracted. Okay. Now what I need to do, I need to convert it to chunks, because I can't directly convert it to my vector, because input size might be vary, because I told you whenever you are using a large language model, so it has one input size. Okay, so you always need to take care of the input size. So that's why we need to create as a chunks. So to create the chunks, so this is the code, I think you remember. So I'll be just calling this recursive character text splitter, and here you need to give chunk size and chunks overlap. Okay, I think I have already discussed what is chunk size and chunk overlap. Then simply I'll just execute it. Then I will apply on top of my data. Okay, so this is my entire data, and here I'm passing this in my text repeater object. Okay, now it will give me that text chunks. Now let me execute and show you. So guys, this is my text chunks. Okay, see, this is another chunks, this is another chunks. So let me see like how many chunks I got here. So length text chunks. So I got around 168 chunks here. Okay, now if you want to see any specific chunks, so you can also print. Let's say I want to see number 1. You can also print for other. This is number 2. Okay, now here if you read it carefully, you will be able to see like also some chunks overlap is also there, like some text is coming from the previous chunks also. Okay, now guys, you can also print like third one as well. Now guys, first of all I need to download the embedding. So download the embedding, first of all you need to set up the environment. You need to first of all what you need to do, you need to set up your OpenAI API key. Okay, so I think you remember I can use my previous notebook. So in my previous notebook I already created this API key and I already set up my environment. I'll just copy this code and here I will paste it at. Okay, now I'll set my OpenAI API key. So let me set it. Yeah, now first of all I need to download the embeddings. So this is the code for it. So it will give you the embeddings, like OpenAI embeddings. Now first of all let me test one thing here. So what I can do, I'll just call my embedding. Like I just want to show you like what is the length of the vector it will generate. Okay, so I'll just call embedding.embed query, and here if you pass any word, let's say I will give hello. Okay, now if I execute, you will able to see the vector. Okay, see, this is the representation of the hello. Okay, and this is the vector. Okay, this is the vector representation, numerical representation. So I'll store it in a variable called result. Okay, now if I show you the length of this result, so let me see the vector length. Yeah, so by default actually if you are using OpenAI embedding, so the each vector length would be 1536. Let's say if I give any word here, let's say I'll give something called good. Okay, let's say good. If I give good, so you will see the length would be same. Okay, now if I give, let's say anything like I can give hello, or let's say how are you, how are you. So again the length would be same. See, length would be same. So basically what is happening, I think I was discussing this thing in my theoretical lecture. So whenever it is like trying to generate these kinds of vectors, okay, so it was following this approach. Basically it was creating some features. Okay, so with the help of the features actually it was generating these kinds of vector. So basically what is happening, so the sentence you have given, so this sentence is representing in this dimension actually 1536. Okay, this is the dimension of the sentence. Okay, and it is representing in that. Here I was referring this word by word, but you can refer as a sentence by sentence. So basically this king is appearing in this dimension actually 1 2 3 4 5 6. Okay, 6 feature we have created. So this was the 6th dimension. Okay, 6th dimension, this king was representing there. Okay, but whenever I'm using OpenAI, so I have written like how are you there. Okay, how are you is representing with the help of 1590 sorry 1536 vector. Okay, this is the dimension. Okay, if I plot it, okay, so this should be the dimension and this is the representation of the how are you. Okay, I think you are getting like how it is generating this vector and all. Okay, so if you give any sentence here, so this should be the length. So now I need to store these are the vectors. Okay, like I will apply this vectors embedding on top of my data. I have created the chunks, then I will store it on in my Pinecone vector database. So for this, first of all I need to initialize the Pinecone. So let me initialize it. So for this, first of all, what you need to do, you need to collect some Pinecone credential. So you need to collect like Pinecone API key and Pinecone environment. Okay, so how to collect it? So just go to Pinecone, and this is my dashboard, and here I already told you how to collect this API key. Just create a API key and try to just copy, and here just replace your value. Okay, no need to use my value because I'll be removing my keys. So you need to use your value. Okay, so just try to replace this value. Okay, then you need to also collect something called Pinecone API environment. Okay, so how to collect it? So here, if I go to now just click on index, so here you just need to create one index here. So first of all, it would be empty, and here you just only can create one index because it's a free one I am using. Okay, now I'll just click on create index and need to give the name. So here I'm using, let's say this is my test, or you can give any name. I'll give test index, and here you just need to specify the dimension of the vector. Okay, now here I already showed you, so this is the dimension of my each vector. Okay, so this is the dimension. I'll copy this value, and here I'll just write it, and you can also select the metrics, like what kinds of metric you want to use to retrieve your similar kinds of vector. Okay, so by default it is cosine. You can also use Euclidean and dot product, but cosine is a little bit fast. Okay, because if it calculating cosine distance, okay, so it will be like a little bit fast, okay, to calculate, because I was already discussing, right? If I show you that graph, so see, if I want to calculate cosine similarity within these two vector, so it will just create one angle here and it will give me the cosine similarity score. But if I'm using Euclidean distance, so it will just calculate with respect to all the data points I have here. Okay, so that's why cosine is first in this case. Okay, so I'll be using cosine metric. Now here, this is the default pod you need to select, and this is the free plan I already told you. Now I'll just create the index. Now see guys, it is initializing, so you need to wait for some times. Once it is done, so it will give you this green status. Okay, now see guys, it has created. Now here you will see the environment name. Okay, and this is the GCP provider. So basically this cluster has been created in the GCP cloud, and this is the region, and this is the environment name. So this parameter you can set if you are taking their paid subscription, but by default if you are using free one, so they will assign these kinds of provider and region. Okay, now I'll copy this environment name, and here I'll just need to replace. Okay, so for me I have already replaced, which is nothing but GCP starter. Okay, now let me just quickly set this environment variables, okay, inside my environment. Now here I will initialize my Pinecone. So if you visit Pinecone documentation, so they have given this code, like that's how you need to initialize Pinecone. So here you just need to provide this API key. So here is my API key. It will read from my environment, and here is my Pinecone API environment. So this is the environment. So it will automatically read it and it will initialize that. Okay. And here you also need to provide the index name. So this is my index name we have created called test. But if you are creating any other name, you can give the same name here. Now let me just quickly initialize this Pinecone. Yeah, so it has initialized. Now what I need to do, I need to create embeddings from my chunks. So let me first of all comment. So to create the embeddings from the chunks, so this is the particular code you need to execute. So first of all, here, whatever embedding I'll be generating, okay, so I'll store it in my Pinecone. That's why I'm just writing Pinecone from text. Okay, and here I've just written one list comprehension. Okay, I think you know list comprehension in Python. Okay, so basically the chunks, text chunks I have, so I'm just reading one by one. Then I'm just reading the page content. Okay, then this is my embedding object. I think you remember. So this is my embedding object, and I'm also passing my embedding, okay, embedding objects, and also I'm giving my index name. Okay, that means this is the index name. So this Pinecone client will automatically take it, and it will automatically convert your chunks to embedding with the help of this embedding objects, and it will store inside this index name. That means this index. Okay, inside this index it will store all of my vector. Okay, and it will give you one object called docsars. Okay, now let me just quickly execute and show you what will happen. See guys, it is taking all of my chunks one by one, and it has converted to vectors, and it has stored inside the Pinecone cluster. Now if I go to my Pinecone cluster, and here if I refresh this page, so guys, as you can see, I refreshed my page, and now I am able to see all of the vector here. If you see, if you just click on browsers, so here is the vector. Okay, and first of all it will show you the, like top 50 vector here. If you see, this is the representation. So this is the text, and on top of that, actually this is my vector. Okay, I'm getting, so you can also copy the vector and you can also see. Okay, and the length of the vector is this one. Actually, I think you remember, 1536. Okay, this is the length, and this is the beauty of this cloud vector DB. You can see your vector here, like how this vector has been created and what is the text with respect to that, and you can also see the scores. Okay, like what is the scores with respect to these vectors. Like this is the distance actually. Okay, that's how it create the index. Okay, I think I was also talking about like index in vector database, right? Indexes in vector database. This is the score. Okay, using this score actually it try to figure out the similar kinds of vector whenever you search any query, right? So this is the beauty of this vector, and I love this Pinecone one because it looks very easy, and it's like very beautiful interface it provides. Okay, and you can also see the second page, and you can see all kinds of vector here. Even you can also change the parameter. Let's say I want to see top 100 vector here. So if I just search the query, so it will give me all the 100. Okay, 100 vector here. Okay, so yes guys, and you can also see the metrics, like how many times you are raising the request and all. So it will give you all kinds of log here, like if any request is failed, so it will give the error logs and all, everything it will give you. Okay, so yes, so this is the simple interface of my this Pinecone, and vector counts is 168, because if I show you my chunks, okay, my chunk size was 168, so that's why you are able to see this vector count is 168, because I had 168 chunks. So with respect to that, this vector has been created. Okay, so yes guys, this is all about my Pinecone one. Now we are able to successfully store our data here, and this is the cosine, and this is the dimension, and all kinds of host and provider you can see here. Now let me show you like how to query out on top of your vector and all. So for this, what you can do, you can use something called similarity search. But before that, let's say if you have already one cluster here. Okay, so what you can do, you can load this cluster directly instead of storing that vector again and again. So this is the code for it. So let's say I have already one cluster, so you just need to give the index name, which is nothing but, let's say, test. And here you also need to give the embedding. Like here I'm using OpenAI embedding, so here I'm giving the embedding objects. Now if you execute, it will automatically load this index. Okay, it will automatically load, these are the vector here. Now see, it has loaded this vector. Now on top of that, you can perform similarity score operation. Now here, let's say I will ask one query. Let's say I have one YOLO V7 paper here. I think you saw that. So here I'm raising one query like YOLO V7 outperform which model. Okay, like we have lots of YOLO model, right? So from them actually YOLO V7 performs actually which model. So this is the query I'm asking. So now this query I will give it to my doc source. This doc source, this is the object. Okay, basically it will have all the like you can say vector objects and all. Okay, so here I'm going so here actually I can directly ask the query. So it has one function called similarity search. Okay, so inside that you just need to pass the query, and you need to set the k. Okay, I think you know what is k. So k means like how many output you want to get, okay, from your search results. Okay, so it will give me 3 results. Okay, now if I execute and show you, query is not defined because I haven't executed. Now let me show you. See, so it will give me a top similar 3 output. See, this is the 3 output it has given, but again it's not readable. So what you can do, you can take the help from LLM. So LLM, if you give this query and this output to the LLM will try to understand this query and the output, and it will give you the best answer, okay, from them. So here let's ask this query to my LLM. So I'll first of all initialize my LLM, and here I'll be using a retrieval question answer from Langchain. I think you remember I was also using, and chain type is stuff, and here I'm just giving this retriever object as my doc source. Okay, and as retriever. Okay, you need to give it like that, then it will consider you are you want to ask any kinds of question. Okay, and you want to get the answer. Now let me initialize this question answer object. Now you can ask the query here. So I'll ask the same query. So this is my query, and I will ask it to my LLM model. So I'll just initialize QA.run, and if I give the query, so it will give me the answer. See guys, YOLO V7 outperforms YOLO V5, L6, YOLO X, YOLO EX. Okay, so these are the model actually. It outperforms. Okay, see, it is giving the correct answer. Now I'm not getting this kinds of answer. Okay, I'm getting my relevant answer. Now I have one resume, I think you know. Okay, I have one resume also, Richard Gray CV. So let's ask some query from this resume also. So here is one question I prepared called Richard's Green experience. Okay, like what is her experience? Okay, so see, it will automatically give you that experience as well. This is the power of LLM. See, it's giving Richard Green has a PhD in English from the University of. It is giving like some more information about Richard Green, but it's pretty good, right? Yeah. So you can ask any kinds of questions. So you can also create one while loop here. So let me show you how to create while loop. So this is the while loop I have created, and here I'm taking the user prompt. So here you need to import one library called sys. Basically, whenever you are you want to exit, so you can exit it also. So this is like input I'm taking from the user, and if user is giving like exit, so it will exit. Okay, this code would be exit, and if it is not, then it will take the query and it will return you the answer. Okay, now let me show you. So if I ask like what is YOLO v7, now if I press enter, so it will give me the answer. See, YOLO v7 is a real-time object detection which surpassed all known object detection in bound speed and accuracy. Okay, it's giving the correct answer. Now let's ask any query. Tell me about Rachel Green. Yeah, I think Rachel spelling is not correct. I think it should be E. Now let me ask. See, it's giving the correct answer. Okay. Now if I press, let's say, exit, now it should exit the, yeah. Okay guys, I think you saw the entire like demo, how we can use the Pinecone, and you got the clear cut idea. Now in the next video, we'll be learning another amazing vector database called Weaviate. Weaviate is also a like you can say cloud-based vector database. There also you can create a cluster and you can store your embeddings. So if you search Weaviate in Google, you will get this documentation. So here they have already mentioned like how to connect this Weaviate with the Langchain and all, everything they have given, all the integration and all, how to install, okay, how to configure, everything they have given. So guys, what I've done, I prepared one notebook. This notebook will give you the entire understanding like how we can use this Weaviate vector database. Now this is the official website of the Weaviate, Weaviate.io. So here you need to create one account first of all. Make sure you have created the account, and after creating the account, actually you will get free credits. With the free credits, you can only create one cluster. The same way you did for the Pinecone as well, right? And again, it's a paid one, guys. You have to pay if you want to use their, let's say, advanced, let's say, I mean, functionality. You have to pay for that. So here we'll be only exploring the, let's say, free one, the free tier one, because free tier one is enough for landing. Fine. Later on, if you need it, you can also upgrade your subscription. So if you want to create the account, just click on try now button. So you will see they will ask for the email and password. With that, actually, you can create your account and you can log in with this Weaviate. So guys, now let's try to see the practical how we can use this Weaviate vector database. So here, first of all, you need to install some of the libraries. So these are the libraries are common. So guys, here now I'm using something called Weaviate. So this is the like Python package like Weaviate client. So you need to install this package to connect with your Weaviate. Okay, Weaviate cloud database. Now let me just quickly set up them. Now guys, what to do, you need to collect some of the credentials. So these are the credentials are required. So first of all, I need my OpenAI API key. Then I need my Weaviate API key and Weaviate cluster. Okay, cluster URL. So this three thing actually I need. So I think we already created my OpenAI API key. Just try to copy from my previous notebook. So here is my API key. So I'll just copy. And here I will just try to paste it. Okay. Now let's see like how we can collect this Weaviate API key. So for this, just visit your Weaviate dashboard, and here just try to create one cluster. Just click on create cluster. Okay, you need to give the cluster name. So let's give any name. So I'll give test. Okay, so you can give any name. So everything will remain same because this is a free one, and it will expire in 21 days because this is the free version, free tier I am using. Okay, but if you want to use for your production grade applications, at that time you can take the subscription. Okay, now just try to create the cluster. So it will take some time. Once it is ready, so it will give you the status message. And guys, if you see, Weaviate also support these kinds of client like Python client, Java client, CLI, TypeScript, then Go. So it has actually multiple client support. So like those are working in Java and all, so you can also use it. Now guys, see, my Weaviate cluster is ready. Now if I click on detail, now here it should give me that detail of my cluster. Now here, first of all, I need to copy this cluster URL. Okay, just copy this cluster URL here. From here you can also copy. Now let's go back to my Weaviate, and here you need to paste it. Oh sorry, this is my API, so I need to paste it here. This is my cluster URL. Okay, now I also need to copy the API. So here is the API option. Just click here, and this is the API key. Just try to copy and don't share. I'll delete it after this recording, so that's why I'm sharing. And I'll just paste it here. Okay, now I got my 3 credentials. Now let me execute them. Okay, so first of all, I need to read my data. So let me read the data. So here, first of all, I will create one directory called mkdirs data. Okay, now data folder has been created. Now inside that I will upload one. PDF file I have here. So this is the YOLO paper, actually YOLO related content. So you can download any kinds of PDF and you can upload here. No issue with that. You can either use text data, okay, doc data. It's up to you. So guys, as you can see, my PDF has been uploaded here. Now what I will do, I'll just try to load this PDF, okay, and I'll just extract that text from it. So let me show you like how this PDF will look like. So guys, see, this is the YOLO like presentation, okay. So I have downloaded as PDF. I'll just execute this particular code. So here I'm giving the data directory and I'm telling just load the PDF file, okay. Then I'm loading the data. Now let me load. So it's giving one error. It's telling unstructured package not found. Please install it with pip install unstructured. Okay, so what is happening actually? So if you see here, I have downloaded this Google, like you can say slide. Okay, Google slide as PDF. That's why it is considering as unstructured PDF. Okay, so that's why we need to install one package called unstructured PDF. So let me install it. So this is the command to install. But if you are having like PDF, like very simple PDF, so you don't need to install it. Okay, so this is for like unstructured PDF. So if you have any complex PDF, so you need to install this package. So previously I was using like paper and all. Okay, that's why it was simple PDF, but now I'm using like Google slide PDF. That's why it's giving this error. And it's pretty good. Like it will tell you like what are the packages you need to install and all. So it will give you the message as well. So guys, it's done. Now it's telling just restart the runtime. So let's restart our runtime. Okay, now let me execute this code. Now it is extracting all the text from this PDF. You can also upload multiple PDF here. It's up to you, but I have already added one PDF. I just want to show you the quick demo. Done. Now let me show you the data. So guys, this is the entire data I got from my PDF. Okay. Now I need to apply something called text splitting. I think you remember. I need to convert it to chunks. So let's convert it. So recursive character text splitter. Okay, I'm importing from Langchain, and this is the chunk size and chunks overlap. You can give any number here. So let me just do it quickly. Now I got my chunks. Okay, see, this is my chunks, and also let me see the length. See, all the things are common only. We are just changing the data database client. Okay, like I'm using ChromaDB, Pinecone, and Weaviate. So just client is changing, but steps are same. I think you are getting. Now I need to convert to embeddings. So let me just comment it out. So here I'm going to use OpenAI embedding. OpenAI embedding, and here you need to pass the OpenAI API key. If you're not passing, it's fine. You need to add inside the environment variable. So previously we added, if you see here, environment variable, but here I'm not adding environment variable. If you're not adding inside environment variable, you can directly pass them. Okay, that will also work. Okay, it's giving error. OpenAI is not defined because we have restarted the runtime. So I need to execute this cell again. Now I think it should work. Now here I'll be initializing my Weaviate vector database. So if you visit Weaviate documentation, there is the documentation, and here they have given the installation guideline, then configuration, then what is the schema, libraries, everything they have explained. Okay, so you can visit the documentation and you can get all the information. But here I already gone through the documentation and I prepared this notebook. So this is the code actually you need to write to initialize your Weaviate actually. That's why actually I like Pinecone one, because Pinecone looks easy. To me, because what I feel like Pinecone is like more easy, and it's like more easy to understand and like more clear. But if you're using Weaviate, so you need to write some extra code it. Okay, but it's completely fine. Okay, no issue. You can use it. I will share my notebook. You can use this notebook as it is. So here I'm just first of all importing Weaviate from Langchain. You can also import directly. It is also fine. Now here you just so first of all you just need to connect with your Weaviate cluster. Okay, this cluster we have created here, I think you remember this is the cluster. So to connect with the cluster you need to give the API key, Weaviate API key, and I think you know we already collected the Weaviate API key here, and I stored in the variable. Okay, then I also need collected the cluster URL. Okay, both I have collected. Now cluster URL you also need to give, then you need to initialize the client, and inside that you need to give the cluster URL and as well as the OpenAI API key also, because using the OpenAI API key, it will use the OpenAI embedding. Okay, whenever it will convert your data to vector embedding, so it will use that OpenAI embedding. Okay, so that's why you need to give the OpenAI API key here. Now I also need to give something called authentication configuration. So this is the authentication configuration, which is nothing but my API key, Weaviate API key, and this is the startup period. These are some default parameter you need to give, and let's execute. Okay, now if you want to check it whether this client is ready or not, so this is the code for it. So is ready. So now it is true. That means my client is ready. Now it is connected with my Weaviate client. Now Weaviate is telling you need to prepare something called schema. Okay, here they have given one client schema. So if you visit this client libraries, okay, so here if you see example client schema, so you also need to define some schema here. Schema is nothing but it just it kinds of configuration it will take, okay, as an input. Like you can change the configuration with the help of code. So that's why these are the things they are giving. But if you're not able to get it, okay, it's completely fine. So you just need to give this schema and it will come on for every experiment you'll be doing. So this is the complete schema, guys. Okay, so client schema detail. First of all, if it has any schema, it will delete, then it will add this schema. So here you can give any name. Okay, so I have given chatbot here. Then here you can give any description. Then what are the vector actually model you are using, you can give the name here. So in OpenAI actually you have ADA model. Okay, so here I'm using ADA model, I think you remember. If I print my embedding, so here I was using something called ADA model. Okay, as you can see here I was using something called text ADA embedding ADA model. So that's why you can also give the name, and these are some description you can give, and after that you can create the schema and you can create your client. Okay, now this is the code, so you can execute, and this thing is not required in Pinecone. So Pinecone can handle these are the thing automatically, but in Weaviate you need to provide. That's why I personally like Pinecone. Okay, now once it is done you need to initialize the vector store. Okay, so now this code will initialize the vector. So what it will do, basically it will take your documents. Okay, I think you remember we have created the documents. Okay, we have created a cluster, and from this cluster with the help of this embedding we are just trying to generating the vector and storing inside our Weaviate. Okay, now let me execute and show you. Now see guys, now if I go to my Weaviate and refresh, now it hasn't updated yet. So after some times you will see it will update, like how many embeddings had generated. Okay, then how many times you have you can say did the request, everything it will show you here. Okay, so all the information actually it will give you, and these are the, and guys, these are the embedding model are available by default with this Weaviate, so you can use any of them, it's completely fine. But we are using this ADA model, OpenAI generative model. Okay, so yeah. So guys, usually it takes some time, around 5 to 6 minutes. After that you will able to see all the update here. So in between, what I can do, I can show you the other step. Now we have successfully stored our embeddings. Now let me just do the similarity measurement, that means similarity search. So here, first of all, I will ask one query called what is YOLO, because this is the YOLO related content. And here I'm initializing this similarity search. Okay, because the vector store is, this is my object, and on top of that I'm just writing similarity search. Here I'm giving the query, and top k, that means how many output you want to get. So here I'm given 20, you can give any number. Now it will return like 20 results. Okay, 20 similar kinds of results. See, okay, but I can't actually take the answer. So what I can give one chain with the help of Langchain. So here there is another parameter called question answering. Okay, load QA chain. You can also use this chain. Otherwise, you can also use retrieve QA chain. Okay, that is also fine. Now here I'm going to use OpenAI LLM. Now I'll define my chain, and here I need to pass my OpenAI API key, and this is the chain type. And temperature means like if temperature is 0, so your model would be like more you can say stick to the answer, like it won't be giving any randomness. And if you're changing the temperature to close to 1, so it will give some random output as well. Okay, so this parameter you can change. I think if you have learned like LLM, so I think you know this parameter and all. Okay, so these are like basics thing, okay, in LLM. Now let me define my chain. Now here I will ask this query. So chain.run input documents. So this is my documents, this is my entire documents I'm giving. Okay, the documents I have, and see, this is the documents. That means I got all the answer, right? 20 answer, and from this 20 answer I want my query. That means the query I'm asking, which is nothing but what is YOLO. So now with the help of my LLM, I will get my authentic answer. See, YOLO is an algorithm for object detection that is unified, real-time, and has higher accuracy. It is presented by Shivang Singh, and this is the date of the publication. Okay, so yes, I'm getting my output and all. So now you can ask any kinds of question about YOLO and all. Okay, I think you got it. Like I already showed you multiple times. You can either create one while loop, and you can ask many question here. All right, guys, I think everything is clear now. How we can use this Weaviate vector database. So we have learned different vector database, guys, so far. Now we'll be using all of them to implement different like Gen AI application. If you don't know about Langchain is a generative AI framework. With the help of that, we can implement any kinds of generative AI based application with the help of large language model. So I think you already used something called PyTorch and TensorFlow whenever you used to learn deep learning, right? So inside deep learning, we used to implement computer vision project, NLP project. So there we used to use these kinds of framework like PyTorch and TensorFlow. So both are actually deep learning based frameworks. So with the help of that, you can create a neural network, right? That means all the functionality this framework provides to implement any kinds of neural network to, let's say, work with your data, to load your image, everything you can perform there. So similar wise, if you want to work in the field of generative AI, so inside generative AI, if you want to work with the large language model and all, so you have to use this Langchain framework, because Langchain is having all kinds of integration, all kinds of functionality. Okay, so only you just need to learn how we can use this Langchain properly, and with the help of that, how we can access different large language model, and how we can build different kinds of application. I think you saw the ChatGPT, right? ChatGPT, like, it's a very powerful application. So if you, let's say, give any kinds of prompt, that particular prompt actually it will try to remember. Okay, then if you are asking the next prompt, it will also try to remember that prompt, because it is using something called memory. Okay, memory inside ChatGPT, and how this memory is utilizing. So this concept is already available inside Langchain. Langchain is also having the memory functionality. So if you use this Langchain to implement this kinds of project, so you can also create a memory, okay, memory for that application, so that if user is giving any kinds of prompt, this prompt would be also remembered by your application. So not only that, actually it provides actually lots of functionality, guys. Unless and until you are not learning about Langchain, so you won't be able to understand. So what I will do, guys, let's quickly start our this practical demo of Langchain, because Langchain is all about practical here, nothing theory is there. So I already prepared one amazing notebook for you. So there I will show you the entire Langchain demo. So guys, as you can see, this is the collab notebook I prepared. So first of all, let's connect this notebook. And make sure you select GPU, because going forward, actually we'll be using some open source large language model from the Hugging Face itself. And to use that one, you need a GPU based machine. Okay, so make sure you selected the GPU. If you're selecting CPU, it's completely fine. It will also work, but the execution time would be a little bit high. Okay, that is the thing. Now let me cancel. Now, if you want to see the official GitHub of Langchain, guys, this is so you can see this is the official GitHub of the Langchain. Okay, see, it's like very active resource. The last commit was 3 hours ago only. Okay, now we can see they have given all the, let's say, tutorial how we can install and how we can access let's say different services of the Langchain. Everything they have given. Apart from that, see, they are having actually a very huge community. That means these are the communities supporting this library a lot. That means if anything is going wrong in this library, they are let's instantly solving that let's say issue. Even they're also upgrading this framework day by day. Now, apart from that, it is also having one beautiful documentation. So let me show you guys. This is the documentation link. If you just search Langchain documentation on Google, you will see this documentation. Now see, this is the entire documentation they are having. Okay, now see, different things they have developed. They have also developed ecosystem like LangSmith, LangGraph. We'll be also discussing about LangSmith and LangGraph. No need to worry. First of all, let's try to understand the fundamental of Langchain, like how we can install the Langchain, how we can integrate with different let's say platform. Like you can see, it is having different integration. Let me show you. So if I open the third-party integration, see, it supports Anthropic, then AWS, Google, Hugging Face, Microsoft, OpenAI, and many more. Okay, many more. See, all the different cloud Gen AI service it is also support. All the different let's say large language model platform it is support. Even you can also integrate with Hugging Face. That means whatever Hugging Face model I think I showed you now, I think you remember, all kinds of open source large language model is available inside Hugging Face. You can also easily use these are the model with the help of Langchain. And always try to remember, guys, Langchain doesn't have any kinds of large language model. Okay, Langchain is just a framework. It's just a framework to work with the generative AI based application with the help of large language model. Large language model wise, it will connect with different platforms. Let's say Hugging Face, let's say OpenAI, let's say AWS, let's say you can see different integration it is there. Let's say Microsoft. Okay, so those who actually provides these kinds of large language model, okay, so it can connect with those platform. This is the idea only. Got it? So it's just a framework. You can see they have also written Langchain is a framework for developing application powered by large language model LLM. Okay, I hope it is clear. Now see, they have written so many things. So what I did, guys, I just prepared one amazing notebook. So this notebook will give you the comprehensive idea how we can install and how we can use this Langchain. I think this is enough for you, okay, to learn about Langchain. Now see, this is the overview. So these are the things actually we'll be covering inside Langchain, like installation. We'll be learning about how we can like access different large language model. We'll be learning about prompt template, chains, agents and tool, memory, document loader, and indexes. Okay, so these are the things we'll be learning. Apart from that, we'll be learning some more advanced, let's say, technique. Like we'll be learning about ecosystem like LangSmith, LangGraph. Okay, these are the things also we'll be trying to cover. Now let's see how we can install the Langchain. So this is the command, guys, to install the Langchain. Just right pip install Langchain, and with that you need to install another package called Langchain community. Now let me install the Langchain. Okay, so after installing, I just need to set up some environment. Like I need to set up my OpenAI API key as well as the Hugging Face API token. Okay, why? Because here I'll show you how we can use OpenAI. Okay, OpenAI large language model. If you want to use, that's any kinds of commercial model, how we can access it. Even I will also show you how we can access any kinds of open source large language model from the Hugging Face, let's say, hub. Okay, so for this, I need to collect this authentication API. I think you know, or we have already generated one OpenAI API key. So see, here I have already written my OpenAI API key. So you can also write your OpenAI API key, and you need to also give the Hugging Face API token. And where you will get the Hugging Face API token, go to the Hugging Face platform, click on the profile, go to the settings. Now left hand side you will see access tokens. Now you need to create a token. For me, I already created the token, guys. You can see Langchain. Now if you want to create, just create a token, give the name. Let's say I'll give test. Okay, after that give the read permission and create the token. Now copy this token and try to mention it here. Okay, I hope it is clear. Now let me delete. I think I already created, so I don't need it. I will delete it. Okay, this token. So my token name is Langchain. You can give any kinds of name. It's up to you. Now let me set, these are the tokens inside my environment. Okay, it is giving one error because I have to initialize the operating system package first of all. then let me set inside my environment variable. Okay, now what will happen whenever you will be using Langchain, now it will automatically load these are the API key from the environment itself. Okay, you don't need to manually set that. This is the idea. Now we'll be learning about how we can use any kinds of large language model with the help of Langchain. So I think we saw we are having like two kinds of large language model. One is like commercial model, one is like open source large language model. Okay, commercial wise, we already saw the entire OpenAI platform. We are having GPT based model, and the open source wise, we are having this Huggingface model. That means we are having, let's say, Llama model, we are having Mistral model, Falcon model, like different models are available. Okay, in the Huggingface hub, if you see, okay, there are thousands of like large language models are available. I think I showed you one platform, OpenLLM. Okay, it should be OpenLLM GitHub. Now list of all the OpenLLM. See, all kinds of large language model you can see, and these are actually open source large language model. Fine. Now, first of all, let's try to see how we can access actually OpenAI large language model. See, whenever I think I showed you the OpenAI platform and I showed you the demo of the, let's say, model, like if I want to access this model, if I want to give any kinds of prompt, so how we can do it. See, this OpenAI is already integrated inside Langchain. So I think I showed you the integration now. So this open source integration, just open it up. Now see, OpenAI is already integrated with Langchain. So you don't need to manually, so here you don't need to manually use the OpenAI platform like the way we used previously, like ChatCompletion API, completion API. No, you don't need to use like that. See, it's the very simple. First of all, install the OpenAI. Then just import from Langchain large language model. I want to use OpenAI. Okay, OpenAI platform. That means OpenAI large language model. Just try to import this particular class. Now here, just try to set the temperature parameter. Okay, temperature parameter. Now, what is temperature parameter? I think you remember. Temperature parameter, it's just a creative actually parameter. Like how much creative you want to be your large language model. You can see if it is 0, close to 0, that means temperature, it means the model is very safe and it is not taking any bits. That means it won't be taking any risk. Okay, it will stick to the output. And if it is close to 1, that means this will be taking risk. It might generate wrong output, but it's like very creative. Okay, I think I already explained this part. Now let me initialize my OpenAI wrapper. Now see, I have already initialized my OpenAI wrapper. Now see, this is my large language model. So guys, whenever you initialize this wrapper, by default, actually it will utilize one model called GPT 3.5 Turbo model. Okay, but if you want to use any other model, you can give the model parameter here. There is a model parameter. With the help of that, you can also give any other model name. Okay, later on, I'll show you how we can change the model. As of now, let's take the default model only. Now let's say this is my prompt. You can see what would be a good company name for a company that makes colorful socks. Okay, this is the, let's say, my prompt I'm giving to my large language model. Now let me initialize this prompt. Now see, if I want to, let's say, generate the output, generate the response, I need to call the predict function. LLM.predict. Inside that, I need to give my prompt. Now see, it will give me the answer. Now rainbow threads or vibrant socks company. Okay, so this is suggesting the name of the company. Okay, that makes colorful socks. It's great. Now you can also directly pass this text to the large language model wrapper. So instead of calling the predict, you can also give like that. It will also work. So these are some actually way you can give the input to the large language model. Now see, it is also giving me the name. Now you can see, it has given me this name. Okay, this is the response. Now I can also use something called invoke function. Okay, inside invoke function also you can give the input. It will also work. See, invoke has given some more detailed output. You can see it has suggested me different actually company. I can use this name. That makes actually colorful socks. Okay, it's pretty good. Now let me show you the second example. So I've written the same code, guys. You can see now here I've given another prompt. I want to open a restaurant for a Chinese food. Suggest me a fancy name for this. So now let me give. So it is suggest me Imperial Dragon Palace. Okay, great. Now I can give the input like that also inside LLM object. Now Dragonfire Dining. Okay, great name. Now let me show you the Huggingface. Okay, Huggingface model, because see, at the end OpenAI is a chargeable. That means if you are sending any request to the OpenAI, okay, that means OpenAI model, it will charge you based on the token. So it's at the end there is a cost involvement. But let's say you don't want to spend the money, you don't want to use this kinds of paid model. You can also use open source large language model with the help of Langchain. It is also possible. For this, what you have to do, you have to use Huggingface app. Okay, because inside Huggingface I showed you, we are having lakhs of model. We are having lakhs of model. and all the models are open source. Okay, all the models are open source, and these are like large language model from the different organization. You can see from Meta, from Google, okay, from OpenAI. Then we are also having, see, OpenAI also having some kinds of actually free model. They are published in the Hugging Face. You can also use them. Mistral is also there. Different models. See, that many of models are available inside Hugging Face. It's like very huge model, na? Even I also showed you different tasks you can select. Based on that also you can also select the model. It's up to you. Now let me show you how we can integrate Hugging Face platform and how we can access Hugging Face large language model also. For this you have to install one library called Hugging Face Hub. So let me install Hugging Face Hub. Because the models are available, it is present inside Hugging Face Hub. Because I already told you now, the model they have published, it is called Hub. Okay, Hub. Inside Hub, actually these models are present. Now see, I installed the Hugging Face Hub. Now let me import Hugging Face Hub from Langchain. Now see, this is the model actually I want to use. So I've already provided the link. Let me open. So this is called actually Flan T5 model. This is from Google. And this is one of the large language model, guys. You can see if you are interested, you can go through the documentation. Okay. What can this model can perform and all, everything they have given. They have also given the paper link of the model. Now, if I go to my notebook, now see, here I'm using the large model. See, this is the extra large model and it's like very huge. I don't want to load this model. I want to use some smaller model because here I want to show you the quick demo. That's why. So I'm using this model actually, T5 large model. Let me show you. So this is the model, the same model only, but this is the small variant. This is the small variant and this is the X large variant. Like this is like more bigger than this one. Okay, I hope it is clear. Now, see, if I want to load the LLM object right now, that means large language model, I need to use Hugging Face Hub from Langchain. Inside that, I have to give the repo ID. That means the model you want to use, just copy the repo ID and pass it here. And you have to give some arguments. Okay, you have to give some model arguments. That means the same parameter, I think you remember temperature. What temperature will do? I think I already showed you. This is the creative parameter and the max length. I think you remember inside OpenAI also used to pass the max length. That means how many, let's say, output token you want to get from your large language model. So here I have given 64. Okay, you can increase and decrease as per your requirement. You can also remove this one. Okay, it's completely fine. Because at the end, it won't be charging you. Okay, it's a free model. So you can use as many of length you can. Okay. Now see, this large language model we are using, this is not like very good large language model, but somehow actually just to test, actually I'm using it. Going forward, we'll be using very powerful large language model, like we'll be using Llama model, Mistral model, Falcon model, okay, Jimma model, will be using different model. But this is like very basic large language model. Actually, I just wanted to show you as of now. Now, this is the prompt I have given. Translate English to German. This particular sentence. Okay, now see, how old are you? This sentence I want to do the translate operation English to German. And for this, I'm going to use this model. Okay, now let me execute and let me show you the magic. See, this is the output I got. This is the German translation of how are you? And this model actually, it is trying to access with the help of Hugging Face API. Okay, Hugging Face API, that means the token you collected and I think you just set inside environment variable. With the help of that, it is sending the request to the Hugging Face. Hugging Face is returning the answer. Okay, we are accessing through API request right now. Going forward, we'll be also learning how we can download the model as well. And we'll be loading that model with the help of Langchain, and we can create a LLM wrapper and we can do the application building. Okay, so I'll also show you this part. No need to worry. As of now, I'm showing you the API access. Okay, if I only want to perform the inference operation, how we can perform it. That is the idea. Now, again, I've given the second example. The same example, I want to open a restaurant for Chinese food. Suggest me a fancy name for this. Again, I've initialized my LLM wrapper with the help of my Hugging Face model. Now, if I give this prompt to my large language model, see, it is giving me Chinese restaurant. So this is not actually creative RAM because I told you now I'm using very basic large language model. That's why. Okay, so yes guys, this is the introduction of Langchain. I think you got it. What is Langchain is and how we can use Langchain exactly. Okay, and it's like very easy to use. It will, trust me guys, it will make your task very easy. If you're using Langchain, it will make your task very easy. Okay, now in the next video we'll be learning about something called prompt template. Okay, like how we can create different prompt template and how we can pass to the, let's say, large language model. Okay, with the help of Langchain. So previously, I think I showed you how we can use this Langchain to access different large language model. And whenever I was accessing this large language model, that means whenever I was, let's say, sending my prompt to the large language model, you can see I was giving the complete prompt. Okay, this is the complete prompt actually I was to pass. Let's say this is the prompt. I want to open a restaurant for Chinese food. Suggest me a fancy name for this. Now let's say if user needs to change this food, okay, food, let's say category, let's say he wants to, let's say, put Indian food here. So what he has to write, again, he has to write the complete prompt, yes or no. That means if I show you, let's say I can copy and I can paste it here. Let's say I will comment this line. Now let's say here, instead of Chinese food, I will give Indian food. Okay, Indian food. Now if I execute, see, it is giving me Indian restaurant. Now let's say if I want to give any other food, let's say I want to give Korean food, I want to give, let's say, Pakistani food, I want to give, let's say, Italian food. So I have to every time write the entire prompt. Okay, but let's say you are creating a complete application. You are creating a complete, let's say, web application, or let's say Streamlit application, or any kinds of application. There you don't want to pass this entire prompt again and again, because if user let's say needs to pass this prompt entirely again and again, so it would be little bit actually, let's say, hard for the user. Yes or no? Now see, instead of passing the entire prompt, you can see we can only change this food category. Okay, the food category will only change. Otherwise, see, this prompt will remain same every time. So that time actually I can do the slight modification here. That means I can create a template of the prompt, and user will only select that part he needs to change here. Okay, this is the idea. Now let me show you how it can be done. So for this actually we'll be using something called prompt template. Okay, now inside Langchain we are having inside Langchain prompts we are having something called prompt template. Now here I've created a prompt template, and here I've given the input variables is equal to cuisine. Now this is the same prompt I have written. You can see I want to open a restaurant for. Now you can see in the bracket I have written cuisine. Okay, now this is going to be the input only, and rest of the let's say prompt will remain same. Okay, as per the prompt you have written previously. Suggest me a fancy food dish. Okay, now here is the prompt template I'm creating. I'm just doing the format operation, and cuisine is equal to Italian. That means user will only give the food category right now. Let's say Italian, Indian, Pakistani, okay, or let's say Bangladeshi, anything they can put here. It's up to them. Now user don't have to write the entire prompt. User will only change the food category here. Got it? So this is called actually prompt template. So whenever we'll be creating any kinds of let's say large language powered application, whenever we'll be creating any kinds of GenAI application, we always need to take care of this particular prompt. Let's say I don't need to pass the entire prompt. Instead of that, what I can give, I can only give the prompt which is required to get my output. Okay, this is the idea. Now see, if I execute this line, now see, it is creating my complete prompt. That means user is giving Italian food. Now see, in the cuisine section it will come the now you can see in the cuisine section it will replace with the Italian. Now if I give, let's say, Indian, now see here it Indian will come. Okay, I think you got it. Now there is another way you can define this prompt template. Now you can write prompt template dot from underscore template. Now this is another prompt I have given. What is the good name for the company that makes? Now you can see product should be the input. Now here you can pass the product name like that. Prompt dot format product is equal to colorful socks, or any other name, let's say cakes, or let's say biscuits, anything you can give here. Now if I execute, see, in the product this input would be replaced. Okay, so this is called actually prompt template inside Langchain, and this is like very powerful concept, guys, because going forward whenever you will be implementing application, this concept will help you a lot. Got it? So yes, this is what I just wanted to show you. In the next video we'll be learning about chains inside Langchain, and with the help of chain actually we'll be integrating this prompt template as well as the large language model, and we'll be again doing the inference operation. And what is the use of prompt template? I already explained. Now see, if I want to use this prompt template with my large language model, so what I have to do, I have to combine my large language model as well as the prompt template I have created. Okay, for this we'll be using something called chains. You can see combine LLMs and prompt in a multi-steps workflows. Okay, to create a multi-step workflows, I have to create a chains. Now let me show you one example. I think then this part would be clear. Let's say first of all I will initialize my large language model wrapper, and here I'm using OpenAI model. Now see, previously, I think you remember, we learned this prompt template. That means if I want to, let's say, give any kinds of prompt, but I don't need to pass the entire prompt, only I want to pass some specific, let's say, point of that particular prompt. You can see here only I want to change the product name. So for this I created a prompt template, and the product name I've given the colorful socks. Okay, this is my entire prompt. You can see now it will create my entire prompt. So which is the good name for the company that makes colorful socks. That means whatever input you are giving, it will replace it here. Fine. Now as of now, let me comment this line. Let's say this is the prompt I have created. This is the entire prompt I have created. I think you would remember. Now, if I want to use this prompt, the prompt template I have created with my large language model, I have to use something called LLM chain. And how to import LLM chain? So from langchain.chains, import LLM chain. Now the first parameter you have to give the large language model. The large language model you have defined, which is nothing but open AI large language model. You can also use open source large language model. You can use Huggingface large language model as well, the way I showed you. Then you have to give the prompt template. The second parameter is, you can see prompt is equal to prompt. That means the prompt template I have created, this object actually I'm passing here. Then just try to call this function chain.run, and inside that give the input. Let's say whatever input you used to give like that. Instead of giving, you have to give chain.run and give the input. Let's say colorful socks. Now if I execute, see, it will give me the output. See, rainbow threads or chroma shocks, I think. Okay, chroma shocks, actually it is giving me the output. That means now we are able to use our prompt template as well as the let's say LLM. Okay, and for this we are using something called LLM chain. That means first of all it is creating the entire prompt template. First of all it is creating the entire prompt template. That means this entire prompt template, if I show you, that means it is first of all creating the entire prompt template, and this prompt actually it is passing to the large language model, and how things are happening with the help of LLM chain. Okay, that's why here I have written with multi-step workflows. That means it is creating a workflow in the backend. It is creating a pipeline. So first of all it will create the prompt, then this prompt would be passed to the large language model, and these things are handling by the LLM chain. I think you know what is chain, na? Chain means like one, let's say chain would be connected with another one. Okay, that means complete pipeline, complete workflow, sequence of, you can say, chains. Okay, so I think now you got it, what is chains exactly inside Langchain. Now let me show you another example, example 2. So again I'll initialize my large language model, and see, now here I'm using the second approach. I think, remember, we can also create the prompt template like that. So let's say here input variable is nothing but my cuisine. That means cuisine will only change and rest of the prompt will remain same. Okay, now this is my prompt template. Now if I want to pass this prompt template to my large language model, what I will do, I'll use the LLM chain. Inside LLM chain, I'll first of all give the LLM, then I will pass my prompt template, the prompt template I have created. Now you can see I'm calling chain.run, and here I'm giving the input. Let's say Mexican. I want to see the Mexican. Now here you can see I've given Mexican as an input. That means I want to open a restaurant for the Mexican food. Now if I execute, so it should suggest me some fancy name for this. See, this is the name it has suggested me, El Sabor de Mexico. Okay, the flavor of Mexico. Now if you want to see internally how it is like creating the entire prompt, for this you can activate one parameter called verbose is equal to true. Now see, if I again execute, it will show you, see, internally first of all it will create the complete prompt template. That means here you have given Mexican, so it will first of all create the complete prompt template with the help of Mexican. This prompt template will be passed to my large language model, and large language model will give you the output. Got it? So this is the work of chains. Now this is called actually single chains. Now let's see if you want to create a multiple chain. That means let's say you want to create a chain, and this chain output you want to again pass to another chain. Okay, for this you can use something called multiple chain. Okay, multi-chain. And to use the multi-chain, you have to use something called simple sequence chain. So there is another class inside Langchain chain called simple sequential chain. We'll be using this one. Let me show you one example. Let's say this is my large language model I have defined, and this is the prompt I have created. The first prompt, you can see the same prompt. I want to open a restaurant for the cuisine's food. Suggest me a fancy for name for this. So it will take the cuisine input, and this is the LLM chain I have created. Okay, I think you remember, this is the LLM chain I have created. That means this is my LLM wrapper and this is my prompt template. Okay, now what I want, whatever, let's say restaurant name actually it will suggest. Okay, whatever restaurant name this prompt will suggest, that means this large language model will suggest this name. Again I want to pass to another prompt template. For this I created another prompt template. Now input variable is restaurant name. That means this prompt will give you the restaurant name, yes or no, because here you have given cuisine's food, suggest me a fancy name for this. Okay, now it will give you restaurant name, and this restaurant name I want to utilize, and here I have written another prompt, suggest me some menu item for this restaurant name. That means let's say you have given Indian, let's say food. Now it will give you some Indian restaurant name, and this Indian restaurant name here I will pass, and it will give me some menu item for the Indian restaurant name. Okay, I think you got it, how it is interconnected with each other. This is called actually multiple chain. Okay, now see here I have created another chain. Now if you want to use this both chain, I have to use something called simple sequential chain. Now there are some limitation inside simple sequential chain. I'll tell you what is the limitation. As of now, let me show you the, let's say, example. So you can see I have initialized the simple sequential chain. Inside that, chain is equal to, first of all I will give my name chain. You can see first of all I will give my name chain. That means it will give me the restaurant name. Okay, then I will give my food item chain. That means this particular chain. That means whatever restaurant name I will be getting from this chain, I want to pass to the next chain. Okay, which is nothing but my suggest me some menu items for the restaurant name. Okay, now here is the final code, chain.run. Here I have given the Indian. That means first of all it will go inside that, and it will give the output, and this output will go in the next chain. Okay, now it will give me the output. Let me show you. Now see, I have given Indian. Now see, this is the Indian menu I got. That means what is happening? First of all, it is executing this prompt template. then it is executing this prompt template. Okay, and how it is handling? It is handling by the simple sequential prompt template. That means it is following the sequence. First of all, this sequence will execute, then this sequence will execute. That's how we can create multiple prompts. Not only 2 prompts, you can create 3, 4, 5, 6, and so on. If you need any kinds of, let's say, application, this is like interconnected with, let's say, previous prompt. Okay, you can create this kinds of sequential prompt. Now I think you got the idea how ChatGPT works. Okay, how ChatGPT works. Let's say how, let's say if you are giving any kinds of input, how it is connected with the previous prompt as well. Okay, they are also using something called this sequential chain in the backend. Okay, chain method they are also using. I think it is clear now. Now the limitation of simple sequential chain is it is only showing you the last output, last chain output. You can see only the menu item. But if I want to also see the previous chain output, what is the output it is giving, for this you have to use something called sequential chain only. Okay, sequential chain, not the simple sequential chain. Okay, this is the difference only. Now let me show you one example. Let's say I've given the same example. So I want to open a restaurant cuisine name. Okay, here I have to pass, and here creating the LLM chain. Okay, now this is the another chain I've created, guys. You can see. So whatever, let's say restaurant name actually I will get from my first chain. You can see output key, it will return you the restaurant name. So it should be the input for the next chain, which is nothing but my menu. Okay, menu of the restaurant name. Here you've given the input is equal to restaurant name, and this is the template. Suggest me the menu of the item for restaurant name, and this is my second actually chain I have created. And what is the output of this chain? The output would be menu item. That means whatever menu actually it will suggest you. Now here I have initialized my sequential chain. Now inside sequential chain I have to pass my chain. First of all I have to give my name chain. That means the first chain I have created. Then I have to give the second chain. Now here you have to specify the input variable. What is the input variable? I think you saw the first input variable is nothing but cuisine. Okay, cuisine should be my input variable. And what with the output variable? Output variable would be the restaurant name as well as the menu item. Okay, restaurant name as well as the menu item. That means both it will show me. Now let me execute and let me show you. See, now I'll call my chain, and here I'll give the input only, which is nothing but Indian. That means cuisine name. Now see, it will give you the output. See, first of all, it will give you the cuisine, then the restaurant name as well as the menu item. That means this prompt, it is giving you the output. This prompt, it is giving you the output. Even the menu item, it is also giving you the output. That means complete output you can see here. So which is not available inside my simple sequential chain. Okay, this is the difference only. I think you got it right now. Got it? So yes, that's how actually we can use chain to interconnect my prompt template with my large language model, and we can easily get any kinds of response from my LLM. Okay, now in the next video we'll be learning about something called agents and tool inside Langchain. So what is agents and tool exactly? Let me show you. See, agents and tools is actually a very powerful concept inside Langchain. So it will help you to, let's say, plug in with different kinds of, let's say, tool. Let's say if I give you one example, let's say I have traveled from Dubai to Canada. I type this in ChatGPT. Now give me 2 flight option from Dubai to Canada on September 1, 2024. Now ChatGPT will not be able to give the answer because it has actually knowledge till September 2021. That means after 2021, if you are asking anything to the ChatGPT, it won't be able to give the answer because it doesn't have like the new information regarding 2024. But ChatGPT Plus has Expedia plugin. If we enable this plugin, it will go to the Expedia plugin, and it will try to pull the information about flights, and it will show the information. That means if it is not able to give the answer related to 2024, what it will do, it will try to connect some third-party plugins, third-party API. Okay, and from there actually it will pull the information and it will show you. Let me show you one example. Let's say this is my ChatGPT. Now here, if I give this prompt, what was the GDP of Canada in 2024? Now see, if I give this to the ChatGPT, see, ChatGPT is searching Canada, GPT, see, it is already searching. Okay, it is already searching in the third-party API. Now see, in 2024, now you can see it has given me the answer in 2024. What was the GDP? Okay, in that Canada. That means it doesn't have the information about, let's say, 2024. What is the Canada GDP? But it was searching. Okay, it was searching in the third-party API. That means it has some plugins inside that. Okay, so it is happening with the help of this agents only, agents and tool. Okay, with the help of agents and tool, they are doing this kinds of tasks. Now let me show you how you can also perform this agents and tool operation inside Langchain. Let's say you want to create an application, and this application will also be able to give the answer from the newest, actually, let's say information, okay, over the internet. For this, you can connect actually different tools, different plugins. You can connect SARP API. See, this is the SARP API. SARP API is a Google search, actually, let's say API. You can also directly search from the Google. Even you can also connect the Wikipedia. Okay, let me show you one Wikipedia example. Even you can also connect different actually third-party plugins. Okay, there are so many third-party plugins. If you search on Google, you will see different third-party plugins they are using. Okay, you can also connect it to weather. Okay, weather API to get the, let's say, recent weather. It is also possible. Now see, first of all, I will be installing Wikipedia just to show you the demo of the Wikipedia. Now you can see I'm importing these agents from the Langchain. I'm importing agents type, then initialize agents and load tools and all. Then I'm also importing my OpenAI. That means I want to use OpenAI large language model as of now. Now this is my, let's say, LLM wrapper. Okay. Now if you want to define the agents, so you have to define like that, guys. First of all, call this load tools, and inside that, first of all, mention which, let's say, plugins you want to use. I want to use Wikipedia plugins. That means whatever things actually I'll be searching, if it is not available inside my ChatGPT, let's say knowledge base, it will go to the Wikipedia. Okay, it will hit the Wikipedia, and from Wikipedia actually it will get the response. Then it will also use something called LLM math tool. And why LLM math tool? Because let's say if you are asking something related GDP, or let's say any kinds of number, any kinds of numerical representation. So for this, actually this LLM math is required. Okay, they are suggesting if you go to the documentation, you will see that. Then I'm also passing my LLM wrapper, this particular object. Okay, that will give me the tool. Now here I have to initialize the agents. First of all, give the tool you have created, then give the LLM you have created, as well as the agent type. So this is the agent type you can give, and verbose is equal to true means it will also show you the output, okay, like what it is executing in the backend. Now just simply search agent.run. What was the GDP of US in 2024? Let's say this is my question. 2024 GDP I want to ask. Okay. Now see, if I execute this program, now see, it has actually connected with my Wikipedia, and it has fetched the information, and this is the final results, guys. You can see the GDP of US in 2024 was 28.269 trillion dollar. Okay, it's great. That means it is also able to get the current information, okay, newest information over from the internet itself. And this is like very powerful tool, guys. Trust me, if you want to implement any kinds of let's say LLM powered application and you want to integrate this kinds of functionality, you can use this agents, okay, because ChatGPT is also using agents in the backend. I hope it is clear. Okay, now in the next video we'll be also learning about memory. Let's say I told you now ChatGPT can also remember the previous context. Let's say if I give one let's say message here, give me a code to add 2 numbers in Python. Let's say this is the prompt I have given. Now see, it has given me the code. Now see, it has given me one function, but I don't need the function. I'll just write without function. Now see, it has automatically remembered my previous prompt I have given, and now see, beautifully it has given me the second response. That means it is having some memory, okay, a buffer memory in the backend. With the help of that, actually it is trying to remember my previous context. So we'll be learning this part in the memory part. I think I already showed you one demo of the ChatGPT. ChatGPT can remember my previous let's say prompt. That means whatever previous prompt you are giving, it can remember that context, right? So how they're remembering the previous, let's say, prompt and context? Because they're using something called memory, okay, memory in their application. Now with the help of Langchain, actually we can create this memory. So whenever you want to create any kinds of generative AI application, so definitely you should integrate the memory with that, because people will be asking the question and your application should remember that particular context. Okay, this is the important things. Now let me show you one demo of the memory. So here I've already written chatbot application like ChatGPT. You will notice it will remember the past information. And how they're remembering the past information, they're using memory. So let me first of all initialize my LLM wrapper. I'm using the OpenAI LLM here. Now, first of all, let me show you, if you are not using like memory, okay, memory, let's say functionality from the Langchain, what will happen? Let's say here I've created a prompt template, the same prompt template. I want to open a restaurant for the cuisines food. Suggest me a fancy name for this. Now, see if I create this prompt template, and if I give this prompt template, what I have to do, I have to use LLM chain. Here I'm passing the LLM, and here I'm giving the prompt template. Okay. Now this is the, let's say, input I've given Mexican. So it will give me the output, the restaurant name. So guys, you can see it has suggested me different restaurant name. Now, if I give Indian also, see, it has also given me Indian restaurant name. Now, if I show you the chain memory, that means whether it has saved anything or not. So I'll just write chain.memory. See, it is none type. That means it hasn't saved my previous information. Whatever, let's say, question I have asked, it hasn't saved any kinds of information. Okay, you can see it's a none type. Completely it's a none type. Now, if I want to add the memory functionality, what I can do, I can use actually 3 kinds of memory inside Langchain. I'll discuss all of them one by one. First of all, let's try to see conversation buffer memory. Okay, so just try to import Langchain.memory, import conversation buffer memory. Okay, now see, this memory will try to remember the previous conversation. Now, first of all, create a memory object. You can see conversation buffer memory object. Now, same thing you have to initialize, only another parameter you have to pass, memory is equal to memory. Okay, now again, I'm giving Mexican food. Now I have given, let's say, Arabic food. Okay, now if I show you my chain.memory.buffer, you will see that it has remembered my previous context. So if human has given Mexican, then AI has replied. Again, human has given the, let's say, Arabic input, then again my agent has replied. That means it is trying to remember my previous conversation. Amazing, right? Now, one issue actually will get with this conversation buffer memory, it can remember all the input it will be giving. Let's say whatever input it will be giving, all the input actually it will try to remember. So whenever it is trying to remember all the input, that means it is occupying your memory space. So I don't need to remember all the, let's say, context of the user. I can only remember, let's say, 5 to 10, let's say, context. It would be enough for me, because if you go to the ChatGPT also, it can only remember 5 to, let's say, 6, let's say, context, 5 to 6 conversation. Okay, apart from that, whatever things it will say previously, it will delete. Okay, so for this actually we can use another actually memory called conversation chain. Okay, now here I have already written conversation buffer memory goes growing endlessly. That means it can save all the information. And if I want to set only, let's say, 5 conversation, or let's say, or 10 to 20 conversation, that time I will be using conversation chain. Now here is the example of conversation chain. First of all, you have to define the conversation chain, and inside that you have to pass your LLM wrapper. Now let me show you the template. Now see, this is the template actually it will give you. Okay, now you can see current conversation, there is no conversation, that's why it's empty. Now let me do some conversation. So here I have given the first conversation, who won the first cricket World Cup. Let's say this is my first conversation. So this is the output I am getting. You can see the first cricket World Cup owned by the India in 1983. Okay, now here I will give another, let's say, prompt. How much is 5 plus 5? See, this is the irrelevant question I'm asking. Now this 5 plus 5 is equal to 10. Now again I'm asking who was the captain of the winning team. Now it will refer my this actually prompt. Okay, this context. Now see, the captain of the winning team in India was Kapil Dev. Do you have any other question? See, amazingly, it has remembered my previous let's say conversation. Okay, that's how also ChatGPT is working. I think the same example I have given you. You can also ask this question like this add number code question. You will also see the same output. Okay. Now if I show you the my buffer memory right now, so this was my input, then this was my model output. Then again I asked this question, again this was the output, again I asked this question, this is the output. Okay, that's how actually you can save 5 to 10 conversation here. Okay, 5 to 10 conversation here. After that it will remove everything. Okay, now you can also set the window size, like how many conversation you want to save. You also have one parameter to set. For this, you have to use something called conversation buffer memory window. Sorry, conversation buffer window memory. Now, just try to define the memory. Inside that, just mention this parameter k is equal to 1. That means it will only remember one conversation. Okay. Now, just try to define this conversation chain. Inside that, mention your LLM as well as the memory. Now, if I again do the conversation, who won the first cricket World Cup? Now, I'll again ask how much is 5 plus 5. Now, it is giving me the output. Now, again, if I ask who was the captain of the winning team? Now see, it is telling I don't have enough information, context, answer this question. Okay, because I have only given k is equal to 1. That means it is only saving my one information. Okay, now if I give, let's say k is equal to 3. Now it will remember my previous 3 conversation. Let me show you. Now again, if I ask this question, who was the captain of winning team? Now see guys, it is giving me the output. Okay, now if I show you the conversation, now you can see it is remembering my previous context. Got it? So that's how whenever you are creating any kinds of application, guys, try to use this memory. Okay, memory inside your application. This will make your application very powerful. And now I think you are getting the logic behind ChatGPT, how ChatGPT is working. It's just an application, guys. Always try to remember ChatGPT is an application. Inside that, they're using large language model, which is nothing but GPT series. Okay, and whatever functionality they have created, this memory functionality, then chain functionality, prompt template functionality, they're using this kinds of framework, Langchain framework or LlamaIndex framework. There is another framework called LlamaIndex. This is the alternative framework of Langchain. We'll be also discussing this part as well. Fine. Okay, great. Now in the next video, we'll be learning about documents loader. let's say whenever you want to build any kinds of RAG based application, retrieval augmented generation, let's say you have some custom documents, and if you want to load these documents and you want to connect with your, let's say large language model, that time you have to load your documents. Okay, whatever documents you are having, whether it's a PDF documents, documents, or let's say TXT documents. Even you can also load the website also, just on any kinds of file format you can open, any kinds of website you can integrate here. Okay, so Langchain is very powerful, guys. You will be loving a lot, trust me, guys. So in the next video, we'll be learning how we can load the documents. Then after learning this, Langchain will be also implementing different projects, so that this concept would be clear, how we can load our custom documents, how we can create a RAG based application, okay, how we can create a chatbot, different things we'll be learning. So if you go to the Langchain documentation, you will see we can also load different documents with the help of Langchain. So you can load, let's say, custom documents, let's say any kinds of file format, CSV, then a file directory, HTML, JSON, Markdown, okay, Microsoft Office, PDF, text, Twitter, okay, any kinds of documents you can load with the help of this Langchain. Even you can also connect different, let's say, platform. You can also connect Slack, you can also connect, let's say, Discord, and from there also you can extract the data. It's like very powerful, guys. You can go through the documentation, you will get each and every idea. Even they have also given the code snippet, okay, how we can, let's say, connect with different, let's say, document format, and how we can load the documents. Fine. See, always try to remember, whatever, let's say, data we are loading inside Langchain, it would be considered as a document. Let me show you one example. So here, let's say I want to load one PDF documents. Let's say PDF I want to load. Let's say I'm having one PDF. Let me show you. So this is my research paper, guys. This is my research paper, guys. I published some years back. You can see I'm the author. So this is the author. Okay, I'm the author. Now you can see this paper is about actually development of multiple combined regression method for the rainfall measurement. Okay, and this paper is already published in the ResearchGate. Let me show you. If you go to my LinkedIn profile, this is my LinkedIn profile. You can connect me on LinkedIn, guys. You can follow me. So if you have any question, you can ask me there. I'll try to reply. Now see, if I show you this particular publication, so see, this is what I've already added. Now if I open this publication, see, this is the publication, and this is in the ResearchGate. Okay, even if you open the Google Scholar also, you will get it there. So this PDF actually I have downloaded, this paper PDF I have downloaded. Now what I will do, I'll just try to load the documents. Okay, whatever, let's say, information I'm having in this, let's say, PDF, I want to extract these are the information. For this, I'll be using Langchain. So let me show you. First of all, I need to install one package called PyPDF. Now let me upload that PDF here. So my paper, I'll upload it here. Now see, it is getting uploaded. You can use any kinds of documents, guys, docs, TXT, CSV, JSON, anything. And again, visit the documentation, you will get all the code snippet. Let's say you want to use JSON. So this is the JSON, okay, JSON loader you have to use. Let's say you want to load CSV. You have to use CSV loader for this. Okay, now I'll be loading something called PDF. That's why I'll be using PDF loader. Okay, now see, this is updated. Now I'm importing this PDF loader from Langchain. You can see document loader, PDF loader. Now here you have to give the location of the file. Let's say this is my location. Okay, now you have to call loader.load. Now see, it will automatically extract all the information, and this data would be considered as a document. Let me show you. Always try to remember, inside Langchain, inside Generative AI, all the data would be considered as a documents. Okay, that's why I think you remember in the vector database session, I was talking about documents. Okay, chunking documents, these are the thing. Okay, now I think you got it. Now see, it has extracted all the pages. Now see, this is considering as a document. This is the type of documents right now, and all the information present inside my paper. Got it? Now we can use this data to implement any kinds of RAG based application. That means with the help of vector database, I can store these are the data with the help of embeddings, and I can connect my large language model, and I can ask some information there. Okay, don't need to worry. I'll be explaining this RAG concept and all. Okay, why RAG is important, why we have to create the RAG. Even we'll be also learning about fine tuning. Okay, how we can, let's say, take our custom data and we can perform the fine tuning. As of now, we have learned the fundamentals of Langchain, and I think I covered almost everything about the Langchain, whatever things you need to work with the Langchain. But I will show you some more advanced concept of the Langchain. This will also help you. Okay, so far I think we have covered so many things inside Langchain. We have learned the entire fundamental concept of the Langchain. So one thing I wanted to tell you, see, Langchain also can work with this your pandas data frame. That means directly pandas data frame you can pass to the large language model, and you can ask some question there. Okay, it is also possible. For this, you can use your large language model, any kinds of large language model, and with the help of Langchain framework, you can perform these kinds of operation. Let me show you. So first of all, I have to install some of the library. So here you can see I'm installing Langchain and Langchain experimental. Why Langchain experimental? Because this pandas data frame actually agents will be using. Nah, this is available inside Langchain experimental. Okay, that's why I have to import all of them. So let me import. And I'm going to use OpenAI large language model. That's why I'm using OpenAI here. Now I'm going to import some of the required libraries I need. Now you can see from Langchain experimental agents toolkits, I'm importing create pandas data frame agents. Okay, you can go to the documentation. You can see pandas data frame documentation inside Langchain, and they're also loading in that way. Okay, and they're giving a data set. Okay, any kinds of data set they're loading with the help of pandas, and they're performing lots of operation. Okay, so you can use different large language model, and you can perform chat operation. Okay, with this data frame. Let me show you. So let me import the library first of all. I'll import the pandas as well. I'll set my OpenAI API key. Then this is the data I want to load. Let's say this is the CSV data, Titanic CSV data. It is available in this GitHub. If I show you the live GitHub link. So this is the data, guys. It is already available. So let me first of all load this data with the help of pandas. So here is the data, guys. I think you are already familiar with this Titanic data. Now, first of all, we'll be performing this chat operation with the single data frame. So I'll initialize my large language model. Now create an agent. To create an agent, just call this create pandas data frame agents, this class. Inside that, give the LLM data frame. Verbose is equal to true means it will show you the entire, let's say, execution details. And here you have to give another parameter called allow dangerous code is equal to true. Now I'll create the agents. Now here I can ask the question right now. I'll ask how many rows are there in the, let's say, data frame. Now see, it will count and it will automatically give me the answer. See, around 891 okay rows are available. I will give another question. How many people have more than 23 edges? See, amazingly your model will try to go through that data frame and it will give you the answer. See, 468. Now I can also work with multi-data frame. So for this, what I can do, I can copy this data in another variable called df1. See, I'm copying this df only. Now I'm creating another df1 here. This is the data. Now what I will do, I'll just fill the none value, okay, which is present inside age, because age is having some none value. I'm just filling. Now again, I'm creating the agents. You can see. Now here you can see I'm giving multi-data frame, df and df1. Okay. Now let me create the agents. Now I'll ask one question. How many rows in the ages columns are different? Okay. Now let me show you. Because I already filled the information. Now around 177 rows have the null value. Now you can see rows have different values in the age column. I think you got it. Now I'll create another data frame called df2. And now I will just multiply 2 with the age. Whatever age I'm having, I'm just multiplying 2. Now this is the results. Now I'll create another agents and it will have 3 different data frame. Okay. Now let me create the agents. Now I'll ask one question. Are the 3 of the columns same in the all the data frames or not? Definitely it should be same for all the data frame because I've just copy pasted the same data frame again and again 3 times. So here all the column name should be same. If I show you the output, see. So see guys, I'm getting the output agent stop due to the iteration limit or time limit because I'm executing multiple time now. That's why I just use the limit. Okay, that means my limit has been done. So what you can do, you can restart the runtime again. You can execute the entire code. You will see that all the column should be same, okay, in 3 different data frame. Okay, we'll get this kinds of output. Now you can ask any kinds of question, okay, about this data frame. So this is called actually multi-data frame agents inside Langchain, and this like again very powerful concept if you want to work with the data frame and all. Going forward, we'll be also implementing some projects with that. Okay, this concept will help you a lot. So as of now, I think I showed you lots of example, lots of demo of the Langchain, like what are the things we can perform. Even I also told you we can also, let's say, access different open source large language model from the Huggingface itself. Okay, so this would be the dedicated video about this Langchain integration with the Huggingface. So there you will see that how we can access different model with 2 kinds of method. Like one method I will show you how we can access through the API request. Another method I will tell you how we can download the model, okay, in our Google Colab, and how we can use this particular model. Okay, this is the idea. So first of all, let me install some required package. So you can see I'm installing Langchain community, Huggingface app, transformer. Why transformer? Because I want to use a Huggingface platform. I want to download the Huggingface model. That's why transformer is required. I think I already taught you about the Huggingface, like how to use Huggingface and what is transformer library. Everything I already discussed. And these are some actually dependency package you need to also install with the Huggingface. That means your transformer. Now let me install all the library one by one. So guys, as you can see, my installation is completed. Now let's import some of the library. You can see I'm importing prompt template, Huggingface app, LLM chain from the Langchain itself. Now, first thing what you have to do, you have to setting up the environment. For this, you have to set the Huggingface API token. And how to get the Huggingface API token, I think I already explained. Go to the settings and left hand side, you will see access token option. So you can create a new token here. I already showed you how to create a token. Okay, so I'm not going to show you again. So now let me set my token. Now we'll be learning the first approach, like access the hosted model on Huggingface through API request. Okay. Now see, here we'll be accessing one text to text generation model. So first of all, let's create a prompt template. So here's the prompt template I have prepared. What is the good name for a company that makes product? So product should be my input here. Now here I'm creating the LLM chain. I'm giving my large language model, and you can see I'm using Huggingface app and I'm giving this model ID. That means I will be using this model. So this is the Flan T5 model. This is from Google actually. So we'll be using this model here. So let me load this model. And here is the model arguments. That means temperature and max length parameter. And here I'm giving the prompt. Okay, the prompt template I've created. Now let me create the chain object. Now here you can give the output. Let's say I will give colorful socks. Let's see whether it is able to give the response or not. See, it has given me sock mania. Okay, this should be the name. Now let me show you another prompt. You can see I have written another prompt. Can you tell me about famous footballer? So it will take the famous footballer name and it will tell you about him. So let me show you. So again, I'll create the chain and see the same code actually I'm using. Now if I give Messi, now you can see guys, it is giving me the response. Messi is a footballer who plays for Argentina. Great. Now you can give another prompt. Let's say, can you tell me food items for the cuisines restaurant? So cuisine should be the input. Let's create. And I'm using the same code snippet. Now let me initialize the chain and let me give the input. Let's say Indian. Now see, it is giving me vegetable. Okay. Can you tell me the food items? Yeah, vegetable is fine. Now if I again execute, let's see. Okay, vegetable it is giving, because I told you now this model is not good. Now guys, let's see how we can use any other model. See, again I have prepared one prompt template and again I'm using the same thing. Can you please tell me about famous footballer? Now see, instead of this T5 model, I'm using Falcon 7B. So this is one of the large language model. It is already available in the Hugging Face. Okay, you can see. So this is the organization, they published this Falcon, and Falcon is having different variant, Falcon 7B, 13B. Okay, that's how it is having different variant. And this is one of the like great large language model you can use. Now let me show you one demo. Now let's load it and see, I'm using the same code snippet and I'm sending the request. See, this model actually I'm not downloading in my machine. So it is using the API to access the model and it is giving me the response, and that response actually I can see. Okay. Now see, this is the response I got, and it's like very detailed response I got. Okay, than your previous response. Now let's see the approach to like how we can download this model locally and how we can create a pipeline. That means that Hugging Face pipeline, I think, remember, right? For this, let's import Hugging Face pipeline from Langchain. Then I'm also importing some additional library like auto tokenizer, auto model for casual LLM, then pipeline. Okay, these are the thing I'm importing because I think you remember how to create the pipeline. So let me import them. Now see, I'm using this Flan T5 model again. So let's initialize the model. And first of all, I have to create the tokenizer. If I want to download the model, I have to create a tokenizer. I think you know that, right? Tokenizer will pre-process your input. That means it will process input, it will create the embeddings, and then it will pass to the model. Now here I'm going to initialize my model. You can see I'm giving the model ID, then device map is equal to auto. That means it will load the model inside my GPU. And make sure whenever you are like downloading the model locally, you are using GPU based machine. Okay, good configuration machine. Otherwise, execution time would be very like slow. Okay, but if you're accessing through API, you don't need a GPU based machine. Now let's create a pipeline. You can see it's a text to text generation model. So here I've given text to text generation model, tokenizer, and max length. Now let me create the pipeline. Now I'm going to initialize my LLM wrapper. So I think you remember we called this Hugging Face pipeline from Langchain. Now, so here you can see I have initialized my LLM wrapper and pipeline. The pipeline object I'm getting, I'm passing inside this Hugging Face pipeline. Now this is going to be my wrapper. Now again, I'm going to create the prompt template, and this is the example I have taken, the same company. Okay, company example. Now let me pass to the LLM chain and as well as my prompt. See, I'm passing my large language model as well as my prompt. And now see, the model actually I'm passing, this model actually I've downloaded. Okay, LLM, local LLM, not the API one. Okay, so both way you can use this Hugging Face. Now let me show you the results. See, socks mania. Now let me prepare another prompt. Can you tell me about famous footballer? Now let me initialize the chain. Now let me ask about Messi. See, Messi is a footballer who plays for the Argentina. Okay, so That's why, guys, we can access Huggingface model, open source large language model, with the help of Langchain. And going forward, we'll be using this concept, guys. And with this concept, we'll be implementing so many applications.